AI coding agents are everywhere. Claude Code, Cursor, Codex, Gemini CLI. For the longest time, I thought, how complex could building this really be? You send a prompt to an LLM, it generates some code, maybe runs a command, that's it. And honestly, I wasn't wrong. It really is just an LLM. But what changed for me was realizing how much leverage you get from everything around it. Once you start adding scaffolding, things like tools, memory, context management, feedback loops, the model stops feeling like a chatbot and starts feeling like a system. It's not smarter, it's just more useful, more reliable, and more intentional. So I wanted to see what that actually looks like when you build it yourself. This is a Claude Code style agent built from scratch. It can read your codebase, write and edit files, run commands, search the web, it remembers important context about you across sessions, plans, executes, and even spawns sub-agents when tasks get complex. When context gets too long, it compacts and prunes so it can keep running until the task is done. It catches itself when it's looping, it also learns from its mistakes through a feedback loop, and users can extend it. They can add their own tools, connect to third-party services through MCP, control how much autonomy it gets, save sessions, restore checkpoints, and more. In this video, we'll build the entire thing. If you know Python fundamentals, that's enough. I'll explain everything else. Let's get started. Let's start by creating a project. So I'm going to cd into desktop. CD stands for change directory. So I'm going to the desktop folder, and over here I'm going to create a new folder, which I'll do by typing in mkdir, which stands for make directory, and let's call this AI agent. You can give your AI agent any name you want. I'm just going to go ahead with the simple AI agent. After that, I'm going to cd into AI agent again, and I'm going to open this up in Visual Studio Code. If you want, you can use any other editor of your choice, but I'm going to move ahead with Visual Studio Code. Once we have that done, I'm going to open up the integrated terminal that the VS Code provides us with, and after that, I'm going to create a virtual environment. Why do we need a virtual environment? Well, think of it this way. Whenever we try to install a dependency using pip, it globally installs it in your system. But let's say we have two projects which use the same dependency, and both of the projects use the same dependency but have different versions. So one, for example, AI agent uses dependency with the version 1.0.0, and another project on the same machine uses the same dependency but with the version 2.0.0. They're conflicting, right? And we can only have one version installed in our system. That's what pip does. So we need two different versions, and that's why we need a virtual environment which will be able to keep all the dependencies to itself. It won't be installed globally in the system, and it won't interrupt with any of our other projects. So to create a virtual environment, we can type in Python -m followed by venv and the name of the folder, which is .venv. So Python -m venv stands for, well, we want to create a virtual environment, and this is the name of the virtual environment folder. Once I hit enter, the folder with .venv is created, which is the virtual environment folder. Now, if this command did not work for you, you can try using Python 3 -mvenv.venv, and that should work for you. Otherwise, you'll have to install Python and look into all of that. Now, if you expand this .venv folder and expand the bin folder within it, you see the activate script. That's what we want to run. We've created the virtual environment. Now we want to basically activate the virtual environment. We know the virtual environment is not started because there's no prefix or there's no indication telling us that, we have the virtual environment started. So to run it, what we need to do is source.venv/bin/activate and then hit enter. Once you do that, you can see the prefix of .venv. This suggests that the virtual environment is up and running. Now I'll just go ahead and create a new file, and let's call this file main.py. Here, I'm just going to print out hello world, nothing too fancy, because I just want to ensure that everything within this virtual environment is working out fine or not. Now, to run this script, I can just run Python, which is present over here, or you can run Python 3 if you want, followed by main.py, the file I want to execute. And it does print out hello world. That's great. So everything is working. Now, what is the step 1 to building an AI agent? Well, step 1 is connecting to an LLM, right? We're not going to look into agent as of now. Agentic stuff will come in when your LLM starts to take action. But we're not adding any action stuff as of now. First, we need to get the LLM in. We need to create a connection to the LLM and fetch the responses from the LLM. Once that's done, we can look into all of the additional agentic stuff like taking actions. So first of all, I'm just going to go ahead and create a folder called client. Within this client, I'm going to have a new file and let's call this LLM client.py. This will handle all of the response fetching, the streaming of the response, and retrying with exponential backoff. All that sorts of stuff will go into this LLM client. Now we have a requirement for our LLM client. We want it to operate with any LLM provider of our choice. How do you get that done? Well, to do that, you can use multiple packages that do allow this, like Pydantic, which also has support for creating your own agent by just mentioning one line. But since we are interested in building our own agent from scratch, we're going to use this dependency, the OpenAI dependency. This comes directly from the OpenAI company, but they allow us to change the base URL so that we can connect to any LLM provider of our choice. Other options include OpenRouter SDK, which you can use completely fine, but I'm going to stick with OpenAI. And within OpenAI, we're going to specify a base URL that points to OpenRouter. And I'll talk more about OpenRouter in just a minute, but let's just install OpenAI first. Also, I'm going to terminate this terminal, open up the integrated terminal here again, and then run pip install OpenAI. Now, if that doesn't work for you, you can try using pip3 and that should work for you. But anyways, now that OpenAI package is installed, I can start depending on it. So what is the first thing that I need to do? Well, over here, I want to create a class called LLM Client, which is going to have an init function, obviously. This init function is going to return, well, nothing. So I'm just going to pass the return types as null. And here, there's going to be multiple things coming in, like a configuration system that we're going to add, because the user can specify their own API key. That's something we'll need. The user can specify their own base URL so that they can connect to any LLM provider of their choice. But as of now, we're going in simple. We're hard coding everything. So if you're uploading your project to GitHub, this might not be the right time to do it because your environment variables will not be stored in environment variables. They'll be stored or hard coded in this code itself, which is not good. Anyways, the first thing that we need is a client. We have to establish the OpenAI dependency. If you look at the documentation present over here, this is how you can create a client. But this is synchronous. We want an asynchronous response. So this is what we'll be going with, async usage, where we use async OpenAI instead of OpenAI, and then we can use async await to do all of our tasks. That's really good. So let me go ahead and import this from OpenAI. Awesome. Now I'll have self.client, and client can be a protected or a private variable, anything you want. I'm going to keep it private or protected so that, it doesn't go outside of this class. The client is only used within this class. And after that, it can be of the type of async OpenAI or null. And initially, we are going to instantiate it as null. Now, why are we not doing async OpenAI like this over here? You can totally do that. But the reason we're not doing is because we're going to create a separate function to get the client. So we're going to have def get client, and this get client is going to get self. It's going to return async OpenAI, an instance of async OpenAI. But first, we'll check here. If self.client is none, that means it has not been instantiated ever, or it has been instantiated before, but the dependency was closed. That means a connection was established, the request was completed, and let's say the entire thing was completed, so the client closed. That's totally possible because later on, or actually now itself, we can create a function called close, and it's going to be an asynchronous function. And what this close function does is that it doesn't return anything. So that's the good thing about this. What it does is it just checks that, hey, listen, if self.client is present, that means it is not none, then I want to close this client's connection. So we have self.client.close, And then I can just set self.client equal to null. And we are going to use this close function in our own code, but it's good to have this helper function right now. All it's doing is closing the connection that has been established. And if this is done, and let's say in the future, we again want to get this client and get some response from the LLM, we'll call this function. It will check that, hey, the client is null because we set it to null over here. So let me just create another instance which establishes a new connection. And this check also establishes that, hey, we are only going to have one instance of client every single time, because we only create an instance if self.client is null. Otherwise, we are just going to return the self.client, So that's good. Now let's create an instance of the client. So we're going to have self.client is equal to async OpenAI. And then I'll pass in the API key. That's one of the things we require. And then we need a base URL as well. There's nothing related to model over here, because when you're trying to establish connection, you're not really choosing the model. The model of what LLM you want to use will be used whenever you send a message, right? So every message that you send to an AI agent can have a different model that you use with it. And we're going to support that as well. So there's no one fixed model. The user can just change the model anytime. And in the future, if you want to expand this application, you can have the router where the user can just select an auto model and you route to the model of your choice by putting in some logic. We're not going to cover that, but it's something that Cursor does. So let me just remove this. And now we need to pass in two things, API key and base URL. Now to get the base URL, we're going to use OpenRouter. Now, base URL can also point to the Gemini API URL. It can also point to Anthropic's API. It can also point to OpenAI. But generally, whenever you're using OpenAI, the base URL is the OpenAI URL. So you don't need to worry about that. But we'll be using OpenRouter. OpenRouter is the unified interface for LLMs. You'll find all of the models over here. You can try seeing the model by ZAI. So if you look into the providers, there's one by ZAI, Deep Infra, Parsing, Novita AI, and so on. Like, there are so many providers, and based on the uptime, it will just route to the correct provider so that your application always fetches the response. And obviously you can monitor almost everything over here, like throughput, latency, uptime, everything is monitored over here. Another reason I'm using OpenRouter is because there are a bunch of free models that we can take use of, and none of the models by Anthropic or OpenAI seem to be available for free. So we'll make use of that. Now, to get the base URL, you can go to this OpenRouter quick start guide where they mention multiple ways to get started with OpenRouter. Since we're using the OpenAI SDK, this is how they say it. This is the base URL that we should be using. Let me copy that and paste it over here. Later on, the user will be able to configure this base URL by themselves using the configuration system we're going to add. The same goes for API key, but as of now, let's get the API key for OpenRouter. So we can go to OpenRouter, sign up. You can select any of the options available here. I'll see you after I've created an account. And once you've done that, you can go over here, click on keys, and then create a new API key. So you can give it any name of your choice. I'm just going to call it AI agent again. There's no expiration, but you can obviously set it. I'll set mine to 30 days, I think. Don't use my API key. I'll definitely delete it before the video gets public. Create your own. It's absolutely free, and you'll only pay if you want to. They have not taken any credit card as of now, so don't worry. We can pass in the API key over here. Again, we're going to take all of that through the configuration system, and there's going to be all the environment variables that are created, so don't worry. As of now, this is the setup. Cool. So we have the connection established now. The next thing we are interested in is, well, the response, right? We want to fetch the response from the LLM. Now there's two types of responses that you can get from an LLM. One is a streaming response. Another one is a non-streaming response. Non-streaming response means we just wait for the LLM to give us an entire response. Okay, that's good. Another one is a streaming response. Streaming response means whenever you talk to an AI agent or an LLM, you might have seen that the LLM gives out a bunch of text, chunks of text like 30 words or something together. It does that because LLMs are auto-regressive. They generate one token at a time. And whenever, a bunch of tokens are ready, it just sends it through the API for us. And if we have the non-streaming response version, you'll see the entire response when it's done. So it might take, let's say, 15 seconds to get the entire response. That's not a good user experience. That's why they stream the response. As soon as a bunch of tokens are available, they send it to us. So we show the user a response every 1 second. So first 30 words or first 30 tokens are coming in the first second itself, and then another 30, then another 30, like that. So the user doesn't have to wait the entire 15 seconds. They can just get started reading the entire thing as soon as the first set of words come in. We are going to implement both of these streaming and non-streaming responses. The reason for that is streaming response will be shown to the user. That's good user experience. But the non-streaming version will be required when we have to do compaction or summarization, when we have hit context length. We're going to talk more about that later on, but that's something we will need. So let's just create it as of now, and let's just get done with the LLM client. So let's create a function. This function is going to be chat completion. Cool. Now let me just lowercase this. It's going to have self. Then it's also going to have messages, which is going to be a list of dictionary of string, any, and I need to get any from typing. So if you just press command full stop, you'll see add from typing import any, because we do want to import this any keyword, and then we can decide what to do. Another argument that we'll need here is stream. It is going to be of the type of Boolean, and by default it is true because everything should be streamed. Now what is this messages and stream? So the thing about LLMs is that they are stateless. They do not really contain any state. If you have a bunch of messages, for example, whenever I'm talking to ChatGPT, I say hi, that is one message from my side, and then there's this message from ChatGPT's end. So it's a list of messages, right? The first one has a role of user, that it's a message I've sent and this is the text. The second one is coming from the assistant and it's the message they have. Now, if I want to continue this chat, let's say I just type in nothing much. I'm continuing this conversation. So the LLM doesn't inherently remember that these were the text that was in this conversation. No, whenever we send another text, this entire list that was present gets resent to the LLM. To contrast this with something like a actual chat app like WhatsApp, where whenever you send a message, only the last message gets sent, that's not the case over here. In ChatGPT, all of the messages are sent back because that's how the auto-regressive generation will work. So again, this message, and this message gets sent so that we get this message. That's what I mean by stateless. It doesn't really contain any state. We have to keep sending it all of this data. And that's why we have messages, which is a list of dictionary. It is a list because we'll have multiple messages. It's a dictionary because it will contain 2 states, or actually more than that. But as of now, 2 states. There'll be a role. Whose message is it? Is it my message or is it the assistant's message? So that's why a dictionary. Awesome. Based on the streaming version, we have to decide if we want to stream the response or do we have to non-stream the response. So let's have the condition here. If the stream is true, that means we have to create a new function that will stream the response. So let me just create self.stream response. I'm just trying to write good code. Otherwise, we don't have stream response, so we have non-stream response. These are both protected or private methods because I don't want to use them outside of the class. There's only this function related to streaming that will be exposed outside of this class, so that whenever we want to connect to an LLM or get a response from an LLM, we just call this function, only source of truth. Now let's go ahead and create both of these functions. So first we have asynchronous def, which is going to be stream response. There's going to be a type associated with it. It's not going to be a simple string or anything of that sort. It is going to be an async generator because we are streaming the response. We're going to use yield if that's something you know in Python. Otherwise, I'll walk you through it. Don't worry. But as of now, I'm just going to pass. Then another function, which is non-stream response. And then this function is going to return directly the event, and that event is going to have multiple things. We'll talk about that. But yeah, these are the two things that are created. Great. Now let's go ahead and complete one function. I'll start off with non-stream response. Now what does non-stream response require over here? The first thing is the client. So let's take in the client, which is going to be of the type of async OpenAI. And that's true for stream response as well. Both of them are going to take client because at the top over here, we're going to instantiate the client itself so that there's no code duplication. So we have client is equal to self dot get client. That's great. It returns async OpenAI. That's also good. And another thing we will require over here is the keyword arguments. So quads. And it's going to be of the type of dict, and it will have the key as a string, and the value can be anything because it can either be a string as the value, it can also be an integer as the value. We don't know, or actually we do know, but everything will have a different value. It's totally possible. Now, what are the keyword arguments that we need over here, and how is it useful? Well, these keyword arguments are essentially the request arguments. For example, what model do we want to use? What list of messages do we want to send to the model? And what is the stream option? Is it true? Is it false? What is it? So let's just create it at the very top. So we have keyword arguments is equal to, and then we have model. The model will be set up by the user. So it's going to come in from the configuration system, but we don't have it as of now. We'll hard code it. Then we have messages, which is going to be a list, and we already do have access to it. And then we'll require the stream option, which is also present to us, and we'll just pass it in. So as you can see, messages is a list, stream is a Boolean value, and model is going to be a simple string. Now let's decide the model we want to use. If you go to OpenRouter, make sure you've copied your key. You won't be able to use it again. You won't be able to see it again. And then close it. Then we can go to models where a list of models are available. You can see their pricing listed out over here. For example, Gemini 3 Flash Review, which is 0.5 for million of input tokens and $3 per million output tokens. So that's there. But we're interested in free models. If you're interested in free models, you can click over here, prompt pricing. You can set this to free, and you can see all of the models that are available for free. They'll obviously take your data so that they can reuse it for their model training. But for development, this is good enough. You can try it. I would recommend you to try out bigger and better models because they obviously work better in agentic tasks. I'm also going to select this particular model, Mistral Destral 2, because I tried it offline and it worked really well with agentic coding. That's what we're going after, so I'll use it. Now, if you have money to burn, you can use Claude models for our agentic stuff. It does tool calling extremely well. I don't think any other model comes close to that performance in tool calling as of now. So yeah, definitely a choice you can take. So I'll pass in the model name over here, and that's good. We have everything set up. Now I can pass in the keyword arguments and the client, both of them. So I'll pass in the client, I'll pass in the keyword arguments, and boom, there we go. Now in this non-stream response, the very first thing I like to do is, well, get the response from the LLM, right? So we'll have client, which is the client that we have over here, .chat, .completions, .create, because we want to create a completion. This is how you create a chat. And here you need to pass in all of the keyword arguments, right? You have to specify what model you want to use. what are the previous messages, and you also need to append your current message into this. All right. For example, we add hi, hey, what's up? And then we sent in nothing much, right? We have to specify nothing much in this messages list. So messages really cannot end with an assistant. Messages always has to end with a user because you want a response back, right? And this is the response that we'll be getting. So let's await it because create will return a coroutine. We want to await it, and then we can pass in the keyword arguments. I'm doing this so that we deconstruct this object and pass everything together. But yeah, that's done. Now we can go ahead and print the response. And if you see, there are multiple things returned by the response. What we are interested in is choices. But anyways, I'll just print out response and see what we get. Now I'll go to the main.py function and call this chat completion with stream set to false so that we can get a non-stream response. So let me create a def main function. Within this function, I'm going to create an instance of LLM Client. So I import that from client.llm client. I don't have to pass in anything as of now, but as I said, later on, we're going to pass in the configuration system. And now I can just call client.chatCompletion. The messages is going to be a list. I'll hardcode it as of now. Then we'll look into taking it from the constructor or from the user arguments through the CLI. But let's just go one step at a time, right? So we have a messages list, which is equal to, well, something like this. You need to specify the role. What role is it? So the first one is going to be the user. Then you specify the content, and let's say the content is what's up. All right. So that's there. Now we can pass in the messages. Obviously, we're going to expand on this because we need to pass in the system prompt, what the LLM has to do given the user query. Then the user query comes in, and then we'll wait for the assistant's response. We're going to append it to this messages list, and there's a whole lot of context management that we'll have to do to get it up and running. But let's just pass in messages now, and then the stream value is going to be false. Now you can also have asynchronous def, then we await it, and then we say print done, just in case, nothing gets printed out. We know that this worked out and there's some error happening over here. So what's going to happen is this function gets called, then we get a client, we see that the stream is false, so we call this function, and then it contacts OpenRouter, it prints out the response. So let me just clear off the terminal and run Python main.py again, and nothing gets printed out because we have not called the main function. Let me just go ahead and call this main function. Now let's run it again, and it says coroutine main was never awaited. So we get this error, and the reason for it is this is an asynchronous function. We have to call await, and obviously we can't call await like this. So to run this, what we need to do is import async IO at the top. And after that, we can just do async IO dot run and then call the main function within that. Now we can try running python main.py again. And again, we've made the same error. That non-stream response was never awaited. Let's await that as well. Now let's run it again. And we are waiting for the response right now. And as soon as the response comes in, we print this out and we get done. So this is the entire chat completion object that we get. There's an ID associated with it. We get choices. Choices is basically what the LLM responded with. You can modify this choices. As of now, if you notice, we only get one choice over here. There's only one prediction that's done, one completion that's done. If you want, you can extend this by passing in the correct data within either the client or the keyword arguments. I'm not too sure. You'll have to look that up. But yeah, in our case, we only need one choice. The reason multiple people do several choices, they increase the number of choices, which means you have to wait a longer time to get the response. But the benefit of that is you can select which response you like better and display it to your user. But anyways, I just needed one. So this is our choice. It gives us the finish reason. We'll have to store that. Why did it finish? Did it error out? Did it actually stop? What is it? Then we have the message, which we are interested in, which is the chat completion message. And this is what the LLM responded us with. Hey, not much, just chilling in the digital void, ready to help with whatever you need. What's up with you? So that is the message we'll have to store. Then we have refusal. Did it refuse because it reached some safety concern or something? Then what is the role? It is an assistant responding to us. Then audio. Function call is what we'll be interested in. Tool calls is what we'll be interested in. If there's reasoning, it will respond with that as well. Then we're also interested in usage. How much usage happened over here? The completion tokens were 32. That means this entire response was 32 tokens. And our prompt tokens were only 6. Yeah, just 2 or 3 words and 6 tokens were consumed in that, because that's how tokens are counted. Tokens are not equivalent to words. Remember that. Tokens are equivalent to the smallest kind of possible word. And I won't talk in detail about that because that will just make this an LLM course. Not interested in that. This is the total tokens, which is just completion plus prompt tokens. And yeah, these are all of the things. The provider is also mentioned if you want to display that. Great. So the non-streaming response is working. Now let's extract everything and return it out. I'll just scroll up a little bit. Always have this terminal up now because we are interested in referring to what is present over here. So the very first thing is the choice, because we need to extract the message, right? So we have choice is equal to response.choices because, well, that's the one. And we are only interested in the first index because we'll only get one message always. If we get more than one, not interested. I'm only interested in the first message. Then we have message, which is equal to, well, whatever choice gives us because it's this particular object. And I want to extract its message over here. Cool. So we have choice.message. Now, obviously, we are interested in the text over here. And to extract the text content, we'll first have to check that, hey, if message.content is present, that means the message object has the content property. If it does not, we might be running into an error. But if message has a content, then we are interested in the text. The text is going to be, well, none initially. It can be the case the LLM responds with no text. It only gives us a bunch of tool calls to do, meaning we have to take a bunch of actions, but we're not interested in that as of now. We are more interested in getting the text. So we have text is equal to, and now we need to create something known as a text delta because, well, we come to the point of what will be returned from this non-stream response. I told you that there's a lot of things that we actually need. We need to get access to the usage. What was the finish reason? If there are any tool calls, what is the text? What is the type of the message? Because it can be that the entire thing errored out, or it can be that you have the message completed. And when we include streaming response, there'll be more events that will be added. So what I'm going to do is go to this client folder and create a new file called response.py. This response.py is going to contain a new schema or a new class definition of what the event from a model can be. And I'm going to call this stream event. Obviously, this is going to be a data class. So from data classes, we can import data class. The reason it's going to be a data class is because I don't want to write out all of the representation, string, and equal to methods. Data class will handle all of that. All I need to type out is what are the attributes of this class. So the very first thing is going to be the type of the stream event. What type is it going to be? I told you there will be multiple types, but let's just add types as we want it on the fly. So the very first class we are going to have here is event type, where it's going to be an enum, because event types can be multiple things. It can be a text delta. Text delta refers to any text that the LLM gave you. Specifically in streaming responses, whenever you get those bunch of tokens, a first set of tokens, those are text delta, because the message has not been completed yet. You're still waiting for the text, but you have a text. Then another event is going to be message complete, that hey, the message is completed, the LLM is done. Then there's going to be error, then there's going to be tool related stuff as well. So that's why we need an event type over here. It's going to be a string and an enum, and we're going to import the enum from enum. So let's do that quickly. Now these are all the types of streaming events. We are going to have text delta, which is going to be text delta. And here, when we have text, we're going to create a text delta. We'll talk about that in just a minute. Then we have message complete. And then let's just call this message complete. You can probably also give this an auto. I don't think it would matter, but yeah. Then we have error, and we just pass an error. There's going to be more event types related to tool calls. We'll add that later on. Now let's pass in the type of this event type. The next thing that our streaming event is going to have is a text delta, because if the event is a text delta, we actually need to capture the text, right? So this is going to be of the type of text delta, and it can be null. Remember that. By default, it is null, but yeah, the user can enter any sort of text delta. Now, why can it be null? As I told you before, if you have a tool call and no text given out by the LLM, you don't have a text delta. Now let's go ahead and create that text delta. It's going to be quite simple. @data class, and I forgot to put data class for this event type. And even over here we have data class, and then we have text delta. Content is going to be of the type of string, and I'm going to override the string method so that I just return the self.content. The text delta is going to return self.content. It's not going to contain anything related to text delta followed by content, nothing like that. Just return the string. After that, we're going to have error, and error, you can create another class for that, but errors are generally just strings. The reason I had text delta within a class is because you can easily extend it. Maybe sometime in the future you realize just content is not enough. You want to add some more data with it. So that's why it's a class. But error is probably always going to be a string. So it can either be a string or null, and well, it is defaulted to null. Then we have finish reason, which is equal, well, the type of that is also going to be a string, and by default it is null. And then you have usage. Usage is all of these things, all the completion usage stuff. So I'm going to create a new data class for that as well. We have @data class, and then we have class token usage. This token usage class will be used quite a lot, because based on the token usage, we will be determining how much time we have to wait before we can do any sort of context compaction. So this token usage class is going to store all the statistics related to token usage, and it will be quite helpful. Probably our entire app is going to depend on this particular thing. So we have prompt tokens, which is equal to 0. So prompt tokens are this thing, whatever you prompt. Even the system token or system prompt counts as a prompt token. Then you have completion tokens, which is going to be an integer, again defaulted to 0. Let me just open up and see. Yep, this is completion tokens. Then you have total tokens, which is an integer, which is equal to 0. And the reason we have total tokens is because it's over here as well. Then we are also going to have cached tokens. So we have cached tokens, which is an integer, which is equal to 0 as well. Now let's create an add magic function. Now the reason we are adding add over here is because I know how I want two token usages class to be added. For example, if you have A, which is of the type of token usage, and then you have B, which is also of the type of token usage, how should it look like? So you have two classes that are being added to each other. So what we need to do is, well, just add up the prompt tokens of A and the prompt tokens of B to get the new prompt tokens, right? So here we are going to have other, which is also going to be of the type of token usage. Now, since we are using token usage within the class of token usage, we'll have to do something. We'll have to import at the top from future import annotations, and that will allow us to specify token usage like this. Understand the problem. The problem was that we have token usage class created over here. How are you using token usage class within this class if you've not, instantiated it? Like, it's not possible. We imported from future annotations, and that allows us to do this. Otherwise, before some Python version, I think it's 3.9, you had to specify token usage like that and it would work out. But now we can just import this and use token usage like that. Great. Now let me just return the new token usage class. So we have prompt tokens. The prompt tokens is just equal to self.prompt tokens, whatever you have over here, plus other.prompt tokens. Then you have the same for completion tokens, self.completion tokens plus other.completion tokens. Then you have total tokens is equal to self.total tokens plus other.total tokens. And finally, you have cache tokens equal to self.cache tokens plus other.cache tokens. Just to explain what's happening to you, we have A, which is of the type of token usage, and then you have B, which is of the type of token usage. So what's happening is this A gets triggered, this add function will get triggered, and then B is passed as other. So you're essentially having A dot add B like that. So B is passed as other, and what we're doing is that, hey, A's prompt tokens plus B's prompt tokens is the new token usage because we have to add both of them up. So that's how it's working. It will be quite useful because, yeah, we will be using this more often than you think. And the usage is just token usage or null, and by default it is null because many times it can be the case that maybe the LLM just doesn't send us the usage. It has happened to me with another provider, so we're just handling that edge case. So that is a stream event. There's going to be more tool call related stuff added over here, but as of now looks good. Now text over here that we had, well, this text is going to be of the type of text delta. So let's just rename this to text delta. Again, the reason we have text delta is because it will be really helpful with stream responses. It is called text delta because delta refers to a change and we have a change in text. So that's why text delta. Now let's create text delta. We have to import it from client, just import it correctly. And then you have to pass in the content. Content is just message.content, right? If you look over here, message.content. Great, we have a string now. After that, we have done everything related to extracting the text content. Now we have to track the usage. Later on when we add tool calling, we'll have to parse the tool calls as well. So now we have if response.usage, usage is equal to token usage. We have to import that from client.response as well. And now I have to pass in the prompt tokens. Prompt tokens, well, how do I get that? If you look over here, we have response, this entire response dot usage dot prompt tokens. So I can just do response dot usage dot prompt tokens. Great. Then I have completion tokens, and it's the same thing. We have response dot usage dot completion tokens. And finally, after that, we'll have total tokens. So we have total tokens is equal to response.usage.total tokens. Great. So all these three things are done. Now what I'm interested in is cached tokens. Now to get the cached tokens, we can have cached tokens is equal to response dot, and then it's not present in usage if you notice. Cached tokens is present within prompt token details. So let me just copy this. And we have response.prompt token details dot cache tokens. Cache tokens. So something like this. Otherwise, the response.usage is not present, so usage is equal to null. We are explicitly setting this usage to null because we have not created the usage variable. We have not done something like usage is equal to null, right? Now I have, so we can remove the else condition. And now from here, I'm going to return a stream event. So the return type of this function is going to be stream event. And we import that from client.response as well. And after that, we have return stream event. Then we have the type of the event. So type is equal to event type. Event type is going to be an enum. So let's import it from client.response again. And the message is complete. We're not putting in text delta over here. Text delta implies that we are still waiting for the bunch of tokens that you have to arrive. But we're not interested in that. We are saying that, hey, the message is totally complete because it's a non-streaming response. Whatever response we get is the final response. Then we have text delta and we pass in the text delta. Then we have finish reason, and finish reason can be found out in the choice object itself. So we have choice dot finish reason, and then we pass in the usage, which is just usage. Great. So yeah, this entire non-stream response is now done. So I can just do event is equal to await self.nonstream response, and then I can yield the event. The reason I'm yielding the event over here is because we have an async generator that's going to be returned over here. Ideally, or most of the times, you would have a generator returned, but since we have an asynchronous function, we're going to return an async generator. What async generator does is that instead of returning like we have over here, we are just returning a stream event, right? What you can do is yield a stream event. Or over here, we have yielded the event. So what the difference between return and yield is that, let's say I called this non-stream response, right? It got the response, it returned, and then once it returned, only then did you move forward and go to the next statement. But with yield, what happens is that, let's say this function was called, you yielded the event from here. So wherever this function was called, for example, in main.py, this function was called, the control goes back to this function. So you basically pass the control that, hey, I'm executing this statement, I've yielded it. So it goes back to this main.py wherever this function was called, and then it executes further. And once that's done, you come back to this yield and continue this function again. That is the difference between return and yield. So in our stream response, for example, whenever you yield an event, what's going to happen is that you yield it over here. This function will kind of consume whatever the chat completion function gives you. It will print it out, for example, and then you go back to this LLM client and complete rest of the function. So that's why even over here, we are going to yield it. Right now, for non-streaming response, we only yield one event. So the source control goes back over here. It does whatever it needs to do to complete this function and comes back over here. But with streaming response, what's going to happen is you'll get a list of events. So you yield it, then you basically do whatever operation you had to do over here. Then you come back over here, and let's say there are more events, those will be yielded. Then you come back over here, you print them out, and then you again go back over here. And it keeps going on until you have no more events left. So the only reason I'm doing yield over here instead of return is because we are going to return an async generator, and async generator is returned just for stream response. That's the entire thing. Now the async generator is going to have a stream event that's returned, and whenever you have to terminate, you just return null. Now from typing, you'll have to import async generator. Just do that. And now you're all set. Another thing I would like to do here is, let's say this entire thing got over, then you just return. Now there's a bunch of error handling techniques and retries that we'll have to take care of. So I'll do that once we've completed the stream response as well. But as of now, what I like to do is go back to this chat completion, and this does not await anymore because you're returning an async generator, not an async await or a coroutine. So what we'll have to do is async for event in client.chat completion, and then we can just print out the event so that we know that we are getting the right data. Now let's try to run everything again, and we get an error. It says chat completion object has no attribute prompt token details. Well, that's because it is present in usage. I misread it. So the prompt tokens detail is present within usage, and then you go to prompt token details. I got confused by this parenthesis here, but this parenthesis is just really for this completion tokens. So we can go back to LLM client and here update the token over here. So instead of having response.prompt tokens, you have response.usage.prompt tokens. Now we can try running it again. And yeah, it does print out. It prints out stream event, type is event type.message complete. The text delta is present. Then we have error none, finish reason is stop, and the usage, well, we have prompt tokens is 6, completion is 31, total is 37, and cached is 0 because we have not cached any. Cache tokens generally happens when you basically have a lot of tokens and they are reused, and they're generally happening in the system prompt. So in a system prompt, you just keep it static so that the KV cache can be reused. I don't want to get into it a lot, but the point is cache will happen if the system prompt is kept static and is allowed by the provider. For example, Gemini or Google models do allow that. I think even Claude and OpenAI do allow that. I don't know about this model, but yeah, we'll see later on. So yeah, this is done. Now we are interested in streaming the response. And once we have streamed the response, we'll be interested in having retry and failure exception handling. And after that, we'll look into the CLI so that we can start running the user prompts. So let's have the client and the keyword arguments passed to the stream response as well. And after that, we can pass in the client and the keyword arguments here as well. Now, similar to this particular line, we can just copy and paste that in, because we are going to have a response, and let me just fix the indentation here. We are having a response as equal to await client.chartCompletions.create, and we pass in the same keyword arguments, but this time we know that the stream is set to true. And now if you try to print out the response, it's going to be an async generator. Whenever you have a stream returned out, whenever stream is set to true, you will have an async generator return. And since we have an async generator returned over here, we are going to return an async generator here as well. So we have async generator, then we get stream event, and then we have none, same thing as this particular return type. And now we'll go over every chunk in the response. So we'll have async for chunk in response. And now I would just like to print out the chunk to see what we are dealing with. So yeah, nothing too fancy, just printing out all of the chunks to see what's going on. Now I can go to the main.py file and set this stream to true. Then I can run this again. So we get, well, runtime warning, enable trace malloc to get object. So it's the same thing again. We have just called self.stream response, but what we are interested in is going through every event that is yielded out by this generator. So you have async for event in self.stream response, and then you just yield out the event. Great. And even over here, we are not printing out the chunk. We are going to yield the chunk so that, I am able to explain to you how this entire flow is working. So from here, we have a async generator. It is yielding the chunk. So as soon as we have the first chunk, for example, the response gives us, let's say 30 chunks. We yield the first chunk. It goes over here, because that's where the function was called. It yields this event. So this one event that we have, it is yielded over here and it's printed out. Then it goes back and then it yields another chunk. Then the same thing keeps on happening until we have no more chunks left. So now let's try to run this again. So we have python main.py. And as you can see, we had a streaming response. It was really fast because this model is really fast. But yeah, as you can see, we get a chat completion chunk, choices. The first choice is what we are interested in. The content is empty over here. After that, you have another one where the content is hey. Then you have an exclamation mark. Then you have not much going on. So this is the entire basically. So this is the streaming response, and it is working out fine. And it actually looks pretty much like the response that's given out by non-stream response. The only problem here is that I don't see any usage statistics. Only the last message has the usage statistics. So the usage statistic will be taken out from the last prompt that we get. So first, let's just try to extract all of the data. All right, we are not going to yield the chunk, right? We are going to yield the stream event that we have to create. To create a stream event, we will need the usage. So let's just first focus on the usage. So as mentioned, the usage will be in the final chunk, nowhere else. So we'll first check if has attribute chunk, and we are looking for the usage and chunk.usage. So here what we have tried to do is just check that, hey, if chunk.usage is present, that means we are at the final chunk. Let me just get the usage attribute. So we have usage is equal to token usage, and then we get prompt tokens, and well, everything similar to what we had over here, right? So let's just copy it and paste it over here. Let's indent it properly. Great. So we have chunk.usage everywhere. After that, I'm assuming we have usage, or if we don't have usage, totally fine in either case. Then we check, hey, if not chunk.choices, we just continue that, hey, we did not have any choices. It was an empty string. We saw that the very first response that we got in our print message was choices set to an empty list. That can be the case. So we'll just continue if this is the case. Otherwise, we do have a choice. So let me just have choice is equal to chunk.choices at 0. Then we have delta, and I would like to print it out again just so we see everything, and I can't. So let me just remove everything. I yield chunk for just a minute so that I can run python main.py again. These are all the chunks I get. Now I'll command Z so that I go back to my code, and now I can see what I'm dealing with. So let's just say we are on the very first chat completion chunk, right? This is not chat completion like a non-stream response. It is a chunk. So it is a delta that we are getting. When we have choice, this is the thing we have, we get a delta. Within the delta, there is content. We want to extract that. So first, let's just get the delta, which is equal to choice.delta. And after that, we can check the finish reason if it's present. So if choice.finish reason is present, we'll just get the finish reason as well, which is equal to choice.finish reason. And we have to create variables for each one of them. So let me just create it at the top. So usage is of the type of token usage or null, and initially it is just set to null. Then another thing we have access to is finish reason, which is a string or null and set to null. And yeah, that's pretty much it for now. The reason we have defined it at the top instead of within this for loop is because there will only be one finish reason. There will only be one token usage. Awesome. So we have both of them here. Now the next thing that I'm interested in is handling the text content. So if delta.content is present, like we have over here, delta.content, if it is not an empty string, so here it is an empty string, so we totally ignore this. Then we have content, it is hey, so we are not going to ignore that. So if delta.content is present, we'll yield a stream event, correct? Now in this stream event, we are going to specify the type, which is event type dot text delta. Then we are going to have a text delta itself, and now we need to pass in the text delta, which is, well, the content. The content is delta.content. Great. I told you about this. Whenever we have text delta, well, we'll have a text delta over here as well, right? And we just reuse the text delta that was meant for stream response and non-stream response, so that we did not have to create another attribute that basically does the same task. Cool. Now, assuming we've completed sending all of the chunks from here, which are all of the text deltas, we will get out of this for loop. Cool. And once we get out of this for loop, we will yield a stream event. This stream event is just going to say that, hey, we have completed the message. So we have event type dot message complete, and the finish reason is what we had tracked over here. The last message that we had in this for loop was the finish reason, and the usage was the same thing. The last message that we had is the usage. Great. So from here we have returned all of the text, and finally we yield the stream event, which just says that the message is complete. And in the main.py, when we get all of these events, we're going to parse them that, hey, we have a message complete, so we'll update our usage as of now. And if we have a text delta, we'll keep displaying that to the user in the terminal user interface. Now let me just clear it off. Let's run python main.py again. And here we go. We get stream event, text delta, hey, exclamation mark, not much, just chirp, ilin, and then you have all of these things. Awesome. At the end, we also get message complete with prompt token set to 6, completion is 32, total is 38, everything seems to be working fine. That's great. So with this, we have completed the streaming and non-streaming response of chat completion. Now the next thing I would like to do here is just have retries. So here, every request that we have sent till now was successful. But what if the request is not successful? Maybe there's an API connection error. Maybe we have rate limited, because when you're using OpenRouter on free, there are multiple times that you've hit rate limit error. I think you're allowed like 50 messages in a day. Or the upstream provider might just set your limit to 10. So we don't know. And we have to handle all those errors. So let's just wrap everything in a try and except block. So we have try, and then you have except. The first error I would like to handle is the rate limit error, and we handle that as E. Now I'll import this rate limit error from OpenAI. You don't have to import that from anywhere else, just OpenAI. And then if you're passing through a rate limit, it can be because, well, you've been rate limited for a particular minute. Rate limiting is not just for a day or for a week, nothing like that. It can be for a second as well. So if it's just for a second, I would like to retry. So to retry, what I'm going to do is wrap this entire thing in a for loop. Now, if you want to make your life much easier, there are packages that will allow you to basically do your own retries. But I'm going to write this from scratch as well. So we are going to have for attempt in range, and then you can decide what number of max retries you want. I'm going to define it here at the top. So you have self.max retries, and it's going to be an integer is 3. And if you want, you can also take this value from the configurator, the configuration system we'll add. But yeah, I'm just going to hard code this. So I'll just go until max retries plus 1, because range will exclude the last value. So I want to go up till 3, including 3. So we do plus 1. Then over here, we'll just check that, hey, if the attempt is less than self.max retries, in that case, I want to try again. But what I want to do is wait for a second or 2 seconds or 4 seconds. We want to do exponential backoff, meaning, let's say we did an attempt, it failed. Okay. Now I want to do a second attempt, but if I do it instantly, it will again fail, because the rate limit might be there for 3 seconds or 5 seconds or 10 seconds. We don't know. So I'll wait for some time. So how long do I have to wait? Well, first I can try waiting for 1 second. Then if it fails, then what I can do is try for 2 seconds. Then it fails. Then I can try for 4 seconds. So I'm just multiplying by 2 every single time. This is called exponential backoff. So I'll just say wait time is equal to 2 to the power of attempt. So in our first attempt, we'll wait for 0 seconds. So in our first attempt, we'll wait for 2 seconds. In our second attempt, we wait for 4 seconds. In our third attempt, we wait for 8 seconds. And then you can just do await async IO dot sleep, and then you sleep for the wait time. Now let's import async IO as well. Now if the attempt is greater than or equal to self.max retries, we'll just yield the stream event. And here I'll pass in the type. The type is going to be event type dot error. And the error message is going to be passed in, which is, hey, the rate limit exceeded. So let's pass that in, and then we have E passed in like that. Great. So yeah, if the attempt is less than several max retries, we retry, we sleep, and after let's say 2 seconds or 4 seconds, we are in a for loop, right? So it will re-execute this line. Now another error we can face is an API connection error. So let me just copy this because the logic is largely going to be the same, and we have except API connection error. The connection was not established. So we import that from OpenAI as well. And then we just paste this logic in. If attempt is less than this, we sleep again, but this time we have a connection error. So we can just say connection error. And another error we might have is related to API error. Maybe, the parsing went well or went wrong, because many times it can be the case that LLMs don't respond properly. So OpenAI package also does not respond nicely, or maybe there was some error with the API, not with the connection, but with the API itself. So yeah, we are just handling this. Now, if you have an API error, I don't want to retry. I'll just yield the stream event, which is an API error. If you want to retry it, go for it. I'm not. And I'll just return out over here. Even over here, I'll just return out because we have exceeded the max number of tries. And even over here, I'll just return out. Awesome. So we have done retrying with exponential backoff and exception handling in chat completion. We've not faced any errors, but this is just premature optimization. Now, another thing I would like to do is get this client and keyword arguments out of this for loop, because we don't want them to rebuild every single time, right? I don't want so many client connections to be created. I only want one client connection, and actually our logic will help us create only one connection. But even then, why do you want it within the for loop? So yeah, this is how our code is going to look like. We have these two created outside. Then we have retries. If it is successful in the first try, we just return instantly. So we don't go through any of the for loop iterations again. And if we run into any error, we do the retrying with exponential backoff. Amazing. So we have had all of our LLM client created properly. Now I just need to create this main function into a CLI application. And then we have to display the data that we are getting from here nicely. We need a place for user to type a prompt. So we'll get to all of that step by step. Step 1 is just converting this into a CLI application. We don't want this hard coded. We need to create a system prompt. I'll walk you through the system prompt that we'll paste in. What are the tricks related to prompting? I'll talk to you about that. And we also take the argument from the user. So instead of passing in Python main.py and executing it, we actually have the user pass in the data. So that's exciting. Let's get to it. To get this command line working, we're going to install a package called Click. Click is a Python package for creating beautiful command line interfaces in a composable way with as little code as necessary. We'll just directly take a look at this example. As you can see, first we have to specify @click.command, which just says that this function is going to be, a command executable thing. Then we specify all the options and all the arguments that we might want to add. For example, when we do click.option, we can specify the count with a flag like that. And the same goes for name. We are also going to have an argument which will allow us to pass in a prompt without specifying -- prompt. So let's install this. I'll just copy this, open up our terminal, run this command and hit enter, and Click is now installed. Now, I just want this main function to be a Click thing, right? So first I'll just have to import Click. So at the top, I'll just do import Click, and then as the decorator of the main function, I'm going to add @click.command. This says that the command is going to be, this says that the entire function is going to be a command executable. That means it's going to be a CLI thing. After that, we are going to specify the prompt. Now, whenever we want to access the terminal, we don't want to do AI agent or something like -- prompt is equal to well, what is the name? Something like that. We don't want to do anything like this. What we want to do is directly type in what is the name. And obviously this is run single mode. That means you only pass in the prompt and the CLI will run once. But then we will go into a more interactive mode where we just pass an AI agent like this, and it opens up in a nice interactive mode. And then you can talk to the AI agent passing in all of the input and stuff, whatever you saw in the demo. So first things first, let's get the single mode up and running. So we'll have @click.argument, and then we'll pass in all the parameter declarations. So what is the name? Well, the name of this is going to be prompt. And is it required? Well, I'm just going to say false because it's not required. If it was required, you would have to pass in the prompt every single time. But sometimes you can just do AI agent and it will open up your command line, the entire TUI interface. So yeah, now what I like to do is take this stuff from the parameter. So we'll have prompt, which is going to be a string, or it can be null, and by default it is set to null, but we can just set it like that. Now we have access to the prompt. Now I would like to just go ahead and print out the user prompt just to see what it's looking like. And now I can try running it. And also, by the way, now I don't need to do async io.run main, I think. Or actually, let's just do it and see what happens. So we'll have python main.py, and then I'll pass in, hey, how are you doing? And actually it will make a lot more sense if we just pass in the prompt as the content, and then, yep. Now let's run it, and it just prints out python main.py, hey, how are you doing, clear, for some reason. And the reason it breaks is because Click does not support asynchronous functions. So if you want to use Click, you cannot do async def main. So what I'll have to do is something like this. We have def main. I'll have to remove this async io.run from here. Then we'll have to create another function that will be asynchronous def run. And these are all temporary functions, all right? Later on, we are going to remove all of the logic from here and put it in an agent class and stuff. But as of now, this is good enough for our use case. So we're just going to pass in the messages list here, which is just going to be a dict string any. And now you have to import any from typing. And now you can pass in all of these things. So there we go. Awesome. Now we also need to create an instance of client. So I'll just create it over here. And now I can just pass in the messages like that. Great. So yeah, this is how it's going to run. Now I have to do async io.run over here. And then I can just pass in the run function, pass in the messages list as well. Awesome. So this is the entire function. Now I can go ahead and try to run this again. So it does print out, hey, how are you doing, clear. And then it says, hey, I'm just a bunch of code, so I don't have feelings. Okay, good. So everything seems to be working. Now we also have a run single mode. Let's just make it more official in a way. So what I can do is create a class CLI at the top, and this CLI will have an init function. In this init function, we are going to get the configurator. We are going to get other values as well. But as of now, we're just going to have pass just like that. After that, we're going to have a mode of run single. So we have def run single, and this run single mode is going to essentially call the agent. This agent will be giving us all sorts of message. Right now, if you notice, we get the event in the form of stream event. We do not really need stream event over here because we don't need all of the events that chat completion gives us. We only need certain events. So for example, if we get an error, that's good. We might want that. But if we get some other type of response, like, there'll be a tool call and all of that, a text delta, message complete, we probably won't care about many of them. So what I want to do is create an interface before them. So an interface between main.py or the CLI class and the LLM client, which is going to be the agent. That agent is going to interact with this LLM client. It will handle all sorts of things like context compaction or compression or pruning or the tool calls. All of that stuff will be handled by that middle layer, and this CLI is just going to call that agent. So first I would just go ahead and pass in self here, put a pass. Now we can go ahead and work on this agent class. That is going to be the main logical function of our entire code base. So here I'm going to create a folder called agent, and in there we are going to have another file. Let's call that agent as well. Now in this agent, first we need to create a class agent, then we have an init function as well. And in this init function, we'll have to introduce many things. Again, the configurator will be present here. Then there'll be session. Session is going to contain all of the objects like context management and details about everything related to a session, because we can have multiple sessions, right? Each session will have its own context. That's why the context will be present within a session. But we will talk about that later on. Now, if we want to do any context management, I'll just create a class and use it inside of this agent. Later on, we will refactor it outside of this agent to be put into a session. Don't worry, it will be quite straightforward. Now, let's go ahead and just create the agentic loop. Remember, agentic loop is just a call to an LLM where we are handling the context and making some tool calls. Tool calls will allow us to do some sort of action. So I'll just go ahead and create async def agentic loop. It's going to be a private or protected function. The reason for it is because this agentic loop is going to return an async generator. It will be returning an async generator, and let me import that from the typing module. And the return type of this async generator is going to be agent event. It's not going to be a stream event anymore. It's going to be agent event, because what the agent cares about in main.py will be more stuff. For example, we might care about, well, one turn starting, because we have multi-turn conversations, right? If the turn started, we have some stuff to do. If the turn ended, we have some stuff to do. If we have the context compressed, we will have something to show. If we run into an error, we'll have something to show. If the text completion is done, we'll have something to show. And if the tool starts doing tool calls, well, if the tool call starts, there'll be something to show. And if the tool call ends, there'll be something to show. So the agent has more microscopic details that needs to be sent to the UI, because the UI will have to display all of those details. The stream response is only concerned with details related to streaming the response, right? Only related to the response, but agent has to do a lot more, because if a tool call starts, you have to show it. If a tool call ends, you have to show it. So this agent event is that's why created. We can't use stream event because it doesn't go that microscopic. So let's go ahead and create this agent event, and we can create that within this agent folder. So we have events.py, and then we're going to have a class of agent event, right? The first thing is going to be a type. What is the event type? Now this event type is not the streaming event type, whatever we had in response. That's not what we're talking about. What we're talking about is agent event type. So let me just call this agent event type. And now what I'm going to do is create an enum for this event type as well. So quite similar to what we had with the streaming event. That's what we're doing over here. But now the values of this enum are going to be different. So let me just import from enum, and then we also need obviously the data classes. So let me just import it right here. This agent event class is going to be a data class. And after that, we have an enum. So the very first thing is going to be agent start. This is related to agent lifecycle. So we have the agent has started. So we'll have some data to show to the user. Then we have agent ending. Probably we'll also show to the user, or we'll just kill off the application. Then we have agent error out, which is, well, agent just erroring out. We have to probably display that in some different color. And we'll also have something related to streaming, right? The text delta, which is equal to text delta. And then we'll have text complete, which is equal to text complete. Cool. Now, let me just put in some comments. This is agent lifecycle related stuff. And this is text streaming. Okay. Now we'll have other agent event types as well. For example, the turn has started, the turn has ended, and maybe the tool call execution stuff. If we have the confirmation requirement from the user, then if the context is compacted or if the loop is detected, everything will go in this agent event type. Awesome. The next thing we'll have here is data. If there's any data that the user might want to send, that will be of the type of string, any, and we'll import from typing any. And we'll default it to field. Field will allow us to just pass in a default factory, and the default factory is going to be a dict. If nothing is present, we have a dict. It's not null. Great. Now, if you want, you can just use this agent event class everywhere, just like we did with event type, or actually with stream event. Instead of, yielding stream event over here, what we could have done is created a method here called @class method. And then we could have created something like this, a definition which just says stream error. And then we have self. Then we return the class where we pass in the type, which is the event type dot error or whatever there was. And then you pass in the error details as well. So instead of passing in yield stream event like this every single time, you could have just done stream event dot error, something like this, right? Or stream error, whatever this was called. That would have been much better. So now I'm not going to rewrite this entire thing again. So if you want, go ahead, do it. I'm not going to do it. I'll do this thing in agent.py because there will be a lot of stuff, or actually in events.py, because there will be a lot of stuff that will be used again and again. For example, agent start. We might want to use that again and again. So it just seems nice to have that. So the very first thing is a class method with agent start. Then we get access to class because it's a class method. And then we have a message string where we return agent event. Now, again, we can't use that. So first we'll have to import it from future. We'll import annotations. And now we are able to use that. Now I'll just return a class from here where we have agent start, right? So the type is equal to event type or agent event type dot agent start. And the data will be passed in as well, because when the agent starts, we need a message to be transmitted. So we'll have that message here. So here we go. We passed in the message as the data, and there we go. Cool. Let me just format this nicely. So I'll put a comma here and it's formatted. The same thing will go for agent end or agent error as well. So let me do it quickly. We have agent end. And when the agent ends, we just get a response, which is of the type of string or null, and it will be null. And we also get the usage, which will be token usage or none, and it is equal to null. Now let me import token usage from client.response. And this time the data is going to be both of them. It's going to be the response and it's also going to be the usage. So we pass in usage, but the thing is usage is a token usage class. What do we do? Well, we can just do usage dot dict like that. So it gets converted into dictionary if the usage is present. Otherwise, we just pass in null because, well, if we don't put this condition, we're calling dot dict like this on a null variable. So it's just going to return in a runtime error. Awesome. Similar to this, we have agent error as well. So let me just copy this, paste it again, and then we have agent error. We're going to get a class. Then we get the error message, which is a string. And then if there are any details about the error, we can have that as well. So details will be dict string any, and it can also be null. By default, it is null. Then we pass in the error, which is this error, and then we pass in the details as well, which is details or an empty bracket. Because if details is not present, we want an empty dictionary to be present. Now similar stuff can be done for all the other things as well, like text delta. So let me just paste that in, or actually let me copy it and then paste it. So we have text delta. So we get a class, then we get a content which is of the type of string, and then we return the class where we say, well, this is not agent start, this is agent error, this is agent end, and now we've reached agent event type dot text delta. The message is just going to be content and then content. Great. After that, we have text complete. So we have text complete. It just means all the text has come in. So that's good. And now we have content again. Great. So this is all of the events we have for now. Obviously, it's going to expand when we have tools and all other features. Essentially, this will be the glue between main.py, agent.py, because main.py will only interact with this agent event. It won't interact with all the streaming events, because think about it, streaming event is just related to response. Agents are not just about fetching a response from the LLM, it's also about other things. An agent event captures all of that and goes into minute details. Okay, now let's go ahead and import agent event. So from agent.events import agent event, then we have null. Now in this agentic loop, as I mentioned, it's going to be a multi-turn conversation. The user will be able to interact more than one time, but we'll get to that later on. First, we just care about getting all of the things that were present over here in this run function out of here. So we get this data out of here and just put it in the agent. So we'll have client is equal to LLM client. Obviously, we're going to instantiate it within session, because session will have its own client, right? A user can have multiple sessions open so that they can interact with the agent multiple times, and each session will have its own connection to the LLM, because we won't be reusing the same connection, right? So client or the LLM client instantiation will also be present within session, but we have not created session yet, so I'm just instantiating everything here, including the context manager that will come in next. But yeah, we will be refactoring, so don't worry. Now we have LLM client. So from client.llm client, we import LLM client. Let me remove that import from here. Great. Now we have self.client.chat completion. Then the messages needs to be present. Now where will this messages come from? Well, messages needs to come from the context, right? We won't be taking it from this agentic loop itself, because, well, if the agentic loop is on, why would you be getting it from messages? Like, why would a messages dictionary be present over there? What you need is a class that will handle all of the messages for you. So every single time a new assistant message comes in, you store it in your context management class. If you get your own user sends a new message, it will be stored in a context management class. So everything will be within a context manager. And therefore, we'll have to create a context manager to get this done. But as of now, since we don't have any messages or any context manager, I would not like to introduce a new thing over here. So what I'll do is just keep a messages list here. Or actually, let me copy this, paste the messages list here. The next step, after I've figured out what to do in this agentic loop for a while, is creating the context manager that will handle all of these things. But as of now, let's keep it simple. I'll just type in, hey, what is going on? So that is the messages. Now, chat completion is going to give us a list or a bunch of stream events, right? We want to handle all of those stream events, and in some cases, we'll have to return it outside of this agentic loop. So now only we can just check that, hey, if the stream or if the event dot type is equal to stream event type, and now we'll have to import stream event type. So, well, there's nothing like stream event type. It is just called event type. So let me change it to stream event type before it's too late. Seems to be a better name because in events.py we have agent event type. Now let's import from client.response stream event type. And now if the event type is, let's say, text delta, in that case, we want to return the response, right? So what we'll do is content is equal to event dot text delta dot content, and then I'll just yield the agent event, and then I'll pass in the text delta. So I can just call the dot text delta function that we created, and now I just need to pass in the content. The content is the content that we extracted here, right? So from LLM client, we got the event, correct? In this async for loop where we are catching the events, we just check that, hey, if the type is text delta, cool, I'll just convert it into agent event and send it across, as straightforward as it gets. Similarly, if we have another thing, let's say if event.type is equal to stream event type dot error, in that case, I would like to yield agent event dot agent error. And this time, we'll have to pass in the error. What is the error? Well, it's just going to be event.error, right? Because if the stream event type is error, we know event is going to contain the error variable for sure. And if it does not, then we just say unknown error occurred. That's some good error handling that we're doing. Now, if you want, you can terminate the app here because there's an agent error. I would just like to stop the execution, or we can let the app keep going, not worrying that, hey, there was an agent error. Okay, maybe there was an agent error, but we'll keep going until this agent error is resolved. So in the next turn, maybe the agent error is resolved, or even in the next message, the agent error is resolved. So this is the most basic agentic loop. It is not even an agentic loop because we have not created anything related to how many turns there are, how many times will this agentic loop keep going, because yeah, if the user sends a message once, it works. But what if the user wants to send it another time? We have not handled that. So we'll have to do that. But before we get to that, let me just complete the entire thing we were working on about single run. And then we can focus on a more interactive environment. So this agentic loop is a private function, right? It will be called within this public function run. This run will get the message of the type of string. That is what the user will give us. So this particular function will process the user message and it will return the events. And this is the function that will also be called in main.py. So at the very beginning, we can just say yield agent event dot agent start, because yeah, we received the message, let's start it, and this is the message. After that, we'll have to update the context, but we have nothing, no concept of context as of now. So I'll just put in a comment here reminding us that we need to add the user message to context. Then we want to call the agentic loop. So we'll have async for event in self.agentic loop, and then we're just going to yield the event. Whatever event we get, we're just yielding it as soon as we get it. Now there are a lot of things that need to be done after and before it. For example, when we add hooks, there'll be an after agent hook that can run, and before it also an before agent hook can run, but we'll get to it one step at a time. Now let's say this entire function completed. In that case, what we want to do is yield agent event dot agent end, because, well, the entire function completed, the agent has ended. If when we get the message, the agent starts, then when the function ends, the agent should end, right? So yeah, there we go. Again, I'd just like to remind you, this entire thing just processes one single message and runs one single time for one message. Again, later on when we add our tool calls and stuff, it can run multiple times. If it can run multiple times, we can get more events in, and then we'll have to put in the logic of when to terminate our agent, because it can keep running for a long time, right? So in this agent end, we have to first specify the response. What is the final response going to be? Well, the final response will be fetched whenever we get an event of text complete. Right now we have handled text delta, but nothing related to text complete, which is never being returned in this particular class, even though if we go to our events.py, we have created text complete. Because text complete is going to contain the final response as well. The content that you see over here is just the final response. So let's go back to this agentic loop, and here outside of this for loop, I'm going to create a variable called response text, which is just an empty string. And then in the text delta, whenever we get a content, we're just going to do response text plus equals content. Cool. And then we'll send off the text delta event. So this response text is really just the final response text. And then outside of this async for loop, I can just check that, hey, if the response text is present, that means we have a final response. We can yield an event saying agent event dot text complete. And the text is just the response text. So now from the agentic loop, we are also returning an agent event. And now we can just handle this event within this particular for loop. We can just say that, hey, if the event is equal to, and actually we want if event.type is equal to agent event type, and I don't know why I'm not getting that autocomplete. Let me just copy paste that in, and let's import it from agent.events. So if the event type is equal to agent event type dot text complete, remember we are using agent event type here, and we are using stream event type here because we are just trying to catch whatever we have returned from here. It might just seem very weird that we are catching all of the events here, returning it or yielding it in the run function, which is yielding it in the main function. But trust me, we need this because there'll be a lot more functions added in the future, which will necessitate having these two functions. So now we can have final response, which is equal to event.data.get content. And now I can just pass in the final response to this agent end. There's another usage that you can also pass in, but we'll get to it later on. As of now, I think we are good to go ahead and call this agent within main.py. But before we do that, I would like to do one thing. I would like to create a close function as well. So if you notice, I've created an LLM connection, but I'm never really closing it. So what I like to do is use this agent class as a context itself. So what I like to do is convert this class agent into, like we can use this agent class with statement. So if you don't know the Python's with statement, it just simplifies resource management by automatically handling setup and cleanup operations. So what we need to do is create two things, enter and exit. What we'll be doing is creating a enter and a exit because we have asynchronous stuff. So that will allow us to have asynchronous context management. And if you've ever done file handling in Python, with open as file. So this is what I'm talking about. We can use our agent class like this as well. And what this does is, well, we don't have to do fp.close whenever we do this, right? All of that is handled behind the scenes. Same thing with agent. We don't have to explicitly go ahead and call client.close. It will automatically happen behind the scenes. So I like to just define these magic functions over here. First, we'll have asynchronous def __ a enter __ self, and this will return an agent back. Now again, we would have to import from future annotations. Now we can use that. And as of now, we don't have anything. So I'll just return self here. But for asynchronous def a exit, we have something. We'll have to close the LLM connection. We'll have to do something like this. Await self.client.close. And we only want to do that if self.client is still present. And then we will also do self.client is equal to null. Now it's not there. And in a exit, we get multiple things like exception type. Then we also get exception value. Then we also get exception. I don't know what TB really stands for. It's probably traceback. So yeah, we get all of these things. And now we can use agent with. So like we can just do with agent. And that's what we're going to do in main.py. So in the init, what we'll have to do is create an agent, and well, it can be of the type of agent or null, and initially it will be null because we're not going to establish the LLM connection as soon as CLI is called, right? Because that would just be weird. The reason it would be weird is because imagine I call run single over here and the user has not specified the prompt. Or let's say we are in a run interactive mode and the user has not specified any prompt and we have established the LLM connection. That doesn't make any sense. Why do we want to waste resources if the user just opens it up but does not send any message, right? That's why we are setting this to null. We'll only create it as soon as run single is actually called, which is like this, async with agent, and this is going to be an asynchronous function. Now I'll pass in the agent like that, and then, well, we have to pass in the configurator, all of that, but we don't have it as of now. Then we have agent, then we can just update our self.agent to be agent that we get here, and then we have to process the message because we know that this is going to return a bunch of events to us. So first we'll have to call agent.run, and that agent.run is going to yield all of the events. So we need to capture them and based on that display the data to the user. And the same logic that we put over here will also be used within run interactive because the process messaging. So let's create an helper function. So we have self.process message and we just pass in the message over here. Cool. And run single is going to get a message. So let's take that from the parameter. And if you're confused about how this function is going to be used, well, it's quite simply something like this. If the message is present, then, or if the prompt is present, sorry, we are in the single shot mode. We have to run it single time. So we'll just do async io.run. And now we'll pass in the CLI. Now we have to create the CLI as well. Let me remove this print. So we have CLI like that. And now I can do CLI.run single and then I'll pass in the prompt like that. Amazing. So I can remove this part. We can remove done as well because there's no need. And yeah, that's pretty much it. I can comment out the messages line. We'll remove it completely once we add context management in. Now let me create that function. So we have def and let's call this asynchronous def process message. We get self. We also get the message, which is of the type of string, and this will return either a string or a null value. And the entire job over here is just to process the events that we get and display the results out on the screen. So first of all, let's just check that, hey, if self.agent is not present, then we just want to return null, that we have nothing to do with this. It's all over. The entire thing is complete. But if the agent is not null, in that case, I want to go over all of the events that agent.run gives us, and we'll pass in the message here, and I can just check what the event type is. The event type can be text delta, text complete. So if the event.type is equal to event type, or let's call this agent event type, let me import that from agent.events. And if the type is, let's say, agent start, if it's agent start, what do I want to do? Nothing really. Because if the agent starts, what do you want to do? But if you want to do something, we already have laid the groundwork for it. Let's try to handle something else. Let's say we have agent, or actually instead of agent anything, let's just do text delta because we have text streaming out. We would like to display it, correct? So we have content is equal to event.data.get, and then we have content. If we don't get any content, it's just an empty string because we don't want to display null out on the screen, right? And now I would like to display stuff on the screen. Now, how do you display it on the screen? Well, for that, I would like to create another folder called UI. Within this UI, we will have TUI.py, or you can call it anything of your choice, maybe like renderer or something. Now for TUI, for displaying stuff on the screen, we'll be making use of another package, rich. Rich will help us render rich text, tables, progress bar, syntax highlighting, markdown, and more. We are not using most of the things, but we will be using syntax highlighting, I think, and we'll also be using rich text and tables, I think, even panels. But yeah, if you want, you can extend and add more UI features. This tutorial is not really about UI. So let's just import or install rich. So we have pip install rich. And now we do have rich. That's great. Now from rich, we can import multiple things. One of the things we'll need is console, and it's not present in rich actually, it's present in rich.console. So yeah, just import that. And then we are going to import this thing, agent theme. So this is just how my agent is going to look like, what UI elements are present. So if there's anything information related, it's going to be of the color cyan or cyan, however you pronounce it. Then you have warning, yellow. Then you have error, which is bright red and bolded. Success is green. Dim is just dim. Muted is gray 50. Border is gray 35. Highlight is bold cyan. Highlight is bold cyan. I really don't know how to pronounce that. Roles is user, bright blue bold. Assistance is bright white. And so on for other tools and code blocks as well. So we will be making use of that. Now we need to import this theme from rich as well. So you do that doing from rich.theme import theme. So this is our agent theme. And here what we've done is just described a mapping between all of the colors. Bright, magenta, bold is actually kind of a class within rich. And now I'm saying that, hey, whenever I use tool, you need to replace it with this color. That just makes it easy for us to write down anything we want because it is more readable for us. For example, instead of writing yellow, I can have warning. So it tells me that, yeah, it's a warning. And then if I want to replace out any of the colors in the future, I can just say that, hey, all warnings should now be red, for example. So everything will be red. That allows me to have a centralized control of how the theme looks like. So that is the agent theme. Another thing we'll need is the console, because we need to get the main console instance where we are going to write everything. And there we are also going to pass in the agent theme. So we have def get console and it returns to us a console. And this console comes from rich.console. And it's going to be a global singleton instance. So we have console, which is of the type of console or none. By default, it is set to null. And then we are going to check if console is none, then we are going to have console equal to console like that. And then we pass in the theme. The theme is just this agent theme that we created. And the highlight is equal to false. You can set it to true and notice the differences. But yeah. Then we'll just return the console if not it's present, we've created it. And also we want to tell here that this is not a console variable that we have created just now. This is going to be the global console variable that's present. This is the one we'll be using. All right. Now, why do we have a global instance here? The reason for that is singleton. We want a single instance of this console to exist in our entire program. Because if we don't have a single instance, there'll be multiple instances and that will cause problems. Now let's go ahead and create the class of TUI. This is just going to be the main terminal UI renderer. And here I can create an init function, the self, and we are going to return null from here, nothing. And then we are also going to get a console. Console is going to be of the type of console or null, or actually we probably don't even want console. We can just reuse this console that's present. So we have self.console is equal to this console that we already have access to, or let's just take it from the constructor. I don't know, feels weird to not take it from the constructor now. By default it is null, but yeah, we can use that one. And if it's not present, then we'll just do get console and we get a new console variable. Cool. Now here, the first function that we need is related to what we want to do here. We just want to display out the data to the user. And to do that, we're going to create a function called stream assistant delta. It's going to be a self, then we have a content which is of the type of string, and it returns nothing. It just prints out on the console. And now we can just do self.console.print. Then we print out the content. The end is an empty string. So by default, the end is probably going to be a new line, right? You go to a new line, but this time you set it to an empty string because when the text delta is coming in, you just get a bunch of tokens. You don't want to go to a new line when every new token comes in. You want it to keep going so that you can display a sentence nicely to the user. And the markup is going to be set to false. Just means that it will not italicize anything or bold anything or anything as such. It will not interpret any markup in the model output. So that's what we're going for. And yeah, as of now, this is the only function. Of course, we're going to beautify this in just a minute, or actually a bit later, I don't know. We'll go with the flow. And then we can just say self dot, well, we want this TUI, right? So we can just have self dot TUI, which is equal to TUI like that. And now we want to import from UI.TUI. Then we want to pass in console, and console we can just instantiate over here. Console is equal to get console. So from UI.TUI, you also import get console. And if you want, you can also create it over here and use it. But I would like to do it at the top. And yeah, that's it. Now we can just have self.tui.streamAssistantDelta, and then we pass in the content. Great. So we have handled the case of text delta. Let's see how this works out. I would like to just open up the terminal and run python main.py, and then we pass in the command. What's going on? I don't think it will get triggered in any case because in agent.py, we're just having the message here. We're not doing anything about it. We're not adding it to this messages list because we don't have any context management yet. And we will be introducing that next. But anyways, now let's just hit enter. And it says cannot import name event type from client.response. And that is happening in response.py. Sorry, this is happening in LLM client, I think. So yeah, we are importing event type here, but there's no event type. There's stream event type. And we'll have to change everything here as well. So I will just do command F, event type, whatever was event type now gets shifted to stream event type. And now I'll just find and replace all. So that's done. And yeah, let's just import it correctly at the top. So yeah, stream event type is now done. Now let's run this again. We have python main.py, what's going on? And it says got unexpected extra arguments. Let's try running this. I just put in double quotes and we get another error message saying process message was never awaited, and that's true. If we go to agent.py, we did call process message, or actually in run single we did get self.process message. So yeah, we would like to await it and also return as soon as we get our message, right? So we don't want to go any further than this. We've got a message, we processed it, that's it, done. Even in this, when we do async io.run, cli.run single, we know run single is going to return something, right? It's either going to return a string or a null value. If it returns a string value, good. If it doesn't return a string value, well, we are having a null, and that confirmed my suspicion that there's nothing more to run here. So if a result is null, in that case, I just want to exit out of this. So we have system.exit 1. Because if the result is null, we were waiting for a string. If the result is null, there has been some error. So yeah, we'll just have 1. Let's try to run this again and hope no error occurs. So I just hit enter. And yeah, we do get a streaming output, right? If you notice over here, we did get it streaming out, and it's all in the same line. So that means the console display part is working, but in agentic loop line 31, it said none type object has no attribute content. Here I'm just going to put in a condition that, hey, if the event.textDelta is not null, in that case, we have content is equal to event.textDelta.content. Then we'll have response text plus equals content, and then we'll yield it. All of this will happen if text delta is present. And then we can try running it again, and this time we should see no error. That's great. So our one shot single run is now working. I would like to beautify this a little bit. So what I like to do is, as soon as the user just passes in a message, I would like to show a little bar saying that, hey, the assistant is replying now. Whatever you see from now on is the assistant's message. So let me go back to the TUI here and create another function that is just begin assistant. It just says that, hey, the assistant is now starting to reply, and it is going to return null again. And this time we're going to have self.console.print so that we go on a new line. And after that, I'll again have self.console.print, and then I'll have a rule because I want to display a ruler, kind of a single horizontal line. And then we're going to import the rule. So from rich.rule, we are going to import rule. And then here we go. We have rule imported out. Now we want the text to be present. So text can be displayed just like that. And now from rich.text, we have to import text as well. So there we go. And now we have the text passed in. After that, we'll pass in the message here that, hey, this is the assistant. So between the ruler, assistant will be written, and the style is going to be, well, assistant. Now, what is style assistant? Well, if you go back to our agent theme, here I said that the assistant is just a bright white. So a white message will be displayed over here with a white ruler and stuff. And I would also like to maintain a state that just says if the assistant streaming is going on or not. So here, initially, the assistant stream open is going to be set to false. But as soon as the begin assistant comes in, we have self.assistant stream open equal to true. Why do we need this variable? It will help us later on. Now that we have begin assistant, I would like to go back to this run single, and outside of this process message, I would like to create a boolean value of assistant streaming equal to false if the assistant is streaming or not. And then I can here just check that, hey, if the assistant is not streaming, in that case, this is the first message that the user has. So I would just like to have self.tui.begin assistant. Cool. And after that, we'll have assistant streaming equal to true. Because now the first message is coming in. Just imagine, we have the first event with a text delta coming in. We just check that, hey, is the assistant streaming equal to true or a false? If it is false, then we begin the assistant. That means it will display that thing that I want to display. And then it sets assistant streaming to true. And then it streams the text message that comes in. After that, what will happen? In the next message, the next text delta that comes in, it will again check that, hey, is the assistant streaming? Well, the assistant is streaming, so it will not execute it. So begin assistant will not display. The ruler will not display again. And all the text will be coming in side by side on one line. Now let's try to run it and see how it looks. So as you can see, assistant shows up over here, and below that we get all of the user related text. So that is text delta. But there's another state, right? From agent, we are also sending text complete. If the text is complete, then what do we want to do? Well, we want to set this assistant streaming to false, right? So here I'll put in an elif event.type is equal to event type, agent event type actually, dot text complete. And then we'll just have a final response. The final response is equal to event.data.get. And now we get the content. After that, we'll again check if assistant is streaming, because that was the variable created, right? If the assistant streaming is set to true, I would like to end the assistant. So I would have assistant streaming is equal to false, and let's also display a UI component. So in the TUI, I would like to go ahead and create another function, which is def end assistant. We get a self here. It will return absolutely nothing. And it just checks that, hey, if self.assistant stream is open, because even over here we were tracking the state, right? If the assistant stream was open, then we want to print out a new line. And after that, I would like to set the assistant stream open to false. It's no longer open. And now I'll go back to main.py and here have self.tui.endAssistant. And now that we have the final response with us, I would just like to return it outside of this for loop, because I told you if process message returns something, this run single is going to return something, and if run single returns something, the result is not null, so we'll not do system.exit1. But if it is null, in that case, unfortunately, we have an error. So it will exit with the error code 1. So this is text complete. Let's try to run it again and see the difference. And the difference is just this much. %sign is also gone. It's no longer there because we are properly closing and ending everything out. Self.console.print helps over here. Now let's also handle the case of agent error. Just in case we're sending the agent error, I would like to display the error out loud. So let's go back to the main.py and here we'll have elif event.type is equal to agent event type dot agent error. If that is the case, then we're going to extract error, which is event.data.get. We have error and the default string is just unknown error. Now if assistant streaming is true, okay, the same variable, if it is true, in that case I just want to shut it off because we have an error. I don't want to deal with it anymore. If that's how we want to deal with it, right? Because if we would have done return over here, the entire thing would be over. We don't have anything more to go with. But that's not what I'm going to do. The assistant streaming can keep on going even if there's an error, because in a later message, in a later tool call, it can resolve stuff. So I'm not going to do that. Instead, I'm just going to print out the error. So console.print, and then I'll have an error printed out. For error, we don't really have any agent stuff over here. Like I'm not created anything related to error, right? Or actually I have. So we can probably just use that. So we have error like that. And we spit out the error, which is, well, whatever we extract over here, followed by \error again, or /error. So that's the agent error stuff. Now I would like to actually make an error in the agent. So what I'll do is change the model name in LLM Client. So I'll go to this keyword arguments part, misspell it. Now let's run it again. And it says cannot access local variable final response where it is not associated with a value. We can fix that. The problem here is that we have a final response which is returned, right? But many times final response is not defined. For example, when we have an agent error. So what I like to do in that case is have a new variable here. Let's call this final response, which is of the type of string or null, and by default it is null. Now if I try to run this, we do get an error. And actually the error did not come from this place, process message, even though it can totally come from here as well because it's the same thing. But the same problem even occurred in agent.py. If you scroll down and find final response, so if the text is complete, we do get the final response and then agent ends. But if we don't, then there's an error returned out. So outside of this for loop, we are going to be tracking this variable again. Final response string or null is equal to null. And now we can try running it again and hope it works out. And well, it errors out, as you can see. So I figured out what the error was, and it's a pretty stupid error. If you go back to our agent, the client specifically, in the response.py, here we have @data class for the stream event type. We don't want the enum to be a data class, right? That is the error. And now if we remove that, you'll figure out, we will run this, and yeah, we do get the error clearly displaying out over here. Now, the reason or the way I got to know that this was the error is because I just printed out the event over here and matched it. So event.type was equal to stream type.error, All right. So that means the elif condition should have been caught over here. But then I tried printing out this particular line. Event.type is equal to stream event type.text delta. And that was true as well. That means this if condition was catching the entire thing. But how can the event type be text delta if when I printed out the event, it was clearly an error? And that's how I checked that, hey, is it possible that stream event type.text delta is equal to stream event type.error? And they were both equal. And that's how I figured out that I've configured the enum wrong somewhere. And then I found out that I had passed in the @data class at the top, and which is why we got that error. So anyways, it's resolved. We can display the error clearly over here, and that's great. Now let's fix the LLM client again. I want the model to be displaying correctly over here. So now we'll change this back to Mistral AI. Now we can run this and we should be seeing the correct data, and that's great. Awesome. So now, having configured all of those things, we'll keep working on the UI side by side. There are a lot of components to add, but now I will just like to get started on the context management thing. So how do you get started with the context? Well, it's quite easy. You just go and create a new folder called manager, or let's just call it context. And here we will create a new class called manager.py or context manager.py, whatever you want to call it. Here we are going to create a new class. Let's call it context manager. Then we are going to have an init function. And in this init function, we are going to get self. Now, this self is going to return nothing. And now we would like to get access to some things, right? This is a context manager. That means we are loading all of the context from the things that we have back into the model. So the very first thing we'll need is the system prompt. We've not talked about system prompt as of now. What is a system prompt? Well, system prompt is just a prompt that is neither of the role of user, neither it is of the role of assistant. It is just a system prompt. It is telling the LLM how to behave. What are its instructions? Not what the user specified, but what are its instructions from the side of system. Like, how should the AI agent respond? Because the user prompt is not going to tell how the LLM should behave, right? Should it be polite? Should it be rude? Should it be sassy? Nothing is mentioned in the user prompt. The user just passes in their query. What we have is a system prompt. System prompt tells that the LLM should behave in a certain manner, or the date and time right now is this, or many other things. All of that comes under system prompt, and we'll be curating our own system prompt. So here I'm going to create another folder called prompts, within which we have system.py. And I'm just going to paste in all of the stuff over here. If you want to find it out, what the system prompt is, I've mentioned the link in the description to the GitHub repository. You'll get a bunch of functions more because there's more stuff to add to the system prompt, but you can remove all of the lines that essentially give you an error because they use all the configuration system that we're going to add later on. What we need is these sections as of now: identity section, agents MD section, security section, operational section, and yeah, rest of the things are just this. So let's go over it one by one. Okay, first of all, we have a list. In each list, we are going to have one item appended, which is just going to be a massive multi-line string. All of them will have multi-line strings attached to them, and all of them will be concatenated by a separator of 2 lines. Now, the first section that we add is the identity section. It just gives the LLM instructions about who it is, what it does, what is its role, how it should behave, what is its identity essentially. This helps because, well, if you tell an LLM that they need to behave like a principal engineer, they start focusing on the architecture or the clean code. Essentially, they start thinking in a manner of principal engineer. Whatever data they have on principal engineers, they start focusing in that particular zone. You can think of them as activating that particular identity. So we are saying that, hey, you are an AI coding agent, a terminal-based coding assistant. You are expected to be precise, safe, and helpful. The capabilities are receiving user prompts and other context provided by the harness, such as files in the workspace. This is a bit also related to what we are going to have in the future. So yeah, keep that in mind. We want to communicate with the user by streaming responses and making tool calls. Right now, we have not specified any tool calls it needs to make, because I've just removed a lot of stuff that was present in the system prompt, because I would like to add them on demand. For example, tool calls. I would like to add a section about tool calls when we actually implement tool calls. But anyways, emit function. So this is all the capabilities. Depending on configuration, you can request that function calls be escalated to user for approval before running. This is related to the approval system. And remember, you are pair programming with the user to help them accomplish their goals. You should be proactive, thorough, and focused on delivering high quality results. We've just given its identity, what its capabilities are, what the goal is. So that is the identity section, making the agent or the LLM think in a particular manner. The next part is the agent's MD specification. So many times what happens is that the repositories or the folders that you're already working with might contain an agents.md file, a file specifically created for agents to understand how the code base works. That is not a file that the user will interact with. That's just a file created for LLMs. And many repositories are getting into that phase where they create an agents.md file. So we just tell it that, hey, repos might contain agents.md. These files can appear anywhere. Just find out if there's an agents.md. There'll be instruction in the agent.md. And yeah, so that's just stuff about agents.md. You can read the entire prompt yourself. Then we have the security guidelines. What are the security concerns related to our project? Now, this is not an exhaustive list. There can be multiple more, and I'm very sure I'm missing out on multiple things. But yeah, the security section is never expose secrets. That means API keys, password, tokens. We validate all of the paths, so we ensure file operations stay within the project workspace. We be cautious with the commands, because shell commands might just delete your entire repository. You might have seen the news that a shell command just deletes the database because, well, they have the YOLO mode going on. We'll also have all of those modes. So we want to ensure that the LLM is cautious with those commands. Then we have prompt injection defense. We ignore any instructions embedded in file. Then there's no arbitrary code execution, and always focus on security first. If the code doesn't work, it's fine, but just ensure you don't delete stuff for the user. That's very important for them, because it might never be retrievable. Now, the next stuff is the operational guidelines. So what are the operation guidelines? Well, what is the tone and style? How should the CLI interact? It needs to be concise and direct, minimal output, clarity over brevity, no chit chat. It should format everything using Markdown. Then you have tools versus text. It should use tools for actions, text output style only for communication, handle inability. So if it is not able to fulfill a request, it just states it out loud. And this is actually a very powerful statement, because many times the LLM will just hallucinate, but if you give them a way out, they will try to tell you that, hey, I can't complete this, I'm sorry. Then you have primary workflows, software engineering task. So whenever requested, like fixing bugs or adding features, first they need to understand, then they plan, then they implement, then they verify with test, then they verify standard, then they finalize. Now, you can obviously tweak according to your preferences. By no means is this like a perfect prompt. I just put in what I think should be present in a prompt. Then you have task execution. So they are a code agent. So please keep going until the query is completely resolved. And then we talk about tool usage. We are going to support parallelism, right? So if there are multiple independent tool calls in parallel, just use them so that we don't burn through a lot of tokens. Then you have command execution, file operation, file creation, remembering facts, which is using the memory tool. Then you have task management using the to-dos tool. Well, we're going to add all of that back again, because there are specific sections that talk about tool usage in detail. Then you have error recovery, what should happen when something goes wrong. Then there are code references. For example, when we are referencing some specific functions when talking to the LLM, we would like to have them marked in this back ticks so that, in the front end, if we want to display it nicely, we can. Then it also spits out the folder, the line number, everything. Then technical accuracy is prioritized, and these are all the coding guidelines. You can obviously add more of them. By no means is a system prompt just a one-shot prompt. You analyze your user's request, then you tweak your prompt, then you see how the users are behaving again, or you run your independent evaluations and see how it works out. So that is the system prompt, and that's what we're going to use over here as well. Again, this system prompt needs a lot of work. We will be adding more stuff later on, but as of now, this is good enough. Let's import it from prompts.system. Another thing this is going to have is a messages list. So we'll have self.messages, and also system prompt can be an underscore. Self.messages will be an empty list. And the type of this messages is going to be message item, a list of message item. And we're going to create this class of message item. And that is going to be a data class. So from data classes, we are going to import data class. And then we're going to have @data class message item. And now what are the properties in a message? What is each message in the context going to contain? Well, there's going to be a role which is going to be of the type of string. So it can be a user, assistant, tool, system, whatever is the role. Then you have content associated with it, which is also going to be a string. Then there are multiple things like tool call ID, tool calls, token count, compaction date. We're going to add all of them as we need them. Maybe we can add token count now itself. So we have an integer or null, which is by default null. Awesome. Now in this context manager, well, we have the messages list, right? This is what we have to maintain. So the very first thing I'm going to add is the user message function. So just in case we want to add a user message, we're going to get that self content, which is of the type of string, and we return null. Now an item is going to be created like this message item where you pass in the role, which is a user, because we have added a new user message, right? Then we have a content, which is just content. And then you finally have token count. Now, how do you count the number of tokens? Well, it depends on the model. Each model has a different token count. Just to demonstrate, you can go to platform.openai.com/tokenizer and you learn about language model tokenization. If I type in some text here, hi, this is Revan, and how is it going? You'll notice there are 10 tokens over here. Now, if I switch to another model like GPT 3.5 and GPT 4, there are 11 tokens. And if I move to GPT 3, I again have 11 tokens. So as you can see, the tokenizer between GPT 3.5 and GPT 4 and GPT 4.0 changed because the number of tokens has changed. So my point here is that each model, even different models of OpenAI, the newer ones will have different tokenizers. It's inevitable. So it really depends on the tokenizer about what the token is. But a rough estimation is that, let's say we have 10 tokens here and 37 characters. So one token is roughly 4 characters. That is the estimation. So we can do that estimation and it will work out. Otherwise, you can go ahead and install a package called Tick Tokenizer. And this Tick Tokenizer is coming from PyPy. It's not the NPM package. And actually it's called Tick Token. It is a fast BPE tokenizer, which stands for byte pair encoding. But those are very specific LLM terms. However, what we are interested in is getting the number of tokens using Tick Token. Or we can just estimate the number of tokens using a rough estimation, right? So let me just go ahead and install Tick Token right here. Cool. And after that, I'm going to create a new folder called utils, within which we have text.py, and within this text.py we're going to have a function called getTokenizer. Then we get a model which is of the type of string, and well, we just get the tokenizer over here. Now, what is the point of tokenizer? Well, it will help convert to tokens, but what we are interested in is not converting it into tokens, but just getting the length of the token or the number of tokens that are present. And we don't have to worry about the speed because it's almost instantaneous. So we can just do this try, and then we have an exception, and if exception occurs, then what we're going to do is encoding is equal to tick token, and we have to import tick token. Now if the import tick token has been successful, that's great. We'll do tick token dot get encoding, and then we'll pass in the base as CL100K underscore base, which is used by GPT-4, and then we'll just do return encoding dot encode. This is the function that's returned, and then in the try block we want to do encoding is equal to tick token dot encoding for model, because specifically we want to get the encoding for whatever model is present, right? And then we just return encoding dot encode like that. So we'll try it for this specific model. If it's not present, then we fall back to GPT-4 tokenizer. And now we want to create a function to count the tokens. So we'll get a text which is of the type of string, then we'll get a model which is of the type of string, and yeah, we'll just return null or integer, sorry, because we are counting the tokens, right? And now we'll do tokenizer is equal to get tokenizer. We'll pass in the model, and then we can just do if tokenizer is present, we return the length of the tokenizer of text. Otherwise, if the tokenizer is not present, we don't get anything back. What we want to do is estimate the number of tokens. So we are going to have def estimate tokens. We get a text which is of the type of string, and then we return an integer, and then we return max of 1 comma length of text divided by 4. What have we done over here? Well, we are just saying that we want to take the max number between 1 and length of text divided by 4. Length of text is just how many characters there are present in a sentence, and we divide it by 4 to get the number of tokens, right? Because on average, one token is equal to 4 characters. With GPT-4o, we saw that 10 tokens was about 37 characters, which is approximately 4. So that's what we did over here as well. So now if the tokenizer is not present or we run into any sort of error, we can just return estimate tokens and pass in the text. Awesome. So that is it about tokenizer. Now let's use this count tokens function. So we have count tokens, and we take that from utils.text. Then we need to pass in the content. The content is passed in over here, and then we need the model name. Now the model name is obviously hard coded, but we will be getting it from the configuration system. As of now, let me just copy what we had in LLM Client, which is Mistral AI Destrel. Obviously, we will be changing that. And now we have self.model name. And I think most likely in tick token, this model is not present. And that's why we'll be shifting to the GPT-4 tokenizer. So it's not going to be very accurate, but it's fairly accurate. It won't create a lot of difference. So now that we have created this item, what we want to do is add the user message, right? So what we want to do is self.messages.append, and we want to append this item to this messages list. So that is the add user message. Now we are going to copy this function and similarly create something for add assistant message. So we have add assistant message like that. Then we are going to get a content, and yeah, there'll also be tool calls that the assistant can do, but we'll ignore it as of now. Then we get assistant. Then there's content. If the content is not present, it's going to be an empty string. And then we can count the number of tokens. And now I can just do self.messages.append item. Great. Now obviously there's more functions that we can add, like get messages, which just gets all the messages in a dictionary format. So right now all the messages are a list of message infos, but we would like to get them in a dictionary format, right? So we can do that and we should do that. Let's do that. So we have def get messages, and then we have, okay, let me have messages here, then self, and we're going to return a list of dictionary of string comma any. Cool. Now that we have any, we'll import that from typing. And now, first of all, we'll create a messages list. After that, we want to check if the system prompt is present. So if self.system prompt is present, which it should have, but if it's not empty, then what we want to do is messages.append, and we're going to append to this a dictionary where we pass in the role, which is system, and then we pass in the content, which is self.system prompt. Cool. After that, we'll go over every element in self.messages. So I have for item in self.messages, and then we'll just do messages.append item. But we want this item to be converted into a dictionary, right? So what we want to do is go over here and create a function called toDictionary, which is self. And here we're going to return a dictionary with string as the key and the value can be any. Then we have a result, which is also a dictionary with the key as string and any as a value. And then first of all, we'll pass in the role. The role is just going to be self.role. We're just converting it into a dictionary, right? So we will pass in the role. After that, we need to pass in the content as well. So here we can just pass in if self.content is present, then we're going to do result at content is equal to self.content. And then there can be tool calls and stuff, but we'll add that later on. And now we'll just return the result. So that is toDictionary. We are not passing in the token count. Token count is solely there for our purposes, and I'll explain later why we need it, because we'll be using that in a function. So now I can go over here and just call toDictionary. Cool. So now we are in an OpenAI format where we have a list of dictionaries with role and content passed to it. If there are tool calls, we'll add that later on. And finally, after everything is done, we can return the messages, which is a list over here. Now there's other function we can add as well, but I'm not diving into that. We'll create them as and when we need it, but these are three basic functions: adding the user message, adding assistant, and getting all of the messages in a dictionary format so that we can pass it to our agent. Now let's come back to our agentic loop and see what we need over here. So in the run function, I told you that we will have to add the user message to context, right? Let's add it. So first we'll have to instantiate context manager. So we have self.context manager, and just like client, context manager should also be within a session because, well, it just makes sense to have a context manager in a session. If you have multiple context managers, you have multiple sessions. One session can have one context manager. So yeah, we have context manager instantiated. Now we can just have self.contextManager.add user message, because right now we just add the user message to context, right? So we add the user message, and now we need to pass in the content. The content is the message itself. That's great. So we have added the user message to context now. The next thing we want to do is that whenever we run the agentic loop, we get the event, right? And we get the user's text. Now we want to record that user's text. So just before we have response text, we'll just check over here that, hey, we have self.contextManager.add assistant message, the content. Now what is the content going to be? Well, it's just going to be the response text, right? And if it's not present, if it's empty, then we just pass in null, that it's fine. The assistant message can be null. And then obviously if there's any tool calls, we would like to add that as well. Again, let's just leave it for now. So now we have the entire context with us. I can remove this messages list. And now instead of having messages passed in, and then we can just pass in self.contextManager dot get messages. And now we have access to the entire messages in the OpenAI JSON format, right? Because we have a list of dictionaries. So what have we done here? The changes we have made is adding the user message because the user clicked on run, right? So when a user first passes in a prompt, we go to this run method. We add the user message, then we run the agentic loop. Within the agentic loop, we just get all of the messages. The get messages will get the system prompt. So yeah, we have appended the system prompt over here. The first thing should be the system prompt. After that, we add all of the user related and the assistant related messages, whatever is present. So in our self.messages right now, we just have a user message because we just added a user message. But obviously if it's a multi-turn event, there can be multiple assistant related messages. There can be multiple user related messages. And that's what we're going to work on next. But as of now, we have created a good functioning context management system. Now we are no longer depending on a hard-coded text. So now I would just like to clear everything off and run this particular thing. Now instead of this prompt, I would like to say what is 1 plus 1 and then hit enter. And then the assistant responds with 2. That means our entire context is now working. All the hard-coded context related stuff is out now. And now we can start working on another thing, which is tool calling. Now what is tool calling? Tool calling is essentially an LLM taking actions for us. I would like to explain this with a diagram by OpenAI itself. Let's say we have the developer, we have given it instructions that you have this tool, just use them on time so that you can do stuff for us. So let's say the user says that, hey, in my repository or in my folder, you want to fix a bug. Now, to understand what bug to fix, the agent or the LLM will have to read the file, right? But how can it read the file? We're not loading any file reading stuff into the model. If we load all of the file content within the LLM, it will just go out of context because there are so many files and they consume so many tokens. So obviously we can't do that, but we can tell the model that, hey, if you want to read one specific file, or a bunch of files, not all of the files, we can give it to you, just let us know. So we tell it that, hey, here's a tool call. If at all in the future you want to read a file, just let me know by telling that, hey, please execute this read file. So what happens is the user asks a question like, what's the weather in Paris? It tells it this is the tool definition. So it passes it in. The model decides that, hey, if we want to understand what's the weather in Paris, we will like to call this tool like that, get weather with Paris passed to it. So it comes to the developer. Now the developer will execute that tool call. The model has no capability of calling the tool, right? Because in our case, if we want to read the file, how can the model read a file when it's operating remotely on another computer in the cloud? We will have to read the file for them because our tool, the developer's tool, is running locally. So the model will tell us that, hey, please call get weather or read file tool for us. Then we'll execute that tool or the function code. Tool is just a function code, all right? If you want to read a file, we just say that, hey, go and read these file. If you want to read a file from this line to this line, again, the model will let us know through the parameters. So let's say the model calls read file. And they want to read what file? Well, they can specify some path to a file .txt, right? Now, they can also specify other things like line number. If they want to read line number from 14 to 30, so they can specify that over here, the beginning line and the ending line. So they just let the developer know that, hey, we want to call this tool. I think it would be relevant. So we execute that function code. We'll read the file for the user, or we'll call the get weather Paris function for the user, and it gets a temperature. In our case, it will get the file's content from lines 14 to 30. And then we send that back to the model. Now the model has access to the file, or it has access to the temperature. Then it sees that, hey, can I do something else with this? Well, In this case, the prompt was very easy. What's the weather in Paris? It notices, yeah, we have gotten the weather. Let me just frame it in a nice way. So it will say it's currently 14 degrees Celsius in Paris. But in our case, reading file was step number 1. Our prompt was fixing the bug. So now that it has read the file, it will determine that, hey, this file looks relevant. There is the bug. I know how to fix it. So it will just call something like edit file. So edit file will again pass the path to this particular file, and then it will also pass in all of the content that needs to be passed in over here. The content is that you need to replace at line, let's say 14, maybe you've typed out print statement, you need to replace that with a logger. So you have logger.getInfo and all of that. It's just an example, but you get the point. The LLM gets access to the file that it has been reading. The LLM gets access to the file it read over here. It wanted to read over here. The LLM gets access to the file it wanted to read. Then it reads it, and then it understands that, yeah, I understood the bug, let's fix it. And then it calls another tool to fix it. So that is the purpose of tool. Without tools, it won't be able to take any action. Tool is essentially LLM's way to interact with the outside world. So it was a very big example and a very big talk, but that's how tools will help us. And we're going to create a bunch of tools. So let's open our sidebar, and over here, I'm going to create another folder. Now this folder is going to be called tools. Within this folder, we are going to have multiple tools. There are going to be built-in tools. There's going to be MCP, because MCP is essentially just a tool call. So that's what we're going to have. But we're going to start off by creating something known as a base.py. This base.py is going to contain the base class for all of the abstraction that the tools are going to have. So here we're going to define a class tool, which is going to be a base class. And all the other tools like read file or write file or edit file or patching, everything will extend this tool. So it's going to be an abstract base class. So let's import ABC, and then we're going to inherit from abc.abc. That's how you create an abstract class within Python. So this is the base class for all of the tools. Now we're going to have an init function. And in this init function, as of now, we're going to have, well, absolutely nothing. So it's just going to be null like that. Okay, nothing done over here. After that, we're going to define the name property over here, which is going to be of the type of string, which is going to be, let's call it base tool. After that, we're going to have a description. And all of the tools are going to have these properties, all right? Name is going to be present in whatever tool inherits from this tool. So read tool will have its own name. It's going to have its own description. So the name helps us, well, display it on the screen, what type of tool it is. And description will specifically help us when we want to select what tool to do. So if we come back to this particular diagram where we are telling the model to select one of the tools to do a tool call, how does it know what tool to call, right? It just doesn't take in the name and decide what to do. It also takes in a description of when the tool should be called. So we are going to specify a description as well. This is just going to be base tool. And then we are going to have a kind. What is the kind of this tool? Is it going to be a read-only tool? Is it going to do network operations? Is it going to do a write operation? What kind of tool is it? So we are going to create that enum at the top. So we are going to have from enum import enum, and then a class tool kind where we go ahead and create an enum. Now the first one is going to be read, which is just read only operations tool. So that's going to be read file. Then we have write one, which is equal to write. So these are file modifications. Then we have shell, which is, well, shell operations. Then we have shell operations just means command line operations, all right. Then you have network, which is equal to network. These are all things that would happen over the network, like searching the web, fetching a particular URL, all of that. After that, we're going to have memory, because we're going to have one tool dedicated to memory, because memory is a pretty cool feature. You can note down your memories and your agent knows it about you. So it can be applied to all or the current project, whatever. Then you have an MCP, which is just equal to MCP. whatever tools are MCP related, we are not exactly going to know what type of tool it is, right? Like, is it specifically a read operation or a write operation? All we know is that it's an MCP. We're not going to analyze the code base to understand what that MCP does. It will just do the job. Then the kind here is going to be of the type tool kind, and then that is equal to tool kind dot read. Or you can change it to whatever. I'm just going to change it to read because it's the most basic permission that we have, or the basic tool kind that we have. Awesome. So in this init function, we are also going to have the configuration, and we're going to create that once we have figured out everything related to tools and sessions and all of that. So yeah. After that, we're going to have another property here, which is going to be schema. Now the schema will be created as a function, but each abstract class will have to implement this schema. So here what we're going to do is have @property. This is essentially a property that you can use in the class that inherits from this class. If you don't understand, don't worry. We'll create a read-only tool and you'll be able to understand it then. So the schema can return a dictionary, which is having the key as string, and the value can be any because, well, it can be a string, integer, whatever, we don't know. Or it can also be of the type of base model. Where is this base model coming from? This base model comes from a package known as Pydantic. So Pydantic is the most widely used data validation library for Python. We'll be using this. There's another package called Pydantic AI, which does all of the things that we have talked about with the OpenAI package, but it just has the Pydantic AI flavor to it. So it uses Pydantic and all of that stuff, and it connects to any model. And it also has functions related to creating your own agent. So whatever agentic loop we created, Pydantic AI can do that as well by just writing one simple function, but it does not allow as much configuration as we need. You cannot put in a lot of customization into that agentic loop. So that's why we created our own agentic loop. So let's install Pydantic. We'll just open up our terminal and here have pip install Pydantic. So we have installed it. That's great. Now let's go at the top and do two things. First, from Pydantic, we are going to import base model, and then also at the top we are going to do from future import annotations. Almost every file that we're going to talk about is going to have this line. It will be useful somewhere or the other. And then for the schema in this base tool, well, we don't have anything to do. What the schema does is represents what the tool schema definition is, what kind of parameters this tool is going to have. For example, in the read operation, I told you whenever we are trying to read a file, you need to specify the path of the file. If there's any offset, if there's any limit, whatever, you need to specify it through these parameters, right? That is the schema that I'm talking about. Now the base tool is obviously not going to have any schema. Every tool that we create is going to have the schema property where it defines all of the parameters. So here we are just going to raise a not implemented error because every tool must define schema property. This is an error from our side and we don't want to miss out on that. So we'll just raise this error or class attribute. Awesome. After that, we're going to define another function, and that is the execute function. This execute function is going to be an abstract method. Every tool will have to define this function. So we are going to have @abc.abstractClassMethod or abstract method. That should be fine. And we don't have to call it like that. Maybe this is fine. And then we'll have async def execute. This execute function is essentially what should happen if the tool is executed. So let's say the model tells us that we need to call get weather tool call. So we have to execute this function code, right? What should happen when the function is executed? That's what's going to be defined in the execute part. Now this is going to take in a bunch of tool methods. So we are going to have invocation, and this is just going to contain all of the parameters of the tool invocation. So we are going to create a custom class called tool invocation, and it's going to return something known as tool result, which is also something we have to create. These are two custom classes that we'll create right at the top. So the very first thing is tool invocation, right? So we'll have a data class, and let me import the data class. And to import data class, we have to do from data classes, import data class. And then here we can have class tool invocation. And now what are the parameters that I need to execute a tool call? What details will I need? Not many. The first thing that we'll require is the current working directory. So CWD stands for current working directory, and it's going to refer to a path. Which path do we want to execute this tool in? And this is especially useful when you're trying to do a read operation, right? What is the current working directory? Or if you're doing a write operation, because what path are we writing to? And what path are we in right now? This is especially useful with safety permissions that we're going to add, because let's say I started the AI agent in an interactive mode and I start it in this AI agent folder itself. By default, my AI agent will not be allowed to make any operations outside of this folder. So if I want to make any changes in desktop, it will require my permission. That's how our AI agent is going to work. So having the current working directory will give us a perspective of where we are, and if the agent is trying to make any changes outside of where we have opened it. For example, it's trying to make changes in desktop, but we are in AI agent, then it will get to know that it's in desktop, not in this current folder. So we'll ask for the user permission. So this is particularly useful over there. We'll find other use cases as well, but this is one of the use cases. Now let's import path from pathlib. Another thing that we'll require is parameters. What are the other parameters that you can have? Because read operation will require something else, write will require something else, shell operation will require something else. So yeah. Also, I fixed the tool invocation name over here. So yeah. Next thing we need is a tool result. Now, tool result is essentially what happened after the tool was executed. Was it a success? If it was a success, what was the output? If there was an error, what was the error? Then if there's any metadata that you want to attach and all of that stuff. So let's create a data class for tool result as well. So we are going to have a class tool result. And just so you know, we are only creating data classes and classes for all of that because this is a more object oriented way of going about things. If you want, you can directly return a dictionary over here and that's totally fine. But I want that nice autocomplete. That's majorly why I've stuck to creating data classes. So we have success, which is a Boolean value, if it was a success or not. Then we have an output, which is of the type of string. Then we have an error, which is of the type of string or null, and by default it is null. Then you have metadata. Metadata is any data that you want to attach to this already existing data, right? Data on top of data. Now, metadata can refer to multiple things. For example, in list directory, that's a tool that we're going to create when we try to list out the directory. So let's say if I'm in this directory, I want to see what all directories or files are present within this AI agent directory, right? So I can use a tool to do that. And that tool will give out metadata like what was the last modification time for this folder? What was the last modification time for this folder? What was the size of this folder? What was the size of this file? All of that data will be stored in metadata. But in the output, we are going to have, well, the list of files or folders that are present within the directory. So that is the difference between output and metadata. Again, when we work on it, it will get clearer. So we have string, any. And by default, this is going to be a field which is coming from data classes as well. And the default factory is going to be a dictionary. If nothing is present, it's not going to be a null value. It's going to be an empty dictionary. Now there's other things that we want to add as well, which are related to displaying. So there's going to be a diff that we can add, some truncation logic, like if the response was truncated or not, and then an exit code. But we'll look into that later on. Now, we've just defined how this abstract method is going to look like. That's good enough for now. Next function that we're going to have is validate parameters. So we want to validate the tool parameters, right? So we can do that. We'll have self parameters coming from the, arguments, and then you have string, any. And this thing is going to return a list of string. Why is it returning a list of strings? Because we are going to return a list of validation errors if validation errors exist. Otherwise, we're going to return an empty list. That means there are no validation errors, it's valid. Now what this validate parameters is trying to do is that if we again go back to this diagram, let's say the model gives us get weather, Paris, and then it also gives us another integer. The model got confused about how to call the function. So it gives us invalid parameters. So before executing it, I would just like to check if the parameters are correct in the first place or not, right? That's a good way to go about it. Otherwise, I'll execute it and something will just go wrong, because in this case, it tried to pass an integer when no integer is required after Paris. There's no second argument to be passed. So those are the kind of parameter validations that we require. And for us, it's actually quite easy. The reason it's easy is because we're using Pydantic. Pydantic by itself is a package helping us to do validation. So here, first we can extract the schema. The schema is just equal to self.schema, this property that we had. And the only reason this is in a function type is because we want to raise a not implemented error if no schema is present. Otherwise, you could have written schema over here and that would be totally fine. Now that we have schema with us, I want to check if the schema's type is base model. Because if it's a base model, then we have a Pydantic schema. As I said over here, the return type of the schema, the type of the schema can be base model or it can be a dictionary. The reason it can be a dictionary is because we have MCP tools. MCP tools will define the dictionary to us as it is. They're not going to give us the schema in a Pydantic format. Pydantic is for us. Of course, a random MCP is not going to give us data in the format that we want. So here we are having a dictionary, but the base model is there whenever we are trying to create our own MCP schema. But we have base model when we are trying to create our own tool, because all of our tools parameters or schemas are going to have base models, and we'll look at that in just a minute once we've completed this class. So this is for MCP, dictionaries for MCP, and base model is for our inbuilt tools. So first I'll just check that, hey, if the instance of schema is of type and if it is subclass of base model, then we have a Pydantic model. If there's a Pydantic model, it will automatically do the validation if we just do schema, which is of the type of base model, right? So we can just call this base model like that. So similar to this part where we could just create a base model like that and pass in any data. Now, since schema is essentially a base model, we can just call schema like that, pass in all of the data. So we'll have all the parameters passing in, and that's it. Now, this can result in an error in case there's a validation error. So we're going to have a try block. We call schema within this, and then we have except validation error. And then we have validation error as E. Now let's import validation error from Pydantic. So again, just to revise, what we have done over here is just call base model like that, whatever base model it is. Let's say it's going to be read file schema. So it's called like that with all of the parameters passed to it, like what is the path of the file, what is the limit, what is the offset. And if this does not return any error or it does not raise any exception, it's good for us. We have not raised any validation error. Everything looks good. All the parameters are great. But if it raises validation error, then we have a problem. So we have to catch all of the errors and give it to the model, right? Because if we give it to the model will understand and try to improve in the next step. So here we're going to have for error in e.errors, and we can catch all of those errors over here. And now I just want to format all of the error that we have. All right. So we are going to have for x in error dot get LOC, and if LOC is not present, it's just empty. This will return to us x, and we just want to convert that x into a string. Cool. So we'll just join everything. So we have a full stop dot join, and yeah, that's it. This is going to be our field. So essentially what we've tried to do is from the error object that we have tried to extract LOC, which stands for location. and we're just trying to find out where all the what locations did this validation error occur in, and we're just separating them by a full stop. After that, we're going to have a message which is equal to error.getMessage, because we need to know what error message it is. And if that does not exist, we're going to have validation error. That's it. And now to errors, we are going to append this. So we have errors dot append, and then we can just pass in that parameter, and then we pass in the field, and then we pass in the message. So this parameter said that we had got this error message. Simple enough. After this for loop ends, we are just going to return a bunch of errors. Otherwise, we just run into an exception as E, and then we just return whatever error we got. We want to catch all of the edge cases, right? Worst case, we don't format any of the error, just give the entire thing to the LLM, and the LLM will just figure it out. So worst case, we're just sending a string of the error message. Now, if it's not an instance of base model, that means we don't have a Pydantic model, we have a dictionary. If there's a dictionary, basic validation can be done by OpenAI API or the OpenAI SDK that we are using. So we'll just return no errors. If there's any error, it will be caught by the OpenAI package. So that's good for us. Again, just to remind, this is for Pydantic. In Pydantic, we have to do it ourselves because it's a custom layer that we added ourselves, right? The only reason we're using Pydantic is to help ourselves just be more explicit, more clear, and handle all of the validation. If it was a simple dictionary, OpenAI could just handle everything. So yeah, that's about validate parameters. Another function that we're going to have is related to is mutating. So is this function that we're creating or the tool that we're creating modifying any state? For example, if your operation is a read operation, it's not going to mutate any state. It's not going to change anything. But if you have a write operation or an edit operation, it's going to change the state, right? Whatever state your program is in. So here we're going to have parameters, which is of the type of dictionary, string, comma, any. And here we're going to return a Boolean value because mutating can either be true or false. And it's only mutating when there's a certain tool kind, right? For example, if I have read, it's not going to mutate. If it's write, it's going to mutate. So it really depends on the tool kind. So I can just simplify this and just say that, hey, I want to return true if self.kind, the tool kind that we had over here, if it is either in tool kind dot write or it is tool kind dot shell or it is tool kind dot network, because network can actually change our state, or it is tool kind dot memory. So if it's either one of these, then we have a mutating state. Of course, right, you obviously understand shell can be mutating and non-mutating. So if you try to do a cat operation using shell, it's non-mutating. But if you're trying to run a web server using shell, or you're trying to create a new file using shell, those are all mutating. Then you have network. Network operations obviously can be mutating. And memory, you're literally appending to a file what the memory is going to be of your user, right? So if I just say, hey, my name is Ravan, it will be stored in memory. Now, since it's stored in memory, it's stored in an actual file on my system. If it's stored in an actual file on my system, it's mutating. So that's one. Another thing that we're going to have is related to confirmation. So whenever we execute a tool that is outside of our basic permissions, we might get a toolbox saying that, hey, this is what's going to happen with this tool call. Do you want to accept it or disallow it? So for that, we're going to create something related to tool confirmation. And that's also a function we're going to create. Async def get confirmation. Then we're going to get self, then invocation, which is of the type of tool invocation. And here we're going to return either a tool invocation or a null value. So confirmation is not required when there's no mutating thing happening. So if you have read operation, you don't need a confirmation. You can just go ahead and read it. But if you're going through a mutating state, and that mutating state is outside of your directory and you only have permission to read files in the directory, it will ask you to get a confirmation. Let me show you an example. So this is basically what the end state is kind of going to look like. So I can just run this particular command, which is create a hello world Python script outside of the folder I'm in. So I can just run it, and this is the output that we get. Approval required is put in over here, but the data that's been shown over here is related to confirmation. So if you disprove this request, it's gone. It doesn't do it. But, well, if you approve of it, it will actually override the file that already exists, hello world.py. Even when you do any other action, for example, a simple action, let me just approve this, and it's unable to do it because I have less permissions, a very restrictive environment setup. But anyways, my point is, if we try to create a Python file in this environment itself, so I'll just say create in this working directory and then hit enter. As you can see, it creates and writes the file. So this particular thing, it did not ask for my permission now because we are in the same current working directory, right? So it doesn't ask for my permission, it directly just writes it down. Of course, we can restrict it even more, and we're going to add that through configuration system. But the point here is that this dialog that you see is confirmation. It specifies the tool name, it specifies the parameters, it specifies the description, all of that. So here we're going to create the tool confirmation part. If we are just reading a file, we don't need any confirmation. So we'll have if not self dot is mutating, and then we need to pass in the parameters, right? What are the parameters? Well, it's just going to be invocation.parameters, because remember, in invocation, we had the parameters set up, right? And we needed that parameters here as well. Now, obviously, parameters is not used in this mutating function, and it will probably not be used in any mutating function, but it's good to keep it over here. If you want, you can remove it, but just in case we need it for something. Maybe the answer of is mutating is not as simple as like either returning true or returning false. Maybe you want to do some calculations based on the parameters and then deciding. We are going the easy route, but you can obviously go much deeper in this is mutating part. So if is mutating is false, then what I want to do is return none because we don't want any confirmation. However, if is mutating is true, then we want to return tool invocation or tool confirmation, sorry. So we'll have to create a new class called tool confirmation that stores all of the things that we talked about. So at the top again, we're going to create another data class, and this time it's going to be tool confirmation. Then we are going to have tool name, which is of the type of string. Then we have parameters, which is of the type of dictionary. The key can be string, the value can be any. After that, we can have a description of the tool, and that will be a string. Now there's other things as well that's related to display information, right? Over here, we noticed that we have the tool name. We also have the diff displaying over here, right? What things needed to be added, what needs to be removed. So that's the diff. Then we also have command if that's present. Then we have all the affected paths. For example, this particular line. Then if the tool is dangerous or not, and if there's warning attached to it or not, all of that is also possible, and we'll add it as and when we need it. But as of now, let's just focus on tool name, which is equal to self.name. We already have access to all of these things over here. Then we have parameters, which is just equal to invocation.parameters. And then we have description, which is equal to, well, we can just say execute self.name. We want to execute this particular tool. So that's the description. Now, one last function I would like to create for now is to OpenAI schema. So right now we have the schema in Pydantic format, right? I just want to take that Pydantic format and convert it into a dictionary so that we can pass the tool parameters to the API. So if you go to LLM Client.py Here you notice that we're passing in model, messages, and stream. Tools will also be passed as a keyword argument. And we needed to convert it into JSON format, right? Into a dictionary so that it can be sent through the API. But right now we have everything in Pydantic format. So we're just going to create two OpenAI schema, which is going to return a dictionary where the key is a string, value can be any. And then you just have a schema which is equal to self.schema. After that, you're going to check if it's a Pydantic model. To check if it's a Pydantic model or not, we can just copy the same line, paste it down here, and let me just go back. Awesome. After that, we essentially want to convert to JSON, right? And Pydantic has support for that. So we can just call model JSON schema, and we're going to import that. We're going to pass in schema. The mode is going to be serialization, I think. So let's try that. And we also need to import from Pydantic. So we'll have from Pydantic dot JSON schema, we'll import model JSON schema. Great. So this function is called, it will convert it into a dictionary with the type of string comma any. And now we can store that in a variable. After that, we can just return a dictionary with all of our arguments. So the way OpenAI SDK wants it to be structured is something like this. We pass in the name, where we pass in name like that. Then we have a description where we pass in the description like that. Then we have parameters defined, which is of the type of object. Then we have properties, and properties is simply just JSON schema dot get and pass in the properties, an empty dictionary if it's not available. Then we have required, where we have JSON schema dot get required, and if it's not, we just pass in empty list. Parameters is of the type of object. Then we have a bunch of properties within it, which can be dictionary, and then you have required if the property is required and what properties are required. That's what this is. This is just the way OpenAI SDK expects us to pass in the tool schema, alright? And if you search for it, you'll be able to see it. So we have tools defined over here. That's what we're going to do in our LLM client. So over here, when we pass in tools list, we're going to convert each tool that we have into a schema. And then there's the name that we have. Then we have a description. Then we have parameters. Then we have the type of object. Then what properties do we have? Location is one of the properties in get current weather. Then you have type string, description. Then there's another unit, if it's a Celsius or a Fahrenheit. And what is required is just location. So unit can be ignored. That's essentially what the request is, and that's how we have structured it as well. Now, what if the schema is already a dictionary? Totally possible if it's an MCP. So we just check if is instance schema dictionary. In that case, we basically want the same thing. So we'll have result is equal to, we pass in the name. The name is self.name. Then we have a description. The description is self.description. Okay. And then we're going to check one thing, because it is a problem that might exist in MCPs. So we want to check if parameters is present in the schema dictionary. If it is, we'll just set result at parameters equal to schema at parameters. Otherwise, what we're going to do is result at parameters is equal to schema itself. Cool. So if the MCP server has defined all of the parameters as it is, if it's a dictionary that's present, where parameters argument is present, we'll use that. Otherwise, we'll have result at parameters equal to the schema as a whole. So that is our entire parameters list. And then we can just return the result. Now, if it's none of them, if it's not a Pydantic model, if it's not a dictionary, then we just raise a value error. Something went wrong. So we just type an invalid schema type for tool, and then we can pass in self.name. Let's make it an F string. And then we also need to give the type so that the user has a much better understanding of what they did wrong. So we can just have schema. because most likely the user was trying to pass in an MCP, but some formatting or something was just wrong. So we give them as much information as we can. Okay, so these are all of the things that we need for now. We are going to create a new folder called built-in. These are all the built-in tools. And obviously the first file that we are interested in, or the first tool we are interested in, is readfile.py. Now here, we can first define the read file parameters, right? I told you the parameters are going to be a Pydantic base model. So from Pydantic, we can import a base model. Then we are going to create our read file parameters. That is going to extend base model. Now, what are the parameters that we require for read file? The first one is pretty simple, path, which is of the type of string, and it should be a field. What is field? Field is just something that's coming from Pydantic. This time we are not taking it from data classes, we're using it from Pydantic because we are in a Pydantic based model. So data classes are used for everything other than parameters, alright, parameters for tool calling, because they do all the validation stuff. Now in the field, we can have ... because we want to ignore everything. Everything will be default value except the one which is description. What is the description of the path? What is this path parameter supposed to do? Well, this is just the path to the file to read. And then we can just say relative to working directory, right? Or we can just say that it can be an absolute path as well. So yeah, related to working directory or absolute. So if you're in this particular directory, which is AI-agent, you can just do cd ... and you'll go back to the desktop. Okay, that is relative to working directory. And let me write this as relative to working directory. Or absolute path can be /user/revan/desktop/AI-agent. So that is absolute. After that, we have offset, which is of the type of integer, which is equal to field. Everything here is not going to be default. The default value is going to be 1 in offset. Offset just refers to from where do I want to start reading the file? Well, I want to start from line number 1 if nothing is mentioned, right? So offset default value is 1. And the value should be greater than equal to 1. You cannot pass in -1. You cannot pass in 0. What is line number 0? That does not exist. Everything starts from line number 1. Cool. And then there is a description, which is line number to start reading from. And then we can say 1 based because, well, we are programmers, right? We have a tendency of using 0. And then we can also say defaults to 1. Great. After that, we have a last one, which is limit, an integer, or it can also be a null value. If you don't specify it, totally fine. And then we can have a field. The default value is none. And limit is basically that, hey, I'm trying to read a file. I start from line number 1. How many lines should I go till? If the limit is 100, it will start from line number 1 and it will go till 100. If you start from line number 10 and your limit is 50, you go from 10 to 60 because, well, your limit is 50, right? The maximum number of lines you can read. So you can have the greater than equal to 1 because if the limit is 0, that does not make sense. And the description is going to be maximum number of lines to read. If not specified, reads entire file. Awesome. Now we can go ahead and create a new class called readFileTool. And this readFileTool will extend the tool that we created in the base.py. So let's import it from tools.base import tool. And now we have to implement some of the things. The first one is the name. What is the name of the tool? It's called readFile. What is the description? And for description, I'm just going to copy paste it and it looks like this. So the description is we read the content of a text file. By the way, description is very important because it's given to an LLM to decide which tool to call. We say that we want to read the content of a text file. It returns the file content with line numbers. For large files, use offset because we are instructing the LLM, right? How to use this tool. If it decides to use this tool, how should it use it? So description has two tasks. First, should it use the tool? And second, if it uses the tool, how should it use it? Any instructions? So it says for large files, you use offset and limit to read specific portions. And it cannot read binary files like images, executables, probably PDFs as well, etc. So this is a very important and great line, because let's say you say that, hey, please read xyz.png. It will not read it because it will understand that if it's a PNG, it's an image. If it's an image, I cannot read the binary file. So that's great. After that, we'll have a kind, which is equal to toolkind.read, and we have to import toolkind. So let's import it from tools.base. And then we can also define the schema. Now we don't have to create a function for it. It was a property, right? So I can just set schema to read file parameters, right? Schema is a property which is read file parameters, this entire base model. And now we've satisfied the condition of schema being a base model. Amazing. Now we have to go ahead and define the execute function, the main function that needs to be in every tool. So we have async def execute, then we have a self, then we have invocation, which is of the type of tool invocation, and we have to import that from tools.base as well. And this will return a tool result. So we have to import from tools.base tool result. And now first let's just extract all the parameters, right? So we have parameters is equal to read file parameters. And how do we pass in all of the data? Well, it's all stored in invocation.parameters. And now we can just deconstruct it so that if path is specified, it will directly be given to this path field. If offset is specified, it will be given to this field. So we have the parameters with us. Now we also need a path, because obviously a path will be specified over here, right? So I want to check if that file exists. And first of all, I told that the path over here can be relative to working directory. So if it's relative to a working directory, I want to resolve the path. I want to know what is the true actual path. So that's something I'll have to look into. And if it's an absolute path, that's easy for me. So let me go ahead and create in utils something known as paths.py. This will contain all the utility function related to path. So let's create a function called resolve path. So here we're going to take in two things. The first one is a base, which is going to be a string or a path. And then we're going to take from pathlib import path. And then there's going to be an actual path, the path we want to resolve. And that will be a string or a path as well. It can be anything, right? And let me just frame this nicely. Awesome. So the base is the base directory, the current directory we are working in. And then the path to resolve is going to be whatever path the tool threw at us. And now we'll just create path is equal to path, and then we pass in the path. So if it is a string, it will just convert it into a path. And then we just check that, hey, if path is absolute, that means we don't have anything to worry about. We can just say path.resolve and send it across. It's going to be as simple as it is. Otherwise, we have a relative path, and in relative path, we'll have to resolve it. So we just call like that. So what we have done over here is path of base. So we have created a path of base similar to the path we created for this one. And then we are resolving it. So we are making the path absolute. And since we have created it absolute, we are doing /path to it so that we just append whatever there is. So for example, let's say the current working directory is user/revan/desktop. All right. And let's say it's AI agent, this current folder itself. And now we have the path added that, hey, we want to read this base.py file. So it will just say that the path is tools/base.py, correct? So what I've done is concatenated both of them and added users Revan Ranawat desktop AI agent tools.base.py. And we have the entire path with us now. What if the user wants to get out of this AI agent and make some changes in desktop? So they specify something like .. That's how you get out of the current folder. And then maybe you go into Claude code folder. So we just concatenate that. So this is how the path looks like. You go into AI agent, then you go back 2 steps behind, and then you go into Claude code. Or sorry, you go 1 step behind and then you go into Claude code. So that's how this entire thing works. Pretty simple. And now we can call this resolve path function. So we have path is equal to resolve path. Let's import that from utils.path. And then we pass in the current working directory, which is invocation.current working directory. And then we pass in the path that the model, the LLM gave to us, which is params.path. And I cannot spell it properly. So params.path like that. Great. So now that we have the path with us, I first want to check if this file even exists. So I'll just check if not path.exists, because it's totally possible that the LLM hallucinated. So we will just return an error, right? So for an error, I'm just going to create a method within tool result. So I can go back to base.py, and within tool result, similar to the other streaming events and all of that, we're going to create class method where you're going to have error result. So if you have an error result, you get a class, then you get the error string, what is the actual string, what is the output, and if you've not specified any, it's going to be an empty string. After that, we'll just return the class. We can say success is equal to false because, well, it was an error, right? If there's any output, you can attach it. So there we go. After that, you have error, which is equal to the error. So now I can go back to this read file and just say return tool result dot error result. So we tried to execute the command, but whatever the LLM gave us was kind of hallucination, or it did not understand the folder structure really well. That's why we are returning an error, and that will be given to the LLM. So you can write a descriptive message here saying file not found, and it was not found at that particular path. We are passing in this particular path, all right, the resolved path after all of our operations, so that the LLM knows that, hey, we tried this particular thing. Whatever you gave us, we're not just spitting out that. What we tried and what didn't work for us, that's what we're giving to the LLM. Now, another thing is, what if it's not a file? It's a directory. So I would like to tell that to the LLM as well. So I'll just return this tool result.error result, and I can say path is not a file, and then we pass in the path again. Great. Now, if the path exists and the path is a file, that means we want to read it, but we'll not directly read it. There's some other things I would like to do, because I don't want my LLM to get a lot of context, right? Because if it's read file, it can be a file that has thousands of lines. That means it has hundreds or thousands of tokens. I do not want to contaminate my LLM by giving it so much data. So I'll handle that. So the very first thing that I'm going to do is, if the file size exceeds by a big margin, then we are just going to return the error to the user that, hey, the file is too large, and that's what Cursor does. I think Cursor stops at about 20 megabytes or 10 megabytes. If your file is more than 10 megabytes, it will just return an error. So it just can't read it. And that's what we want to do as well. So we'll have file size is equal to path dot stat, whatever path we had, it's stat. And to get the file size, we can just do st size like that. Or like this. It's not a function. It's just a property, an integer. And then I can just check that, hey, if the file size is greater than the max cell size, and we can just define a constant at the top, max file size, which is equal to 1024 into 1024 into 10. So we have bytes into kilobytes into 10 because, well, we want it to be in bytes. And 10 megabytes is just these many bytes. So we just do self.max file size. If it is greater than, we just return the tool result.error message that, hey, this is too big. Sorry, I can't read it for you. So we can say file too large. Then we can say what is the file's actual size in megabytes. So as of now, this size is in bytes, this size is in bytes. And that's why we're going to have file size divided by 1024 into 1024. And I want this to be limited to one floating point digit. So we have 0.1f, and then you have megabyte written down. Cool. So the file is too large and the file is these many megabytes long. And maybe we can also add another message, which is what is the maximum length. So we can have maximum is, and then we have self.max file size. Let me put an F string here, divided by 1024 into 1024. And then we'll again have one F like that. Or actually, let's keep it limited to 0F because it's 10 megabytes. And then we'll just put MP. The reason we are not hard coding it down to 10 MB is because we are defining the max file size over here. So just in case in the future we decide we want 20 megabytes, we just change it over here and it will be reflected everywhere in our code. Now, if the file size is proper, then the other thing that I want to do is check if it's a binary file. If it's a binary file, I don't want to read it. I'll again raise an error. So if it is a binary file, and we will have to create a function to detect a binary file, and it will be used everywhere in almost many tools. So we can pass in the path over here, and now we'll have to create it in paths.py. So we have def is binary file, and we get a path over here, which is of the type of string or path itself, and it returns a Boolean value. Then we try to open it. So we'll have try and except. Since it's returning a Boolean value, we'll just return false if we run into errors related to OS error, or we run into IO error, input output error. Or if you want, you can just pass an exception here and just return false. But anyways, we'll just try to open the file. Then we'll open this particular path. Then we'll have RB, which stands for read binary, as F. And then we'll just do chunk is equal to f.read. Then we'll read, let's say 8192 bytes. And then we'll just try to identify it's a binary file or not. So we'll just check if this \x00 exists in this chunk. That means it's a binary file. We'll get to know if it's a binary file or not. So what we've done is essentially we are reading the first 8 kilobytes and we are checking for null bytes in that. If null bytes are present, that means we have a binary file. You can obviously make this more complicated and thorough, but yeah, my work is done here. I'm just going to import it from utils. So let me just return the same error message, tool result.error result. And then we can just say cannot read binary file. So I have cannot read binary file. Let me just write it down. And then we'll pass in the name of the file. So we have path.name, and then we pass in the size of this file just to give the LLM some context. So let's try to extract the size. It would just be easier. So we have f-string, and I'll actually just copy paste it because it's too annoying to write it. I've created one variable which is file size megabytes, which is equal to file size, and we divide it by 1024 into 1024, similar to what we did over here. Just the file size in MB, and then we have size string, which goes up till 2 floating points, and we say we use that file size in megabytes if it is greater than or equal to 1. Otherwise, we just have file size in bytes. Cool. That means if it's greater than 1 megabyte, it will write down megabytes. Otherwise, it will be writing down in bytes. And now I can just say cannot read file with this size string. And then I can also say this tool only reads text files. Awesome. That's pretty much it. Now, if it's not a binary file, it's a text file, then we have all of the other things to do, like reading the actual file finally. So I'll just put in a try and except because reading the file can be a bit difficult. So we have content is equal to path dot read text. And now I'll pass in the encoding, which is UTF-8. So I'll have encoding is equal to UTF-8. That covers all the English characters, so we don't worry about that. Then we have except Unicode decode error. Just in case there was this exception, we try to do path.read text and try the encoding of Latin 1. So let's say this encoding fails, we try Latin 1. That's what we're trying to do. Nothing much. And now, since we have all of the content, I'm just trying to split them in lines so that I can filter by these other parameters like offset and limit, right? So I'll just convert it into an array where each line has a new string in this array. So content.split lines will do that. And then we can also get an understanding of how many lines there are. So length of lines. Now, if the total number of lines is equal to 0, in that case, we are dealing with an empty file. We'll just say tool result.success result, and we'll have to create that thing because we've created everything related to error. But if it's a success, we also want that. So we'll have a class method related to success result. So let's go ahead and have success result. The success is true here. The output is a string. By default, it's an empty string, but let's just say you have to specify it. And this time we can say the error is kind of null. The output is output and the success is true. That's great. That looks good to me. I'll just pass in success result here, and let me just copy that correctly. And now I need to pass in the output. The output here is going to be file is empty. That's it. Now the reason we are doing success result is because, well, if the file is empty and we just return an empty string from here, the LLM might get confused that, hey, this tool only returned an empty string. What does that mean? Did I do something wrong? And the LLM will spend tokens over there. We don't want it to spend tokens over there. That's why we are telling over here that, hey, file is empty. Don't worry about it. But I would also like to send some metadata like we have over here. The metadata is the number of lines, but we are not accepting that from success result. So what I'll do is just have keyword arguments here, which can be of the type of any. And now I can pass in all of the keyword arguments that are required. I'm not explicitly saying that metadata should be passed in. I'm just saying you can pass in anything else and I'll attach it to this tool result class if it accepts that. And now I can just pass in the metadata, which is over here. Metadata is equal to, and then we pass in the lines as 0. There are 0 lines in this entire file. Now let's try to apply the offset. So first we'll have the start index. Where are we starting from? Well, we want to start from 0 or offset -1. Remember, this is an index, not a position. That's why we have 0 over here. And we're just trying to take whatever value is present. Maybe the user or the LLM specifies that the offset we need to start from is going to be 3. So 3 minus 1 is 2. That is the index. Because remember, we have lines as an array, right? Since lines is an array, it is 0 indexed. But our entire system works on 1 based system. That's why what we're trying to do is offset -1. If the user or if the LLM says that I want to read line number 3, or we want to start from line number 3, we will do 3 minus 1, 2. That will be the index because the actual position is still 3. But the array starts from 0. So when we try to do lines at start index, we have a good indexing going on. We are actually referring to the third position, but in the array is the second index. And obviously offset is not present. We have to do params.offset. So that is the start index. Now if there's any limit applied, we have to get the end index as well. So if limit is not none, and we have to get the limit, which is just params.limit. So if params.limit is not none, we'll have end index is equal to, and then we want the minimum value, right? So the minimum value is just going to be start index plus the limit, which is params.limit, comma, total number of lines. So we are trying to take the minimum value of start index, which is, let's say 0, plus limit is 100, and the total number of lines are 1000. So it will just take 100 as the end index. But what if the limit is told to be 1000 and the total number of lines are just 100? So we just take 100 because our end index should always be less than total lines, right? Otherwise, the params.limit is null, and in that case, the end index is definitely going to be total lines because that's the end part, right? And now I want to extract all of the lines, which will be, well, something like this. Selected lines is equal to, and then we go from lines from start index to end index. Awesome. And that's why we did not do -1 over here, right? Because index is also going to have -1, right? So both of them should have -1. But the thing is, if you do -1 and then you do end index, it will not count end index -1. So it will not count the last character that we have, and that's not acceptable to us. That's why we are leaving it at this so that it goes until the very last character. And now I want to add line numbers to this because I told that the read file is going to give out line numbers, and that's helpful to the LLM as well. So that, after reading the file, if it wants to write or edit, it knows what line numbers to change. So we'll have formatted lines is equal to an empty list, and then we'll have for I comma line in enumerate. We go over the selected lines array and we start from the start index +1. And then we just do formatted lines dot append. Let me call append. And now I need to pass in the line number. So we'll have I up until 6 characters. And then I'll put in this particular OR symbol, and then I have line. So it gives out the index and then it gives out the line. It only spits out 6 characters because obviously if you go more than 6 characters, I've probably already stopped it. It's not allowed. Our LLM cannot handle that much data. And now the output is just going to be \n. Let me do \n dot join, and then we format all of the lines. So each line goes on a new line and it's in a string format now. Now we also want to take a look at whether we should truncate the output or not. So what we can do is count the tokens, and we can use the count token function that we've created already from utils.txt import count tokens. And now I can check that if that token count is greater than the max number of output tokens. So I'll create it max output tokens, which is equal to, and then maybe the max number of output tokens is 25,000 from a read file. You can obviously update it based on your user's preferences or on your preferences if you're using it for yourself. And then we can just set output is equal to, and now I have to truncate the text. How will that truncation work? Well, there are multiple types of truncation. One is a truncation that happens at the end of the string. Then there's a truncation that happens in the middle of the string, or the one that happens at the start of the string. So we'll have to define that. But first we'll have to create the function, and truncation is one of those features which will be used quite a bit. So I'm going to create within text.py a function. Let's call this truncate text. Let me just name this properly. We get a text which is of the type of string. Then we have max tokens, which is an integer. And that's it. Oh, we might also get a suffix, by the way. So suffix is a string which is equal to, let's just say \n ... truncated. So this suffix is essentially like I truncated the text. After that, I'm just telling the model that, hey, I truncated the text down. So yeah, that's what we're doing. Now again, what we're going to do here is current tokens is equal to count tokens, and we'll pass in the text. Let's also pass in the model. And actually we don't have the model, but in some cases we might have a model. So yeah, let's take that in, and let me just format everything. Cool. Let's pass in the model here. These are the current tokens. If the current tokens is less than or equal to the max number of tokens, in that case I'll just return the text. Otherwise, I have to count the suffix tokens. What is the count of suffix tokens? Which is just suffix, and then we'll pass in the model name again, and then we have to target how many tokens we want to add over here. So the target tokens is just target tokens equal to max tokens minus the suffix tokens. So how many max number of tokens can we have in this minus what are the suffix tokens? And now based on this target tokens, we are going to, well, truncate, right? And actually, I don't want to spend much time on this truncate text logic because it's quite simple. So what I'm going to do is just paste out a bunch of logic. If you want, you can copy it from the repository mentioned below. Otherwise, I'll go through this with you line by line. So the very first thing that we have is if target tokens is less than equal to 0, we're just returning the suffix that, hey, the target token is less than, whatever you're targeting for is already less than 0. You are within the reach. So you don't have to truncate. We return the suffix as it is. Then we have another property, which is preserve lines. So if preserve lines is true, that means we want to truncate by line. If preserve lines is false, in that case, we want to truncate by characters. So we will truncate by lines. We'll pass in the text, target token, suffix, and the model. And let me remove this unnecessary docstring. So lines is equal to text.split by a new line. So we're just getting the lines again. Then we have result lines, current tokens is equal to 0. Then for every line, we're just counting the number of tokens in it. And if current tokens that we have over here, plus the line tokens, whatever tokens exist in one line is greater than the target tokens, we just break out of this loop. Otherwise, we append to this result lines and then have current tokens plus equal line tokens. So as long as we have not hit the target tokens limit or we have not exceeded it, we'll keep adding to the current tokens. As soon as we hit the limit, we break out. And then we check if not result lines, if result lines is an empty list. If it is, that means it did not work properly. Maybe everything was mentioned in one line, so we cannot truncate much. And that's why we'll fall back to the character truncation. And then we call this particular function, which is truncate by characters. And to truncate by characters, we use a simple binary search. We go from low to high, and we're just checking in the middle how many characters we have. So to truncate by characters, the one approach you could have taken is linear search. So you go through every character and truncate them. Or what you could have done is go until the target token's number and attach suffix to it. So this is the log of n approach, because linear search is O of n and this is O of log n. We are just looking in one side continuously and shrinking the search space by half every single time. So yeah, that's it. Now we can just copy this truncate text. Also, by the way, if preserve lines is false, we just call truncate by characters. Now we can call truncate text over here. So let's import it from utils.text. And now I need to specify the output. Then I need to specify the max number of output tokens. And we have already created that variable. After that, we are going to have a suffix, and our suffix is going to look a bit different. We are going to have \n ... and then we have truncated, and then we also say that the total lines are the total number of lines in this particular file. And let's also create a variable to track if truncation was done or not. So we have truncated is equal to false, and then we have truncated equal to true here. Now we might also want to add metadata about what was the file's content that was actually read. So we have a variable called metadata lines, which is equal to an empty list. And then we just say that, hey, if the start index was greater than 0 or the end index was less than the total number of lines, in that case, we'll have metadata lines dot append telling that, hey, we are showing lines start index +1 because index is 0 based. I want actual line number to display to the user. And then we have end index because that is 1 index based. This is not 0 index based of the total number of lines. So this line will just tell the LLM and it will actually be displayed out to us saying that, hey, we are showing lines, let's say 30 to 70 of 170 lines. This is what this metadata lines is doing. And it obviously only does it if the start index is greater than 0. If we are reading the entire file, then there's a point showing all of these things. But if you exceed, we've done something wrong and we're not going to display anything. So that's about metadata. Now, if metadata lines is available, then we're going to add a header saying this dot join, and then we have metadata lines plus 2 backslashes. This is just related to show off, and the output is going to be header plus the output. By show off, by the way, I mean this will be displayed to the user, so we're just having good things just displaying over here. And output is header plus output because we want to display this header at the top. We are showing lines 30 to 70, and then we have the truncated output. So if we have 1,000 lines, it will just show, let's say 60 lines or 70 lines or whatever. So yeah, that's done. And by the way, we are not preserving lines over here, and I misspelled over here, but we are not preserving lines. So we are actually going to truncate by characters. So that's cool. And now we can return the tool output or tool result dot success result. Then we pass in the output, which is, well, the output that we just captured over here. Then we are going to add in keyword arguments, which is truncated, which is equal to truncated, because in success result and specifically in tool result, we're going to capture one thing, which is a variable called truncated, which is going to be a Boolean value. And by default, it is false because we want to avoid truncation. But it's just that if the files are long, you have to truncate it. Otherwise, there'll be some problems. So yeah, now we have access to truncated as well. And then the final thing that we're going to have is all of the metadata. Now the metadata is not going to be very simply like just the total number of lines. No. First, we're going to pass in the path. At what path are we doing this? And by the way, all of this metadata is really useful when we want to display it to the user. So what path did we read the file from? That is an indication given to user. Or even when we try to write a file, as you can see, it tells us it created this particular path, right? How does it know that? And how does it know how many lines it created? All of that is coming from metadata, from tool result. So it's especially useful to help us in the TUI. So we'll have total lines displayed. Then we are going to have shown start. Where did we start from? And then we have start index plus 1. Then we have shown end, which is the end index. And that is just 1 based. So just end index, not plus 1. So yeah, that is everything related to reading a file. Let's try to do a try and except, or actually this just feels good enough. I think we've tried to handle all of the errors. But anyways, let's say just in case something wrong goes, I would like to have a try and except done there as well. So I'll just tab everything, and then we have a try block, and then we have an except with exception as E, and then we just return tool result dot error result, and then I pass in fail to read file, and I'll just pass in the entire error stack as it is. No need to format anything or whatever. So that is our read file tool. We have actually implemented everything. Now I'd like to go ahead and register this tool. Now registering this tool is as easy as, maintaining a dictionary where the key is the tool's name and the value is this particular tool, which is converted into OpenAI spec format, right? Because we had created OpenAI schema here. We can just call this, so we get the entire dictionary format, and then we can just pass it to the LLM client. But that is kind of a lousy way to do it. If our application gets bigger, the dictionary will need its own management. And that's why we're going to create a class called tool registry. That tool registry class is going to deal with registration of all of the tools, including MCP. And in the future, if you want to enable or disable each MCP, you can do that. You can add that feature yourself. We're not going to add it in this tutorial, but it's fairly straightforward. You'll be able to do it if you understand this tutorial. So what I like to do is create a new file here called registry.py. That deals with the registry of all of the tools that we have. Essentially, it's trying to manage the entire dictionary of tools. But you can register tools, you can register MCP tools, you can unregister any tools, and obviously you can have all of the tools listed out in OpenAI spec format or the schema format. So yeah, all of that is going to be done in this part. So let's quickly create it. Once we have this registry created, we can go ahead in our agent, initialize this registry, and then from the agent we can pass it to the LLM client, and then the LLM client will give us the tool call to do, and then we can actually execute the tool call. So that's going to be a lot of fun. But step one is just creating a tool registry class and maintaining that tools dictionary. So I'll go ahead and create the class called tool registry, and then within the init function I'm going to go ahead and create, well, the tools dictionary that I was talking about. So we'll have self underscore tools. I want it to be protected or private, not to be used outside. And then we have a dictionary with the key as a string and the value as a tool itself. And from tools.base, we will import tool, and we will have an empty dictionary as of now. After that, the next thing we require is a register function, because we want to register a tool. So we'll have register, and then we'll have a self tool, which will also be of the type of tool, and then we're going to return nothing from here. After that, well, how do we register a tool? I told you it's going to be a simple dictionary. The key is going to be the tool's name and the value is going to be the tool. So first I'll just check that, hey, if tool.name is in the self.tools dictionary, in that case, well, the tool already exists. And that's why what I'm going to do is put out a warning. Now, to print out a warning, I'm not going to use the TUI or whatever. Instead, I'm just going to create a logger. So I'm going to have a logger which is equal to logging.getLogger. If you're unfamiliar, logging allows us to pass in multiple things. It can be a warning message, it can be a normal message, it can be an error message. It displays all of that, and we need exactly that. So what I'm going to do is import logging at the top. It comes in with Python. That's the only difference between print and logging. Logging just gives us nice methods to print out warning or error message, but print only gives us print statement to print out stuff. And all of them get printed out on standard output. So yeah, that's good for us. We'll print out logger.warning. And if that tool already exists, we are saying, well, overwriting existing tool, and then we pass in the tool's name. Great. After that, we have self.tools at tool.name, which is equal to tool. This is how we register the tool. And now I can just do logger.debug saying, well, I registered the tool. So that's done. And now we have tool.name. And this will only show up when, we have the debug mode on. Otherwise, it won't show up. That's how we are going to configure the logger as well. Now, if you want, you can totally remove the logger. It's no need. I just wanted it just in case I run into any error. And we can add that in all of the places. I might forget to add somewhere else, but you keep it in mind. Please add it as much as you can to help us debug just in case we run into errors. So the next thing that we want is an unregister function, right? Unregister will help us unregister a tool. So we just need the name of the tool, and we are going to return a Boolean value. Did we unregister it or not? So if the name is in the self.tools, in that case, we are going to return true. And also what I'm going to do is delete from self.tools. So I'll do delete self._tools. And from there, I'm going to delete this particular property or the key that we added, right? We had a key and a value pair of that tool. So I'm deleting it from the dictionary. Now, if the name wasn't in self.tools, what we can do is return false. Obviously, when we add MCP support, we'll have to check if that tool exists in MCP as well. And if it doesn't exist in MCP, then we can return false. But as of now, this is good enough. Now, I'll go ahead and create the function called getSchemas. So we'll have def get schemas. And what this function does is it just prints out all of the schemas in OpenAI format. So we'll have self, and well, as of now, this is it, but we can have more. And then we're just going to return a list of dictionary, right? Because it's going to be in OpenAI format and the value can be anything. And then we will do return. And now for every tool in this self.get tools, which is what we're going to create next, self.get tools essentially refers to the function that will get all of the registered tools. So we'll go ahead and create that function. We have def get tools, then we have self, and then we are going to have a list of tools here, which is going to be an empty list initially, but then we'll go over all of the tools within this. So we have self.tools.values, and then we have, well, tools.append tool. Great. And then we just go ahead and return the tools. Obviously, this function will get more complicated once we have MCP. Not complicated as such, but like we'll have to just get all of the tools from MCP tools dictionary as well. So we'll be maintaining another dictionary to maintain MCP related tools. So yeah, nothing too complex. Now we can call get tools function, which we did over here. And that function is going to return a list of tools. Okay. And now for every tool that we get over here, we are just going to convert it to OpenAI schema. So we have tool.to OpenAI schema, and that's it. Now another thing that we can create is a wrapper around invoking or executing a function. So as you know, to execute a function, we have created a function called tool.execute. If we go to base.py, here it was execute. And in read file, we override this method and create a new execute function which is specific to read file. In write file, we'll do the same, but with write file specific logic. In grep, glop, everything is going to have the same thing. But that's just executing. If we really want to invoke a tool, we'll also have to call validate parameters. So what are we going to do? We're going to create a wrapper around both of these methods. So what we'll do is have async def invoke. We'll get a self, then we'll get a name of the type of string. Then we might also get call ID, but what we are more interested in is parameters, which is a dictionary string comma any. And we might also get the current working directory, which is path or null. And now let's import path. So we can just import that from pathlib. Awesome. Now in invoke, we are just getting the name, right? So first we need to get the actual tool that we are talking about. And for this also, we can create a helper function called get. Now again, this get is going to be very, very simple. It's nothing extraordinary. It's a 2-line, 3-line function, but it can return a tool or a null. And we are given the name of the tool. So it can be a string. And now we are saying that, hey, if the name is in self.tools, in that case, we'll return self.tools at name. Cool. And then when we have MCP, we'll have the MCP related stuff over here as well. Now, as of now, if that doesn't exist, we'll just return null. That, hey, we do not find the tool with this name. And now what I can do is just call get over here. So we have self.get, and then I pass in the name. And that gives me the tool itself. So we have tool is equal to self.get. And if tool is none, in that case, we have an error because the user or the LLM has invoked a tool that does not really exist. So we'll just return tool result. And we'll have to import that from tools.base. And then we have error result. And now I can pass in the data, which is unknown tool. And then we pass in the name. Now, if you want as the metadata, you can pass the tool name again so that it can be shown to the user. And that's exactly what I'm going to do. I'll pass in metadata is equal to tool name. And then I have the name passed in. Now, error result does not explicitly take metadata. So similar to success result, we are going to have keyword arguments over here. And then I say if any keyword arguments are present, we'll just put it down at the bottom. Now coming back to the registry, let's say the tool is not null. In that case, what do I want to do? I want to validate the parameters. So I'll just call tool.validate parameters, and then I call parameters dictionary. So what is the parameters dictionary? Well, we just get it from here. The LLM is going to give all of the parameters to us because when we tell the LLM that, hey, these are the tool calls, it will give us all of the parameters, right? So yeah, that's that. And we know validate parameters gives us a list of strings, and those are just validation errors if they exist. And if it's empty, then we have no validation errors. So I can just do if validation errors, we have failed. That means the list is not empty. So we'll have return tool result and not tool registry, tool result dot, and then we have error result. Cool. Now I'll pass in the error message, which is invalid parameters. Then let's format this nicely. So I'm going to join all of the validation errors that we get. So we have a colon that's joining all of the validation errors. And there we go. We'll also pass in the metadata over here. The metadata, again, for the user to see it, is just the tool name. So yeah, that's the tool name. And then we also pass in all of the validation errors that we had until this point. So there we go. Awesome. The user, if you want, you can remove this, by the way, because you might not want to show your user all of the validation errors. But since my target audience is going to be developers, I would like to display that, right? Now I would like to call tool.execute. So I can just do await tool.execute because it's an asynchronous function, but I need to pass an invocation. So I have to create an invocation context. So we have invocation is equal to tool invocation, and then I have to import it from tools.base. And now I can pass in the parameters, which is just parameters, and then the current working directory, which is also being given either by the LLM or we just pass in our own current working directory. We'll see what we have to do. Obviously, when the configurator is present, when we add configuration, which is probably not so late because now we just have to register the tools. We pass that to OpenAI, then we execute the tool, and yeah, then we'll start working on the configuration system. After that, we'll come back to update all of the configuration systems. So because most of the places we've just hard coded, right? So we'll update the configuration system and then we'll add rest of the tools that are remaining because they do depend on a configuration system. So yeah, that's how we're going to go about it. Now we can just pass in the invocation context. And let's put it in try except because there might be a possibility of error because, well, if we go to built-in tools, read file, here, if there's any error, we are handling it. But it might happen that in some other tool, we are not handling it. So I'll just catch a broad exception. I just don't want my app to fail. So I'll just pass in a logger.exception here saying that, hey, the tool with this name raised unexpected error. If you want, you can pass E as well, but I don't think it will give any valuable information. And then we'll just return tool result dot error result. Then obviously we'll pass in the internal error because, well, for the LLM, it's going to be quite a useful information, whatever this E contains. And then I can pass in the metadata. Again, it's just going to be the tool name. We want to display the tool name, right? So we have to pass that information outside. Awesome. So yeah, this looks good enough for now. Let's create a function. It's going to be a global function, which will create a new tool registry here. And then what it will do is it will register all the built-in tools. So whatever tools you create over here, we'll just assemble them, register them, and create a registry. So it's like a singleton instance. We're creating one instance of this registry. We're registering everything and we're returning the registry out from here. So we'll have create default registry, and then we're just going to return the tool registry from here. After that, we are going to create an instance of registry, which is tool registry like that. And we're going to return this registry. But before returning it, what we're going to do is register all of the built-in tools. So first, I need to get access to all of the built-in tools. And I'm just going to maintain the constant here called built-in tools, which is equal to a list. And then we just pass in a read tool, right? Read file tool, whatever it was called. So let's just pass it in. Let's import it from tools.builtin.read file. Now, from every file in tools.builtin, you'll have to go ahead and import this particular line. So when we have write file, you'll have to do something like this: write underscore file, import write file tool. And we have about 10 tools, 15 tools, I don't know. So we'll have to write down 15 lines. Instead of wasting those lines, what we can do is in built-in, we can create what's known as an init.py. You might have seen this in multiple packages or multiple projects, but what it essentially does is it's creating built-in folder as a module. Instead of saying built-in.read file, we'll import read file tool, you can now just say from tools.builtin, we are going to import read file tool. So that allows us to do from tools.builtin import write file. From tools.builtin, we import shell, and we can also define a thing here called all. So these are all the things that are exported from this module. And the first thing that we're going to have is read file tool, because that's the only thing created so far. And here we can have all of the import done. So from unified agent.tools, so from tools.builtin, we are going to import read file tool. And actually I forgot to do from tools.builtin.read file, we'll import read file tool. And now I can also create a new function over here called get all built-in tools. So I have get all built-in tools. Great. And this will return a list of, well, it can be a list of any, but let's just say list of one particular type. And that type is going to be tool. So maybe you can also add tool over here, and we can import that from tools.base. But type also seems fine. And now we can just return a list called read file tool. That's it. And now whenever we add a new tool, we'll have to register it over here. And we'll call this function within registry. So now, the point of doing all of this was that instead of writing tools.builtin.read file, you can do tools.builtin. We'll import read file tool. It is exported correctly. And we can also import get all built-in tools. So instead of having everything on a new line, you have everything on the same line. That's just clean. And now I can just say every tool class in the get all built-in tools, we are going to call and register this. So we have registry.register, and now I have to register this tool. But now I have access to the tool class. Remember that. If we go to get all built-in tools, this is a class called read file tool. Okay. So I have access to the class. Now I can just go ahead and instantiate this class like read file tool and pass in all of the parameters that I want, right? As of now, this does not require any parameters, but in the future, we might want to pass in the configuration system. So I'll just pass in tool class like this now. And yeah, that's pretty much it. We have registered the tool. Now I can just use this create default registry wherever I want, and that will register all of the tools and it will return the registry to me so that I can get access to this method of get schemas. Once I have access to get schemas, I can call to OpenAI schema and convert it to JSON so that I can pass it everywhere. Awesome. So now I'll go back to my agent.py file. We've not touched it in a while, but here in the init function, along with these two things, we are going to have self.tool registry. Of course, just like client and context manager, even the tool registry is going to be within session. Everything is going to be encapsulated within a session. Session is that strong, yeah. Because whatever tools are registered for one session might not be applicable to another one, especially when we add tool discovery. When we add tool discovery, it is totally possible that the tools are registered for one project because they are useful for one project, but they're not applicable to another project. So we need tool registry specific to a session. And now that we have tool registry with us, we can scroll down, go to our agentic loop where we have called self.client.chat completion. Before that, we can get access to the entire tool schemas, right? So we have tool schemas is equal to self.toolregistry.get schemas. And then we have a list of dictionary. We'll just copy this tool schemas and send it across. we can have before this boolean actually we'll do tools is equal to tool schemas if tool schemas is present, otherwise we'll just pass in null that hey, we did not find anything, because we don't want to pass in an empty list, right? And chat completion requires a stream value which we've already passed in, which is true, and by default also it is true, so even if we don't pass it in, that's totally fine. Now let's go to chat completion and have a new thing here. So yeah, we can go ahead and have tools with list and list like this. Then we have a dict, and then we have string comma any, or the value can be null, and by default it is null. Okay. Now I want to pass this tools list into this keyword argument if it is not null. So I'll just check if tools, then we'll have keyword arguments at tool, and I think we should pass in tools, which is equal to, well, we can pass in tools just like that, but if you remember, the schema looks something like this. Let me go to base.py, and here you'll notice that the OpenAI schema is name, description, and parameters, exactly what we want. But we're not encapsulating it within the function attribute. So the actual thing should be something like this, where you have this dictionary and this is encapsulated within another dictionary, which is type function. And it did not feel right to do it over here because, well, it's just a lot of boilerplate code to add for every single tool. So instead, what we can do is create a function called build tool. So we have def build tools, then we have self tools, which is just a list of dictionaries, string comma any. It can't be null anymore because you've already checked that. And we return a list because, well, we have tools list, right? We'll go over every tool in this tools list, and then we are going to create an object for everyone. And then we'll have a type of function, and then we'll actually pass in the function where the value is going to be, well, everything we have done so far. The tool's name, then we have the description, which is going to be tool.getDescription, and if it doesn't have that, it's going to be empty. And then finally we are going to have parameters, which is tool.getParameters. And if that does not exist, then we are going to default to an object where the key is type object, and then the properties is just an empty dictionary. So yeah, that's all. This is how build tools is going to look like, and that's the function we are going to call. We are just going through every tool that we have, and we are trying to extract relevant features from it and encapsulate it within the type function, because earlier we did not have type function, right? We just had these things. And now we can call self.build tools. Then we need to pass in the tools list, which we'll pass like that. Awesome. Another thing I would like to do is specify the tool choice here. So the tool choice is equal to auto. If you want, you can force it to use a particular tool, but yeah, I'll stick to auto. And yeah, this looks good enough. Now, what I like to do is go to the stream response and the non-stream response, but in our case, it's majorly just stream response, and check if it gives us any tool calls, because every delta here can give us tool calls. So I'll just go ahead and print out delta.tool calls and see if it spits out anything. And now I can one response. So I'll have Python main.py, and let's say we tell it to read agent.py file. Well, it doesn't know agent.py. We have not given it the ability to go through the folders as of now. So maybe we can just tell it to read main.py, because, you know, agent.py is within a folder and our agent obviously doesn't know it's within a folder. It doesn't have the ability to even call list directory, right? So let me just say read main.py file for me. So let me just hit enter, and it spits out an error. Well, it does give out null. I don't know what that null is for. but then we also get choice delta tool call. Okay, maybe it's the streaming response that's coming in. So the very first thing it gives us is a delta tool call where the index is 0. It gives us the call ID. Then we get a function of choice delta tool call function. Arguments are present where the path is given, which is just main.py. And then we have the name of the tool. Yeah, so it is spitting it out, but then we run into an error, which I'm not sure what that is about. So yeah, once it gives us the tool call, we are trying to invoke the tool call, right? But when we invoke the tool call, we run into an error related to counting the tokens and specifically the length of the tokenizer. So let's go to utils.text where we had called return length of tokenizer. And this specifically occurs because the text is null. Since the text that's coming in over here is null, tokenizer cannot accept null value, we're getting an error. But why is it null? Well, if we go to find all references of count tokens, you'll realize that we called it in manager, right? And whenever we try to call it in manager, well, when we add user message or add assistant message, so we did content or an empty string. So same thing over here, content or an empty string here is required as well. And now when we try to run it again, let's see if we run into that same error. And we don't. So that was the issue. We just had to put in or an empty string because many times the content will not be present. For example, when the tool call is made, maybe the LLM decides that, hey, I don't have any text for you to show. And actually we don't see any text at all because all it does is a tool call. It doesn't even talk to us, our agent. So yeah, let's go ahead and parse this response that's given to us, the delta tool call, so that we can actually go ahead and invoke the tool. So here we can first go to LLM client and first check that, hey, if delta.toolCalls is present, that means tool calls is not an empty list. We'll go over all of the tool calls that's given to us. So we'll have tool call delta in delta.toolCalls. And then we need to get the index of tool call delta, right? So here the index is 0, but many times it can stack up a bunch of tool calls for us. And then it will provide the index to us. That's what we're going to use. So we have index is equal to tool call delta dot index. And then I can check if index is not in tool calls, and tool calls is a dictionary that we are going to have. So we have tool calls like this, which is just a dictionary with integer as the key, which is the index. And the value is again a dictionary of string comma any. Now, why is it a dictionary of string comma any? Because whatever value that we get over here is going to be a key and a value pair, right? Path main.py. Well, the arguments are key value pairs. So that's what we're going to have. Now, if index is not in tool calls, then what are we going to do? Well, we'll just do tool calls at index is equal to, and then we create a new dictionary where we're going to pass in the ID, which is tool call delta dot ID. If you notice, we have the ID given to us by the LLM, or it can just be an empty string. Otherwise, it will crash the application. Then we have the name of the tool call. As of now, we don't have it, but we are going to update it. And then we have arguments. As of now, we don't have it, but we are going to update it. Now, we have created tool calls at index, but now the next step is to extract everything. So first I'll check that, hey, if this index has the function, right? If it has the function argument, then I want to get into that. If tool call delta dot function is present, then I want to check if tool call delta dot function dot name is present within it. If that is true, that means function dot name is given to us, that is read file. If it's given to us, then I want to update the tool call. So I'll have tool calls at index at name. So I access that particular object within which I have this name key, and I'm just updating it to be tool call delta dot function dot name. And as soon as we get the name of the function, we can just send a stream event saying that hey, the tool call has started. Now we are starting to do a tool call, and whenever tool call start event comes to the UI, what's going to happen? Well, we'll show a dialog box saying that hey, we are executing this thing that you see, this tool call, and then when it gets over, we'll again show another tool call. So just to demonstrate to you, we have write file over here, right? So this is what tool call start will do. As you can see, this is gray. Whenever this is gray, it means the tool call has started, we are working on it. And then we have write file with tick mark, and then it gives us the confirmation dialog or tool confirmation, whatever we worked on. This is what I'm talking about. Tool call start should show this. So now let me just go ahead and yield this event. So I have yield stream event, and then I'll pass in the type. The type is going to be event type or stream event type dot. And now I have to go ahead and create a new event type called tool call start. So let's go. And then we have tool call start over here. And then we have it within a string. And since we are already over here, let's just create other tool calls as well, like tool call delta, which just gives us all of the tool call pieces. So example, we have one tool call, we just send it across, then we get another tool call, we'll just send it across like that. So tool call start is as soon as we just get the name of the event or of the tool call, we send it across. But tool call delta is when we get one complete tool call, that means arguments as well, and we start executing it. That's tool call delta. And then tool call complete is when everything starts finishing. You know, the tool call is now complete. So that's another one. Tool call complete, like that. So this is great. We have all the 6 events that we need. Now I can go back to my LLM client and have dot tool call start. And now here I need to pass in what's known as a tool call delta. But obviously we've not created it within stream event. So I'll have to create a new thing called tool call delta within a stream event as well. So we have here, let's just create it here at the top, tool call delta, which is of the type of tool call delta again, or it can be null because many times tool calls are not there. Also, let me just take this as L. And since we are here, let's just create another event as well, which is tool call, like that. So this is a complete tool call, and there we go. Now let's create both of them. We're going to create first tool call delta. So we have class tool call delta. Then we have the call ID associated with it, which is a string. We already saw that. Then we have a name, which can be null. Many times the LLM might just not send it. And then you have arguments delta. That is just all of the arguments that are present. Cool. And by default, it is going to be an empty string. Then we are going to have another data class. Let's call this complete tool call. This is not half a tool call or anything. Over here, this is half a tool call, right? It doesn't have arguments passed in. But here, we have a complete tool call from the model. So again, we're going to have similar stuff here as well. The call ID, the name, and the argument. But this time, the only difference is in the type. This is called tool call and this is called tool call delta. Great. Now I can go back to LLM client and say tool call delta is equal to, and I'll pass in the tool call delta over here. And from client.response, we'll import tool call delta. And now we need to pass in the call ID. The call ID, well, what is it? Well, if we go to the tool calls at a particular index and the ID, because we already saw tool call at that particular index, which is this one, and then its ID, that's the call ID. Then we have the name, which is equal to, well, whatever we extracted over here. So you can either do tool calls at index at name, or you can just copy paste this particular line. Same thing. So yeah, this is the stream event yielding. Now, this is a partial tool call. We still have to give out the entire tool call, right? So we can have if the tool call delta dot function is present. That means this particular thing is present. In that case, I want to go one step further and check if tool call delta.function.name is present or not. And if that is the case, then I'll just do tool calls at index at name. Oh, sorry, we have already done this function name, right? So we don't have to worry about that. We are interested in extracting the arguments as of now. So let me just do it here. If tool call delta.function.arguments is present, in that case, we'll have tool calls at index at arguments, and then we'll plus equal to whatever arguments already existed over here, which is just an empty string, but whatever existed, we are just going to append to it. So we have tool call delta.function.arguments, and let's see if I spell that right. Nope. Let me just do arguments. And now since we have the entire arguments, we can go ahead and yield the stream event as well, which is tool call delta. There's a change. There's an update. That's why tool call delta. And then we pass in the ID, then we pass in the name, and then we also pass in the argument, which is tool calls at index at arguments. Nothing too fancy. So let's just copy this, and we have arguments delta is equal to this. Now outside of this for loop, this particular tool calls thing, once we have completed all of the tool calls here, what I'm going to do is go over all of the tool calls that were present here and emit a complete tool call event type, because, well, we have done the complete tool call. So we have for index comma tool call in tool calls dot items, and then we yield the stream event type again. And I don't want to write that out, so I'm just going to copy this and paste it over here. Okay. So the type is event type dot message complete. The tool call is not going to be a delta anymore. It's just going to be a complete tool call because, well, we have completed. And now we pass in a tool call. From client.response, we import tool call. And now we have call ID equal to tool call at ID, because that's how we've been storing it, right? At arguments, at name, and at ID. Then we are going to have name, which is equal to TC at name. And finally, we have arguments. And now for arguments, it's going to be called arguments, not arguments delta, because we're not having a change anymore. It's the complete tool call. And now we need to parse the tool call arguments. So over here, we're just getting the arguments in a string format, right? Now I don't want to be in a string anymore. I want to convert it into actual key value pair. And that's why we can use JSON.loads and pass in the argument string. But the problem is, what if it's not a valid string? Maybe this entire dictionary is broken the way LLM sent it. And that's why what I'm going to do is go to response.py. Here I'm going to create a new function, and let's call this parse tool call arguments. Then we pass in the argument string, which is of the type of string, and obviously we need this to be in parameter. This will return a dictionary with string and any as the key. Let's import it from typing. And now we can go ahead and check. If not argument string, that means it's empty. We will return an empty dictionary. But if it's not, then I'm just going to try and JSON load this. So we have return JSON.loads, and we pass in the argument string. And obviously we need to import JSON, which I'll do in this function itself. I'm lazy loading it. Obviously you can just do it at the top as well. It shouldn't be a problem. If this returns an error, which is of the type of JSON decode error, that means the LLM sent a malformed string, and we'll have to handle that case, which is just like this, where we have raw arguments given to us, and that is the argument string. So this is our safe parsing of tool call arguments, which we'll call over here. Let's import it from client.response. And with this, we are essentially done. We'll pass in the TC argument string that we captured, and yeah, we'll yield the message not the message complete, but actually it should be tool call complete. So earlier we sent tool call start that we are beginning to do a tool call. Then we sent updates, step changes to whatever we received. And then we sent that, hey, a complete tool call is now happening. So earlier when I said that tool call start is whenever we want to display a dialog box, then tool call complete is whenever we want to say that the tool call has been executed. That was wrong. That's really not the case. Tool call complete just suggests that the tool call is complete. I made a mistake over there. I got confused. Tool calls complete is just that, hey, we have a complete tool call with us. This is what we are going to execute. And then we do the actual execution. And whenever that completes, we let the agent know it again. So this yielding that we are doing continuously really helps us whenever we want to display anything to the user, right? This is continuous streaming. So first we get the tool calls ID and the name. So we just tell it that, hey, we have the name. This is the function that we have. And then we get another data from the tool call. We just update it in our UI to tell the user that we have these many arguments. And then when the tool call is completed, well, we just send an indication that now we are starting another process. So yeah, this is just streaming in a nutshell. Now this is all of the things for streaming response. Now for non-streaming response, thing is going to be quite similar and actually quite easy because we're not going to get deltas. We're directly going to get the tool call. So once we check that, hey, if there's any message, we can go ahead and check, hey, is there any tool call? If message dot tool calls, then we are going to go ahead and store it. So we have tool calls, which is just a list of actual tool calls, an empty list initially, and I misspelled it so badly. After that, we'll go over every tool call in message.toolcalls and then append it to the tool calls list. Nothing too fancy. We don't have any delta. We're not worrying about anything else. We're just caring about the actual completed tool call. So because it's a non-stream response, we don't have to stream anything. Then we pass in the name, which is just tc.function.name. Nothing really changes. And then arguments is just going to be parse tool call argument tc.function.arguments. That's it. This is everything related to tool calls in LLM Client. And I think with that, we've actually covered everything in client. Now, obviously, we need the configuration system, but then the file is over. We won't be coming back to this file. Now we need to go back to agent because that's where we are going to get all of our event types. And actually in LLM client, let me just remove any print statement or any tool call statements that we did. And yeah, we don't have them anymore. That's great because over here, I'm going to print out all of the events. So if we have any tool calls, I would like to see if they're coming back to us because at the end of the day, we are putting in chat completion, right? All the events that we are yielding should come over here. Let's run this. And we get a bunch of stream events. We get tool call start, tool call delta, tool call complete. As you can see, our prompt tokens is now up to 2,635. It's totally normal because we have a very large system prompt. If you want, you can go ahead and read the system prompt for Claude. It is a lot more. And even in our system prompt, we are going to add more things, right? And if you notice the tool calls over here, the stream events that we are getting, we got one start, that's good. Then we got one delta, but then we got two tool call completes and then one message complete. Why are we getting two tool call completes? The reason we are getting two tool call completes is because we made a mistake over here. We were doing for loop of tool calls.items within this async for loop itself. We have to move outside of here at the same level as the yield stream event because we go over every chunk that is present in the response and we store it in tool call. And once we've done that, once we've completed it, we have a dictionary of all the tool calls possible. So we just yield the stream event. And now let's try to run it again. And this time we only get 4 events: tool call start, tool call delta, tool call complete, and message complete. So that's awesome. As you can see, the LLM did not talk at all. That's fine. But anyways, now in the agent, we have to catch this event and execute the tool call. So yeah, let's work on that next. So let's go ahead and put an elif condition here. So we'll have elif event.type, which is if it's equal to stream event type dot tool complete. Well, you can also have something done for tool call delta, tool call start if you want to display it to the user. As of now, we'll just focus on tool call complete, which just suggests that, hey, the tool call is now ready with us. Let's show it to the user and execute it. So we'll have tool calls.append. So we are going to maintain a list called tool calls, and that will contain all of the tool calls that we get from the stream events. And then later on, we'll invoke all of these tool calls either sequentially or parallelly, depending on the configuration. For now, let's just go ahead and create a variable called tool calls, which is just going to be a list of tool call, and let's import tool call from client.response, and it's going to be an empty state initially. After that, we are going to have tool calls.append, and here we are going to append stream event or the event dot tool call. Now it is possible that the tool call is not present. It can be null. So first let's just check if event.toolCall even exists. If it exists, then we want to do tool calls.append, and then we do have tool calls. So that's great. And now we can go ahead and execute all of the tool calls after we've displayed the response to the user. So let's say the LLM gives us a response text and tool call both. That is totally possible. So what we'll do is just return the response text, and then we'll go ahead and execute the tool call. So we'll have for tool call in the list of tool calls that we had earlier, this one. We're just going to go ahead and execute it. Now, how do I execute a tool call? But first, before that, I would like to display to the user that we are executing a tool call, right? To do that, we are going to create a new event in agent. So we are going to go ahead and go to events.py. Here we have a new event state, and that's going to be related to tool call start. So let's create a class method here called tool call start. Let's go ahead. We have that. Now we'll have a class, then we'll get a call ID, which is of the type of string. Then we'll get a name of the tool call that we're doing. That is going to be a string. And then a bunch of other arguments that we might not know about, which is string, any. After that, we just want to return a class where the type is the event type or agent event type dot tool call start. Now we want to create a new agent event type right at the top. So let me just copy this line, go to agent event type, and here we have stuff related to tool calls. So let me put a comment and let's call this tool calls. Then we have tool call start is equal to tool call start, like that. Now since we're already here, we can go ahead and create other tool calls as well. The next thing we will need is tool call complete. Then there's other things like pending and approve, but that's more related to confirmation side of things. That is something we're going to focus on later. But as of now, let's just get tool call working initially, right? When we have tools that require permission like write, because if you write outside the window or outside the folder, you might need confirmation. That's why. So let's go ahead and first just have tool call start, and now we can pass in all of the data. The data that's required here is first the call ID, which is going to be just the call ID. Then we have the name of the tool call, which is the name, and arguments, well, whatever arguments the tool called, right? For example, in read file, it can give us arguments like limit, path, offset. So those are the arguments that we are passing in over here. And yeah, that's pretty much it for tool call start. For tool call complete, we'll come back because there's more things to do there, especially when you're writing. But yeah, for now, in agent.py, we can just do yield agent event dot tool call start. And now we can pass in the call ID, which is tool call dot call ID. Then we have to pass in the name, which is, well, tool call dot name. And then the arguments, which is tool call dot arguments. Awesome. So we've given back to the terminal tool call start. Okay, but in reality, we have just given the event over here, right? Because agentic loop is called in this run function. So even from this run function, we'll have to yield it back, and we're already yielding the event, so we don't have to worry about that. But essentially, we've yielded agent event.tool called start here, then we've yielded the event from here where the agentic loop is called, and from run function, which is called in main.py, we are giving out an event. So based on this event, we'll display to the user a terminal box. More specifically, something like this. So if you have list directory or read file, what it's going to do is a box like this where it specifies that the tool is being executed, then you have the name of the tool, then the tool call ID, and then you have all of the arguments showing up. And then it also says running because, well, the tool call is still running, right? And then we also want the box to be blue. So now let's come back to our agent.py, and here in the agentic loop, we can go ahead and execute the tool call, right? To call the tool, we had created in registry.py something called as invoke, right? It was a wrapper around validate parameters and the execute function. We're going to call this itself. So we'll have self.toolregistry.invoke, and then we need to pass in the name, parameters, the current working directory. So we'll call just that. So we have tool call dot name, which is the name of the tool. Then you have tool call dot call ID, and then you have tool call dot arguments. Okay, and then actually we don't need to pass in the call ID over here. For invoke, the call ID is not required, so we can remove that. But the tool call ID is required when we are displaying out to the user. But when actually invoking, call ID does not really help us in any way. So just the name and the arguments, and then we can pass in the current working directory. So the current working directory is whatever the user will specify in the configurator. And if they don't mention anything, it's just going to be null. So as of now, we can just leave it to null and see what the agent says. If we go to invoke, the current working directory is over here, and we do pass it in tool invocation. Finally, for the current working directory, we can just pass in path, which we'll import from pathlib, dot current working directory. Now, obviously, this current working directory is going to come from the configuration system that we're going to add later on. But as of now, just path.cwd is fine. The reason we are passing it is because if you look over here, it does say path or none. So current working directory is allowed to be null. But when we go in the invoke function and see where this current working directory is called, it's called within tool invocation, and tool invocation requires current working directory to be passed in all the time. So what we can do is just remove this confusion. It can never be null. It always has to be present. Once the tool invocation is passed in, it will execute it, and whatever is the response and whatever is the result from here, we want to return it, but we have not done that, because tool.execute does return a tool result, and that's what we want to return from this invoke function as well. So what I can do is specify the return type over here, which is tool result, not tool registry, tool result. And then whenever we have success, we will get the tool result from tool.execute, and then we can go ahead and return the result. If you want, you can also return the result from here. It doesn't really matter, because if you have an exception, it will return the tool result.error result here. So we don't execute any further. But if there's a success, you are going to return a result. So that's good. And obviously, if you want to make this cleaner, you can just do result is equal to tool result.error result. Now both of them contain the same variable result. So we can just return it at the end. Cool. So now let's come back to agent.py, where we are calling the invoke function. Whenever the invoke is correctly done, what we want to do is return. So we have result is equal to self.toolregistry.invoke. Now this result can be a failure, it can be a success. Also, let's await it. It's totally possible. It can be, well, anything. So what I want to do is just return it with the tool call, right? So whenever the tool call is empty, I would like to again tell to the user that, hey, either it passed or either it failed. In any case, I want to display the stuff to the user. So let's go back to base.py, or actually events.py, and here create a new function called tool call complete. This is when the actual execution is over, which is something related to this. This one was for when the tool call started, and this is when the tool call is over. It will have a tick mark sign, then it will have the tool call name, and then we'll have the call ID. Rest of the design is same, but over here we display the result of the tool execution. It is totally possible that we run into some sort of error because the LLM hallucinated, it gave us the wrong path or something. In that case, we will display a nice red error message to the user. So here we'll have a class, then we'll have a call ID, which is of the type of string, then we have name, type of string, and then you have the result. Instead of arguments which were displayed, now we're going to display the content of the result. And we have tool result here. Let's import it from tools.base. And now we can just go ahead and return the class where the type is event type or agent event type dot tool call complete. And then we'll pass in all of the data. The first data point is the call ID. So let's just pass it as it is. Then we have name, again, just the name from the parameter, and then we have to extract all of the details from tool result. So first it can be a success. That's why we are going to get result.success. Then we have output, which can be result.output. Then we have error, which can be result.error. So just extracting everything result might contain. Another thing is metadata. So it will be result.metadata. And then I think we also had truncated, which is result.truncated. I don't know if we had exit code or not. We did not, but later on we are going to add exit code, all the diff related stuff, because when we are trying to edit or when we are trying to write a new file, we would like to display to the user the diff created. So what was the file earlier? Now with the new edit, what is possible? So a diffing view, just like Claude Code, Cursor, or even Visual Studio's GitHub has it, right? Or even similar to Visual Studio Code's Git. So if you go over here and you've done git init and stuff, you can go to the source control, try to see what all changes were made as of now. And it will show you in red whatever lines were removed and in green whatever lines were added in this commit. So yeah, for now the tool call complete looks good. Later on we can add more stuff. Now let's go back to agent.py, and here we can yield another event. This event is going to be agent event dot tool call complete, and then we pass in the call ID again, which is tool call dot call ID. Then we pass in tool call dot name, and then we finally pass in the result, which is just this result. Remember, even if it's an error, it's a good enough result. And let me ensure in events.py we did pass in error, so that's good. That will be helpful for us. So think about it. As of now, what have we done? Well, if the LLM gives us any tool calls, we're just trying to execute those tool calls. And with this thing, we have executed the tool call. So we do a tool call start, we tell to the user that we are executing a tool call, then we execute the tool call, and then we tell to the user that, hey, this is the result of your tool call execution. But one thing we've missed out on is adding to the context. So if we execute any tool call, we will have to add it back to our context, right? Because whatever are the results of the tool call, it might be helpful for the next iteration. Obviously, we are in run single mode. In run single mode, it doesn't matter if you put it back into the context or not. But when we have a run interactive mode, which is quite soon, you'll notice that we'll have to put the results back into the context so that the LLM can make its next decision, because we are not going to have just a single iteration. We're going to keep going as long as the tool call is not empty. The entire decision here will be made based on tool calls. So anyways, the point I'm trying to make here is just that we have executed a tool call, so it's our duty to just put it back into our context. Whatever is the result of tool call, let's just put it back into context. So what I can do is outside of this for loop, I'll create a function or a variable called tool call results, which is going to be a list of tool call or tool result message which is going to be an empty list. This tool result message is another data class that we're going to create, and it will contain all of the data or information about the tool call. And then obviously we'll add that into the context. So it's just a good way of writing code. Obviously, if you're using object-oriented programming. So let's go to response.py. It's obviously not going to be created in events because it's not related to agent event. It is more like a schema that we're creating, and all of the schemas or anything related to that has been created in response.py. That's why we're going to have here @data class, and then we have a tool result message. And then the first thing that we're going to have is a tool call ID, which is a string. Then we have a content of the tool result, what is the output, and then if it's an error or not. If it's an error, well, it's going to be a Boolean value, and by default it is false. Now we also need to structure it in the format of OpenAI message, because when you're adding it back into the context of the LLM, you need it to be of the OpenAI type, right? For example, when we go back to our context manager, if we go back to our context manager in context manager.py, here, if we add message item or get messages, what we did is called toDict, and toDict just converted it into OpenAI format. Similar to that, even this tool result message needs to have a function that will convert it into an OpenAI message format. Now, OpenAI SDK allows us to pass in the role of a tool call. So that's what we're going to use. So we'll have def2 OpenAI message, then we have self, it will return, and let me just fix that. It will return a dictionary with string comma any, and then we'll just go ahead and return first the role, because if you remember, in user related message the role was user. If the assistant gave us a message, it's going to be of the role assistant. But now it's a tool call that happened, and OpenAI allows us to pass in a tool here. Then we need to pass in the tool call ID so that OpenAI can know what tool call we are talking about. So we have self.toolCallID. It doesn't really understand the name of the tool call. That's irrelevant. The ID is the most relevant thing. It's the unique identifier created. And then we need to pass in the content. What is the output of this tool that you want to display to the LLM? So let's say I executed read file. I read 400 lines in it. I want to take that 400 lines and give it back to the LLM, right? So this content is going to contain that. And then you have self.content passed in. So that's about tool result message. Nothing too complicated. So let's go back to our LLM, or actually agent.py. And here we can append this result to the tool call result. So first we'll just display this tool call complete to the user, and then we can have tool call results dot append, and then we'll go ahead and append tool result message. Let's import it. So we have from client.response import tool result message. Then we pass in the tool call ID, which is tool call dot call ID. Then the content, which is equal to result, and this result needs to be converted into, well, content, right? Something that we can give to the model. So let's go to this tool call or tool result, which is this function. And here we've just created error result and success result functions. Another function I would like to create here is toModel output. So we just extract the output, format it in the format a model will like it. So here we have another function. Let's call it @class method. Now let's create the function toModel output, and then we'll get a self, and it's just going to return a string. We're just trying to create a model's output. Now what is the output? Well, if we run into any success, it's going to be, well, just the output that we have, right? If it is a success, we just return the output. But if it's an error, I just want to give it a nice output. Okay, I'll just say what the error message is, and then what we are displaying back to the user, or what we are displaying back to the LLM, whatever output we have created for the error result, right? So if we have any success, we'll just return the output. If you want, you can also format this output. totally possible. But I think the LLM will just appreciate the output because it will be able to determine that, yeah, this looks good enough for my use case. Now let's move on to the next thing. But if it's an error, then what I want to do is just prefix it with error. That, hey, we did not run into any sort of success. I'm explicitly saying that we ran into an error, and the error is self.error. Then we have 2 lines left so that, we are just formatting it nicely. And then we'll just pass in the output, which is, well, you can just put it on a new line, and then we have self.output. Now this has to be an S string and this has to be a brace. So yeah, now it's totally possible that this self.output is, so yeah, this looks good enough. I can save it. And now in the agent.py for the content, I'll just have result.toModel output. So instead of creating the complex formatting logic here, I just created it in base.py, abstracting away all of the logic in the relevant classes. Now, another thing I would like to add is error, and well, we'll have to know if it's an error or not. How do I know that? Well, if the result does not have any success, it is an error, right? So I can just say here not result.success. If this is false, that means it's an error. So this will just convert it into true because it is an error. Great. Now that we have caught all of the tool call results, I would like it to be added to the context. So let's go outside of this loop. Once we have completed all the sequential execution, I'll add it to the context. I'm not doing self.contextManager.add over here. Instead, I'll add it later on because just in case we run into any error with the context related stuff, it doesn't error out the tool execution or anything like that. So outside of this for loop, just after this, we'll have for tool result in tool results or tool call results. And then we'll just do self.contextManager.add tool result. So we have a function for add assistant message, add user message. We'll also have add tool result. And here we're going to pass in the result.tool call ID, and it should be tool result.tool call ID. And then we have tool result dot content, and that's it. So let's go ahead and create a function in context manager called add tool result. So let's create the function here. We have def add tool result. We have a self. Then we get the tool call ID, which is of the type is string. And then we get content, which is also of the type of string. Then we return null from here. We don't want to return anything, just like we did not return anything from add assistant and add user messages. Now first, we'll just create an item, which is a message item. And then we have the role of tool. Then we have content, which is just equal to content. Then we need to pass in the tool call ID, which is the tool call ID we got from here. Let me just say equal to. After that, we have the token count. Now for the token count, and actually tool call ID is not required here. So let me just add that to message item, because as I mentioned, in the context, the tool call ID should be present. It's very, very useful for the LLM, and well, if it's useful for LLM, it's also useful for us. So at the top, we'll have tool call ID, which is a string or null. By default, it is going to be null. Another thing I would like to add here is all the tool calls that we've made. So the tool calls will be a list of dictionary of string comma any. And by default, we'll just have an empty dictionary passed in. So we have field, which we'll import from data classes, where we pass in the default factory, which is a dict. Or actually it's a list. So let me just pass in a list. So this just contains all of the tool calls that were made in one message, because as I mentioned, the LLM can just throw at us 7 or 8 tool calls in just one message. That's why we're doing a sequential or a parallel execution later on, because there can be multiple tool calls. And now obviously we need to add it to toDictionary, because toDictionary is called in get messages, and if we have a tool call, we like to add it into our context, right? So let's go back to this to dictionary, and here we'll just check that, hey, if the role is related to tool, so here we'll just check if the tool call ID is present, because it can be null, right? If the LLM just gives out a text message, there's no tool call ID. But if the tool call ID is present, then I want to append it to the result. So we have result at tool call ID, which is just equal to self.toolCallID. Then we have if self.toolCalls is present, if it's not an empty list, then I want to add it to the result. So we have result at tool calls, which is just equal to self.toolCalls. And then we go ahead and return the result. That's good. So whenever toDict is called, which is in get messages, it will convert it into a dictionary, and get messages is called when we want to send data to the LLM. If you remember, in agent.py itself, we called get messages. Now, add tool result will just add it to this messages list, right? Whatever we had in self.messages. So yeah, that's what we're going to do. But first, let's just convert it into a token count. For token count, we can just call the utility function count tokens, where we pass in the text, which is the content, and then we'll pass in self.max or model name. Sorry. For the model name, again, it's going to be hard coded, which is over here, self._model name. Great. Finally, once we have this item, we'll just go ahead and add it to the messages list, which is item. So yeah, this does look good as of now. Let's just call add tool result in agent.py. So we'll scroll down, and I think it's over here. We did call add tool result, and that's great. So now all we need to do is remove the print statement from here. I don't need that anymore. I'm confident that this is good enough for now. I'll just go back to the main.py file, because that's where we have all of our process message related code, because now we should be getting the event over here. So let me put the print event here. Now let me run it. So I have python main.py, and it gives out agent event. That's great. So agent start comes in, it gives the right message, then the tool call start happens, and it does give that. Then another tool call start happens, and this is actually the tool call complete. So we have a bug in agent.py. We call tool call start 2 times. So when we execute, it gives us tool call start, as we can see. But then we see tool call start again. That means in tool call complete, we're actually calling tool call start. As you can see, even though this is called tool call complete, this is tool call start. So let's just fix that. And then this part will be fixed. It should be tool call complete. So this is actually the output of our execution. And it says that read file ran into an error. Base model cannot be instantiated directly. So somewhere we have called base model directly like this. So I'm going to search throughout my code base. Hey, where have I called base model like this? And in base.py, I did call it. So when I was trying to explain to you that, hey, whenever we have schema here, which is self.schema, we're trying to call base model like that. Now, you cannot directly call base model like that, because it's a base class. You cannot instantiate it. But whatever class extends base model, you can call that. And schema is a class that will extend base model. It's not base model itself. So we can go ahead and call schema like that, and it should work out. Let me run this again. And I get agent start, which is my message to the LLM. Then I get tool call start with the particular path. And then it says tool read file raised unexpected error. Argument should be a string or an os.path-like object, where this returns a string, not a method. And then we get agent event, because whatever output is there, we just send it back to the user and an LLM. So this goes back to the context, right? But anyways, let's try to fix this error. And I think I know where this error lies. This error is wherever we call path.cwd. So whenever we try to instantiate the current working directory, we call this function, right? Well, it's a function. We passed in a function directly. What we need to do is call this function, which gives us a path. So let's go back and try it again. Let's run python main.py. We get agent start again. We again run into another error, but this time it looks a bit different. So again, the problem is in tool call complete. When we execute the code, it says type object tool result has no attribute success. And the reason we run into this error is because if you check the output here of agent event, first we have success spelled out incorrectly. So we need to fix that. Now where is that coming from? Well, it's easy to find out. We'll just copy this success string and search in the entire code base. So when we search for success, we see in events.py, we call it success like this. We want double C to be present. Then we'll go to base.py as well and change this function. It should be success result like that. And then in read file, we'll just change this back to success result. And another place where we called success result, let's change it over there as well. Everything should be spelled the same way. Now, another error that I found over here was that whenever I'm trying to check if it's a binary file or not, so let me just scroll a little bit up where we have is binary file. Here I'm doing f\x00. I want to convert this string back into bytes, alright? So once I convert it into bytes, I can check if it's a binary file or not. If I just use an f string, I'm just checking, hey, is there \x00 in the chunk? But when I convert it into bytes, it means something related to bytes, right? I'm not checking a string. And then finally, if we go back to our function where we create toModel output, and I don't remember where I created it. So let's go back to our base.py file where we had toModel output. Here we check for if self.success. If we have self, well, it cannot be a class method, right? It has to be an instance method. Class method is created whenever you do something like tool result dot success result. But whenever you have toModel output, which is having self, what you're trying to do is something like tool result, where you have created an instance of tool result and then called toModel output. And that's when you get access to self and all of its properties. That's why it's not going to be a class method anymore. It's just an instance method. So we don't have to annotate it with anything. And now if you notice, wherever we call toModel output, so I'll just go to its references, which is over here, I get an instance of result, right? Whatever invoke gives us, it's essentially an instance of result. So I'll just highlight this part, which is tool result.error result. It's an instance of result which we are returning. And that's why we can call toModel output on it. Now let me close all the save files. I opened way too many. Let me clear it off and let's run it again. And this time we see agent start, tool call start and tool call complete. Now we have a much better error message saying fail to read file, string object has no attribute join. Now we again misspelled somewhere, or I misspelled somewhere. You might have seen that in the video. So I just search in the entire code base. Somewhere I typed in join G. It should just be called join because we are trying to access the join method. I'll save file and let's run it again. This time hopefully it works out. And it doesn't. It says fail to read file, count tokens, missing one required positional argument. So based on our past data, we know that the code executed till here. So obviously the output is in a future line. And as we can see, the problem is over here. In count tokens, I did not specify a model. So let me pass in the model, and my model is just going to be the same Mistral model. I don't quite remember the name. So I'm going to go to LLM Client where I had defined the model. Oh, okay, it wasn't an LLM Client. So I'm going to go to the manager where I had defined my model name, which is this particular thing. Of course, we'll have to get all of this data from the configurator. This is just temporary fixes. So now let's try to run it again and hopefully it works this time. And it does. So what we get is an agent start, then it starts the tool call, then the tool call completes. So we get read file, then we get success as true. The output is line number 1 is import async IO, line number 2 is import sys, import click, and that is our main.py file. And all of them have line numbers attached to it, and they go on a new line. Since in a string format, you might not be able to understand this better, but to an LLM, it should be good enough. You can obviously do all of your magical stuff in it so that the LLM can use lesser resources to understand this better, but in our case, it works just fine. Let me remove the print event now, and now what we're going for is printing it out on the screen. So whenever we have tool call start, I want to display that panel that I talked about earlier. And as a reference, I'm going to have these two boxes with me on the side so that we can take inspiration from them and clone it. So here, let's try to catch the first event, which is if the event type is, let's say, tool call start, right? Agent event type dot tool call start. In that case, we first want to get the tool name. So we have tool name is equal to event dot data dot get, and then we get the name. And if we don't get the name, it is unknown. Then we can go ahead to this renderer or the TUI that we had created. Let me open this up. In the UI TUI.py, I want to create a function that will display whatever I want in tool call start. So I'll scroll down, and then we have def tool call start. Then we get a self method. Then we get the call ID, which is of the type of string. Then I want the name of the tool, and then I want all the arguments, everything we've talked about till now. And arguments is just a dictionary of string, comma, any. Let's import any from typing, and yeah. Now, the next thing is, well, what is this going to return? It's going to return absolutely nothing. And let's put a comma here so that everything is formatted nicely. So the very first thing I would like to do here is at the top, create a new property called tool args by call ID. And it is going to be of the type of dictionary, where the key is going to be the call ID and the value is going to be the argument for that tool ID. So we know that each tool has its own tool ID, right? If it's trying to call read file or list directory, it has its own ID. For example, when we have list directory, this is the tool ID, correct? In read file, it then gets a new tool call ID. So what I want to do here is that whenever we have a tool call ID, I want to display it, and obviously the next thing is going to be the tool call completed, either with a success or an error. So whenever we're trying to call tool call complete, I want the same tool call to be shown and the arguments to be listed out here if necessary. So I'm just storing them in this dictionary so that I don't have to repeat them again and again. Kind of like caching. Now the next thing I need is what kind of, well, first let's just store it. So we have self.toolArgs by call ID. Then the key is going to be the call ID and the value is going to be the arguments that we got over here. The next thing we need is tool kind resolver. Basically, what kind of tool do we have? If it's a read, it's going to be cyan or whatever. Then there's write yellow, shell is magenta. All of these colors need to be put in. For that, we first need to know what kind of tool we're dealing with, right? We've already created tool.kind. If you go to base.py, here we add read, write, shell, network, memory, MCP. Similar thing over here. It's just lowercase and you have a tool dot prefix before that. And that's exactly what I want to deal with. So given the tool name, I just want to extract from the tool registry what kind of tool we're dealing with. And for that, we'll have to go over here. We'll have to talk to this particular agent's registry, right? So we have self.agent. Now this agent has access to tool registry. From the tool registry, we can get the tool name. Once we get the tool name, and it's not going to be a string, the tool name is this particular tool name. Based on this tool name, we can check if this tool exists. If this tool does exist, or let's say if this tool does not exist, we return null. Or let's say the tool kind is equal to null, and we just return tool kind as it is because it's a null value. Or actually, let's say tool kind is equal to null. Now, if the tool does exist, in that case, I want to get its kind. So I'll just access tool.kind.value, right? Because if the tool exists, it will have kind, and then kind will give us the enum, which is tool kind enum. Let's just go back to this tool kind enum. And now I want to get its value because it's all lowercase. So I'll just get its value, and that is my tool kind value. And I want to give that to the function in TUI. So I'll just call tool kind is equal to tool kind.value. That's good. Now probably we'll create a utility function for this because this will be needed in almost every tool call. Because think about it. So now whenever I call this particular function tool call start, so let's have self.tui.tool call start, I need to pass in the call ID, then I need to pass in the name, then I need to pass in the arguments, and another thing I'll pass in over here is tool kind, which is of the type of string. Okay, and here I can just pass in the tool kind as well, but we'll come back to this later on. As of now, I'll go back to this TUI, and here based on the kind I want to get the border style. Now that should be quite simple, right? I'll just create a function or a variable called border style, which is equal to, and then I have tool kind. Whatever tool kind I have, I just need to prefix it with dot. Now this tool kind can also be a null value, as we see over here. If there's no tool with that name, we have a tool kind of null, but most likely we will have a tool because the LLM doesn't hallucinate that much. We are just handling the edge cases here. So I can just say that, hey, if the tool kind is not null, in that case, the string is going to be something like this, where you have tool kind prefixed with tool dot. Okay, so you have tool dot memory, tool dot MCP, tool dot shell, all of that. Otherwise, we can say that the border style is tool, because border style just refers to this agent style. Tool or tool.read, tool.write. So if we don't have anything, I would just like it to be bright magenta bold. Okay, awesome. We have border style. Now we just need to get to designing the layout. So of course, the first thing is going to be creating this title. So to create a title, I need this dot, the grayish dot. Then I have the name of the tool and then the call ID. So let's have a title which is equal to text.assemble. That will help me construct a text instance by combining a sequence of strings with optional style. And we are going to have optional style. The very first thing is going to be this dot thing, right? This exact dot thing. And the style for it is going to be muted. Muted refers to this grayish style. We have defined it up in this agent. Muted is gray 50. After that, we have another one, which is the name of the tool. And then we will give it the style of tool itself. If you want, you can also refer to this as border style, but I would just like to have this as tool, which is this particular theme, bright magenta bold. After that, we have a space left in. So let's leave 2 spaces here and have muted just for some show. And then finally the call ID. So the call ID is just going to be hash followed by the call ID up to 8 characters. If it's more than 8 characters, well, I'll just truncate it. And then I have muted, because if we have a very long string, it won't look as good. So we have the title with us. Now we want to create an entire panel. So to create a panel, we can just do panel is equal to panel, and now I have to import it. I can just go at the top and do from rich dot panel import panel. Then let's go back down and here pass in all of the things required. The first thing is a title. So the title is going to be the title we just created, and let's pass that in correctly. Now, obviously, the first thing is not title. Before that, we have to pass in the box and renderable. Renderable is essentially what do you want to show within this panel. So we have this entire panel. What do you want to show within this? Well, I want to show the key value of the arguments. So I have path. What is the value of the path? And if we have limit, what is going to be the limit? What is the offset? All of those things. and it should work for every tool call. So I can't hard code anything. So I just want to take this arguments that I have and I want to display them nicely. So what we want is essentially a table, right? A table with key and value. So let me create a function, a helper function that will allow me to create a table. So we have render arguments table here where we get the tool name, which is of the type of string, then args, which is of the type of dictionary, string, comma, any. And what we're doing is just returning a simple table. Now we have to import that table from rich. So we have from rich.table import table, and then we can scroll down and here let's just call it table properly. And then I can do table is equal to table.grid. What is the grid? How many headers do we want? How much padding do we want? Well, I don't want any headers. As you can see, there's no headers here. I just want to display the key and the value. So I'm just going to specify the padding here because I don't want it to be stuck over here, right? So I'll leave a padding of 0, 10 on the X, Y on the 1 on the Y axis. Then we have table.add column. The first column that we are going to add is related to this key. Now, whatever values we add here is going to be muted color, right? It's somewhat gray color, similar to this tool called ID. So we can say that the style here is muted. Then the justify is equal to right and no wrap is equal to true. That means if it overflows, it overflows. We don't wrap it. And similar to this, we are going to have another table.add column, which is code, this particular thing. And if you scroll up, code refers to this white color, nothing else. And let me remove this extra line. The justify is not going to be right on this side. We're just going to have overflow is equal to fold. So if it overflows, you just fold it. Obviously over here, if you want, you can set overflow to ellipses or whatever. I'm not worrying about that now. The next thing I want to do is just order all of the arguments. So let's say we have read file. In read file, we get path, offset, and limit, right? So first I want to prioritize those arguments. So I'll display them first. After that, let's say the LLM hallucinated, I'll pass in all of the other arguments later on. So let me create a function, helper function for that as well. So we have def ordered arguments, then we get a self, and I forgot to put self here. Then we get a self, again the tool name, because based on the tool name, I will be doing the ordering. Then we have args, which is of the dictionary, string, comma, any. And then we just return a list of tuple. Now I'll just create a constant here of preferred order. That means I just want the arguments that I have in what format. So let's say we have read file. First, I want to display to the user what is the value of read file. For example, if I have read file, first I want to tell to the user what is the path. The lower priority is offset, the lowest priority is limit. And after that, if the LLM sends anything else, I'll display them. So that is what the preferred order is about. And we are going to have a dictionary here where we have a read file. The value is going to be a list where I specify the priority. The first one is going to be path, then you have offset, and then you have limit. Cool. And now I've maintained this as a dictionary because later on we are going to add more tool calls or tool names. So if we have write file, or if we have web search, or we have edit, all of those will be added here where priority is given. So here I'll just say preferred is equal to preferred order dot get, and then you pass in the tool name. By default, it is an empty list. Let's say the tool name doesn't exist. So we'll just have an empty list here. And now I'll go over every key in this preferred list. So let's say read file was the tool. I go over every element in this step by step. So the order matters here. And then I just check that, hey, if the key is present in the arguments, because it can be the case that, let's say the LLM specifies path and offset, but doesn't specify limit. So I'll just check that, hey, if the key is present in that dictionary, In that case, I want to add that into an order that I'm trying to create. So let me create a new list called order where I have a list of tuple of string comma any. Let's import tuple from typing. Let's have from typing import tuple string comma any. Whenever we add a tuple to this list, the first element is going to be a string, which is going to be the argument like path or offset. And then the value or the second value of this tuple is going to be, well, anything. It's going to be the argument at that particular key. What is the value? So for example, we have path. So the tuple's first element is going to be path itself, and the second value is going to be what is the value of that path. So let's have an empty list as of now. And then we'll check if key is in arguments, then we'll do ordered dot append, and then we'll add the key, which is path, and then we want to get the value of that path, whatever the LLM gave us. What path do we want to read the file from? And then we have args at key because that is the value. Now I'll also maintain a list of or a set of scene values. So what this means is, let's say the LLM passes in arguments like path, offset, and then it passes in a third one where it hallucinates and passes in something like offset 2. Okay, just an example. Let's say it passes offset 2. In that case, I've given priority to path and offset, but I've missed out on offset 2. That is something I should display to the user, because just in case LLM is not able to fix it, I, as the user, can tell the LLM that, hey, listen, you've done it wrong. You don't have to pass an offset 2 to this built-in tool. So here I'll maintain a scene set, and what this is going to do is contain everything, all the tools that we have added so far. Okay, so I've added path, I've added offset. Offset 2 is not present. So in a later loop, I'll go over all of the remaining keys. So I have remaining keys is equal to set of args.keys. So whatever arguments we got from the dictionary, we go over all of them, we get all of its keys, and we subtract it from whatever we've seen so far. So we've seen path and offset, but the args dictionary contains path, offset, and offset 2. So we'll subtract path, offset, offset 2 from, so we'll subtract path offset from path, offset, offset 2. So we'll have something like this, where you're trying to do this set minus this set. So you only have offset 2 remaining, which can be displayed or added back to this ordered list. And I explained why we want to do that. It's just so that if there's any error, the user can intervene and stop this from going any further. So we have key, args at key, and we go over every key in the remaining keys. Okay, so if we have offset 2 remaining, and let's say some other arguments are also present, we go over every key in that set and create a tuple where offset 2 is present and what is the value the LLM suggested for that offset 2. And then I can go ahead and return this ordered thing. Now I have the ordered args with me. I can go over every key value in this ordered args. Let me just call self.ordered args, where I pass in the tool name, I pass in the arguments, and that's it. Because remember, we have a list of tuple. So I'm going over every element, and every element is going to be tuple. So I've extracted the key and the value from that tuple. And now I'm going to do table.addRow. So I've defined my 2 columns, this particular path and then this particular thing. Or for read file, we have again path and the value. So we pass in the key because that is the path, and then I want the value, which is going to be whatever value we have over here. And finally, once we have gone over everything, we'll just return this table that we created. Now I can call this render args table down over here. So I'll have render args table passed in. Let me do self.render args table, and then I can pass in the tool name, which is just the name that we got at the top from the parameter. And then the second thing we need is the display arguments. Now remember, whatever argument the LLM gives us, for example, a path, the LLM is just going to say main.py. It's not going to say the entire path to us based on our current working directory. And if to the user we just say main.py, that's like so weird. Instead, what I would like to do is something like AI agent hyphen main.py. So based on my current working directory, I want to show the path. So what I can do is create a new variable here called display arguments, which is equal to a new dictionary of arguments. Then I go over the key in path and current working directory. So whenever we have keys like path and current working directory, I want to get their values. So we have display args.get the key. So we're trying to get path if it's present in the dictionary of arguments LLM gave us, or the current working directory. Because remember, in list directory as well, it can give us a path. In read file, it gives us a path. In write file, it gives us a path. So we're just trying to extract that value. So we just have, let's say, the main.py written out. Now based on this main.py, I want to get the relative path so that to the user we can display stuff nicely. So we'll say that, hey, if the instance is of the type of string, and the reason I put this is because many times the LLM just hallucinated and gave me an integer value for a path. I don't know how, maybe it was something related to my prompt. So I'm just handling that edge case over here. And let's say the current working directory also exists. So I have to create that variable right at the top, which is self.currentWorkingDirectory is equal to path.cwd. Again, this current working directory will also be coming from the configurator towards the next part of our application. Then I pass in the display args, and actually I've not completed it. So we have the current working directory now. Now we'll just say that, hey, display args at key is just going to be, well, the formatted display path where we are having the absolute path or the relative path based on the current working directory essentially. So what I can do is extract the function from paths.py. So here we created resolve path, right? Based on the base and the relative path, we want to create a new path, and that's what I want to show to the user as well. So we have string resolve path, and from utils.path we'll import resolve path. The reason I'm converting it into string is because we get a path here. Now path is not entirely visible on the screen, that's why we've converted it into a string. Now I'll just pass in the value here, whatever value we extracted, and the base directory is going to be self.currentWorkingDirectory. And that is the overrided value. Display args now contains the true value. And that's why I created display args over here. I didn't want to modify the original arguments dictionary coming to us. Cool. So I want to do this render args table if the display or if the arguments exist in the first place. Let's just say if display arguments exist in the first place. Otherwise, we will just say that, hey, we got no arguments, because that is also totally possible. Because many times the LLM does not have to pass in the arguments at all. For example, list directory. If we just want to list out whatever is in our current directory, it will just say list directory tool call. Because the default value of that is the current directory. So why does it have to pass in any arguments? And now the style is going to be muted. And that's it. That looks good to me. Now let's just try to make this perfect. I'll pass in the padding, which is 1,2, similar to the padding that was present for the table. Then we have box is equal to box.rounded, and we have to import box. So I'll just go at the top from rich.box import box, and we have to import lowercase box, not capital box. And then we have box.rounded, which is an enum. We want the box to be rounded, right? Then we have created a border style. Let's just use that border style as well. Then we need the subtitle. The subtitle is this particular thing, if it's running or if it's done, and what color do we want it in. So we'll have a text where we pass in running, that's the subtitle, and the style is equal to muted, because if it's running, we don't want much focus. If it's done, then it's going to be green, and we'll add that later on. The next thing is title align. We want the title to be aligned to the left hand side. And let's say the subtitle is aligned on the right hand side. Let's call subtitle align like that. Great. So this looks good. Now I can just go ahead and print this. So we have self.console.print panel. And before we print it out, I would like to leave a new line as well. It just looks good. So let me just print again. And this time it's just going to be empty. We leave a new line. And here we're getting an error saying this parenthesis was not closed. Let me just see where we missed a parenthesis. And it's not really about the parenthesis. It's because I forgot to put a comma here. And now we're good. I think there is a typo as well. So over here I passed in tuple like that. I needed to pass in tuple correctly spelled. And yeah, that looks good enough. Let's just call tool call start over here. So what are the arguments that we need to pass in? The first thing is the call ID. So we'll just have event.data.get call ID. And if it's not present, let's pass in an empty string. Then we have tool name, which is just the tool name that we've already extracted. Then the third thing is tool kind. That is also something we've already extracted. And the fourth thing is going to be the arguments, which is just event.data.get arguments. And it's an empty dictionary if not present. So that looks good to me. Let me just start this entire thing. Let me clear it off. I can't seem to type today. Let's see. I'll pass in this readmain.py file for me. Hit enter. And it says invalid syntax. Order.extend. So that is in TUI.py where I have order.extend. This is incorrect syntax. I need to end the tuple over here itself because we are trying to create a tuple of key and the value, right? So the tuple ends over here, and for every key in the remaining keys, we're creating this tuple. Now let's save it. Let's run it again. And it says cannot import box from rich.box. And yeah, it does seem right because rich.box module does not have any box, well, file, because box is a module, right? So what we want to do is from rich, we'll import box, and that exists. So that's good. And here it has defined rounded like we have over here. So that's also nice. Now let's run it again. So it does display it nicely. We have all of the title showing up. Running also shows up. That looks good to me, but the path is incorrectly formatted. And the reason it's incorrectly formatted is because we've been using resolve path. Resolve path comes from this part where we're just trying to find out the working directory we're in. But we have not passed in, but it does not really give us the main.py relative to AI agent. So we'll have to create a new function that displays the path the way we want. So let's go back to paths.py, and this time we'll create a function. Let's call this display path relative to current working directory, where we'll get a path which is of the type is string, and then we get the current working directory which is of the type of path. And now we are going to return a string where we display the path, right? So first we'll try to convert this path into an actual path object. So first we'll have a try p is equal to path, and then we pass in the path here. And if we run into any exception, we are just dealing with a wrong path. So we'll just return the path as it is, because let's say it gives us path.main.py. We are not able to convert it into a path. So we'll just return path as it is. We don't care about anything else. Now, if it gets converted into the path object, then we'll have a current working directory, right? If that is present, so this current working directory can be null as well. If this current working directory is present, then what we'll do is return the path that we had dot relative to the current working directory. Now let's say the current working directory is not present, then we'll just have return string of p. So whatever path we are on, we'll just return the string of that. But most likely we will have current working directory, so that's good. Now we can just use this function instead of resolve path, let's import it from utils.path and remove this resolve path function. Now let's try to run it again and see what we get. We get an error, main.py is not in the subpath of /user/run/desktop/AI agent. So the relative to did not work. In that case, we can just have a try except here as well. So we try to return path relative to current working directory. Otherwise, we don't get it. So we have a value error where we don't do anything because later on we are just returning a string of path. Let's try to run it again and we'll just see main.py being displayed out over here. And we do see just the main.py. But when we have list directory tool come in, so let's say this particular tool is present with us, it will try to list out everything in this AI agent folder. Then it will notice there's a main.py and it will give a better path. And then once it gives a better path, we will have this function display path relative to current working directory nicely working for us. But as of now, this looks good enough for tool call start. Now let's get started on tool call complete. And we know tool call complete actually looks quite similar to tool call start. We just have to display different things in the box. We'll have another elif condition here if event.type is equal to event type dot tool call complete, and then we'll have the tool name which is equal to event.data.get name, and otherwise if it's not present the value is unknown. And then we can go ahead and create a new function in tool call complete in TUI called tool call complete, which is going to be quite similar to tool call start. So I'll just copy paste the same function. So instead of tool call start, we'll call this tool call complete. We'll get the call ID, we'll get the name, but this time we are not interested in the tool kind. We have already cached it in this tool args by call ID, right? So we don't really care about the arguments. What we care about is the result. Was it a success? So that's something we'll be getting, and I misspelled it again. Then you have output, which is a string. Then we have error, which can be a string or a null value. Then we have metadata, which can be a dictionary of string, any, and it can also be null. Then you have truncated, which is a Boolean value. It can be any of these things. Cool, so we can remove this line of arguments. Then we have border style like that. And then we need the icon. Was it a success? Was it a failure? What was it? So we'll need a status icon here, which is basically this part over here. Okay. So status icon is equal to a tick mark if it's a success. Otherwise, it's going to be a cross mark. And you can use fancy logos over here. And I do have it with me. I have this tick mark icon and then I have this cross icon. You can refer to the repository if you want these exact icons or look for more stylish ones. Go ahead. Now, this is the icon. We are also interested in the style. So we'll create a new variable called status style, which is going to be equal to success. And I'm misspelling it continuously. If success is present, otherwise there'll be error, right? And if you go to agent theme, we've already defined all of these. We have success, which is green, and error, which is bright red bold. Cool. So status style is also present. The next thing is text.assemble, where we pass in the status icon. That's there. Then we pass in the status style. So if you have a tick mark, you have green. If you have a cross, you have a red. Then you have a name tool. Then you have muted, and then you have the call ID passed in. Rest of the things remain the same. Now for the displaying part, we will have to extract some data out of here, right? Because if we have read file, we will need this entire thing to be displayed. What did the agent just read? So over here, it read lines 1 to 23 of 23, and this was the path. And what did it read? Well, these files. So we'll have to create kind of a syntax here where it has all of these line numbers and then what was the data associated with it. So we have to display that nicely as well. And it's actually not going to be very difficult for us. The reason for it is We don't have to worry about this entire syntax displaying part because Rich already has a class that we can use to display this out. But we do need to get the text that was read. From the output, we need to get the start line. We need to get all of the code that was read. Then we also need this path. So yeah, those are the things we need to worry about now. But it's relatively easy, so let's get started over here. So let's just go ahead and create a helper function called extract read file code. And this is going to be a private function, and then we're going to have self and text taken in from the parameter. Text is just the text that we're getting from the output, and I'll discuss how it is structured. Then we're going to return a tuple where the first value is going to be an integer, the second value is going to be a string, otherwise we'll return null if that doesn't exist. Now, what is this tuple? Tuple where we have the first element as the integer. Why is the first element an integer? It just represents the start line. So if the output is present, that means we are going to have a start line, and then we have all of the code written out. So yeah, that's what we're going to do. Now, if you remember, the text content that we're going to get from read file is structured something like this. At the top, we're going to have something like showing lines, and then you have x to y of z, something like that, where x, y, and z are just integers. So you're just saying that, hey, we are showing lines 1 to 10 of 100 lines that are present. And then you have 2 \n because you're leaving lines. And after that, we have the line number followed by the actual code. Let's say main function like that. This is how it's structured. Then maybe you have \n again, then you have 2, and then you have this again. So this is the text that we're dealing with. Now what we want to do is extract all of the content out of here. So let's do it one by one. First, we'll just focus on show lines of x to y of z, and we'll be using regex for this. So let's say we have body equal to text. After that, we are going to do a header match using regex. Now, if you don't already know regex, I'm not going to dive totally deep into that, but I've created a tutorial on making your own regex engine where you will be able to understand how to read regex. So first, we are just going to go at the top and import re because, well, that's how you use regex in Python. And then we are going to have, well, where did our function go? Yeah, over here. Then you have re.match, and then you match to a particular pattern, right? The pattern we are dealing with is something like this. At the beginning of the sentence or the beginning of the text, we are going to get showing lines, and then we are expecting a number, right? So to catch a number, because we specifically want to catch a number, we're using a capturing group so that the state of that number is saved. So if it's 10, for example, showing lines 10 to 100, we'll be able to capture the integer 10. Then you have \d plus, which just refers to a digit. Then you have hyphen, and then you have another number. So showing lines 10 to 100. So we want to capture 100, which is \d plus. Plus just refers to a digit being present one or more times. So it just means we have one digit here, or it can be 10. So you have 2 in total characters present here, then you have 3, 4, whatever, but there should be one minimum present. After that, we have off, and then you again have another digit, which is just \d plus, because we can have multiple characters in a digit here as well. And then you have 2 \n. Great. And now we are matching this pattern onto a particular text. So we can just pass in the text here, and yeah, we do get that header match. Now, if that header match is present, what I want to do is just trim out my body. So if header match is present, I'm just going to do body is equal to text from header match dot end, and then we go until the end of the string. Okay. What does this mean? Well, we've matched the entire string over here. Now I just want to go till the end, and then we'll be able to get the body again. So I've stripped out the header that has these contents now. So let's say I had something like showing lines 10 to 100 of 150, and then your \n/n followed by line number 1. What I've done is just tried tried to remove all of these things. So I just have one so that I can just focus on extracting the line number and the code associated with those line numbers. Cool. So now my body is up to date. The next thing I want to do is, well, get the code line number, right? So we have code lines, which is going to be a list string. These are all the code related lines. So if you have one def main function like that, and then you have two where let's say there's some indentation and then you write in print, correct? Let's indent this properly, something like this. So I just want def main and print to be present in code lines. Another thing I require is the start index or the start line, which is going to be an integer or a null value, and initially it's just going to be none. If you want, you can default it to 0 as well, but I would like to have this as an integer or a null value. Then what we're going to do is go over every line in body, because body is the new text that is removed or stripped the header off, and then we split lines because I want to go over every line, right? So I have to split the body by lines. And remember, every code that's going to be present is going to be on a new line. That's how we had structured it when we were sending the output. Now we have to match it because I have to remove this one thing over here. So what I'll do is create a regex here, re.match, and well, what are we expecting? Well, we are expecting that in the beginning, we are going to get an integer because our code is structured like this, right? Or maybe there's a space over here. I don't remember, but something like this. So we might have some space in the beginning, then you have digit, then you have this or kind of symbol, and then you have all of the code that we want to capture. And then you should have the end of the line. That's what we're going for. Let me comment this out as a source of inspiration. Now we can give in a pattern. So the very first thing that we want to see is if there's any space present before it, because it's totally possible that there's some space present before it. We saw the LLM output when we tried printing out the events. It was really bad looking. So it's totally possible that there's some space before it. And therefore, we are going to have at the beginning of the sentence, that's what this caret symbol means. At the beginning, we might have \s, which stands for spaces. And those spaces can be 0 or more. It can be 0 spaces, 1, 2, 3, or infinite. Realistically, there's not going to be infinite, but anyways, that's what this means. At the beginning, we have spaces. But after all of those spaces, we'll have \d+ because we have a number, and that number can be multiple characters as well. You can have 1, you can have 11, you can have 111, you can have 1111. Depends on how long your file is. After that, we are going to have an OR symbol. But if I just put an OR symbol, it might mean something else, because in regex, this OR symbol carries a special meaning. I want to remove that special meaning off. This is an alternation symbol in regex, by the way. So I want to remove that special meaning from this regex. So I'll just put a \, so that I treat this OR symbol as a literal character, because I want to match this literal character. I've captured one. Now I've captured this literal character here, and now I can have multiple spaces here as well. But I'm not going to ignore all of those spaces, because the indentation matters to me if it's Python code, right? So if it's def main, I want it to be as it is, because in the next line, you will have something like this, where you have print written out. Now, if I strip off all of the spaces here, what I'm telling the LLM or what I'm telling the user is something like this. This is not our code. Our code has indentation within it. That's why what I'm going to do is not ignore the space and directly capture all of the characters. So dot refers to a character, and then asterisk means that you can have multiple characters after that. And then we are capturing all of that text. So this is stored in state 1 and this is stored in state 2. And then we are saying that after this, there should be end of the line. And we are matching all of that on this particular line that we are going through. Correct? Now, if we do not get a match, then we'll just return null saying that, hey, we did not find anything. Sorry, we are bailing out. We do not have anything to render. So we'll just render the text that LLM gives to us. We'll not try to do any fancy stuff on it. But anyways, if there is a match, then we want to first grab the line number. So the line number is equal to integer, and I told you that we have captured it. When you have a parenthesis around this digit, you're basically saying that I've captured the integer over here. So I can just do m.group1, and that refers to this digit that we caught. Then I also need access to the code, and code is present in m.group2 because this dot asterisk, meaning we can match multiple characters, is within this captured group. Correct? So yeah, we can just store that in code underscore lines dot append, and then you have the code line. Okay. Now, if I have line number, what do I want to do? Well, I want to store the start line. So if the start line is null, in your case, if let's say you start from 0, you can just check if start line is 0, because anyways, starting line should be 1. So if start line is none, you have start line is equal to line number. And yeah, that's basically it for this function. So let's just say at the end, after the for loop is over, if we do not have any start line, so if start line is none, then this entire parsing failed. I just want to return null. But if the start line is present, then I'll return the start line that I have, and then I also want to return all of the code lines, and I want to return it in a string format. So I'll just do \n to leave a new line between every one of them, so that they're not concatenated together. Now they're concatenated by \n, a new line. And now you can just pass in code lines. That's it. Now we can take this function and call it within this tool call complete. So you have self.extract read file code, and now you want to pass in the text. The text is just the output. And we don't want to call extract read file code every time we have a tool call complete, because if there's a tool call complete, it can also refer to other operations like shell or write file. And when write file or shell are happening, we don't want extract read file code to be present over there. So what we're going to do is first check that, hey, if the name of the tool is read file, and if it was a success, because if it's a failure, we do not want to read the output. It's just error filled output. In that case, we're going to have self.extract read file code, and then we're going to get the start line and the code. So now that we have the start line and the code with us, I would like to do another thing, and that is the path. Because if you see over here in read file, we do have the path displaying. For what file are we displaying the lines, right? I want this path with us, and this path is being sent through the tool metadata. So I'll just go to readfile.py, and here when we are having tool result.success result, you can see in the metadata we've passed in the path. So we just have to extract the path from metadata. Now it can be the case that it's not present all the time, because if you go to read file, here we have metadata path present. But if you scroll up, when the file is empty, we do not have the path passed in. So we have to handle that case as well. So here I can just extract the primary path that we are dealing with, which is equal to null. I'm not doing it within this tool call because this path will also be the case in write file. So it will kind of be reused every single time. So we can just check that, hey, if is instance metadata is a dictionary and is instance metadata dot get path. And if this path that we're trying to get is of the type of string, in that case, the primary path is equal to metadata.get path, right? Then we can just use that primary path to display it out on the screen. Now there's other stuff to display as well. For example, I will have to get all of that shown start, shown end kind of things. So if you scroll down, we had shown start, shown end, and total number of lines. Let's just extract all of them as well. So we have shown start, initially null, because again, it can be the case that it's not present in the first success result. If the file is empty, we are not having these properties. the total lines is none. And now if is instance metadata of dictionary, that means it is passed in. And actually I'm assuming metadata is always passed in, so I'm not even going to put that condition in. So I have shown start is equal to metadata dot get shown underscore start. Cool. And now I'll extract everything else. And since we're already doing that, I'll just remove all of these things. All right. So the initialization is done here itself. So we have shown start, then you have shown end, and then you have total lines. And then we can have shown end is equal to that, and then total lines is equal to that. Great. So what I did is earlier, I was thinking that we can again check if metadata is of the type of dictionary or it is an instance of dictionary, but in read file, we're always having metadata sent across. So what I'm saying is if shown start exists, you can set it to this variable, otherwise it will be null. If shown end exists, you'll pass it to this variable, otherwise it will be null, and the same for total lines. Now the last thing that I require from here before we can start displaying is lexer. So whenever we're trying to display the code over here, it would be good to know what programming language we're dealing with, right? So it would make sense to just have a function that gives us a sense of what file we're dealing with. And to check that, all we're going to do is check the path. If the path ends with .py, that means we're dealing with Python. So the syntax highlighting here is going to be Python based. And the same for .js or .ts. So what I'm going to do is at the top, or probably over here, I don't know where to put it. We can just put it over here. I'll paste a function called guessLexer. So what it does is it takes in a path which is of the type of string or null, and it returns a string. Basically the string is going to be what programming language we're dealing with. Now the function guessLexer is probably not right. You can call it guess language. That makes more sense, or guess programming language. And it is going to take in self, and then it takes in a path. If the path is not present, it just says return text, because, well, if the path is not present, how are we going to find out what programming language we're dealing with? So I'll just say this is text, because text is essentially no syntax highlighting kind of thing. Then you have suffix is equal to path at path. So we're just creating a path object. Dot suffix just gives us the extension of the file we're dealing with, and we convert it into lowercase. And then we have a dictionary here defined. You can add more, but I think this is quite a good list, where you have Python, JavaScript, TypeScript, JSX, Go, Java, HTML, TOML, YAML, all of that. And then you call .get suffix on it. So if you have .py, it will just return this Python string to you. If you have .c, it will return C to you. And then you have, well, if you don't have any of these options, it will just return text, because, yeah, that makes the most sense. And that is it about guess language. Now we have to indent this properly. So yeah, that's it. This is why I copy pasted it. It's just a long dictionary with .get called on it. Now I'll just call this function within read file. So we have self.guessLanguage, and then we need to pass in the path. What is the path? It's just the primary paths that we had. So if the primary path does not exist, it will just return text to us, and that is our programming language. Now we can go ahead and try to display something. So what are we trying to display? Well, it looks something like this, right? So first we need an empty line. After that, we are going to add this particular header where we have the path, we have a dot symbol. So let me just copy this dot symbol, and then we have lines 1 to 23 of 23. Should be quite easy. First of all, we want an empty text. At the top, define a blocks list. So blocks is going to be an empty list, and this blocks will contain all of the things. So for example, we'll have blocks.append text, because maybe we want to display an empty line. After that, we're going to have the header. The header needs to have the path, and we've created a function for that. We have display path relative to current working directory, which we're going to use. We're going to pass in the primary path as the path, and the current working directory should be self.current working directory. And this is going to be in header parts. So header parts is also going to be a list. At the end, we'll just concatenate it. The first part is whatever path we have over here. After that, we're going to get the dot symbol here. So we have header parts dot append, and then we append this dot. After that, we are going to have the lines 1 to 23 of 23. Also, let's just put in some space between this. And now we can check that, hey, if shown start is present and shown end is present and total number of lines is present, then it's very easy for us. We'll just have header parts dot append, and then we'll append lines shown start to shown end of total lines. Great. Now we can just join all of these header parts to create an actual header, which is just like this, dot join header parts. And yeah, that looks good enough. Now I'll append to blocks this header. So I'll have blocks dot append text, and then I'll append this header. And the style of this is going to be muted because as you can see, it's somewhat grayish. And finally, we're going to add our own syntax here. So we'll have blocks.append syntax, and at the top we can import from rich.syntax import syntax. Now we can use it in tool call complete, and I have to remain rest of these things, but first let me just focus here. Syntax, what does it require? It requires our code, and we have extracted the code outside, which is this particular thing. Then I need to pass in the lexer. Well, we could have called it lexer, but yeah, this is the programming language that we are dealing with. Then we have all the other things. For theme, you can use anything you want. I'm going to go with Monokai, whatever is present over here. But yeah, it's up to you to make your thing look good. After that, you have line numbers. Should it be true? Yes. Then we need start line number, and we have captured that as well. And then finally, word wrap is equal to false. We don't want it to wrap. And that's about the blocks that we'll require for read. But there's one edge case. What if the primary path does not exist? In that case, we'll run into an error quickly because this path is of the type string. So if null is passed in, it will return an error. So what I like to do here is check that, hey, if primary path is present, in that case, we're going to do all of these things. Otherwise, we don't have a primary path. So we're going to get and display the raw output. Now to display the raw output, we'll first have to truncate whatever we want. So I can call the truncate function that we created in text.py, I believe. So we had truncate text. Let me just copy that. Let me get it from utils.text. Now here I need to pass in the text, which is the output. Then you have the model name. Well, the model name can be passed in whatever. Then you have the max tokens. Let's say it is 240. You can make this configurable by the user, and we're going to work on configuration system. I know I've hyped it a little bit too much, but yeah, we'll get to that. And this is the output display. Cool. And then I can just do blocks.display or blocks.append, sorry. And then I have syntax passed in where I need to pass in the code, which is just the output display, the truncated output display. And then you have text as the lexer or the programming language that we're using. Then you have the theme again as Monokai. Let's use that. And then the word wrap is again equal to false. We don't need to specify the start line because we don't know what the start line is. Now I like to display this in a panel, so I'll just remove all of these display arguments that we have. If we have a panel, then I just want to display all of the blocks within it. So what I'll do is group all of them together. Now I have to import group. So from rich, I can import group, and I think we already have box, so I can import group from here. Or actually it comes from rich.console. So we have from rich.console import group. So group just takes a group of renderable and returns a renderable object. So it's kind of like if we have multiple renderables like a text, a panel or whatever, it can take multiple one of these and just create a wrapper around it so that you can display all of them together. In our case, we have a list of renderables called blocks. So we are going to use that and wrap it within a group. Okay. And then I can pass in all of the renderable, which is like this. So I've destructured all of the blocks within a group. Now the title is present with us. The title align is left. The subtitle is not done anymore. It's not running anymore. It's going to be done. And it's going to be done if we are in success. Otherwise, it is going to be failed. And the style is going to be, well, the status style that we have already talked about before. And we created a variable for it, status style. So a green or a red depending on success or error. Then you have subtitle align right. Then you have the border style. Then you have rounded and then the same padding. Now, yeah, we print out the panel. That looks good to me. One thing I would like to do is what if it's truncated, right? If the tool does any sort of truncation, we would like to display that in the output. So we'll have if truncated is true. In that case, we have blocks.append, and then I'll have a text with the note saying that, hey, the tool output was truncated. And then we have the style of that. The style is just going to be a warning message that, hey, your output was so long that it was truncated. That is a good enough indication for the user. Now we'll go back to main.py where we're going to call this self.tui.toolCall complete. And then we have the call ID passed in, which is event.data.get call ID. That's correct. Then we have the tool name. That's what's required here. Then we have the tool kind, but we have not extracted the tool kind. So we'll have to extract it, and it's the same logic as this one. So what I can do is extract this outside in a helper function. So we'll have def get tool kind, then you have self, and it returns either a string or a null value, and then you just have tool kind returned like that. So you return tool kind. Okay. So by default, tool kind is none. Then from the tool registry, we are getting based on the tool name. So we'll get tool name from the parameter, and it's not called tool king, it's called tool kind. If the tool is not present, then we have tool kind is equal to null. Otherwise, we have tool.kind.value, and then we return the tool kind. Let's just get the tool kind over here in both of these cases actually. So we have tool kind is equal to self.get tool kind. Then we pass in the tool name. Let me copy this and then paste it again. So the tool kind is now passed in. After that, we're going to get the success, right? The success, output, error, metadata, and truncated. That is all related to event.data. So I'll have event.data.get. We don't have arguments anymore. We have success. If it's not present, it's going to be false. Similarly, we're going to paste it for output. If it's not present, we have an empty string. Then we have error. If it's not present, we are going to have null returned. Then we have metadata. Then we have truncated, which is false by default if it's not present. And I think that's it. Yeah, by the way, metadata cannot be false. Metadata either has to be an object or it has to be null. So we'll just set it to null if we don't find it. And that looks good to me. Let's try to run it and see how it works out. So let's run this read main.py file for me. And we run into an error. It says sequence item 0 expected string instance POSIX path found. That means we somewhere used a POSIX path, especially when we had blocks. So here we did display path relative to current working directory. And I think the issue is actually in display path relative to current working directory. So here we created a path and then we return p.relative to in case the current working directory is present. But the problem is this returns a path and we actually want to return a string from here. So what I can do is pass in a string and yeah, that should be good. So the path is converted into a string and then returned from this function. Now I can try running it again. And as you can see, it all works out. It does look a bit weirder than what we have over here. And that's solely because we have one extra line. Since we already created a padding, we don't have to add the text ourselves in the TUI. So here we can remove the blocks.append text because the padding is present. Now let's try running it again. And yeah, that works out again. Looks much better. Then we have a status symbol, read file, and the same tool call ID. Then you have the main.py where it says lines 1 to 93 of 93, and then it prints out everything nicely. If the lines kind of exceed 240, we'll also be truncating, so that's good. Now what I want to do is, instead of just having a run single mode, which seems to be working well, I would like to convert it into a run interactive mode. So I'll close all of the save files for now. I'll go to main.py, and here we have run single function, correct? Similar to this, I would like to create a run interactive method as well. So here I'll just copy everything, paste it over here, and then you have run interactive. Run interactive does not take any message or anything because run interactive is essentially this particular place where I just start the agent once. It gives out this message symbol, then I can pass in any command that I want it to. So we have async with agent as agent, then we set agent correctly, but then we'll have an infinite loop. In this infinite loop, we'll continuously get the user input and handle the commands, and obviously also process the user's message. So first we need to get the user message. So we have while true because we are in an infinite loop, and then we get the user input. Now there can be an error over here because when we try to get the user input, which is done using console, so you have console.input, the user might just click on Control C to exit out of here. Let me give you an example. So let me run this example code again. And now if I want to get out of here, remember we are in a while loop here. We are continuously getting the user's input. I'll just press Control C, and whenever I press Control C, I run into what's known as a keyboard interrupt error. And I would like to avoid that and instead say that, hey, you have to use \exit to quit, or I can just quit. So yeah, let's work on that. And it's quite easy. We can just put a try block here. Then we get the user input. Then we have an except keyboard interrupt error. If that is the case, I can just do console.print \n, and then we're going to have a dim as the style. Then you have use \exit to quit, not continue. And then you have /dim again. Of course, this cannot be exist. It needs to be exit. And yeah, that looks good to me. Now another error we can run into is end of file error. If that is the case, I just want to break out of here. Now let's get the user input. To get the user input, it's quite simple. We have just this symbol showing up, which is just a greater than symbol, I think. And it needs to be colored in blue. And we know that user is converted into blue. Also, we want it to be on a new line. So that's there. Then you have greater than symbol, and then you have another user again. Then you leave some space, and then you strip off the user's input. Okay. So we get the user's input. Whatever they type in, we just remove the trailing spaces from it or leading spaces from it. And we have our user input. Now, if the user input is empty, in that case, we want to continue. We are not going any forward. The user just typed in nothing. Let's try over here. If I click on enter, you see there's a line space, and then we move to the next part because the user did not explicitly say anything. Why should we give it to an LLM? It's just a waste of time and tokens. After this, if this input is valid, we are just going to do return await self.process message. And let's not return that. We'll just do await self.process message, and then we pass in the user input. And let's say after that the agent gets over, this entire context management that we have done is over. Then what I want to do is console.print, and then I have \n. Again in dim light, I want to say goodbye. And then we have /dim. Obviously this needs to be within a string, and that's it. It's just a nice effect that we're going after. It's not a necessity. Now let me just start this in interactive mode. And by the way, we have to connect this to our main function. Meaning if the prompt is not specified, then we have an else condition, and then we have async IO dot run, and then I'm just running the CLI in interactive mode. Then yeah, so let's try to run it. What I'm going to do is just say python main.py because that should open up in interactive mode, and we get an error, but it also works out. The error is syntax warning invalid escape sequence \e. And this exists because here we said use \exit to quit. Actually, it should be /exit. That's how you quit. Yeah, we have to change that. But also the main problem here is \e is considered to be an escape sequence, but it's an invalid that doesn't really exist in Python because anything after / is supposed to be escaped. And that's why the issue existed. Anyways, for us, we just have /. So yeah, now let's try to run it again. And you can see it says use /exit to quit. Now, I don't really have a way to quit because we have not implemented the \exit or /exit command. This aborted because that's how the CLI does it, but we do not have anything related to /exit. So yeah, all of those command handling sequences, we'll do that later on. It's not top of our priority list. For now, what I like to do is just get this interactive thing working. So yeah, the agent has started, but there's really no way for me to know that the agent started. Over here in our done example, when we start, it gives us this entire list. What model are we using? What current working directory are we using? What are the commands that we can use to get some help? I want this exact thing. Now, I'm not going to code it from scratch because it's quite simple actually. I'm just going to copy paste in the TUI. So if we go back to our TUI.py, here we're going to create a function that will print welcome. And it's nothing complicated. The reason I'm printing it outside over here is because it's not too complicated. We have body is equal to \n.join, and we're joining all of the lines. The lines is given to us from the parameter itself. Okay. We can also remove this asterisk because we're not going to have any other arguments here. Now, after that, that is our body. So we're just doing self.console.print a panel. And we know this is a panel. We have already created it. The border is border. So it's just the grayish border type thing. Then you have left. You don't have any subtitle here. The padding remains the same. The text is of the style of highlight. If you go to agent theme, you'll be able to see what highlight means. Bold cyan. These are the things. Now we can go back to main.py and print this out as soon as the interactive mode is called. So here I'll just do self.tui.print welcome. And now I'll pass in the title. The title is, well, AI agent. I've not given it a fancy name. You can. And then I have lines as a list where the first one is the model. What model are we using? Now, that really depends on the configuration. But since we don't have that yet, we are going to add it just after this interactive mode is done. I can just pass in model as this Mistral thing by default. Hard coded. Then you have current working directory. This also comes from the configurator, but we can just do paths.cwd for now. And obviously it will get converted into string. And the final thing is commands. What all commands do we have? /help, /config, /approval, /model, and /exit. Just to let you know what all of these commands mean, /help will list out all of the commands which will help us do whatever we want to do. Config will list out all of our configurations that we have defined in our config.toml file that we're going to create. Then we have /approval, where you can see what approval modes you have. Then you have /model, which refers to a model change. For example, this model is used, you might want to change it. So you can just do /model and change it on the fly, and then /exit, you know exactly what it does. So that's looking good for us. Let's just exit, and to exit, I can just do this. It aborts. Our command obviously doesn't work, because if our command worked, it wouldn't say aborted. It would say goodbye, just like we have over here, graceful handling. Aborted is what TUI or the rich thing that we are using says. Now let's run it again, and it gives us this AI agent. Excellent. Now let's give it a query, read main.py file for me. So let's hit enter and it should work. It does. And then it gives me another message that I can put in. It gives out this read file, then it gives out this read file, just like run single mode would. And the good thing over here is that the context is managed. So if I type in here, what did you do before, and then hit enter, it gives us an error, unexpected role tool after role. Now the reason this error occurs is because if you go to our agent.py file, here we did this, right? We contacted the LLM, then we added the assistant message if the response text was available. Otherwise, we just passed in a null. And if it's a null, then, well, nothing really happens. One thing that we forgot to do is tell that the assistant gave us the tool calls, right? So think about it. We sent a message to the LLM saying, hey, we want to read the file. So we read the main.py file. Okay, the LLM tells us that this is the tool call you have to do. So we have not registered in our context what the assistant or the LLM told us to do. We have only registered the response text. So for example, if I type in, hey, what's up? It gives me, hello, how are you doing? So that hello, how are you doing is stored in the context manager with the assistant tag. But if there's any tool call, we are not registering that in the context, and we have to do that. And to do that, we'll have to go to add assistant message. In the message item, we'll have to pass in the tool call ID and tool calls. We're not really interested in tool call ID when we have an assistant message. We are interested in it when we are adding the tool result, but in assistant message, we do want to put in tool calls. So from the parameters, we are going to take in tool calls as a list of dictionary of string, any. I hope you've understood why we need to do this. It's just so that in the context, we are maintaining the assistant related text. So we give in a message saying read main.py, whatever the assistant gives us, that also needs to be stored in context. And then the result of that tool execution also needs to be stored in the context. Everything goes in the context. But we missed out on one part, which is, well, whatever the assistant gave us. We just store the content. We don't store the tool related stuff. And that's what we're doing here. And now we can pass in tool calls, which is equal to tool calls. And by the way, the tool calls can also be null, and by default it will be null. So if it's not present, then it's going to be an empty list because we cannot pass in null for tool calls. Or it can be an empty list. You can also pass in null value. It's totally fine. But yeah, this just gives it a nice feeling because ultimately it will be converted into dictionary, and in dictionary we are just checking that, hey, if self.toolCalls is present, that means it should not be empty list or it should not be null. Great. So we have managed that add assistant message. Now we can go to the agent. Here we have to pass in the list of tool calls. So I'll have a list where I have a dictionary. The first thing is going to be ID. Well, what is the ID going to be? Well, we're going to go over every tool call in tool calls, right? So it's going to be tc.callID. Then we have type, which is going to be function. And then we're going to pass in the function, which is going to be the name, which is toolcall.name. Then you have arguments, which is going to be string of toolcall.arguments. That looks good enough. Now we only want to create a list if tool calls exists, right? So if tool calls is present, only then do we have this entire list. Otherwise, we have null. And that is it. Now I hope this entire thing works out for us. So I would like to exit. I'm in interactive mode. I'm saying read main.py file for me. Hit enter. And it does give out the entire thing. That's working as expected. Now let's hit enter and see if the LLM realizes what we're saying. And it gives us a message. I read the contents of the main.py file for you. That's awesome. I'll just say read it again just to see if the context is again maintained. I'll hit enter. And yep, it does execute it again. I said read it again. It realizes that it means main.py. So everything is maintained. So that means our agent loop is working. Now there's obviously more stuff to do. And by the way, /exit did not work. It says exiting goodbye. So now the next step for us is creating the configuration system, because the configuration system has a lot of details that we care about. For example, when we are in the agentic loop, this loop can keep going on forever, right? We need to put a max limit to it because it can cost a lot of tokens to us as well. And obviously there's going to be all sorts of context management stuff we'll do later on. But the point here is configuration system handles a lot of things, including setting up the approval and sandbox policies, which is a feature we'll add later on. So it just makes sense to work on configuration system now. And then whatever features we need, we'll keep on adding them as soon as we need it. Also, it requires kind of a refactoring of our system, because many places we just passed in hard-coded strings, like for the model name. We just passed in hard-coded strings. That's not what we want. And that's why we'll have to touch many files in this refactoring. Let's close all the save files. And here, let's minimize all of the folders. I'll create a new folder called config. And within this config, we're going to have two files. One is going to be config.py, which defines how the configurations are going to look like. It will create a schema of configurations. And then you have a loader.py, which contains all loading related aspects of the configuration, because the configuration can be present in your TOML file, right? And TOML file needs to be defined in the root of the folder, root of your entire system. So all of that loading also takes some time. More than time, I'm talking about code. So it is cleaner to just put it in two different files. Let's work on that. We'll start from the config.py file. So here we are going to create a class called config, and then this is going to extend the base model. And from Pydantic, we are going to import base model, and we can't do that. So let's do from Pydantic import base model. Once we do that, we have the class created. And now what is the first configuration that we're going to take in? It's related to the model. And for this, we're going to create a new class called model config. And by default, this is going to instantiate a model config. So let's have default factory here, which is equal to model config itself. Now let's import field from Pydantic and also create the class for model config. The model config class is also going to extend base model. Now, what is this model config class? Well, the reason we are creating a separate class is because when we try to load stuff up, everything related to a model will remain within this class. Okay? And then we can just pass in all of the properties a model can have. It's just easily extendable then. So we have name, which is going to be a string, and by default, it is equal to, well, the Mistral model that we've been talking about. So I can search the entire code base to find Mistral related stuff, and it's this particular thing. So let me just copy it, and then I'll paste it over here. So if nothing is mentioned, we use this model. Then we have the temperature, which is going to be a float value, and that can be a field as well. And then in the field, the default value can be passed in, which is 1. So if the user does not specify temperature, we go with 1. Then we can also pass greater than equal to. So any value should be greater than equal to 0.0 and it should be less than equal to 2.0. That's how temperature works. By the way, if you're not familiar with temperature, temperature just means the creativity of the model. You can think of it that way. So you know LLMs are next word predictors, right? If they are next word predictors, what is the probability of the next word going to be? Temperature controls that. It just controls how creative can the model be. If it's 1, it will choose somewhat of a creative option. If it's set to 0, it will choose the most likely option. So as a thought experiment, if you set the default to 0 and the user doesn't change the temperature, it just means that the model will always give a similar or the same output. In practice, it rarely gives the same output because there's some indeterminism within the model. If you want to read more about that, I can mention an article by Thinking Machines of why this indeterminism occurs, but that's totally possible. The point is 0 will try to always choose the most likely word. 1 gives it a more creative sense, and 2 is the most creative it can get. So many times with 2, you'll have the model hallucinating, but it will be very creative. Because think about it, if it's told to choose the least likely element, for example, the least likely word, it will just generate deformed sentences. Obviously, that does not happen here, but it will hallucinate. It might give you proper English, but it will not make sense, for example. So that's temperature, and the other thing is context window. The user can set the context window length, which is an integer or a null value, and by default it is null because, well, context window is interesting. By the way, if you want, you can remove this null and set it to 256,000 or 128,000. That's what most models are around. I believe this model is 256,000 tokens context window. If you're not familiar with context window, it just means how many tokens can this ChatGPT conversation keep up with. Most models are increasing nowadays. I think we started off with 64,000 or 128,000. And now the GPT 5.2 model is probably around 500,000 tokens of context window. So it's going up, but it is still finite. It's not unlimited, infinite. You cannot just paste in a 100-page PDF and expect it to work. That's why context management is one thing we'll be focusing on in this tutorial. Cool. Now that we have model config, we can just go ahead and set another one, which is current working directory, and it is going to be of the type of path. Let's import path from pathlib, which is equal to, and then we have a field where we pass in the default factory, which is going to be path.cwd. Notice I'm not initializing stuff over here. I'm just mentioning the function so that whenever current working directory needs to be initialized, it can be passed in. Then we have integer like max turns, integer which is equal to 100. What is this max turns? Well, max turns refers to how many turns can our agent go long for. So for example, when we tried to run our application over here, I sent in one message, right? And then I could send in another, then I could send in another. We want to put some sort of limit over here, correct? Because then it will just keep going on forever. That's why this 100 is the default limit we are putting in. But if the user wants, they can increase it. Obviously, it's going to be based on their own API key. This is the bring your own API key format. We don't worry about the cost. We just set up a framework for them to use it. So the cost will be associated with them, but we have done our due diligence of setting the max number of turns. Then we have max tool output tokens. How many tokens should the tool go on for? And we are going to set it to 50,000. So if the tool return 50,500 tokens, we'll just truncate it down to 50,000 tokens. The 500 tokens will be discarded. Then we have instructions like developer instructions, which is, I think, mentioned through the agents.md file. And then the user can also specify user instructions, like how do you want the model, for example, to behave. Now they both kind of overlap each other because developer instructions can also contain how the model should behave, because at the end of the day, both are just combined and sent to the system prompt. But this is just a clear distinction done. If you want, you can totally ignore this. And yeah, so we have this also done. And finally, we are going to have a debug Boolean value, which is going to be false by default. This means if the debug should be on or not. This will help us display the logger related instructions. So if you do --debug, all of the nice UI stuff that we're doing will be gone and we'll only display the logger stuff. So yeah, that's it. Now there are more attributes that we would like to add here. For example, approval, sandbox, how the shell environment should be, then all of the stuff related to hooks, MCP servers. So yeah, those all things are going to be added, but we'll add them as and when we want the feature as a whole to be present in our application. As of now, these are the things that we need to worry about. Now let's go ahead and create a property. So the first property is going to be the API key, because the API key needs to be taken from the environment, right? So we have a self and we will return either a string value or a null. And this just means that we are checking our environment variables. So we import os.environment, and then from the environment, we're trying to get the API key. So that is about our API key. Then another thing we will need is the base URL. The user can set any base URL they want because, well, it only makes sense that they can switch to another model, like Gemini. And if OpenRouter, for example, doesn't have support for it, which is highly unlikely, but yeah, you can just do that. So you have string or null, and then you just do return os.environment.get base URL. After that, we can have the model name. So @property model name. Now you might wonder, why are we creating a function for model name, right? We already have a model name over here in the model config. Why do we need another one? Well, that's because to access a model, we will have to do self.model.name. So instead of that, I'm just giving a convenience feature here, which is return self.model.name. Okay. And we're also going to have a setter for this model name. So we have @model name dot setter. This just means that the user can do something like config.model name is equal to, and then pass in any model name of their choice. This will be really helpful when we want to switch the model, right? For example, here one of the command is /model. So you can just do something like model and then set the name of the model, for example, Gemini. So essentially what we're doing is having a setter over here, and that's exactly what's happening here. So we have def model name as well, then we get a self, then we also get a value which is of the type of string, and we return nothing from here. All we need to do is not even return anything. Self.model.name should be equal to this value that we have. Okay. After that, we have the temperature. Again, this is just a convenience kind of thing. So we have self, and then we have a float, then we have self.model.temperature returned from here. And similar to this model name, we can also have a setter for the temperature. So we have self.model.temperature is equal to the value. And then I believe we can create one function just to check that the configuration is valid. Now, how do we check if the configuration is valid or not? To do that, we will have to check if the API key exists or not. If the API key exists, it means configuration is valid. And we'll also have to check if the current working directory exists or not. Because if the current working directory is not mentioned, or if it does not exist properly, then we have an error as well. So that's another thing we'll have to check. So let's create a function def validate, and then we get a self, and it will return a list of string. It will be empty if there are no errors, and it will contain strings if there are errors. So if we have errors as a list of string, and by default it is just an empty list. Now we just check if not self.api key. In that case, we are going to do errors.append, and then we have no API key found. Set, let me just type it properly, set API key. Let's get this set API key environment variable. Awesome. Another thing I would like to check here is if the current working directory exists or not. So if the current working directory does not exist, in that case, what I want to do is errors.append working directory does not exist. And then we have self.current working directory. I think I misspelled self, so we have this. Great. Now, if either one of these errors are there, we'll have an errors list not empty, otherwise it is empty. So that's about validation. So we have the entire schema created. Let's go to loader.py and create the function that we need, which is load config. We get a current working directory of the type of path or null, and that's all we get as of now. And what this will do is return a config if it exists. So from config.config, we'll import config, and yeah, that looks good enough. Now, the very first thing we want to do is initialize the current working directory. So if current working directory exists, we'll have current working directory, or if it is null, then we will use path.cwd. Okay, the current working directory we are in. Now we want to load the system configuration. Now what is a system configuration path? System configuration path is where basically our system config file is going to live. So that means somewhere in the root of our folder, you can create config.yaml file, and that will be read to extract the values from. So whatever values we have over here, for example, model or max turns, you can set this in a system level configuration file, something like this, where you have the root .config folder, and within that .config folder, maybe you have this AI agent folder, and within that you have config.yaml file. So this is the file, or in our case, it's going to be TOML, similar to OpenAI's Codex CLI, because it's just cleaner to read. So this is the place where we are going to check which is our system configuration path. Now to understand this path correctly, first we must understand what elements are present within it. The first part is the user related configuration directory. So this part that you can see is called the user configuration directory. This is where all of the configs related to all of your programs should be present. And within that, we are creating a new folder called AI agent, within which there'll be a file called config.toml. So let's just create the config directory. This is the user related config directory, and we're going to return a path from here. And now we can just do return path, where we pass in user config directory. We can import that from platform directories that already has access to this part. Obviously this is Linux or Mac, but in Windows there'll be something else which user config directory already takes care of. And now here we can pass in the app name. So we want to get the config directory of our app, right? Our app is AI-agent. If you have some fancy name, you can put that in. Now to get to this particular path, you just have to add in config.toml, correct? Because this part was done by user config directory. Then we said our app's name, which added this particular part. Now we just have to add config.toml. At the top, we can define what our config file name should be so that we can change it from one place. So here we go. And now I can create a function called get system config path. Also, this is going to be def. And this is going to return a path as well. Then we are going to do return get config directory. And then we are going to append it with config file name. Okay. So this is all where all the user related configuration is going to stay. This is where our system configuration is going to be there. And now we can just go ahead and do system path is equal to get system config path. So we get access to a path. And now we can first check, hey, if the system path is a file, only then do we want to move forward, because if it's a directory or something, we're dealing with the wrong thing. Now the first thing I want to do is first ensure that the TOML file is properly parsed. And to parse a TOML file, we can create another function called parse toml, and that is going to be private to the file, or like the loader.py file. It cannot be used outside. We're going to get a path, and from this path, we are going to extract the file and load it in a dictionary format. So we are going to have try, then we have some logic, then except, and we are going to catch one specific error, which is TOML decode error, just in case the decoding goes wrong. And we are going to import it from TOMLI. Okay. And we have it as E, and then we raise a config error. Now we'll have to create what's known as a config error. Now we'll have to create this config error, which we'll go and do in utils errors.py. And this is also something that I'm going to copy paste because it's fairly straightforward, but it's this thing. So what are we doing here? Well, we are creating a class first called agent error, which extends exception. That's the way you can create your custom exception. And then you have the message coming in. Then you have asterisk, which is not really needed. Then you have details with string, comma, any as the dictionary. Then you have details as a dictionary with key as a string, value as any. And then you have cause, which is of the type of exception or null, and by default it is null. And then we are just calling this base exception class, where we are calling self.message is equal to message, self.details is equal to details, self.cause is equal to cause. After that, we have a string representation of this function where we just have self.message as the base. And then we are saying that, hey, if the details exists, then we are just trying to format it nicely. So we just have a comma separated key equals value pair, and we just display it over here. So base is equal to that. And if the cause is present of why this exception occurred, then you will have this base caused by self.cause. Okay, so whatever base you had from here, you just add it over here. This is just nice string formatting, just in case we try to print an error. Okay, and then we also have toDictionary, where we are just trying to convert it to a dictionary. Awesome. Then we have config error, which extends agent error. And since agent error extends exception, config error is also an exception. So here we are getting the message, we are getting the config key, we are getting the config file. So which config attribute caused this exception, and what is the file that is causing the exception. So we just have those details. Then we have the config key, and details at config key is equal to config key. Details at config file is equal to config file. Then you have the init function, and then you have this particular thing where we are just setting the config key and config file. Awesome. And now we can just use the config error over here. The reason I just copy pasted is because it's fairly straightforward and really non-essential to our application. This is just coding practices that I'm following, because yeah, if there's a config error, we raise it over here, but later on, if we parse the toml and we get a config error, we'll really do nothing about it except just print it out. And here we can just type in that, hey, there was an invalid toml in this particular path, and well, the exception was this. And then we can also set up the config file, which is equal to the string of path. And then, yeah, that should be enough. And we can raise this from E. Okay. Now let's say we run into some other sort of error, which is OS error or IO error. So we can deal with them as well. So we will raise a config error for this as well. Let's print it out. And then we have failed to read config file. Then we pass in the path. Then we have E passed in. Then we pass in the config file, and rest of the things just remain the same. Now to parse the toml, how do we do it? Well, it's a one-liner, or actually a two-liner. We'll first open the file. So we pass in the path. Then we have read as bytes, and then we have the file. After that, we'll do return tomli.load, and we first have to import tomli. And since we have imported tomli, we don't have to do this. We can remove this line and then do tmli.tml decode error. And now for this tomli.load, we can pass in the file pointer, which is this. And that will return to us a dictionary format. So we'll pass toml from a binary file object. Now that we have passed the toml, we have a dictionary. So let's just create a variable called config dictionary, which is dictionary string comma any, and we'll have to import from typing any, which is equal to an empty dictionary first of all. After that, if it's a file, then we'll try to parse toml. Then we need to pass in the path, which is just the system path, because we're trying to parse the config.toml file, which is present in the system path, right? And then we can just set this config dictionary to this. We don't really have to merge as of now, because the config dictionary is just empty. Now, obviously, we can run into any sort of error, which we will catch using config error. And yeah, we can just print out logger.warning, and then we can say skipping invalid system config. Then we pass in the system path. Now we have to create a logger as well, which we can do at the top. So we have import logging, then we create a logger dot get logger, and pass in the name like that. So we have a logger. Great. Now we can scroll down and we have the config dictionary initialized. Awesome. Now, another thing that the user can do is instead of setting a system config path, they can also set a project specific config path. So yeah, this place is where system level definitions are done. Okay. But what they can do is also go to user/revan/desktop/AI agent, which is this particular folder. And in there, they can also create a config.toml file, or specifically they can just have .ai agent folder within which they have a config.toml file. You can just have any path of your choice. I'll probably go with this. And what this project wide configuration does is that for this project, the project we are dealing with, this AI agent project, it will follow the configurations mentioned over here. So let's say if you have both of these configurations defined, it will give priority to the attributes mentioned over here. So essentially these attributes will override the config.toml attributes. So let's create a function to find the project config. And that is actually quite straightforward. We can have def get project configuration. Then we get the current working directory, whatever directory we are in. We just have to check the .ai agent folder of that directory. And we are going to return the path, right? It's not going to be a list of paths because we are only expecting to find one project configuration. And now we can just check that, hey, this agent directory should exist in the current working directory. So first of all, let's just initialize the current working directory, which is current working directory.resolve. So it will make the path absolute. And now I can just do current /.ai agent, because whatever project directory we are in, I want to go in its AI agent folder and then check that, hey, if this AI agent or agent directory is a directory, in that case, I want to check the config file. So we have config file is equal to agent directory, and then you pass in the config file name, which is this particular thing, config.toml. And then I can go ahead and check that, hey, if this config file is a file, then I'll just go ahead and return this config file that we are on, right? Because we have found out our configuration, project specific configuration. Otherwise, I can just return null, and the return type of this can be path or null. Now I can take this get project configuration and call it over here, where we are trying to get the project specific configuration. Now I can pass in the current working directory here, which we have already initialized, or which we have already taken from the parameter. And now I get project path. Now, if that project path does exist, in that case, what do I want to do? Well, I want to take whatever path was present there and I want to merge it with the config dictionary. So we have parse toml, and then I'll pass in the project path. That gives me the project config dictionary. Now I want to take this project config dictionary and merge it with the main config dictionary, this particular thing. And since we've called parse toml, let's just do try except as well. So we have try over here, and let me just have that. After that, we also have except, and yeah, here we go. How do I merge this config directory and project config directory? Well, I can create a function that will recursively merge the two dictionaries, because we have to do a deep merge. A shallow merge is not enough. A deep merge means if the values of the dictionary have another dictionary in them, those are properly copied as well, and references are no longer kept. So at the top, we can just create merge dictionaries, where we get a base dictionary, which is string any, and then we get the overriding dictionary. What is the dictionary that is going to kind of rule? Whose rules are we going to follow more? And obviously this is going to return a dictionary of string any. Now we are going to have result is equal to base.copy, because, well, the result is first going to have base, and on top of base, we'll override all of the items, right? So for every key comma value in override dot, let me type it, override dot items, what we are going to do is check if key is in result, and if the result at key is also a dictionary, right? So that means in the base version, we have a key, and the value of that is a dictionary as well. And this value that we are talking about also is of the type of dictionary. Let me just type out dictionary correct. Then what do we want to do? Well, I want to recursively merge the dictionaries. So we'll have result at key equal to, and then we'll call merge dictionaries again, where we'll pass in result at key, and then we pass in the value. Otherwise, it's not a dictionary. We have a simple life. We do result at key equal to value, and then finally, after all of the for loop iterations are done, we return the result. So yeah, let's understand this again. We are going through every item in overrides, and then we are checking if it's present in the result dictionary, which is this one. And then we are checking that result at key, the value of this base dictionary is dictionary, and the value of this override is also a dictionary. That means we are trying to merge from base, or we are trying to merge from override into base, and both the keys and the values are essentially similar. So we are just doing result at key is equal to merge dictionaries. So we go into that dictionary, right? We go into one dictionary. Let me just give you an example. Let's say we have A, B, C, like that, correct? So what we have done is check that, hey, if A is in the base dictionary and the value of this thing is a dictionary as well, and the other dictionary that we are trying to merge within this dictionary, let's say it goes with A, B, C as well. So this value is also of the type of dictionary. Then we'll just go into this dictionary and check all of the keys within that dictionary. That's why we're doing it recursively. Now we can just take this merge dictionaries and call it in over here. We call merge dictionaries. The base dictionary here is going to be the config dictionary, and then we have the overriding dictionary, which is project config dictionary, and this is going to be the config dictionary value. Another thing I would like to do here is for again check that, hey, if the current working directory is not in the config dictionary, then I'll just set config dictionary to current working directory. All right. Now this is probably not required because in config.py, we have told that if we don't find the current working directory, the value should be path.cwd. But anyways, this is good to have for now. What we can do is also load up the developer instructions, because as I told you, developer instructions will be present in agents.md, and I want to read them. So if the developer instructions, let me just have that, if developer instructions are not present within config dictionary, in that case, we are going to read the agent.md file. Where is the agent.md file going to be? It's going to be in that specific project itself. So similar to this get project config, we are going to have an agents.md file as well. So we have get agents.md file. Let's not call it agents. I think agent.md files is good. We pass in the current working directory, and now we are just trying to get the files of agent.md for this project, and there's only going to be one agent.md, right? So we can check here that, hey, if a file with .agent.md exists, then I want to use it. And where should I check it? Well, I'm not going to check it in the AI agent folder, because agents.md can be created in the root itself. They don't have to be created within this specific folder. So I'll just remove this line. We'll just check if current is directory, and if current is directory, then we have a config file, or actually agent.md file. So let's just call it agent.md file, which is equal to current, and then we pass in the agent.md. So let me just say agent.md file, which is equal to agent.md. Okay. Now we'll just use this agent.md file. and pass it in over here. And then we can check that, hey, if the agent MD file is a file, in that case, we will try to read the content. So content is equal to MD file dot read text. And let's just call it agent MD file dot read text. And then we can pass in the encoding if you want. I think the default is also UTF-8. And then we can just go ahead and return this content. I think we can also do a try and except here, but I'm actually too tired to write it out, so I'm not going to write it. But yeah, that's good enough for now. I can take this get agent MD files and call it in. Then we can pass in the current working directory as well. And then we can have agent MD content, which is equal to this. Now, if agent MD content is present, then I will just override, right? Or actually not even override, because developer instructions were not even present. So I'll just set developer instructions to agent MD content. And now finally, after all of this, I am going to do config is equal to agent config, or actually I just have to call it config. And then I can pass in the entire config directory or dictionary after I've deconstructed it. And then I can return the config. One thing to keep in mind here is that while doing this particular line, we can run into any sort of error. So I'll have a try except here as well. And that is an important line. So let's say we run into any sort of error. In that case, I will raise a config error again. And this time we can pass in invalid configuration. We'll pass in E from E. And yeah, that looks good to me. I hope it works out. So we can go ahead and try it. We can go to our main.py, where we are going to go to the main function and here define our configuration. So we have config is equal to load config, and we have to import it from config.loader. And then I can pass in the current working directory, which is, well, it needs to be passed in from the terminal. So here we can just take that as an option. So @click dot option. So command meant that this entire thing is now a CLI tool. Then you have argument, where you don't have to specifically pass in -- prompt, but now with option you need to pass in the current working directory. So you can pass in --cwd, and it's also often that you'll be given -c as well. So if you have a double hyphen, generally people also provide a single hyphen command, which is shorter. And now you can set the help to be current working directory. And then maybe we also want to give it a type. What is the type that we are expecting in this current working directory? Well, it should be a path. So we have click.path. The path should exist. So click will do all of that for us, which is great. If it's a file, are we okay with that? No, the current working directory should be a directory. And obviously the type should be of the type path. So we have initialized that current working directory, and now we can take that from the parameter. So we have current working directory, which is of the type of path or null. And now in load config, we can try to pass in the current working directory. And that is our entire configuration. Now let's say we run into any sort of error here which we have not already caught. We will just do try except exception as E, where we just print out an error. And I think we've already defined how the error is going to look like, because yeah, we do have console.print here. So let me just print it out here. This is given out to the user. This is not something related to a logger. Everything that we did over here is related to a logger. So if we run in debug mode, we'll be able to know it. And yeah, so let's just pass in configuration error, and then we pass in E. Good. After we have the config, I would like to validate it, and I've already created an instance method for it. So we have config.validate. and it will give me a list of errors if they exist. And if the errors exist, then what I want to do is for every error in this error string, I just want to print it out so that I can display all of the errors to the user at the right time. Also, I did not pass in the error tag here. So let me just do that. And similar thing should be done over here. So we have console.print, we pass in the error, and that's it. And maybe if there are errors, we might want to exit out. So I do system.exit where the status code is 1. And then we can initialize CLI after that, because, if we're running into errors, why do we want to instantiate the CLI thing? Why do we want to waste any resource? And yeah, that looks good to me. Now let's try to start something up. So we have python main.py and we run into error. And that is related to invalid escape sequence. Now to avoid that, I can just use double backslashes everywhere. So that should be fixed. Now let's try to do it again. And it says no module named platform directories. That's because we have to install it. So in this virtual environment, I'm going to do pip install platform directories. By the way, whenever I'm running python main.py, what am I expecting? I'm expecting an error. The reason for it is we have not set an API key. We have not set a base URL, and it should be set through the environment variables. That's why this is a good check for us that our configuration is working. Now we get no module named TUMLI because that should also be installed through pip. So let's install that, and there we go. After that, hopefully it works out. So let's run it, and we do get the error message. It's incorrectly formatted because probably \error is not the way to go about it. Maybe it's just /error. I keep getting confused with that. Now let's try to run it again, and we do get the right variable. So that's great. Now let's try to set the API key and use it everywhere. So just so I remember, what I'm going to do is check for the API key wherever it's used. I think it's only used in OpenAI client, so I don't have to worry too much. But for the model name, we'll have to probably worry because there's a lot of places where I passed in the model name. So yeah, the API key is over here. We can just remove it from here and use the configuration instead. We can either take the configuration from the constructor or instantiate the configurator over here. So instead of doing load config every single time, in every single class, we'll just take this configuration object from the constructor. Now we have self.config equal to config, and now I can use self.config.base URL. Similarly, we can use, oh, by the way, let me just put the comment of my API key here because I will forget it. And I'll cut this out so that we can use the base URL. This should be API key, my bad. And yeah, this is the base URL. I'll just copy them whenever I have to from here, or I can put it in my environment variables. Either one of them is fine. By the way, if you're wondering how do we create an environment variable, you just do .env and pass it in. But that's not the route I'm going to take. I'm just going to call export on this thing, and I'll show to you what I'm going to do. But yeah, so I've passed in the API key and base URL. That's good. Now let's try it and run it. So first, I'm just going to copy this entire API key. Then I have export API underscore key equal to this URL or this API key. I don't know what I'm saying. Then I can pass in export base URL is equal to this thing. It's a bad assignment. I can't leave any spaces. So, yep. And now I can try running it. So I try running it and I run into an error. LLM client init missing one required positional argument config. So that means the loading configuration part worked fine, but now we have to pass the config through the instantiation of the LLM client. So there we go. Now I can pass in the configuration, which is, well, how do I pass in the configuration? The agent is also going to take the configuration from here, and we'll import it from config.config and pass in the config here. As simple as it gets. Now, obviously, the next step is taking all of these things and pushing them within a session. what we're going to work on next, because much of our features depend on this session. And again, I'll explain to you why we need a session. But yeah, now whenever this agent is called, which is 2 times, one in run single and then in run interactive. And by the way, we are getting multiple of these agents because there is a function called user agent, default user agent, all of that. If you want to specifically check for this agent where A is capitalized, you can turn on this match case and we get the places where agent is called. This is scripting.py, which is in virtual environment. What I'm interested in just main.py, which is 2 instances. Then I can pass in the configuration. Now configuration needs to be taken in from this constructor as well. So we have self.config equal to config. And I just realized even in agent.py, we have to do self.config is equal to config. And then maybe you can pass in config, you can maybe pass in self.config, both are fine. But the reason we need self.config is because in these functions, we'll be using the configurator. And coming back to main.py, we have self.config equals config. Now I can just pass in self.config here. Then in the run interactive mode as well, we pass in the config. And finally, whenever the CLI is instantiated, I'll pass in the config. Now, if you want to avoid all of this, this is exactly the reason why people created dependency management solutions. So we can just pass in config here. But yeah, you can just find a dependency management solution so that you can pass one object everywhere. But yeah, I'm not doing all of that for this tutorial. I don't want it to be so long. It's already pretty long. And yeah, I think now we should be able to get something up. So we run python main.py. That's great. Now let's see if it works. So I'll just pass in a message. Does it work? And I'm expecting an assistant response. And yeah, I do get, could you clarify what you're referring to? That's good. I'll exit out of here. And now I would like to go ahead and test the config.toml file, right? I told you that this config.toml file can either be created in the project or in the system-wide part. So let me first try out the system level configuration, and it should be somewhere over here, user/Rivan Ranaut for me. And now I'm just going to create a new folder called .ai-agent. That's how I wanted my folder name to be. And I will use dot. Then over here, I can go ahead and create the config.toml file. Now I don't have the option to create a new file and I don't know how to create from here. So what I'm going to do is just create a file over here. So I'll close all the save file. Then I can say create new file, and I have created .ai agent in config.toml. So I created, and here we go. Now, what are the things I'm interested in? I'm interested in changing the model name. And to change the model name, first I have to give it a heading of model, because if you go to our config.py file, you'll notice here we have model config, right? So first I have to pass in this model, and then over here I can set the name, which is, let's say, a new OpenRouter model. I don't know what OpenRouter models are new. It's been a while since I've been recording, but let's try to use this one, the Xiaomi model. So I'll pass it in over here, and let's see if that gets included. I'll keep the config.toml file here. This is a system-wide config.toml file. Now, obviously, we won't be able to see the effects of it because everywhere we are using the hard-coded Mistral AI configuration. So what I like to do is search for this Mistral specifically and change it everywhere to use the configuration object. So we have self.config.model name. Great. Now I can just copy this line and paste it everywhere. So another time is in the context manager. So let's just put it here, and there's no self.config here. And there's no self.config here. So first I'll have to create this config, or actually get this config. Then I have self.config equals to config. I don't think we really need to do this, but anyways. And now whenever context manager is called, I need to pass in the model name. But anyways, in the read file tool as well, we will require this configuration. And maybe if we don't pass in the model here, it should be fine, because in count tokens, how long are we going to keep passing in the model? So maybe here we can just hard code it to GPT-4, and obviously if it doesn't get the model, it will error out or something. So that's all right. And now we can remove it from here, just taking the shorter route. So yeah, now whenever we have the context manager initialized, I want to pass in the configuration object, and that's done in agent.py. So here we can just pass in the config like that. Awesome. Now let's try to run it. And actually, I want to ensure that on the welcome screen as well, we are showing the correct model that's being used. That is the best indication of what model we are using. So we'll come back to main.py, where at the top, we had something like this welcome screen, and here we also hard coded it, correct? So let's change it to config. We have an F string already. This should be easy. Self.config.model name. Great. Now we can try running again, and we still see Mistral model being used. I realized why I was running into an error, and it was because the config.toml file was located in the wrong place. So now to fix it, what we have to do is put it in the right place, which is, well, in your root folder, followed by library, application support, AI-agent, and then config.toml. If you're on Linux or Windows, it will be different for you. You can search web or ask AI, and it should help you. You can ask your own AI agent actually, and it should help you out. So yeah, I've passed in the model. By the way, this model should also be placed like this. It shouldn't be like this, because this refers to a list. So when we try to have MCPs, or when we try to have hooks, that's when we are going to use something like this, because it is list. When we are trying to have model.name, it's not a list, we will have a single bracket. So now let's try to run it. So I'll have python main.py. It loads up the correct model, which is great. And now I can say, hi, how are you doing? And then it can start running. It says, I'm good, thanks, ready to help you. Now what I would like to do is exit out of here. So I have \exit. And now let's try to use a system level configuration. For system level, I just have to go to my current working directory. Here I'll create .ai/agent. And then here I'm going to create config.toml. Here I can set the model, and the name can be different. Let's say I try this Alan AI. I think this will give an error because it's probably not agentic. So yeah, we'll see. Let's try to run it. It does load up the model, and now I can ask it, hi, how are you doing? And it gives us an error, no endpoints found that support tool use. Whenever you see this error, it means that the model probably doesn't support tool calls. And that's why we're running into this error. And let's try to exit out of here. Yep. So the system-wide configuration also works. Now let's close all of the save files, and let's try to go to loader.py file. Let's go to config.py actually. And here, see what do we have. We have a model. We have current working directory, and we know multiple places where we use current working directory, like path.cwd. So I'll just search for this in the entire code base. I see this place. Instead of using this current working directory, I have to use self.config.cwd, correct? And I'll use the same thing everywhere else. So I'll go to this agent where I have my agentic loop, and I can call self.config.currentWorkingDirectory. Then I can pass in the TUI instead of self.cwd like this. We'll have self.config.cwd. And now I need to get the config as well, which is just config. And let's try to import config from config. And also let's import it above console, because there can only be one. And let's try to import it above console. Okay, great. Now we can just do, well, let's also do self.config equals to config, and then self.config.currentWorkingDirectory is initialized. And finally, in the load config, we are passing in the current working directory, and that's all right. So yeah, I think this should be it. Now, one place, which was the TUI, we passed in the config, but we have not passed it to the instance. So whenever we initialize TUI, I would also have to pass in the config, which is this part. Great. Now let's try to run it again. And I have to remove this model name. Instead of this model, I would like to set the temperature to 0. And let's see how that works, because we'll get the most likely output. It would be interesting to see. We go back to the Xiaomi model and I say, hi, how are you doing? Read main.py for me. And it says, I'll read main.py for you. It calls the tool and executes it. Perfect. So yeah, everything seems to be working. So now let's try to pass the max turns and max tool output tokens. Some places we have hard coded what the output tokens should be. So wherever we call something like truncate text, like we have over here, and here we have the max output tokens. The max output tokens is set to 25,000, but here instead of having 25,000, you can depend on the max output tool token to be passed through the config.tuml file. But to me, it sounds not at all useful. Nobody would like to manage this. So I'm just going to remove it out of our application. But it was a demo to show that you can set something like this up. You can also set max turns. We also have developer and user instruction. And I told you that these developer and user instructions, which we are looking for in agents.md file, will be attached to the system prompt. So let's go ahead and update the system prompt. So at the top, we'll add two other things after operational section. We have if config.developer instruction, we'll add get developer. And if user instruction, we'll add get user instruction. And now obviously we need config from the parameter. So let's import it from config.config. Now let's create the two functions, get developer and get user. You can obviously go ahead and copy paste it from the GitHub repository mentioned, but essentially these are just like project instructions. The following instructions were provided by the project maintainers. These are the instructions, and follow these instructions carefully. The same for user instruction. The user has provided following custom instruction. You pass it in. I don't think there's a lot of difference between them, but yeah, I've seen some code base do this, so I just thought of doing it myself. So yeah. We have developer and user instructions in. After that, we are going to add the operational guidelines, because operational guidelines are kind of like a summary. We want these things to be at the top of the mind of our AI agent. That's why we are putting it towards the end. So yeah, as of now, these things seem enough. There's obviously more stuff we can add, and we'll probably look into that once we add all of the tools. But yeah, this is good enough for now. The next thing I'm interested in is whenever the system prompt is called, like we have over here, I want to call the config init, right? So we'll just pass in the config as it is. So that's also good. Now let's go back to our config.py. So developer and user instructions are also used. Now we have max turns. What is max turns about? I told you, max turns is just the maximum number of turns our AI agent can go through. And I also explained why we need that. It's just to prevent infinite loop. So now what I like to do is make use of this max turns as well. So we'll go to our agent.py file where we have our agentic loop. And here, before we do this async for loop, we're going to wrap this entire thing within max turns, because all of the chat completion stuff we are doing, talking to the LLM, executing the tool call, that comes under the turn, right? So above that, we're going to go over a loop, and for each turn, we're going to call this. So at the very top, we're going to have max turns is equal to self.config.max turns. And for turn number, or you can just say I, it's not going to be useful, in range of max turns, what are we going to do? Well, we're going to execute everything that we see over here. So all of this comes under this for loop, okay? But here comes another problem. Let's say the range is 100, right? So we'll keep going for 100 turns. Now the problem is, if you keep going for 100 turns, that means, let's say I say read main.py file. That only requires us to go for one turn. So it does this one turn. It reads the file for me. Okay. After that, the LLM is again called with the context given. And then what will it do? It has already completed our task. So how do we know that we want to get out of this loop? Well, we want to get out of this loop that we have until we don't have any more tool calls to do. Now let me make it completely clear. What is this turn going to do? Well, let's say I give my agent 4 tasks. I tell it to read my main.py file. After that, it has to go and update the main.py file to fix any bugs. After that, it has to review the main.py file, and then it has to write tests for main.py file. Alright, so these are too many tasks I've given in one message, but the LLM should be able to do it. But now the problem is that if I call chat completion first, the chat completion will say, hey, let me read the file first. Okay, so it reads the file, it executes all of the tool calls, and then the turn just ends because the tool call executes and we add it back into the context. But here's the problem. It won't do the remaining tasks. It just stops because all the tool call executed. But in reality, the LLM just told us that, hey, listen, I need to read main.py. There's more stuff to do. But first, I have to read the file to notice any bugs. And that's why this fails. The user will have to rewrite the message just to get the agent to perform the next action. And that's why we are adding these turn related stuff. So here comes the bigger question. How are we going to stop this LLM from executing if it's doing it 100 times? Let's say the LLM goes and does an operation. It takes in 6 steps. Alright. So 6 turns are taken. It reads the file. Then it fixes the bug, so it uses write operations, and then it reviews the code, it reads the file again maybe, then it reviews the code, then it writes the tests for it. So, these many steps are being taken. But now, the range we have specified is 100 turns, but in 6 steps, the entire thing was done. Or if we give a simple message like read main.py file for me, that's 1 step. Why should the LLM keep going for the rest of the 99 steps? And that's why we need to figure out a logic to break outside of this loop as soon as the task is done. And we're saying that the task will be done as long as there's no more tool calls to do. That is what this agentic loop will do. This is how Pydantic AI works as well. If there are no more tool calls to execute, the agentic loop is over, we're out. And that's easy for us, right? We know exactly how to check if there are tool calls or not. So once we add the assistant message and if there's response text, we yield it. Just before executing these tool result operation, we can check if not tool calls. That means there are no more tool calls to do. In that case, we'll return out of here. There's no more stuff to do. The entire agentic loop is over. This simple line will help us get out of this turn. For simple LLM apps, it won't do that agentic workflow as of now. I've been seeing Claude do that agentic work now, and hopefully ChatGPT will also do it in the future. But as of now, one message refers to 1 turn in LLM apps. In agentic apps, it can refer to 7 or 8 turns. So yeah, this is the entire agentic loop. This is configured through the configuration system. And now, whenever we want to add a new feature, it will probably be toggled through the configuration system. For example, safety policies, approval policies. All of that can be configured through our configuration system. But what I like to do is test our application for one time more. I'll say read main.py file. Then I'll tell it to read prompts/system.py file and done. So let's hit enter and see what it does. As you can see, it is doing all of that, but it did it in just 1 turn, I believe. It gave us 2 tool calls together and we execute both of them together. So in just 1 turn, we are able to do both. But when we have write operations, obviously it will require 2 steps. Because as I mentioned, and I'm just drilling this concept into your mind, so forgive me for repeating, but the point is, it has to read first, then it goes into the context, and then it is able to write. So that's why the other turn is required. Because if the LLM doesn't know the file's content, how can it fix it? Even for you, you have to read the file first, to understand what changes to make, right? So anyways, this was done and it also read the system.py, and that is the entire thing. Cool. Now let's go ahead and create a session. In that session, we are going to have multiple things, but the main point is creating the context manager within it, creating the configuration system or the tool registry within it, the LLM client within it, all of that within a session. And again, the reason for that is we can have multiple sessions concurrently running. If that is the case, if multiple sessions can run concurrently, each one should have its own LLM client connection, because in one project, you're connected to one LLM. In another project, you're connected to another LLM, because each one can have their own config.tuml, right? Then you have context manager. Each one maintains its own context. Each one has its own tool registry, and this will be clearer. Why? Because we are just not going to have default built-in tools. We are also going to have tool discovery, which can be very specific to the folder you are in, the project you're working on, or it can be system-wide, I believe. Then there are hooks, which will also be present within session, and MCPs, obviously, which can also be specific to one project. So that's related to tool registry. But anyways, enough talk. Let's just get into session. And after that, we'll composite everything within a session. Lots of stuff to do. Let's get into it. So I'll open up the sidebar, and over here in the agent folder, we are going to create the session.py file. Now within this, we are going to have a simple class session, and then we're going to have an init function. In this init function, we're going to instantiate, well, everything that we instantiated in agent.py file. So let's take this config. We'll need the config. Let's take it from here, pass it in. Cool. Now we have to take the config from the constructor as well. Let's import it from config.config. After that, the next thing we'll require is the client as well. So let's have self.client equal to LLM client. We'll import LLM client here. After that, we will require the context manager and the tool registry as well. So everything just gets instantiated over here. I think cell.config.config, like the config thing, also needs to be instantiated over here, because config, I believe, is being used somewhere down here, as you can see, for the current working directory and even for some other thing, the max turns, yeah. So we will have to instantiate config here as well. So let's just do it. And then we are going to create an instance of session here, which will be used every single time. Now for context manager, we'll have context.manager, import context manager, and then we'll also import default registry. That looks good to me. Now, all the other things that we're going to initialize here are going to be related to, let's say, compression or loop detection, or let's say a hook system or the MCP manager. Everything will come in over here. There are some things that we will still require, like the session ID. So I'll just create it here itself. We have self.session ID equal to string, and then we have UUID. We'll import UUID. It will just help us generate a unique ID, because a session ID just needs to be unique. Now you might be wondering, why do we need a session ID? Well, it will be really useful because let's say we have multiple sessions and we know in the future we'll be adding functionality to save a session. So if you are in a session and you want to save it so that you can come back to it later on, the session ID will help us know that. So this will be the unique identifier for that session. Then we also have created at and updated at, which is also going to be shown whenever the user wants to view all the saved sessions, or when checkpointing is there, because what time was the session created, what time was it updated, we have to know that. So the self.created at is over here, and the updated at is also present. Updated at will change whenever, we add a new turn, or let's say we try to save a session another time. So let's say we have a session, we save it, and then we come back to it 2 days later, and then we again save the session after making some changes in it. Let's say I asked another message to my agent. That will trigger the updated at. Created at will remain a constant. So yeah, that's about session. We'll just create one function, which is to increment the turn count and just return it. So we'll have def increment turn. where we'll get self, and the point of this is just returning an integer. What this will do is keep track of a turn count, which is something we'll have to create right at the top. So we have self dot turn count. This is a private variable. It shouldn't be visible outside. The point of this turn count is to, have some sort of statistic about how many turns have already been taken place, right? So let's say I save a session. Okay, I had 20 turns, then I save the session, then I go create another session that has, let's say, 10 turns in it. I save that as well. Then I come back to the first session. Now I want to resume from this 20 turns, right? I want to discard these 10 turns and start from this 20 turns. So first of all, I need to know how many turns there are. Once we get to know how many turns there are, I can just resume from wherever I left off. So that's where this turn count will help us. Also, to display it as a statistic to the user whenever, they want to inquire about what is the usage of this session. How many tokens have we used, or how many turns have been taken place, how many messages are there, all of that. So let's remove it, and all we need to do here is plus equals 1, and since we've incremented a turn, that means we have to update the updated at as well, because if this agent does one thing, you've updated the session essentially. So let's just copy it and paste it down here, and then we can just return the count that we have right now. Return self.turn count. So these are the two methods as of now. Later on we are going to have many more, because we'll have to create a checkpoint, create a session, list the sessions, resume a session. So yeah, lots of stuff to be done there. But for now, good enough. Now come back to the agent. We'll remove the unused imports, where this is the part of refactoring I was talking about. And now I can just use this session everywhere. So I have self.session is equal to session. So I'll import from agent.session. So whenever I create a new session instance, all of them are created. And now instead of using self.contextManager just like that, we'll do self.session.contextManager. Cool. Now same thing for everything else except for config, because config is instantiated correctly. For tool registry, we'll have self.session.toolRegistry. Then I'll copy again, and then we have context manager again. Let's just paste that in. Another context manager, we'll paste that in. Then we have tool registry, we'll call that session again. And then in the context manager again, we'll just pass in session. Now one thing we've forgotten to do is remove the self.client, because, well, the client is never there. So what we need to do instead is, if the self.session.client exists, in that case I want to do self.session.client.close, and then we'll do self.session.client is equal to null. And actually what we can do is just set the entire session to null, right? Because, well, whenever we exit this agent, the entire session is over. So we can just check that, hey, if the self.session is present and self.session.client is present, then we'll close the client connection, we'll set client to null, or we might just set self.session to null. If we set this to null, everything else will be garbage collected, so client will also be null. That looks good to me. Now I just have to go at the top and update this session to either be of the type of session or null. That's good. Now I just need to ensure that wherever we are using context manager, we just change it back to session, and yeah, that looks good. We've only created context manager in one place, which is session. So we can give this a shot. Let's see if this works. Let's run python main.py, and we run into an error. It says session requires a config, and I did not pass that in. So let's go to agent.py, and here we can pass in self.config. That looks good. Let's run it again, and now we have another error. Module datetime has no attribute now. And the reason for that is something like this. So if we go to session again, and here we imported datetime, correct? But datetime is a module. So instead of doing just import datetime, we'll do from datetime import datetime, and now it should work fine. So we can just run this again, and yeah, we have the model with us. Now we can try to run something. Hey, how are you? That seems like a good message, and we run into an error. Agent object has no attribute client. We forgot to change the session somewhere. So we'll just search for self.client, and yeah, we have to do self.session.client over here. Now let's try to run it again. So, yep. Hey, how are you doing? Read main.py file for me. And yeah, it does give us the response, but the tool calling fails and we see the error message, agent object has no attribute tool registry. So somewhere we called self.agent.tool registry. Instead, we need to do self.agent.session.tool registry. So we'll just search for self.agent.tool registry. We called it in main.py. And now we'll just update this to be self.agent.session.tool registry.get. And yep, that's it. We can try again. Again, I'll put in the same message. And now let's wait for the response. And yep, that works out. It says I'm doing well, thanks. Let me read the main.py file, and it's able to read all of the 147 lines. So yeah, that's about session. Now we can close all, or actually we forgot to do one thing. So I created the function in session called increment turn. Now I'll just like to update this self.turn count, right? Just in case in the future we want to display this turn count out in some way in the session, we'll be able to just use this turn count. So let's just call it, and it's quite easy. We just want to increase the turn count whenever we have a new turn. So we just have to call the function somewhere in this for loop, right? Because we're going for every turn here. And I say we can just do it over here. So we'll have self.session.increment turn, and that will give us a new turn number. If you want to do something with that turn number, go for it, but it doesn't really help us. So yeah, we'll just keep it like this as of now. Just in case we want to use it sometime, we can. There's no harm. So this is a good refactoring to do. Now we can close all of the save files, and now we can again start working on the next aspect, which is adding all of the built-in tools now. So we have read file with us. The next thing I would like to work on is write file. So let's go ahead and create the class called write file tool, and this file tool is going to extend the base model. It's going to extend the tool that we created in tools.base. And then we know we need to define some things, some attributes like name, which is going to be write file. This is the name of the tool. Then we have a description, and we know the description can be quite a bit long. So instead of writing it out, I'm just going to paste it, but we'll go over this. The description is write content to a file, creates the file if it doesn't exist, or overwrites if it does. Parent directories are created automatically. Use this for creating new files or completely replacing file contents. For partial modifications, use the edit tool instead. So in the tool description, we are specifically pointing out what this write file tool is used for. Even in our system prompt, we mentioned something related to write file and edit file differences. We're going to add that part of the system prompt later on. But yeah, it is important to point out the difference in the places where it matters. For this one, it really matters because if the LLM is deciding what tool to call, we need to tell it that, hey, this is only for writing or overwriting. If you want to make edits, there is no point rewriting the entire file with your edits present in it. Just use the edit tool that's already present. So yeah, that's about it. That saves us tokens, by the way. Now we can just say that the kind of this tool is tool kind. We need to import that from tools.base as well. And this is the write tool, right? So that's it. Now we need to define schema. Now the schema for write file, what is it going to look like? Well, we can have write file params, and then the base model will be extended. And it's not going to come from Anthropic. You need to import it from Pydantic. I'm not getting the auto import, so let me import it myself. And there we go. After that, we can define the path. Which path do you want to write in? And that will be a string. Then we'll pass in the field. From Pydantic, we'll import the field, and rest of the fields are going to be the same except description. In description, we're going to say path to the file to write. What does this parameter do essentially? We just want the path to the file to write. and this should be relative to the working directory, or it can be absolute as well. That's important to point out, and I think we also did that when we were in read file, correct? So yeah, that's it. Now another thing we can add is a folder. So if you want to create the directories or not. So let's say the path is something like this, where you have config slash hello slash main.py. Cool. So, we have to create the config folder if it doesn't already exist. We have to create the hello folder if it doesn't already exist. And then you have the main.py file. That's what we're doing here. That can be one argument that we'll add, and that will be called create directories. And that will be boolean, which is equal to field. And then let's give it a default value of true. And let's say if the LLM says you don't have to create directories, it can be set to false. And then you have a description, which is create parent directories if they don't exist. By default, it is true, and in most cases, the LLM will not really care. True value makes a lot of sense, but good to have that in. And one thing I totally forgot is content, because we are writing to a file, but what is the content that we are trying to write? That comes in as well. And then the description, which is content to write to the file. Cool. So that looks good to me. Now I can just take this write file parameters and specify it as the schema. So yeah, that's it. Now let's go ahead and define the execute function. So we have async def execute. Here we're going to get self invocation, just like we did in read file. Then we get tool invocation here. Let's import it from tools.base, and we're going to return tool result. Remember, we have made our structure of code so interesting that we only have to define this write file tool. Then we need to go in the init.py, and here we need to specify the built-in tool as write file tool, and let's import it from tools.builtin.writefile. And now everything should work as expected. This is how elegant our solution is. We have to create a new built-in in this folder, and we have to define the execute, get confirmation, all of those functions, and then we can just pass in the class over here, and we know get all built-in tools is called within the registry, and from the registry we have get default tools, all of that thing, create default registry. We are exposing that out into the session, and the session is being used within the agent. So this makes it really easy for us, because we don't have to edit any of the existing code base by a lot. We only have to edit one file, which is the init.py, where we just have to add a new tool, and the rest is just creating a new file from scratch. So this is one of the solid principles, especially the O, which is open or close principle, meaning the code base should be open for creation but closed for modification. But anyways, let's just come back to this. We have the invocation, which is giving us a set of parameters. We just need to convert that into write file parameters. So we have params is equal to write file params. Then we'll pass in the invocation.parameters by deconstructing it, similar to what we did in read file. Also, we get the path from this invocation. So what I want to do is resolve that path. So I'll just call the resolve path function, which is coming from utils.path. We've already used this many times before. So we have invocation dot current working directory, which is going to be the base directory for this resolve path. And then you have the path parameter that is passed through this parameter, right? So we have params.path. So if you're having difficulty understanding, the invocation.current working directory is wherever we are in right now, whatever folder we are in, and params.path is what the LLM is telling us to write to. And now we're just resolving the path so that we have kind of an absolute or a total path so that we can directly write into it. Now we first have to check if this is a new file or not, because if this is not a new file, then we have to read the existing text, because it will help us in creating a diff. Diff is especially useful when you have a file that already exists. Okay, so let's say I have this write file. I tell my agent to continue writing this function. So, it starts writing all of these things. It completes it, but then it realizes that maybe I've made some bug somewhere over here. So it just decides that instead of using the edit tool, it will be more convenient to just use the write tool, because that will get our job done easily. So what it will do is just rewrite this entire file. And if it rewrites the entire file, the diffing view will help us show the minus and the plus sign. So let's say we had a bug over here. It just removes that line and replaces it with its own. So that is a view that will be given to the user, kind of like Git, or especially GitHub. Also, this will be something that we can probably pass through the metadata then when we try to return a tool result. So that will also be useful. So let's just track this. If it's a new file, then we'll just have not path.exist, because if the path already exists, it's not a new file. And now we can just check that, hey, if it is not a new file, in that case, what I like to do is store the old content. I would like to read the text. So I can just do old content is equal to path.read text. And now I can, let's say, pass in the encoding if I want. The encoding can be UTF-8. Let's put it in a try and catch block. So we have try, except, and if we run into this error, I'll just pass, because even if the old content does not exist, I don't want this entire function to fail, because it's not the most relevant part of our execution tool. The most relevant part is writing to the file path. So we will carry that on even if you're not able to read this text. And yeah, so that's it. Also, this old content is not defined if we run into an exception or if the file does not exist. So let me fix that by having an empty string outside of this if condition. Cool. Now let's try to create the parent directories if it's needed and then write the file. So we'll have a try block here. Let's just put an except as well. And there'll be specific errors. One of the errors we can run into is OS error. So let's catch it as E, and then we'll just return tool result dot error result, and then we'll just say failed to write file, and we'll pass in the error string. That's it. Now let's try to create the parent directories if the parameter says so. So if params dot create directories is true, in that case, we want to ensure that the parent directory already exists, right? And that is actually not very difficult. All we need to do is create a new one using path. But it is a reusable function which I can use across multiple files. So I'll just create it in utils paths.py. And here let's just create a new function, ensure parent directory. This will give us a path which can be a string or a path object itself, and it will return a path no matter what. Then we have path is equal to path, and then we pass in the path string or the path object that we get. And then we have path.parent. So it will just go to its parent directory, the logical parent. And then you have make directory passed in. Now the parents is equal to true. And if they already exist, then we don't want to return any error because it's totally fine. Our entire point is just ensuring if the parent directory is there, and if it does not exist, then we just create the parent directory. And then we just return the path from here. Now we can go ahead and call this function over here, ensure parent directory. Let's import it from utils.path, and we can just pass in the path over here. It is this path, alright? Now what if the path.parent does not really exist? In that case, we would just like to give out an error saying that, hey, this path does not exist. What are you really talking about? Because maybe the LLM hallucinated and it will do the wrong thing. We don't want it to do the wrong thing. So we'll handle that case where if the path parent does not exist, in that case, we'll return the tool result with error message. So we have error result passed in, and then we have parent directory does not exist. And then maybe we can also pass in the path.parent so that the LLM has more context. Now, if this parent directory is created or it is present, our job is done. Now we just have to write to the file. So we have path dot write text, and then we'll just pass in the parameters dot content, and maybe we can also specify the encoding, which is UTF-8. And now we can just return the tool result dot success result. Now the success result will first have the output. What is the output going to be? Well, I would like to format the output in this way. The first line should have the action that was done. So did it create a new file or did it update a new file? If it updates a new file, I just want updated to be written. And if it creates a new file, I want created to be written. And then I want to specify the path where this happened. And then I want to write down the number of lines that are present. So let's just extract all of those details. The first one is action. The action is created if it is a new file that was done. Otherwise, we have updated. Then I want to show the path. We already have the path variable with us. And the next thing I want is the total number of lines. So we'll have the line count, which is equal to the length of params.content.split lines, right? Because if we split the lines, we'll get to know how many lines there are. Cool. Now let's just have the output here. So we have the first thing as action, then we leave some space, then we have path, and then we leave some space again, and then we have line count, which just says these many lines exist. Now this output is interesting, just remember it, because we might want to format this nicely on the TUI part of things if needed, but this is definitely something that's going to the LLM, right? Now in success result, there's another thing I would like to pass, which is a diff. And quickly, I'll just show you the result of the diff. So if the file was null, it will have something like this. We're just minusing null from here. There's nothing. And then we are having a print hello world. Obviously, when this gets bigger, you'll be able to see better changes. But that's what I'm talking about. A plus sign, whatever lines added, and minus whatever we deleted. So now to create this diff, we'll go to the base.py file because we have to update tool result, right? In this tool result, we have to add a new field called diff. And that diff will help us know and display hints. So this diff is going to be of the type of file diff. That is another class that we are going to create, or it will be null because, if we have a read file, there's not going to be any diff. So we don't need a file diff. But in the success result, we can take in the diff through the keyword arguments. So that's good. Now let's just go ahead and create this file diff data class. So we have @data class file diff. Then we have the path. What path do we want to create the file diff in? Then we have the old content, which is a string. Then we have the new content, which is the string. Then we have, let's have some other parameters that will also help us display some nice stuff. For example, if it's a new file, then maybe we want to add that dev null thing that was shown. So, I'm adding this dev null manually because, if it just has a minus sign with an empty line over here, it will make no sense. So if it's a new file, we'll have this. And if we're deleting a file, for example, it will also be useful then. So let's track this to two states. We have is new file, which is a boolean. By default, it is false. It is not a new file. Or it would make sense to set it to true, but anyways. Then we have is deletion, which is going to be a boolean value, and it is going to be false as well by default. And then you create a function over here, which will generate a unified diff string. The reason we have to maintain this diffing string of minuses and plus is because by default, I don't think that Rich has access to a diffing tool as such. There is no class that will help us render a diff given two strings. But in Python, there is a built-in library called difflib that we can use, and that will help us create that string. So let's just go ahead and create that string. So first of all, we'll have to import difflib. This is a built-in module, so we don't have to worry much. After that, we have to create old lines and new lines. because, well, we are creating a diffing tool, right? We have to take this content and give it in the form of lines array, and then we have this new content which you have to give it in a lines array format or a list format, and then the diffing tool will just compare and add the minus signs, plus signs wherever needed. We could really do it on our own as well, but why? Why should we reinvent the wheel? We'll just go ahead and do old lines is equal to old text. Let me get self.old content. Then we'll split the lines, and then we can just say keep ends is equal to true. Keep ends is equal to true just means that it will not remove any \n at the end if it is present. And similar to this, we'll have new lines as well, which is just equal to self.new content.split line, and it will keep ends is equal to true. Then we will have if the old lines exist. It's not an empty array or it is not null, and the old lines last element of the list does not end with a \n. Then we want to add that \n because we do want the last line to be a new line for this diff lib to work. So we'll have and not old lines at -1 dot ends with, and then we have a \n. In that case, we have old lines at -1 is equal or plus equals \n. The reason we are not doing is equal to is because if there is some content on the last line, we'll be overriding it with equal to. Instead, I don't want to override it. I'll just add whatever content exists with \n. Now I'll just copy it and paste it down again. And then we'll check if new lines exists, and new lines at -1 does not end with \n. Then we have new lines at -1 plus equals \n. After that, we can just do difflib.unified_diff. That's how you compare the two sequences and generate the delta. Delta is just the changes that were done. And then you need to pass in the old lines, then you pass in the new lines, then you need to specify the old name of the file and the new name of the file as well, which is done using from file and to file. From file is what file is the old name of the file and what is the new name of the file. So let's just create those variables as well. And this is where the is new file and is deletion will help us. So the old name is going to be /dev/null if it is a new file that's created. Correct? Because if it's a new file, we had nothing before and now we're going to have something. And if it's not a new file, then it's just going to be the string of self.path, whatever path is mentioned over here. And the new name is going to be what? Well, it can also be the case that the file is deleted now. So if the file is deleted, then we'll again have dev null. So if is deletion, then we have dev null. Otherwise, we have self.path again. And now we can pass in the old name and the new name. And this is our unified diff. Let's just store it in a variable called diff, and you'll notice that we again get an iterator back. We passed in a bunch of iterators, lists are iterators, and now we get an iterator back. I just want to convert them into a string format and return it from here. So we have return.join, and then you have the diff. I'm not doing \n because diff will already take care of all of that. We just have to join everything in this list or in this iterator. Now we can go ahead and mention the return type of this function, which is a string. And yeah, that looks good to me. We also have the file diff attached here, and in the success result, it will be taken through the keyword arguments. So let's go to the right file, and here we can pass in the diff. So let's go ahead and set diff is equal to file diff, and we have to import that from tools.base. And now I can pass in the path, old content, new content, all of that. So path is equal to path. Then you have old content is equal to old content. Then new content is equal to parameters.content, because old content is already created as a variable here. New content is just parameters, whatever we are getting from the LLM, right? And if it is a new file or not, we will know that by is new file. Great. Now we can also have metadata attached here. So the metadata is equal to, and what metadata do we want to send from this success result? Well, I would like to send the path because the diffing does not really have the path, because remember, when we have the diff, we'll just call .toUnified diff and that will give us the diffing string. But from metadata, I would like to send the path again as well, because that will be used to display to the user, so there's a clear separation. Even if you don't send it and use it from diff, it's totally fine. This is probably redundant, but alright. We have is new file. Again, you can take that from the diff as well. Then we'll also send in the lines, which is the line count. And then we have the bytes, which is, well, we'll have to do parameters.content.encode, and then we encode it in UTF-8 format, and this will return to us the bytes. Now I want to send the length of this bytes, so I have length of this. Because I don't want to send in the actual bytes, right? What is the point of that? I just want to send the length of the bytes. The reason we're sending all of that is because if you go to this, or actually you can't go over there, but if you just look at this write file tool confirmation that we have, it says path hello world.py and the content is 1 lines 22 bytes in total. That's why we're sending across the bytes, just for UI related stuff. And yeah, that is it about the write file tool. All I need to do is go to the main.py file and here just see if I'm getting any event related to tool call start and tool call end related to writing a file. So let's just print out the event here, and now I can start my AI agent. So I'll just hit enter and I'll say write Python file for me with hello world in it. Let's run it and we get agent start. Then we get text delta. Then we get more text delta. After that, we get a tool call start. We do get write file showing up with the content and the path because those are the arguments. And then we also get the write file with some output being displayed, but it's not really displayed because it's half baked, right? We've added the tool. The LLM already has context to the tool because our entire integration is so well done that we just have to create a file, add it in one list, and everything just works. But the UI obviously is messed up. If you want, you can display the content like this, but I'm not really interested in showing the content here. I would like to show a final diffing view in write file itself. So let me remove this event. Everything is working. Let me just clear everything off and run it again so that I have a more better view of what UI changes we need to make. So there we go. The arguments are showing up correctly, but those are not the arguments we want, right? Or I don't want, at least. If you want, go ahead. Also, as you can see, we have the hello.py file here because, well, the file is written. We do have the tool call saying it's completely done, correctly done. So that's good. And we don't really have to manage anything in the main.py file for this because everything is done within the TUI because that's what handles the entire UI related stuff. So we can just go down here and we have the preferred order. Earlier you saw that content was written out first and then the path. Then later on we have the path written out first and then the content. This happens because we have not specified the preferred order. So let's just parse and write file here with the preferred order. The first thing should always be a path. The second thing should always be the create directories thing that we have because, well, the content, if we're going to display it at all, is going to be the last thing that should be displayed because it's going to take up a lot of room, right? Content is always going to be a bigger string than both of them. So it just makes sense to put that thing in the end. And now we would also like to avoid dumping this entire content string here because we are anyways going to display it if the tool call is successful. So what I'll do is go to this tool call start function, and here whenever we call render args table, we're just passing in the value just like that, right? So instead of just passing in the value, we can format it a little bit. We can just say that, hey, if the key is, let's say, is content, or later on we are going to add more things like old string, new string, because the next tool we are going to work on is edit file. If it's an edit file, even then we'll have a huge blob text some sort of big text coming in, right? What was the old text? What is the new text that we want to remove? So that will be a lot of hassle as well. That's why we are creating this as a set, and we are saying that, hey, if the key is content, or later on we'll have old string, new string. Let me just put it so that, you don't get weirded out by the set. So if we have any of these, in that case, we don't want to dump that huge entire block thing that we had. Instead, what we're going to do is display the lines and the bytes. So we'll have line count, which is equal to the length of value dot split lines. Now we obviously need that value. It is this particular thing. But for that, first, we will also have to check that, hey, this value that we are dealing with is a string or not. So first we'll have if is instance value of the type of string. In that case, we'll check the key if it is in content, and if the key is content, then we find out the line count by splitting the lines. Or, if that length is not specified, we somehow return nothing from here. We can just have 0. And then we have byte count, which is equal to length of value dot encode, and we'll just convert this into byte format where we have UTF-8, and errors can be set to replace. As you can see, by default it is set to strict, meaning that the encoding raises a Unicode encode error. Other possible values are ignore, replace, and this particular thing. And if this works out, in that case, I'll just update the value that we are getting here. I would like to say that the value is now equal to fstring, where we have the line count passed in, then we are going to have lines, then we need this particular dot, and then the number of bytes. So let's put in that dot, and then we have the byte count and then bytes. And then we are already doing table.add row key value, and that should work out. So I'll save it. And that should be it for tool call start. Now for tool call complete, I'll have to find that function. So let me just search it in this file, tool call complete. Here we have already said all the logic related to creating the block. That's why we had this entire thing, but the content here is not defined. The content here is not defined because we had this logic. We are saying that if the tool is read file, then we'll do all of these things. But if it's write file, we've not mentioned anything. And that's what I'm going to do now. So if the name of the tool is equal to, let's say, write file, let me just create this write file. And if it's a success, and let's say the diff was also given to us. So if the diff exists, and now we have to create a variable called diff. And actually this diff should come from the tool call complete itself, because it's attached to the tool result. We're taking success, output, everything from tool result. So we'll have a diff which can be a string or a null value. Now wherever this tool call complete is called, which is in the main.py file, I have to pass in event.data.get diff, and if it's not mentioned, then we'll just pass in null. Cool. Just ensure you've passed in the correct positional argument. If positional arguments confuse you, you can do call ID is equal to this, then you can do name is equal to this, and so on. But these are the arguments. Nothing more will most likely be required now. So I'm good enough for now. I'll just go back to this logic. Now, if the success is there, if the diff is there with us, we are going to display it correctly. So the very first thing I would like to display is the output line. And for us, the output line was already created in the metadata, if you remember. Or sorry, in the output here, action, path, and the number of lines that were added. So let's just have output line, which is equal to output.strip if output.strip exists, and it should. But let's say in any case, the LLM hallucinates and we get an empty output. In that case, we will just write down completed, that hey, your entire thing was completed. We did not get an output as such. It was an empty string at the end of the day. So I'm just saying that, yeah, I've written the file, it's completed. And then we'll just do blocks.append output line. And now this output line needs to go within a text, because blocks is just a bunch of rendering items. and the style of this is going to be muted, somewhat of a grayish color. And now we are going to have the diff text, which is just equal to diff. And the reason we've created diff text is because we are going to truncate it. So we have diff display is equal to, and then we just call truncate text. Then we'll pass in the diff text as the value. Then we have to specify the model name. In truncate text, the model name is not passed in, but we can do the same thing as GPT-4, or we probably do have access to configuration here, right? If I just go at the top, we do have access to configurator, so we can pass in the correct model. So we just have self.config.model name. And then we can also specify the max number of tokens, which is self.max block tokens. I don't know if we've created a variable for that. I don't think so, but I believe the value was 240. Yeah. So instead of just hard coding 240 here, I'll just go to the constructor and have self.max block tokens, which is 240 hard coded here. You can take it from the configuration system as well. You know, how many tokens do you want to display out on the screen? This is definitely a user's choice because, you know, maybe they don't want their terminal to be overly saturated. And after putting in self.max block tokens here, we can also pass it in over here, and that's about it. So we have the diff display as well. Now let's just append it to blocks. So we have blocks.append, and then we'll just pass in the syntax because I told you Rich will not give us the diffing thing. We'll just pass it in syntax and pass in the diff display. Now within syntax, you can specify the lexer to be a diff. That is totally possible. And that will highlight stuff, but it does not do the diffing itself. Remember the difference. Earlier, we did the diffing ourselves so that we got the minus and the plus, all of that logic. But the syntax can help us display it nicely if we just pass in the lexer to be a diff. And now the theme can be the same, monokai. And then you can also set word wrap to true. And that's about it. Let's try to run this again. So I'll just run python main.py and I'll say create hello world Python script for me, please. Let's run it. And still write file doesn't do anything for us. I wonder where the error is. So I understand why this error exists. I went behind the scenes to debug it. What I did is printed out the event.data.getDiff and the value over here was null. So I thought maybe the error wasn't right file. Maybe we did not pass in the diff properly through success result. So I went to success result, printed out the keyword arguments, and that's printed as well. That means the problem is in the transportation between write file to the main.py. So probably the error is in agent.py, and that's exactly where the error was. In agent.py, when we are processing the message, we are tool call start. Now in tool call start, we passed in all of these things. That's fine. That gets printed out correctly. But the problem is in tool call complete, we are just passing in the call ID, call name, and the result. Okay, that's fine too. But in tool call complete, we're not extracting the diff anymore. We're just extracting the metadata, truncated success and output. But what about the new diff that we have? So let's go ahead and add the diff property here as well. So we have result.diff, and now, you know, whenever tool call complete event is sent to the main.py file and we get it over here, the event.data will have the diff value. Now let's try to run it again. I'll say create hello world py script for me, please. Let's run it. And we run into an error. It does print out path and the content nicely, but when we are trying to display the diff, it runs into some sort of error. Now this error exists because, again, if we go to events.py where we have tool call complete, we're just passing in result.diff. Now diff is a file diff, right? If it's just a file diff, we are returning an object. And when we try to return an object from here, and then when we want to check for truncation, if the output is too long, we'll just truncate, right? When it tries to check for that truncation, it gets the file diff. And on file diff, you're trying to call tokenizer. Let's just go to parse.py or actually text.py to understand this better. the error was in this count tokens function. Now we are calling tokenizer of text. The text is a string and we have passed in a file diff over here. And that is a problem because, well, first of all, we shouldn't be sending a file diff from here. We should be sending in a proper diffed string. And that's why we had created a function of toDiff, if you remember. Something like that. I don't quite remember what that function was called. So let me go to base.py and here we have create diff. Maybe we can convert this to toDiff. That makes more sense. And now, we have the toDiff function which will return the string to us. And on that string, we can call truncation and all sorts of things. So that's good. And we only want to call toDiff if the result.diff exists. Because diff can also be null value, right? Now, if that exists, we'll call toDiff. Otherwise, we just have a null value. Because in read file, the diff will be null. And now we can try to run it again. We'll have create hello world py script for me. And then hit enter. And as you can see, the diffing view appears. We have write file where we have a gray icon. And then we have updated because that file already existed. We have created hello.py too many times. That's why it's updated. A new file was not created. This was the old file. This is the new file. Both are basically the same. If you want, you can handle this case as well. If both of the strings are same, maybe you don't want to add minus and plus. And then, this line remains the same. The bang operator, I think that's what it's called. Something like that. Bang line, shell line, I don't remember. It is the same in both the versions. Then you have def main function created in the new one. And then you call the main function, remove the print hello world from here. So that's awesome. And if you count the total number of lines in the new file, it is 7. We can just go to this hello world, hello.py as well. You might also see hello world. That is because, we tried previous prompts and this was the file created. We can also delete this hello.py and that's about it. Now what I like to do is restart this entire thing. I would like to change the model actually, just so that we know it's working on every model. So I'll just go back to our config.toml file and I'll remove this model name from here. Let's run it again and we have our Mistral model back. Now I can tell it to create hello world Python script for me, please. And as you can see, it writes back to us. So it just creates a new file. Hello world.py is the new file. So as you can see, it created it, not updated. It's a new file. And then it gives out the assistant's response as well. Now what I like to check is that it also works with read file. So I'll tell it that, hey, I made some changes to this file. Can you reread and tell what differences I made? So we are just kind of gaslighting the model. And as you can see, it reads the file properly. It gives in the correct path as well. Then, we get this output of what it tried to read. And then it says the file currently contains just this line. There are no changes detected in the file. If you made modifications, please ensure they were saved. That's good. Our agent is now slowly working as expected. Now the next tool that I would like to add is edit file. So I'll go to built-in tools again and create a new file called editfile.py. And let's just go ahead and create the class edit tool here, which is going to extend the base tool class, and we're going to get that from tools.base. Things don't really change much here. We still have to define the name of the tool, which is edit. Then we have to find the description and then pass in the description. Well, for the description, again, I'm going to copy paste. So I'll just paste it down here. The description is edit a file by replacing text. The old string must match exactly, including white space and indentation, and must be unique in this file, unless replace all is true. Use this for precise surgical edits. For creating new files or complete rewrites, use write file instead. So similar to write file, we are just mentioning when to use this edit tool and when not to use this edit tool, because LLM might get confused. After that, we're going to specify the kind of this tool, which is tool kind. We'll import that from tools.base and it's write again. We're trying to write, right? And then we are going to have a schema, and for that we have to create a class of edit parameters. So let's have class edit parameters, which is going to extend the base model. The base model is going to come from Pydantic. So let's import it. After we have done that, we're going to go ahead and have the path. That's the first string. the path is going to be the path where we are going to write or edit the file within. So we have dot 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 description, and the description is going to be path to the file to edit. And this is going to be relative to working directory or absolute path. Cool. Let me just change this to or, and yeah, that looks good. Now let's have the next one, which is going to be an old string. Because remember, edit tool means that, let's say I want to edit this file. If I want to edit this file, I want to take a particular section. So let's say lines 12 to lines 18, I want to take that section and edit it off. So here, I'm not doing it on the basis of lines. I'm going to do it on the basis of string. I'm going to say that, hey, listen, this name is equal to edit. Wherever I see this, I'm going to change this to name is equal to write, for example. Or wherever we see kind is equal to toolkind.write, we can change it to kind is equal to toolkind.read. This is what the edit parameters does. So we need a parameter of old string and then a new string. So the exact text that we need to find and replace, and the new string is going to be the text that should replace the old string. So let's have old string, which is going to be a string where we are going to pass in the field. And by default, the value is going to be an empty string, and then we can pass in the description. And for the description, it's going to be the exact text to find and replace. It must match exactly, including all white space and indentation. For new files, this will be left empty. All right. So whenever we're trying to create new files, we're not really trying to edit it. The LLM might have gotten confused, and because of that, it's still using edit when it should be using write tool. So we should be fixing the prompt instantly, but just so that the user doesn't face any kind of error, we're just saying that, hey, in case you're creating a new file, just leave this empty because there's no old string. And then we're going to add a new string as well. This new string is going to be a field as well. And then everything is going to be the same except description, where we are going to have the text to replace old string with can be empty if we want to delete text, right? Because just think about it. If we are trying to remove this line, the old string will be name is equal to edit, and the new string will be an empty string, and then it will be gone. After that, we're going to add a final parameter for edit, which is replace all. And it's going to be a Boolean value. We'll pass in the field. By default, it's going to be false. We don't want to replace all the occurrences of old string, but if it's set to true, it will replace all occurrences of old string. And by default, it is set to false. Now notice I've set default to lowercase false here because the LLM is going to send us the response, and the LLM is going to respond with JSON, right? So if the JSON is a capital case false like that, we'll not be able to pass the JSON. That's why we are setting this to lowercase f. Awesome. So we have all of our parameters. Now we can just take this edit parameters and pass it as the schema. Awesome. And now we can go ahead and create a function of async def execute, where we're going to get a self invocation. The invocation is going to be of the type of tool invocation. Let me just import that nicely. So from tools.base, we'll import tool invocation. And what are we going to return? A tool result, similar to all of the execute functions we have talked about so far. And now let's think about it. The first thing, like the write tool, we're going to take the parameters that we get from invocation and convert it into edit parameters pydantic model. So we'll have parameters is equal to edit parameters. Then we'll deconstruct invocation dot parameters. And now we have the parameters with us. The other thing we will need is the actual path, because even in write file, we wanted to resolve the path first so that we have an actual path to write to. So I'll just import resolve path from utils.path. I'm not even going to explain this further because I'll just be repeating myself then. And now we're going to have params.path passed in. Awesome. Now the next thing I want to see is if the file already exists, because, well, if this path does not really exist, in that case, I have to create one. Let's say the LLM gives us an invalid path, but then the old string does tell us that, hey, whatever line is present, like parameters is equal to edit parameters, just replace that line, alright? Because, well, I want to replace that line. In that case, it just means that the LLM hallucinated, because if the path is invalid, how are you mentioning old string? The old string should be empty if the path does not exist, because then we'll be creating a new file. That's what we have typed over here, right? For new files, leave this empty. So if the path does not exist and the old string is not empty, we've run into some sort of error. So we'll tell the LLM. But if the path is valid and the old string is empty, in that case, but just in case path is invalid and the old string is empty, in that case we want to go ahead and create that particular file. So that's the check we are going to add here. If the path does not exist, in that case we are going to have if params.oldString. Let's just check if that exists, because if the path does not exist and the old string does exist, we've run into an error. So we'll just do return tool result dot error result, and then we can pass in the error message. The error message is very simple. The file does not exist. So this is the path that you're talking about. So to create a new file, you should use an empty old string instead. Okay. And with this error message, the LLM should know that, hey, the file did not exist. Maybe I passed in the invalid edit path, or I need to pass in the empty old string, which I did not do, because the LLM can mean either of those things. We don't know for sure. Now let's go ahead and ensure that the parent directory exists. If the parent directory does not exist, in that case, we want to create that path and stuff, which this utility function we created will take care of, and we'll pass in the path. Just to remind you, this was the thing. It just creates a path. It creates a directory if needed. So that's good. After that, in this particular path, we are going to go ahead and write text. What is the text that we want to write? Well, at this point, we know that the path does not exist. So the path now exists, and we have to write the text to this particular path. Now, since this path did not exist before, now it exists. That's why we're going to pass in the parameters new string. We don't have to do anything complex other than that. And we'll also set up the encoding, which is UTF-8. That's what we did everywhere else. And now I want to return a tool result success, but in the success, I'm going to pass in some metadata. The metadata is related to, well, what is the path? What is, if it's a new file or not? What are the number of lines? So let me just create a variable to count the number of lines. So we have length of params dot new string dot split lines, because once we call split lines, we'll get the number of lines there are. And now we can just return the tool result dot success result. Then we'll pass in the output. The output is created path. So we pass in the path, and then we'll also specify the line count and then the number of lines. Then we'll pass in the diff, which is equal to file diff. Now let's import that from tools.base, and now we can pass in the path, which is just the path again. Then the old content was empty string, right? Because the parameters.old string is empty. The file did not exist. And the new content is going to be this particular line, params.new string. So let's pass that in. And then we're going to have is new file true, because it is a new file. We just created it. And then we'll pass in the metadata, which is responsible for much of the processing in the main.py and tui.py files. So the first thing is path. We'll just pass in the string path. Then we have is new file again, where we're going to say it is true. And then we have the number of lines, which is the line count. This might seem like redundant data that we're sending across, but it's actually helping us in our code, especially the tui.py file. Because if you notice in write file, and this is the same code that we'll use for edit file as well, because we want the same thing, right? If it's writing a new file or it's editing a new file to the user, it just feels like the same thing. So we just have output displaying, and then we have a diff view. So we just have the diff text displaying. That's why we sent across a diff. And the metadata is helpful when you have something like this. If is instance metadata of dictionary, and if the path exists, which is of the type of string, then we set the primary path. That's where this helps us as well, because this primary path will be used everywhere, including in write file if required. So yeah, cool. That is the success if the file was created newly. But what if the file already exists? If the file already exists, then the first thing I need to do is read the existing content. Because once I read the existing content, I can go in there, find all of the occurrences and replace them with the new string. So I'll have old content is equal to path.read text, and I'll pass in the encoding, which is UTF-8. Let me just spell this correctly. After that, we're going to check if not parameters dot old string. In that case, we'll return a tool result dot error result, and then I'll pass in the error message again, because this time we have the content, but you said that the old string does not exist. That means you want to create a new file. If you want to create a new file, well, the file already exists. So you've run into some sort of logical error. So you'll just say old string is empty, but the file exists. Correct? Now we can just steer the model to go in the right direction by saying provide old string to edit, or use write file instead. Or maybe instead of using instead, we'll write or use write file to overwrite. Because if we want to overwrite, we should be using write, not edit. This is just about creating boundaries about what tool should do what, and if the LLM fail to understand it, we'll just tell it to call another tool. Because again, it can be the case that the model probably wanted to try something else, but it just failed. But now let's say the parameters.oldString also exists. In that case, I want to count the number of occurrences in the old content, right? Because if the occurrences are 0, in that case, well, we don't have any match. What are you trying to edit? The LLM again made some sort of error. There was some hallucination. So we'll just have occurrence count is equal to old content. Let me have old content quickly dot count, and then we'll pass in the parameters dot old string. Awesome. This will give us the number of occurrences of old string in old content. And now we can just go ahead and do if occurrence count is equal to 0. In that case, we've reached a place where the LLM just doesn't know what string exists in the file. Maybe the LLM is thinking of some file data that it wrote. For example, let's say I told it to create a hello world.py script. So it created that. After that, I went ahead and manually edited the file. After that, I tell the LLM that, hey, there's some boilerplate code I want you to write, please write it. So it tries to override the already existing file data that it has previously written. It doesn't know about my new changes because it did not read the file. That is an issue that can happen quite often. Actually, I think Cursor also faces the same issue many times. And that's why we have to steer the model carefully here. So what I'm going to do is create a helper function, because we're going to steer the model very nicely. So we have parameters.oldString passed here. We'll also pass in the old content and the path as well. Now let's go ahead and create this function. Since this function is about steering the model, I'm not going to write it from scratch, but I'll explain what's going on after pasting this function. So here we go. I'll just paste it here. The first thing we have to do is import path from pathlib. We'll do that, and now I can explain what's going on. Well, we took old string, we took content, which is the old content, and then the path. This is going to return a tool result because, well, we have to essentially return an error message. So it's going to return tool result.error result at the end of the day. But here's what's going on. We have the old content, we split it so that we get lines, Then what are we trying to do? Well, I'm trying to split the old string and get its 5 words, because those are the search terms. Because let's say the LLM tried some old string, right? And it failed. But maybe out of that old string, 5 words maybe made sense. The first 5 was somewhere, and maybe it just, hallucinated after that. So we can try with those 5 terms firsthand. If you want, you can go ahead with 10, 15, whatever you want, but I'll just go with 5, and then we'll search for them in this lines. So what I do is, if search terms list exists, in that case, we have the first term, which is search terms at 0, and then we go over every lines starting from 1, because we have already taken into consideration search terms at 0, and search terms at 0 will exist because there is at least one element in search terms, because we have put this condition. And then we'll go over everything from 1 to the end of the lines list, and then we'll check if first term is in line, then we'll just append the line up to 80 characters, because we don't want that entire line to be placed within the partial matches. Because think about it, that line can be infinitely long as far as we care. So we just trim it down to 80 characters. That's enough for the model to understand what string they're dealing with. And then we can just append it to the partial matches. And remember, I'm passing in the I as well, which is the line number associated with it. And now we'll check that, hey, if the length of the partial matches is greater than or equal to 3, then we'll break out. Because we have at least 3 partial matches, that is enough. And then we create an error message. This is all related to formatting of the error message. So the first line is old string not found in path. And now if the partial matches exist, then we can tell the LLM that, hey, these are the possible similar lines that you were going for. And then we have the line number with the line preview. And we'll do that for all the partial matches that we get. Maximum is 3 because we're breaking out at 3. And then at the end, we just say, make sure old string matches exactly, including white space. Maybe you can also put an indentation. So that's good. And then we have an else condition, because we did not find any partial matches. So we are just saying that, hey, make sure the text matches exactly, including all white space and indentation, line breaks, any invisible characters. And then at the end, maybe we can add another line which just says that, hey, listen, maybe try to read the file again. So we'll just add try rereading the file using read file tool and then editing. So that's steering the model in the right direction, because I do think reading the file would probably fix it. Otherwise, the LLM is just pretty dumb. But yeah, this seems like a good thing. Now we can come back to this part. So if the occurrence count is not found, we are returning a no match error, and we are returning the tool result.error result here. So that's good. Let's say the occurrence count is 1 or greater than 1. In that case, we want to replace everything. But there's one edge case that we have to consider. What if there are many occurrences in this edit tool? So maybe you want to edit out this line, but this line exists maybe 100 times in this entire file. It's a pretty large file. And you've set the replace all to false. That just means you want to edit either this line out, or the second occurrence of this, or the third occurrence of this, or the 95th occurrence of this. We don't know which occurrence you care about. So in that case, the LLM will have to be more specific about what it wants to do. Maybe it takes the above line and then edits it, or it just sets replace all to true. So broadly, the LLM will either have to provide more context to make the match unique if the occurrence count is greater than 1, or it will have to set replace all to true. So let's just catch that edge case. So if the occurrence count is greater than 1 and the params.replace all is set to false, in that case, we'll just return the tool result.error result, and then we'll pass in the error string, which is old string found, let's say, occurrence count times. And let's just mention the path, because maybe the LLM, is just going after the wrong path. That's just good context to give. It won't take much of our context space. So here we have two options. Either the LLM can, one, provide more context to make the match unique, or two, it can set replace all is equal to true to replace all the occurrences. Right? Those are the two possible options. If you can think of a third one, go ahead. After that, I'll just attach some metadata of, let's just say, occurrence count. So occurrence count is occurrence count. I don't think this will be really useful for us, but yeah, just in case it's useful, go ahead, let's just attach it. Now, if the occurrence count and all of these edge cases are fine, now we want to perform the replacement. So the first thing we'll have to check is, do we want to replace everything or do we want to replace just one part of the string? So if parameters.replace all is true, then we want to perform replace all. And we can do that using old content.replace. This will just replace everything. Return a copy with all occurrences replaced by new. So we can pass in the parameters.old string, and the thing that we want to write is parameters.new string. Good. And then maybe we can maintain a replaced count, which just checks like how many occurrences did we replace. So replace count here can be occurrence count. Otherwise, replace all is set to false. We only want to replace once. So it's essentially the same thing as this one, but with one adjustment. By default, this replaces all, but you can also set your own count. So if the count is set to 1 after this, it will just replace one part. And then we can set replace count to 1 over here as well. And that's all. I want to verify that the change occurred because, again, it is quite possible. And this is solely based on my experience because I've been using dumb models because they don't cost a lot of money. But they did hallucinate, and the old content and the new content was essentially the same. So no change occurred. If no change occurred, it shouldn't really be a success because something just went wrong. So we'll just say that, hey, if new content, and we'll have to create a variable for new content, and new content will actually be set up over here because whatever old content gives us, that's going to be the new content. So if the new content is equal to the old content, that means something went wrong. So let's just return tool result.error result, and I can say no change made, old string equals new string. Let me put a space here, and that's good. Now we can try to write the file, and as we've done multiple times before, we're just going to have a try and except block here. So it's going to be path.write text. We've done this multiple times as well. We'll pass in the new content, and the encoding is equal to UTF-8. If you want to get hyper optimized, maybe you can try replacing a text, but in my case, just new content is fine. New content is actually beneficial because when we try to send a diff of the view, having the new content and old content will allow us to show all of the changes. So here we have except IO error as E, and then we'll just return tool result dot error result, and then we'll pass in failed to write file, and we'll pass in the error message. Awesome. So now we have written to the file. Now we just have to return the success result dot success result. And in this, we have to specify the output. Well, the output is that we edited this particular path that we have, and we replaced how many occurrences. So we'll pass in the replace count, and we replace these many occurrences. Now it can be an occurrence or an occurrences. So I'll just take a shortcut here and pass in a bracket S because it can be occurrences or occurrence. But if you want, you can again optimize this. If the replace count is equal to 1, then it's occurrence. Otherwise, it's more than that, it's occurrences. And then we can attach a diffing message. The diffing message can be something like how many lines did we add and how many lines did we remove in total. So let's just create that. So we can have a diff message is equal to an empty string. And now we essentially want to know how many lines were added or removed. And to calculate that, first we'll have to calculate the number of old lines, which is length of old content dot split lines. Then we'll do a similar thing for new lines. So we have new lines equal to length of new content dot split lines. And now we have if the line diff, let's just create a new variable line diff, which is just equal to new lines minus old lines. That will give us the number of lines that were changed. And now we can say if the line diff is greater than 0, in that case we'll have a diff message which is equal to an if string where we add plus and then the line diff lines. So let's say we added 10 more lines, and if the line diff was less than 0, in that case the diff message is going to be, we kind of subtracted these many lines, so line diff lines were kind of subtracted, and we're not adding a negative sign here because line diff is already negative, so it will automatically add that negative sign. And yeah, that seems like a good diff message. I can just attach it over here. Seems good. And now I'll just add the diff, which is going to be a file diff. The path is already with us. You might already know the drill here. The old content is going to be old content. New content is going to be new content. And that's all. We are not creating a new file. We don't have to set that option on. And then finally, we can have metadata. Again, we have to set the path here. The path is going to be string of path. That's really useful. Then we can have the replaced count, the thing that we counted so far. How many replaces of occurrences did we do? And that is just the replace count. Finally, we can have the line diff, what was the number of line changes that we did, and we can pass that in. I don't think these both are especially useful in the metadata, but if you want to display it out on the screen, go for it. Now we have an error over here because I forgot to put a comma, so we put that in, and I believe now we're done with the edit file. So let me go ahead and first register this tool in init.py. So I'll have edit tool. Let me import that from tools.builtin.edit file. And now I want to edit my TUI.py file because here I told you that we have to handle the tool call complete, right? Here we are just handling read file and write file, but I also told you that edit file is going to be quite similar to write file because all we want to do in edit is display the things in a diff format. So we can just utilize this. We can check that, hey, if the name is in write file or it is in edit file, so we are having a set where we check for the name, then we'll go over this, we'll append the block, we'll try to truncate the text, and then we display the diffing view. I believe there's one more thing we did earlier, which is something related to old string that we already mentioned here. If the key is in content or old string or new string, because when we are doing a tool call start, we render the args table, which is a key value pair, and there it just puts in the entire blob of old string and new string. We don't want that, so that's why we had the key over here. We don't display the entire blob on the screen for edit as well. And now we have to go in the ordered args because here we have a variable of preferred order. In what order do we want to display the arguments? For edit file, we're going to have, or I don't know what the tool was called. It was either called edit file or edit. That's probably why you should convert this into an enum so that it can be used everywhere. But I'll just go back to edit file and look at the tool name. It is just called edit. So let me just put edit here, and even down there, wherever I called tool call complete, I'll change this to edit, not edit file. Now we'll come back to the preferred order function, and for edit, our preferred order is first. You have to specify the path, where are we editing the file. Then you have to mention replace all if it's set to true or false. And then you have old string, and then you have new string because it just looks better in that order. And I believe we are done now. let's try to rerun our agent and tell it to edit some file. What file I would like to edit? Hello world.py. So I'll tell it that, hey, please edit hello world.py file for me. Change text to, maybe we can tell it to add a new feature. So it will add a new feature of taking user input and printing out user input with hello world attached. Terrible prompting, but let's see if it works. So as you can see, our LLM is smart enough. It just goes and first reads the file because it first needs to get context about, hey, what is the file that I'm dealing with? I'm dealing with hello world.py. Okay, cool. Let me check it out. So it goes and checks it out and then it edits it. And for the edit, it just does, well, this part. It prints hello world, removes it. Then you have user input is equal to input, enter your name. And then it prints hello world after the, followed by the name of the user. And then it just says task completed. That's good. We are able to use multiple tool calls together and it completes the entire tool calling stuff when required. So the agentic loop is getting completed. Now I just want to ensure that the tones are still working. Like a new message, if I put it in, it understands the context. That means everything is working fine. So I'll just tell it, format the output nicely, please. Now let's see what it does. So it goes ahead and edits again. This time it just removes the print line and instead does hello user input, welcome to the world. Well, that's creative. But anyways, I'm done having fun with this. Now the next tool you can work on is apply patch. Apply patch is essentially a tool that can do multiple edits in just one tool. Let's take an example. Let's say I have a file like loader.py. In this file, which is 106 lines long, I want to edit this part out. Maybe I want to change something on line 11, and then maybe I want to change something on line 25, followed by a change on line 37. So with the edit tool, what will happen is we'll have to go ahead and edit out each and every line one by one. You know, one tool call for this one tool call for this one tool call for this one, and so on. Now, instead of doing those 3 tool calls, what you can do is just define a tool called apply patch that will make all of those edits possible in just one tool call. But I'm not focusing on apply patch right now. It is present in Codex CLI, which is by OpenAI. But we're not going to implement that, otherwise this tutorial will get too large. You know, it will be too long. So now what I'm going to do is work on the next tool, which is shell.py. Now in the shell.py tool, we're first going to create a class called shell tool, and then we are going to have an extension of tool, just like we had with other classes as well. After that, we are going to name the tool, which is just shell. After that, we are going to have the kind, which is toolkind.shell. Let me import toolkind from tools.base and shell. So this is the first tool and the only tool that will use shell as the toolkind. After that, we are going to have the description, and the description is a simple one-liner. So I can just write it down. Execute a shell command. Use this for running system commands, scripts, and CLI tools. That's it. You know, as simple as it gets. After that, we have to define a schema. So we'll go at the top and define class shell parameters, which is going to extend the base model, which comes from Pydantic. Let me import that, and here we go. After that, we can go ahead and define the parameters of shell. What do we need here? Well, if a shell is being called, first we need to know what command needs to be executed, right? So we'll have a command of the type of string, and we'll import field from Pydantic again. Everything is going to be the same except description, where we say the shell command to execute. Cool. After that, we'll have the timeout, which is going to be an integer. So there can be multiple instances where a shell command is run, but maybe there's some sort of infinite loop going on or something like that, and we are unable to just look at the output, even if it's an error output. And for that reason, we're going to specify a timeout. So if it's 120 seconds long, 180 seconds long, 200 seconds long, after that, we just time out and close the shell. And then we'll give the relevant information out to the LLM so that it can make appropriate decisions. The default value here is going to be 120 seconds for the timeout, but the LLM can change it. The value should be greater than equal to 1 and it should be less than equal to, let's say, 600 seconds, which is 10 minutes. After that, we can specify the description, and the description is timeout in seconds, and then we can set the default to 120. Great. After that, we're going to add the next one, which is current working directory, which can be a string or a null value, and by default, it's going to be a null value. We can pass in the description, which is working directory for the command. So maybe, we are in this particular AI agent current working directory. That's our main working directory. But the shell command needs to be executed within a specific subfolder. That's where this current working directory can help us out. Now, of course, the LLM can be smart enough to just say cd into the subfolder and then it can execute whatever it wants to. But this just feels like a better way to go about it, forcing the LLM to specifically list out the current working directory. Obviously, by default, it is null. We'll try to execute in the folder we are in. And now we can go ahead and specify the schema, which is shell parameters. Then I'll go ahead and have async def execute function. We're going to get invocation, which is going to be tool invocation. I think from next tool onwards, I'll just import this shell.py class or something like that, so that we don't have to write this boilerplate code again and again. From tools.base, we have imported tool result, and now let's see how we want to execute it. The first thing we always do is get the parameters in the form of shell parameters. So we'll just pass in the invocation dot parameters. That's good. After that, we want to block any unsafe or dangerous command, right? Because the LLM might hallucinate and it gives you a dangerous command to execute. And you might have seen this in the news as well, where the LLM, just completely removes the root folder or the home directory, or even, wipes off the entire database. So you can have those commands in there, and we'll check for any blocked commands. If those exist, then we are going to block them. To block it, first we need to maintain a dictionary of what commands are we going to block. And for that, I'm going to create a constant right at the top. And these are the commands. We have rm-rf home folder, then the root folder, then everything in the home folder, and so on. Now, you can add your own block commands. By no means is this an exhaustive list. So go ahead, add your own thing. But what I'm going to do is just use this block commands. This is just for reference. Obviously you can add more stuff into this. So now let's try to check if the command should be blocked or not. So the first thing I'll do is go over every command in blocked commands list, or the set that we have, and check that, hey, the command that the user mentioned or the LLM mentioned, which can be stored in the variable, let's say command params.command.lower, because we want everything to be in lowercase, right? And we'll probably also strip off anything that's not required. And then we can check that, hey, if this blocked is in command that's present over here, because we are going over a set of block commands. So let's say we have this, and if the command contains rm-rf with this /, then we'll just block it. And in that case, we just want to return a tool result with error result, right? So we'll have error result passed in, and the first thing we're going to pass in is command blocked for safety, and then I'll pass in the parameters.command. After that, we also have a metadata, which is equal to blocked, and it is set to true. By no means is this helpful. Really, this metadata will not help us even while we are trying to display anything on the main screen. If you want, you can go ahead and use this. Initially, I thought that it would help us, but yeah, I was just too lazy to implement anything related to good UX. Now, let's say we have checked for block commands and blocked if any command doesn't suit us. The next thing I want to do is determine the working directory, because in the working directory, are we going to execute the command, right? So I'll check if the parameters.current working directory is specified by the LLM, then I want to get the actual current working directory. So I'll just set current working directory to path, and we'll import from pathlib, and this will be parameters.current working directory. And now I'll check that, hey, if this current working directory is not absolute path, in that case, we'll take the invocation.current working directory, which is the current working directory we are in, the AI agent folder that we set in the main.py as well, and we'll append that with this current working directory that the LLM mentioned to us. So we'll have current working directory is equal to invocation.current working directory / current working directory. This is how we are appending current working directory by the LLM to the current working directory we have set up. After that, we're going to have an else condition. That means the params.current working directory is not set up. In that case, our current working directory is just invocation.current working directory. We're going with whatever current working directory we set up in main.py file. And then I'll just check that, hey, if this current working directory does not exist, let's say it was not absolute, so we went ahead and appended the path, but maybe the LLM hallucinated or something went wrong such that the current working directory does not exist. In that case, I'll just return the tool result.error result and I'll pass in the working directory. So working directory doesn't exist is what I will type in, and then I'll pass in the current working directory so that the LLM knows what working directory we tried and what didn't work. Cool. After that, we want to execute the shell command, right? But the thing to know about shell commands is shell commands are pretty much like this terminal, right? I'm running it on ZSH, but maybe you can use bash as well to run your own thing. The thing is, they're dependent on what platform you're on. So if you're on Windows, some other command will be executed, and if you're on Mac or Linux, you can use bash. So that's one thing we have to determine. The other thing is all of the environment variables that are present in a shell. For example, when I was running my AI agent over here, I already exported some variables like the API key, the base URL. Those are environment variables. And along with that, there are multiple other environment variables like path, or if you set up conda, then you have to specify something related to conda. So, there are multiple paths. The problem is that we have to copy these environment variables from your system into the shell that we are executing, right? Because let's say we tried to run a Python command, but in our shell, the shell we create now, it doesn't have access to the Python command. It doesn't have access to Python command because we don't have the environment variable set up properly for that. So it doesn't know that Python needs to be accessed using Python 3. This is a very rough example, but I hope you understand what I'm trying to mean here. We do need environment variables in our shell. But the problem is there are private keys also available as environment variables, like the API key we passed in over here when we did export API key. So I want to remove or filter out those API keys if they exist and build the environment. Now, obviously, I don't have a magical wand which will just remove the environment variables, because the environment variable can be named anyway. But generally, if I'm creating a confidential secret environment variable that I don't want to give to an LLM, that's why we are trying to filter out the environment variables so that these secret keys don't get leaked to an LLM, because if they get leaked to an LLM and maybe they're used for pre-training another model, they might be exposed outside of the model if they hallucinate or something like that, if the security of the LLMs fail. That's why we want to filter out these variables. But we can only do that based on their name or based on the values. So maybe you can check that, if it's a Google API key, then it's going to have a certain structure to it. If it's Azure API key or AWS API key, it's going to have a certain structure to it. But what we are going to do is just build it on the basis of the name. If the name contains key, then we're going to filter it out. If it contains secret, then we're going to filter it out. And obviously, we want to tell the user that, hey, listen, you have your own list that you can mention of the variable names we need to filter out. And for that, the user will have to specify a configuration. So first, we'll have to go to configuration.py and take this shell command from the config. So we'll create a shell environment here, which is of the type of shell environment policy or config. You can call it whatever you want. And then we're going to pass in the field. The default factory is going to be the shell environment policy. Cool. After that, we're going to have a class of shell environment policy, which is going to extend the base model. And here we can go ahead and define what variables do we need from shell. The first thing is ignore default excludes, which is going to be a boolean value, and by default it is going to be false. What this variable does is that it tells that do we want to ignore the default excludes or not. And yeah, we are going to specify an exclude patterns list. So the user can specify a list of whatever patterns they want to ignore. So maybe they want to ignore API keys that contain key. That's how they can mention it in the list. So key is ignored, or maybe they want to ignore anything that contains shell. Now, why is this specific pattern used? It's kind of like regex, but it's specifically a Unix file pattern matching system. What it's trying to do is just that if there's anything before key, we take all of those characters, and if there's anything after key, we take all of those characters. But the key should be present within the name, and the same thing for shell. Or maybe you have a secret key, or maybe you have a token key. All of that can come within these asterisks. All they mean is that the command or the list that the user mentions should have either a key or a secret or token to be excluded. Otherwise, they'll be included. And what this variable does is that it asks if we want to ignore the default excludes that are present. By default, we want to ignore them, but if it is true, we will not ignore them. And these are the exclude patterns. So we are going to have a list of strings, and we are going to have a field where we are going to have a default factory. And in the default factory, you might have noticed every single time we are passing an instance of the class, we are not really calling a class. Similarly, when we pass in a function, we don't have to pass in the called function. So we can't pass in just a key like that. So you have key, this is the default list of what patterns we want to exclude. Then you have token, then you have secret. You can't just pass in a list. What you need to do is create a lambda function or any sort of function and pass in the reference to that function so that it can be called. So by default, these keys will be ignored. If the user wants to specify anything else, they can. And finally, after this, we are going to have a set variables, which is going to be a dictionary string comma string. And by default, it's going to have the value of a dictionary. Now, what is the set variables? Many times, when we're trying to copy a environment variable, let's say we have something like node environment, and by default, maybe in your shell environment variables, you specified the value to be production. But when the LLM is doing it, you want the node environment to be development. Now, you can't go ahead and change that in any way, right? Because in your real environment variables, you do need production. But in your LLM shell, you want development. So what you can do is set up this overriding variable in the configuration. So yeah, that's exactly what we are doing. And this is all about the shell environment policy. As you can see, we have set it up over here as well. Now I can use the configuration in the shell.py. But before I use it, I'll just create a function to build the environment variables. A helper function would just be nice. So I'll have environment is equal to self.build environment. And then I'll just copy this function and create it out. So we have def build environment, then we get a self, and it's going to return a dictionary of string comma string. Now, the first thing we want to do is copy all of the environment variables that already exist. So we have OS. So let's import OS, and then we have environment.get. That will get us the environment variable dictionary. But what I want to do is copy the dictionary that we get. Because if we do get, we get the actual environment object. We don't want to update it. What I'll do is copy. So I get a copy of that. And now I can update this environment variable as we need it. Also, I want to get access to the config's shell environment, because based on that, we are going to exclude the patterns, set the variables, all of that. So I need to access self.config, but as you can see, we don't have access to config. Now, how do we get access to config? Well, we can get it through the init of the shell tool, but I'll go one step deeper. I'll go into the tool. We have an init function here, and I'll just pass in the config here so that it's given to every tool. In future tools, for example, maybe grep, glob, maybe you want some configuration to be present. So you can access the self.config over there as well. And now I can do self.config is equal to config. And before I forget, wherever this tool is called, I want to pass in the configuration. And that is specifically called in tool registry or registry.py. So here for tool class in get all built-in tools, which is in the create default registry, we will get the configuration. So let's get it. And then we can just pass in the config wherever this tool class is called, because this tool class is going to be of the type of tool, right? Because get all built-in tools does contain everything that just extends tool. So we pass in the config and that's it. Now, wherever this create default registry is called, which is in session.py, we have to pass in the config, and luckily we do have config here. So we'll just pass it in. And that's it. Now we can go to shell and access the self.config. See? And now we get access to the shell environment, and we'll just set it to a variable called policy. Maybe you want to call the shell environment. Anything is fine. And now what I want to do is first check if the default excludes is set to false. If default excludes is set to false, in that case, we want to filter out variables with key, token, secret, or any other thing that the user has mentioned. And if the ignore default excludes is true, then we don't want to do any of the pattern matching based on the exclude patterns list that was present in the config, If this is false, we'll exclude these patterns, otherwise we won't. So let's go ahead and check if not policy dot ignore, or not policy, sorry, if not shell environment dot ignore default excludes. If this is set to false, then we'll go over every pattern in policy or shell environment dot exclude patterns. So now I have access to, let's say, key or token or secret. And now I'll just create a list of whatever keys I want to remove, right? So I'll go over every key that's present in this environment variable, and I'll just match it with this pattern. If it is true, then we'll store it in a list and remove all of the keys from that list. So we have keys to remove, which is equal to a list. And for every key in the environment variable dot keys, we'll check if the fn match, and we have to import fn match. Fn match is essentially a built-in library that allows us to do pattern matching on Unix type file names. And what we have in this patterns list is also Unix type pattern names. So we can just use that. So it will just help us match whatever keys match in the environment variable to a pattern. So the first thing we have to pass in is key.upper, and then we'll also have the pattern.upper, and we'll pass in the key here. Now that I have a list of all the keys that I want to remove, and again, I just found out by going over all of the environment variables and matching them using fn match to the pattern that we got from exclude patterns. And now we just have to delete all of these keys. So we'll do for k in keys to remove, we'll delete the environment at k, because this is an object or a dictionary, and dictionary property can be deleted like that. And now we'll get out of this entire if condition. With this, we have removed all the keys that we wanted to. We filter out everything. And now we just have to apply the overrided variables. So we'll have if the policy or shell environment, I don't know why I keep doing policy, if it is set to the variables, if like that list is not empty, in that case, I'll just do environment.update and pass in the shell environment dot set variables. That's it. Now I can go ahead and return this updated environment object. So now we have access to this environment here. I just have to start the shell. But again, as I mentioned before, we first have to determine the shell we are on based on the platform. So we'll have if system, and let's import system dot platform is equal to Windows 32. In that case, the shell command is going to look something like this. You'll have cmd.exe, then you have to pass in /c and pass in the parameter.command that you want to execute. This is how you open up a shell in Windows. Otherwise, we are on Mac or Linux. In that case, we can just use bash. So we'll have /bin/bash, then you have -c, and you'll pass in the parameters.command again. Now you might notice that this entire thing is blurred out for me, kind of grayed out for me. And the reason for that is Pylance automatically knows that the system.platform we are on is Mac. So obviously this is obviously going to be false for us all the time. This is the one that will be true for me. But however, if we try to upload this package and anyone can use this AI agent, in that case we do need this line so that Windows can execute as well. And now I just have to start the shell. How do I do that? Well, I can just use async.io's method on it. So first I'll import async.io, and now I can call the create subprocess execute command on that. Here I need to pass in multiple things, but first I'll explain what this line does. So this create subprocess exec just spawns a new operating system process, and the operating system process that we are going to pass in over here, the program that we are going to run, is this shell command, and we need to deconstruct it before we can pass it in. The benefit of this is that this create subprocess exec does not block the event loop, so everything can work as expected, and it lets us stream the standard output and standard error asynchronously if that's needed. In our case, we don't really need to stream anything, but it's totally possible. And also, this allows us to fully control how this subprocess works. You can kill it, you can wait, you can read the output, all of that. So let's go ahead and store this in a variable. Let's call this process, which is equal to await this. Now we can pass in multiple other things like standard output. So for the standard output, we can just do async.io.subprocess.pipe. What this pipe does is that it just tells us that, hey, listen, we are capturing the standard output and it will be made available by doing process.standard_output. So if in any case I want to get access to the output, I can just do it using this variable .standard_output. That's what this pipe does. And the same thing we need for standard error. So let me just copy paste that. This will be available as process.standard_error. Then I can pass in the working directory in which we want to execute, which we already have over here. Then we have the environment variables, which we also got access to from here. And after that, we will have a variable start new session equal to true. Every time we try to create a subprocess exec, that means start a new shell tool, it's going to start a new session. You can sync this with our own session.py if you want, but in my case, I always want this new session to be created no matter what, even if we are in the same session. But you can reuse it, totally fine. And now I would like to wait for this entire standard output and standard error to get over. As I said, we are not going to stream this out. So I'll do await async.io.waitFor, and then I'll pass in the first thing, which is a future. What I need to pass in here is process.communicate. So this is going to be the input that we are waiting for. As soon as this coroutine gets over, we'll get some value, and the value we'll get is standard output data and standard error data. And we'll obviously awaited it. Also, we'll specify the timeout here. How much time do we want to wait for? And if we don't specify a timeout, it will go on forever. We don't want that. That's why we had parameters.timeout, and that's good. Now, whenever we run into a timeout error, it will just raise an exception. I want to avoid that, so I'll have try except, and I'll wait for this async.io.timeout error. And now I can just check that, hey, if the system.platform we are in is not equal to Windows 32, in that case Mac or Linux, then we'll just do os dot kill program, so PG, and now I'll just pass in the program ID. Now I need to get the program ID. For that I'll do os dot get PG ID, and then I'll pass in this process variable, which will give me the PID, which is the process ID. So based on the process ID, we'll get the program ID, which we'll pass to os.killpg to kill the shell. And now I'll just pass in the signal.sigkill. Sigkill is just a way to say that we want to immediately terminate this Unix-like operating system. Alright. So if you have a Mac OS or a Linux, you're just forcefully closing off the signal or this thing, in our case the program, without giving it a chance to save any data or clean up resources or anything. Otherwise, we are on Windows, and surprisingly for Windows, it's much easier. You can just do process.kill and it will work. After that, we'll just wait for the process to get over, and once it gets over, I'm just going to return an error result. So we'll have return tool result.error result, and I'll pass in that, hey, this command timed out after, and then I'll pass in the timeout params.timeout seconds. Finally, after all of this, we might get the standard output. So at this point, if there's any exception, we've returned the result, we've closed off everything we have to, so no resources are leaked or unnecessarily used. And now I'll just decode the output. So to decode the output, I can just do standard output data, which is of the type of bytes. I'll just do decoding, and then I'll pass in the UTF, which is UTF-8, and then I'll pass in errors is equal to replace, where, errors replace just means that, let's say when we try to decode the data, it had some byte which was undecodable. So instead of returning a unidecode error or some sort of exception like that, it will just replace that byte that had the problem with a placeholder character so that it doesn't cause any more issues for us. And now we can just store this in standard output. Similar to this, we'll have one done for standard error as well. So we'll have standard error data dot decode. And now I want to format the output very nicely. So I'll have if the standard output dot strip exists, that means we have a successful output. In that case, I'll create a variable at the top and append this standard output to it. So we have output plus equals standard output dot strip. Or actually, let me do rstrip, because from the right hand side we are going to strip out the standard output, because many times it can be the case that the output is nicely formatted. So from the left hand side you have everything indented, and if you remove that off, everything will be in one single line and it might not look good. So let's just maintain that. Other than that, we can also have a standard error, and we'll strip that as well. So if standard error dot strip exists, that means it's not empty. In that case, I just want to check if the output is not an empty string. If output is an empty string, then I want to explicitly tell that, hey, we are having a standard error here. Or actually, even if the output is empty, in that case also, I'll just print out that there's a standard error. So I'll have plus equals 3 hyphens followed by standard error and 3 hyphens again. And let me leave a new line as well here. After that, we can go ahead and append the standard error. So we'll have output plus equals, and then I'll just pass in the standard error dot r strip. Let me also put a \n here so that the standard error can come in on a new line. And finally, I'll check if the exit code is not equal to 0. Now I want to get access to that exit code, which I will at the top over here. Exit code is just equal to process.exit code, right? Or process.return code. Because whatever the process returns, if it's a 0, it's going to be success. If it's anything other than that, it's a failure. So just in case exit code is not equal to 0, then we're going to go ahead and append it to the output. So we have output plus equals, and then you pass in the exit code, which is something like this. Cool. Also, let me put an F string here. Great. So we have our output ready, but before we go any further, I would just like to truncate the output if it's too big. So I'll just check that, hey, if the length of the output is greater than 100 into 1024, which is 100 kilobytes, because the output here is in a string format and string is just a bunch of characters. So one character is equal to 1 byte. So the maximum thing we need is 100 kilobytes, or very simply, it is just 12,400 characters long. In that case, we'll just have output equal to output until 100 into 1024 plus, and then we'll have \n, then we'll have 3 dots where we say output truncated. Cool. Now I can just go ahead and return this tool result dot success result, right? No. I'm just going to return an instance of tool result because we really don't know if it was a success or a failure. We can only know that on the basis of exit code. If the exit code is 0, we are having a success. Otherwise, we are having an error. So let's have success is equal to exit code equal to 0. So that is a success. And for error, we are going to have standard error returned if the exit code is not equal to 0. Otherwise, it's going to be null. Think about it. If exit code is not 0, we are having a failure, so we return standard error, otherwise null, right? And now we'll also mention the exit code, which is exit code. And by the way, your tool result might not have exit code because this is the second time I'm recording this part of the video. There was some software bug in the recording, so I wasn't able to remove everything very cleanly, but the point is the exit code needs to be attached to tool result now. So make sure you have that in the data class and nothing else needs to be changed in the code here. Just add this exit code in the tool result data class. And now, since we have specified the exit code as well, let's pass in the final thing, which is the output. And we already have the output with us. As simple as it gets. So that is it about the shell tool. Now let's go to the init.py where we're going to add the shell tool. So let's import it from tools.builtin.shell, and that's it. Also in the all here, let's just have write tool. Then we also have the edit tool, and we also have the shell tool. These are all of the tools that are imported from tools.builtin. So it's good to have them over here. However, we won't be using these tools outside of the built-in library, alright? The built-in module. Great. Now that we have that done, we can go to our main.py, and here, the first thing I would like to pass is in tool call complete, I would like to get access to the exit code, right? And we do have it over here. You might not have it. Again, I recorded it, but I forgot to remove certain parts when I'm re-recording. So we have exit code here. Let's pass that in from tool call complete. So we have event.data.get exit code. And if it's not present, it's going to be null. And now I believe there's another place where we have to change it because exit code is coming from tool call complete, right? Which is really agent event type.tool call complete. So let me go to this particular part where we have agent tool call complete, where we have the result, and here just make sure you have passed in the exit code. Again, I forgot to remove this part as well. Sorry about that. But yeah, make sure you add this exit code because, if you don't do this, similar to diff, we'll get an error. So you have result.exit code here as well. And now we can go to the tui.py file where we go ahead and instantiate stuff related to shell. So the very first thing is that we'll have to create our own elif condition here to display the shell. But even before that, there were a few things we'll have to change here, right? For example, in the ordered args, we'll have to specify the preferred order. So whenever we have a shell tool, what is the preferred order for us? So we'll have command, timeout, and then we'll have the current working directory. If you want, you can go ahead and change this order, but whenever the user executes a shell command, or whenever the LLM executes a shell command, the user wants to see the command that was executed at the very top. After that, there'll be non kind of essential stuff, but if you think something else might be a better UX, go for it. So we have shell done over here, and then I can just go down where we have tool call complete and just create another elif condition for the shell. So elif, the name is equal to shell. In that case, what do we want to display? Well, first of all, I would like to get access to the command, right? So I'll do command is equal to args.get command, because really we are not sending it the command from our event.data. So the metadata might not contain the command. We're not sending it, but if you want, you can send it. However, for this purposes, we had done something in tool call start. So whenever tool call started, we set self.tool_args by call ID. Call ID is equal to arguments. So based on the tool call ID, I set up the arguments. So now it's time to retrieve those arguments. So I'll just go down here in tool call complete and just have args is equal to self.tool_args by call ID dot get, and then we'll pass in the call ID. If it does not exist, then we're going to have an empty object. And now I can use this args down here to get access to command. And if the command is instance of a string and command.strip does not exist, that means, it's empty or something like that. We don't want to do anything. But if it's not empty, in that case, I want to append this command to the blocks. So we have text, then I'll pass in a $sign, which is usually the way the shell commands look, right? If I want to tell the user that we executed something, dollar followed by a command tells the user that, hey, we executed this. So it's just nice UI technique. And then we're just doing command.strip. And then we can specify the style of this, which is muted. Then we can again check if the exit code is not none. If it is not none, then we'll have blocks.append. Then I'll pass in the text, which is exit code is equal to exit code. And then we'll also have the style is equal to muted. After that, we want to truncate the output if needed. So we can just do output display is equal to truncate text. And then I'll pass in the text, which is the output. Then the model, which is self.model, or actually I think it's self.config.model name. And then finally, we are going to add the max number of token, which is self.max block tokens. Cool. And now we just have to display it out on the screen. So to display it, we're just going to use this blocks.append syntax. So we do that, and then we pass in the output display. The text here is going to be a simple text. It's not a diff. It's a simple text of what the command line did. The theme is monokai and the word wrap is true. So that seems good enough to me. Now let's try to execute it and see if it works. So I'll close all the save files. Let's try to run it. So I'll have python main.py, and now I can tell it to create hello world.py file for me and run it to test it. So let's see if it works. So as you can see, the shell command is executed here. So we have command python hello world.py, and then the output shows up, which is python hello world.py, the command executed, the exit code, and what is the output of the shell, right? So this is the hello world displaying in the syntax form. And then the assistant just tells us it created and executed successfully. The output is hello world. Great. And as you can see, the shell is also of a different color than the write file tool, which is of the yellow color. So this is of the magenta color, and this is specifically because in the agent theme, we specified that our tool.shell should be magenta. So when we have network tool or MCP tool, we're going to add different colors, and that's pretty cool. Just makes our app look fancy. So yeah, that's about it. Let me exit this so that, we can get started on the next thing. And the next tool we are going to work on is the list directory tool. So we have listdir.py file. And now you might wonder, what does this tool do? Well, this tool just lists out all of the contents within a directory. Not all of we're going to ignore some files, but the point is listing out the essential files in a directory. The next question you might have is, since we already have shell tool, why do we need a tool for list directory? The reason for that is the first one: if an LLM passes a command that is like ls-la, which essentially prints out all of the files within a directory, including the files that are hidden like .git, they all will be displayed. And for some directories, it can be messy. So it will be a very large output, and it can be very annoying to parse that output. The second thing is that the output varies by the operating system. What Windows will give as the output versus what Mac OS or Linux will give as the output for this is going to be different. So we don't want to parse that, right? I mean, it will get too annoying. Also, there's this cross-platform consistency issue. If you are on Linux or Mac, you will do ls. But if you're on Windows, you have to do something like dir. Or if you're on PowerShell, you have something like get child item, something like this. We obviously want that to be abstracted away by this list directory tool. Also, this list directory tool is a rather common tool. It will be used multiple times by the LLM. So first of all, maybe when it's tasked to create a hello world.py, it will try to see if this hello world.py file already exists. If it exists, it will try to read it. And then it will try to edit it based on our instructions. So, first it has to know what contents exist within a file. So that's the first time it will do it. And then let's say it makes them changes, and then it lists again just to ensure that its changes are present. Maybe by mistake, it did not delete the hello world.py. According to our system prompt itself, we have told that it should be very conscious about making changes, and it should be very thorough with its changes. Again, for that reason, it might try to use the list directory command. So it's just better to have this as a separate tool. To give you another perspective to this, we're having a list directory tool despite having a shell tool is because of the same reason we need a read file tool or an edit file tool or a write file tool despite having a shell. Because through shell, we can run the commands like cat. Cat just allows us to read a file, right? Then we have something like touch that will allow us to create a new file. Or if it wants to edit anything, there are commands for it. So why do we need to add those tools as well? Just having dedicated tools will help the LLM make a better choice as well. And we don't have to parse anything that's annoying, and it will just make our lives easier. As well as the efficiency of the model. Because as I explained before, if you have ls-la, it can return a large number of files, and that means we will have to truncate it, and some data will be lost in that. How about instead of doing that, we just create a tool which will just parse the stuff we need it to. And if our tool does not satisfy those conditions, the LLM can go back to shell and use that. But in most cases, list dir will be fine. So let's work on that now. Now we know the drill of how to create a list directory tool. So the very first thing is going to be to create the class list directory tool, which is going to extend tool from base. And then we are just going to define a bunch of things like the name of the tool, which is list dir, then the description. And the description is quite simple here. It just lists the contents of a directory, nothing much. After that, we are going to have the kind. What is the kind of this? Well, list directory is simply reading the file, right? All the files that are in a directory. So this will be tool kind. Let's import it. And then we have .read. After that, we have the schema, and now I have to create the schema. So there will be list directory parameters, which is going to extend the base model. Then I have to import from Pydantic import base model. After that, we have this, and then there are two parameters that we're going to have. The first one is the path. What path do we want to list the directory for? So you know what directory we have, and by default the value is going to be a dot because we want it to be in the current directory. Also, let's import from Pydantic field, and then we have the description. Let's me pass in description here, and the description is directory path to list, and by default we have the current directory. Easy. After that, we have the include hidden flag. Basically, do we want to display all of the hidden files as well? Hidden files for our case is just a simple if the file contains a dot in the beginning or not. Because if the file path contains a dot in the beginning, for example, .git, that's a hidden file. Or we have .env, that's a hidden file. So do they want to include the hidden files or not? So let's have that. It's going to be a Boolean value, and by default the value is going to be false because I don't want the hidden files to be displayed unless the LLM turns it on to true, and then we'll just say whether to include hidden files and directories, and maybe we can also specify that the default value is false. Okay, maybe I misspelled, so we have false here. Okay, great. So now I can take this list directory parameters and attach it to the schema. Awesome. And now there's only one thing to do. I have to create the execute function. So I have the execute here, and then we are going to have an invocation of the type of tool invocation, and we're going to return a tool result. Let's import both of them. There we go. And I misspelled this. So let's import it again. Great. Now I want the parameters, right? So I have parameters is equal to list directory parameters, and then I just have invocation.parameters deconstructed so that we have this nice class. After that, we want to resolve the path if the params.path is present, and it should always be present because we have given it a default value, and it is kind of a required value as well, because without the path, what file are you even listing? What directory are you listing? So we have directory path, which is equal to, and now I have to resolve it because this path can be relative or absolute, correct? If it's relative, this dot is just a relative path. Whatever current working directory, we just want to list out the files in that. So that's relative. And it can also be absolute, so we have to resolve the path just like we did in write and read files as well. So here I'll pass in the invocation.cm current working directory, which is the base path, and then the path that the LLM gives us, which is parameters.path. Great. Now I just have to check if this directory path exists, and if it doesn't, or let's say the directory is not a directory, maybe the user or the LLM passed in a file. That's not correct, because how are you going to list all of the content of a file using list directory tool? You need read file tool for that. So we're just going to say if not directory dot, or let's say directory path dot exists. So if the path of the directory does not exist, or the directory path is not a directory at all, it's a file, or maybe it's something else. In that case, we are going to return a tool result dot error result, and I'll pass in, well, the directory does not exist, and then pass in the directory path for the LLM to understand what path we tried to do. And based on that, the next iteration, the LLM can try to resolve this error. Now, one thing I would like to note before moving forward is that you can have more arguments over here. List directory is not a very simple tool. We are having a very simple implementation, but you can have more things like recursive list directory. Meaning, if we have a folder, we go within that folder and find out all of the files within that folder. And if the LLM wants, it can set recursive to true to do that. So yeah, you can go very deep in this list directory parameters, but you get the point of this tool. We'll just add it, and you can expand it, handle more edge cases that I haven't to get it working. Now we'll try to list the directory, and to do that, we just have to do directory path dot iter directory, meaning we iterate over the files in this directory. This does not yield any result for the special paths dot and dot dot dot. Now the thing is, this will give you all the items of the directory. It will list out the directory items. Now the thing about list directory is that when you try to print out all of the items in list directory, it will just spit it out in random order. I want it to be in a consistent order, and for that reason I'm going to call sorted on this, and then also pass in the key where we are going to have a lambda path, which is p, and then I just want to say that, hey, this path should not be a directory. So I have p is directory set to not. And then the other thing should be p.name.lower. So everything is first lowercase. And this will give us the items. And I'll also put this in a try block because we are having iterate directory that might return an error. So we'll just have an except here, exception as e specifically, where I'll just do return tool result dot error result, and I'll pass in, well, error listing directory, and I'll pass in the exception. Great. After that, I'll filter out all of the hidden files if this hidden files is set to true. So I'll just check that, hey, if params.include hidden is true, in that case, I'll just have items is equal to, or actually, if the params.include hidden is set to false, in that case, I want to filter out all of the hidden files, right? Because if include hidden is true, we just have to display everything that items has over here, because iterate directory will give us all of the dot related files as well. And now I can have item for item in items if not item dot name dot starts with, and we, let's say, start with a dot. Cool. So this will filter out all of the hidden files. Else we just want the items to be items, so we don't really need an else condition here. And then I'll just check that, hey, if there are no items, maybe all of the files that are present within a directory are dot related and include hidden is set to false. In that case, the items might be empty. Or let's say overall the items in a folder are just not present. In that case also, we might have an empty directory. So we'll just return tool result dot success result. We don't have to specify a failure, because in this case we do have the directory to be empty. The entire thing was successful. It's just that it is empty, so it's not a failure. I'll also attach some metadata where we'll have the path, which is just going to be the path that we resolved at the top, directory path. And then maybe you can also pass in the entries, the number of entries that this had, which is 0. Or if you want to skip it entirely, go ahead. And then we are just going to format the output now. So I'll create a lines list, and then I'll have for item in items, and then I'll check if item dot is directory. If it is a directory, then what I want to do is just add a / at the end of the path. So I'll have lines.append, then I'll pass in the item.name with a / because a folder always have a / at the end of it. Otherwise, we have a file, and then I'll just do lines.append item.name. After that, I can just go ahead and return tool result.success result, and I'll pass in the output first. The output is going to be \n.join lines. So whatever files and folders we got, we are just adding all of them on a new line. If you want, maybe you can also add a folder emoji over here to specify a folder, and for file, maybe you can use a file, but I don't like emojis, so yeah. Then we are going to have metadata, which is equal to, and then you again have entries and path. So I'll just copy this, paste it over here, and the directory path is going to be the same. Maybe just convert it into string in both the places, because directory path is a path object. So yeah. And now the entries can be the length of the number of items that are present. You know, how many ever items were present here. That's the number of entries. And that's our list directory tool. As I mentioned, you can just go deeper into this. There's lots of stuff to do here. You have full control over this tool now. Now I can go to the TUI.py, where I'm just going to define some things. The first one is the preferred order. In the preferred order, we have the list dir tool, right? And for this, the very first thing that I want to show out is path, and the second thing is include hidden. If you have other parameters like recursive and stuff, you can add it over here, but this is good enough for me. I'll scroll down to tool call complete, where I'm going to add another elif condition after shell. So we have elif tool name is equal to list directory. if that is the case, we'll first get the entries, which is equal to metadata.get, and then we have entries. After that, we have the path, which is equal to metadata.get path. So we have entries and the path, and now I just have to show them. But it is possible that maybe the LLM hallucinated or something else happened that we don't get the path. We don't want our application to crash in such an instance. So I'll just have if is instance path of the type of string. In that case, I'll just append it to a list. So I'll have, let's say, summary, which is equal to a list, and I'll append this summary to a list. So I have summary dot append path. Now another thing I'll check is if the entries is an integer. If that's present, I'll just append the entries as well. And maybe for entries, I can style this a little bit. I'll just say that I have entries number of entries. So let's say 7 entries. And after that, we'll check if the summary list even exists, because let's say the LLM did not pass in or something wrong went, and because of that we don't have any of these things. In that case, I'll just do blocks.append. In that case, I obviously don't want to append any of this to the blocks, right? But if summary exists, that means the list is not empty, then I'll do blocks.append. I'll pass in the text, and within the text I need that dot symbol that kind of acts like a separator. And now we can just call dot join between them and join all of the summary related stuff. Good. And maybe the style of this is muted, and yeah, that looks good enough. I'll go ahead and truncate the output now. So I'll have output display is equal to, and I'll call truncate text here as well. And in the truncate text, we are going to pass in the text, which is, well, the output. Then you have the model, which is self.config.model name. And finally, your self.maxBlock tokens. And now I can again just do blocks.append syntax, because that is the only thing that will allow us to display our stuff nicely. So we have output display, the text here is going to be there, then theme is Monokai, and the word wrap is true. That looks good to me. I can save this entire file and I can start the agent again. This time I'll ask it explicitly to call the list directory tool for me and read all the files within it. Let's see if it completes that request. Well, as it turns out, there is no list directory tool, so it starts calling ls-la. That's a good thing actually, because our assistant is not making any compromises. It will get the task done. So it gets everything out displayed here. And as you can see, it's quite annoying to read this output. On Windows, I'm sure it will be something else. That's why I created our list directory tool as well. Now, let me just exit this. The reason it did not know that there's a list directory tool is because we did not register it in the tools part. So in the built-in init, we did not pass in the list directory tool here. That's how it did not know that, yeah, list directory tool also exists. And now I can import it and we're good again. So now I can close everything and hope that it works now. So I'll just say call, well, let's not explicitly say call list directory. Maybe it will automatically recognize, but I can say read all the files in this directory, and I'll hit enter. And the reason for this error is because this is the first time we are trying to print out a Boolean value on the terminal, and we have not handled that case. So here in our list directory tool, we had include hidden set to a Boolean value, right? But we've never handled the case where if we have a Boolean, we have to essentially return a stringed version of that Boolean to display to the user. So we'll have to go to our TUI so that we handle that case. We can just scroll up wherever we have the formatting done, and that I believe was explicitly done when we passed in old string. So I can just search for old string, and as you see over here, this is the part where we were doing formatting of the arguments table. So if the value was a string and the key was content old string or new string, we just displayed the lines so that we did not have to display the entire blob of text. Similar to this, we can add another if condition here that, hey, listen, if is instance value of the type of boolean, right? Because the key is always going to be a string because it's the tool name. But the value, if it's a boolean value, in that case, I want to convert it into a string. So I'll just have return string of value. Or actually, instead of returning, we just want to do value is equal to string of value because we are adding the row here. Okay, great. Now let's try to do it again and then hit enter. As you can see, it calls the list directory. The path is given here. The include hidden is true. Then we have the directory name. If you want, you can resolve this path using the utility function we created, which is display path relative to current working directory, so that you get to know what directory we tried, which is essentially a dot because we did it in the current directory. So the relative path would be the current directory. And then there are 12 entries to read. Then you have .ai agent, .venv. As you can see, include hidden is set to true. That's why we see all of the hidden files as well. Then we have all of the folders showing up first, and then we have the Python files. Awesome. And now it goes ahead and reads all of the files. And since I've said file, it is only reading out the hello world.py and main.py files. If we add the option for the agent to go recursive, it will do that as well. And as you can see, our agent fails with one of the tool calls. The reason it fails is because it tries to do .ai agent config.json, but there's no config.json in AI agent. It just assumes that there's going to be a config.json. In reality, there's config.toml. So that's one case where you can just improve your system prompt so that it never makes that mistake again. But another thing here is that when the read file goes wrong, it doesn't really display the output error message. And I know how to do that. In tool call complete, every single time we're just checking if it's any of the tool call names. Now, if it's none of the tool calls name and the error object is present, then I want to display the error. So I'll have if error and not success, correct? Because in that case, we have an error, we do not have a success. Then I'll just do blocks dot append, or maybe you can just do blocks is equal to, because you don't want any of the previous items if they are attached. But in our case, it's highly unlikely anything's attached because these all things happen when it is successful. We have explicitly written out over here and success and success. So it's highly unlikely that anything else will be present in blocks list. So we can just append it because creating a new list is taking up more space. I do not want to do that without any reason. So I'll just do text, then I'll pass in a error message, and the error message is a string object, and the style of this can be the error message itself, and I have to pass in the style within this text. Then maybe we can try to truncate the error message as well. So I'll just call truncate text, the error message. Instead of truncating the error message, because we've already printed it out, let's try to truncate the output. And then we'll have the self.config.model name. Then we have the self.max block tokens. And I'll just pass it within the output display variable. And then I'll just do blocks.append. And let me just also check that, hey, if the output display.strip is present. Because it can be the case that the output is just an empty string. If that is the case where output display is present, then we're going to pass in the syntax, and similar to everything we've done till now, we're just going to paste that over here. However, if the output display is not present, in that case, I'll just do blocks.append, and I'll append the text here where I pass in no output. And the style is muted. That's it. Now I can go ahead and run this particular thing. And now whenever we run into an error, we will get to know. So let me just explicitly ask for an error. I'll just say read.ai agent /config.json file for me. And then as you can see, we get a nice error message displaying file not found, and this was the file that was not found. That is it about the error handling as well. Now let's go ahead and create the next tool, which is going to be the grep. Now again, we have a shell tool. Why do we need grep? That's because many times shell does not have the grep inbuilt within it. For example, I think Linux and Mac do have the grep command pre-installed, but in Windows you do not have grep pre-installed. That's why we are having a grep tool as well. And grep and glob tools are going to be different from each other. If you don't know what grep does, grep is used for content searching, meaning it will answer questions like where does this string or pattern appear inside files. So let's say I have function like create subprocess exec, right? In what files does this create subprocess exec exist? That is what grep does. But glob helps us answer the question of which files match of specific patterns. For example, if we have to find all of the files that end with .ts, right? So it can just do ****.ts, meaning what files are present in what folders where we have .ts in the end. So this will return the file paths, not the content. So if you want to find out what files might matter for a task, you'll use glob. But if you want to find out where is a specific definition defined, or how is a specific definition used, or you suspect a bug is here, you'll use grep. So in short, glob will choose where to look, grep will tell you what to care about. Generally, an AI agent goes about doing this. It will do glob so that we know what files are needed, what files might matter. Then you do a grep so that you again do some sort of filtering of where and which files we want to look at because the content is present within those files. And then you read those files and then you reason and then maybe you write or edit or whatever. So this is generally the flow of things, and after writing and edit, maybe it will use shell or something like that. So yeah, that is the point of grep and glob, and this is kind of the workflow of an AI coding agent as well. That's how they generally go. So let's go ahead and define grep now. In this file, we have to basically have the same structure as we did in other files as well. So I'm just going to go to list directory, copy everything and paste it over here. And then I'm just going to change the names. So the first one is going to be the grep tool. The name of the tool is going to be called grep. After that, we are going to add a description. So what is the grep tool trying to do? It is trying to search for a regex pattern, because whatever the grep is going to be, it's going to be in the form of a regex pattern. And we are going to search for that in the file content. And it will return the matching lines with file paths and line numbers. Alright. After that, we are going to have the schema. Also, the kind of this is going to be read again, because grep is just reading. Then we have schema, which is going to be grep params, and then I'm going to create a grep params class over here, which is going to extend the base model. And then we are going to get the first thing as the pattern, right? What is the grep pattern or the regex pattern that we are trying to search for? And that is going to be a string. We are going to have a field. Then we are going to have a description, and the description is going to be regular expression pattern, or you can also say regex. I think most LLMs are able to understand that, to search for. So yeah. Then we can have the path, which is going to be, well, the same thing. This time, we're not going to have a directory specifically. It can be a file or a directory. And this is the path where we want to search. So we can just say to search in. And maybe again, we can just say that the default is current directory. Alright. After that, we are going to have the case insensitive command, which is also going to be a Boolean value. So by default, the case insensitive parameter is going to be false. The description of that is going to be case insensitive search. By default, the value is going to be false. And what does this case insensitive search mean? It just means that the search doesn't care about the uppercase or the lowercase patterns. The case does not really matter if it is set to true. If it is false, the case does matter. And yeah, that looks good. Now we can just take this grep parameters, attach it to schema. Then in the execute also, we can have the grep parameters, call it with invocation.parameters, and that's about it. After that, we can go ahead and resolve the path as well. So we have the search path instead of directory path, because this time, as I mentioned, it doesn't necessarily have to be a directory. It can be a file as well. So it's better to call it a search path. This is the path where we're going to search. And then we can just check that if the search path does not exist, then in that case, we're going to return a tool result.error result. And then I can say path does not exist. Pass in the search path over here. Great. After that, we can maybe try to compile the regex pattern. Whatever pattern is specified by the LLM over here, we will just try to compile it using regex so that all of the error checking and invalid regexes are caught. And after that, we can just use that regex anywhere we want. So we just compile the regex once and then we can use it anywhere. So to do that, we'll do it in a try and except block, because when we call re.compile, which is a function within regex, let me import re, which is a built-in module in Python. So whenever you call this function, it can return an exception, which is specifically re.error. And whenever you get such an error, it just means that the regex pattern given by the LLM was incorrect. So we want to fix that. So in that case, we'll have return tool result.error result, and then we can just say invalid regex pattern and pass in the error message. Now within this re.compile, we have to pass in the pattern and the flags. By default, the flags is set to 0, meaning if there are no flags attached. But we have to attach one flag which is related to ignore case, right? If this case insensitive is on, in that case we want to ignore case, otherwise we'll have 0 flags. So here, let's just set up a variable called flags, which is re.ignoreCase if the params.case insensitive is true. Otherwise, we'll just set it to the default flag and set it over here. Now, before that, we have to pass in the pattern. And for the pattern, the LLM is going to give us the pattern. So I can just pass in parameter.pattern. Now this will return a pattern to me, and this pattern is going to be of the type of pattern given by the regex module or the re module. Now I can use this pattern anywhere I want so that I can do multiple grep searches. And we need this pattern multiple times because we are going to iterate through many files, right? Almost all of the files that you can see within a particular directory, or if a file is mentioned in just that one file. So here's the key point. If we have multiple files, meaning a directory is passed in, we have to iterate through all of the files, get it in a list, and then iterate over all of the elements in that list. If just a file is present, then we just have to use the file to search for this particular pattern. So let's get that coded in. So the very first thing we are going to check for, and I'll remove everything from here because I don't think we need it anymore. The first thing we are going to check for is, so if the search path is a directory, in that case, I'll just create a helper function to help me find all of the files within this search path. So that just means going over all of the folder iteratively. And we'll set this to a variable, let's call this files. And it's going to give us an entire list. So yeah, otherwise it's going to be a file, right? And if it's a file, then we just have the files list as just one single element, which is just the search path that was given to us. So I'll pass in the search path. So in case of a directory, we go over all of the files in the folder. In a case of a file, we just go over one particular file. Now let's go ahead and create this function of find files. So I have def find files, then I get self, then I also get the search path, and within the search path, or actually using the search path, which is going to be of the type of path, and then it is going to return a list of paths. Let me import path from pathlib. We're going to find the files. So initially the files is going to be empty list. After that, we'll go over every path in the search path For that, we can just use os.walk and then pass in the search path. Now let me import os. And when we do walk, it essentially returns a list of tuples, and it yields a 3 tuple list, meaning a list with a tuple in it which has 3 records. And what are the 3 records? So the first one is going to be root, then we have directories, and then we have the file names. Okay. After that, we can go over every file name in file names. And if the file name starts with, let's say, a dot, that means I want to exclude that path, right? So I can just click on continue. After that, I have to check if the file is not a binary file, because our entire application doesn't support binary files. We cannot read from it. So I can just have here if not is binary file, and let me import that from the utils.paths folder or the file, because we had created this helper function, right? And within that, we can just pass in the file path. Now I need to get access to this file path. Right now I don't have the file path. I'll have to create it. So I'll just do file path is equal to path, and then I'll pass in the root folder, whatever is the root folder we are in, followed by / file name. That gives me the entire file path I'm in, because whatever is the root plus the file name, that is the file path. And we pass that in. So if it's not a binary file, we'll just append this file path to our files list. And then maybe we can also have some sort of truncation logic here, because the files can exceed by a lot. Maybe a directory has thousands of files. Our LLM does not need that much context. So I'll just truncate the logic here itself. So I'll just have if the length of the files is greater than or equal to 500, in that case I'll return files. Another reason we're just doing it over here instead of doing it somewhere over here where we get the entire list and maybe we can just call 500 on it, is because let's say if we have billions of files in a folder, seems unlikely but it's possible. In that case, our entire application might just break, because a list cannot contain a billion files. That's why I'm just truncating it off over here to 500. Actually, I'm not sure about Python. I don't know how much Python can handle in terms of the number of elements. But if you're using something like C or C++, it definitely cannot handle these many files. So yeah, cool. So we return the number of files as soon as we hit 500. And if that's not it, then at the end, after the for loop, we'll just return the entire files list. Cool. So that is it about find files. If you want, there is more stuff you can do here. For example, you might want to filter out all of the directories that are not really useful. For example, if you have something like .venv, or if you have .git, or if you have node modules, you might not want to search in those particular directories. That's how you can ignore these folders as well. So now we have the files list. Now what do I want to do? Well, for each file, I want to go over the file path and read its text. Once I get all of the content within that file, I want to run the pattern that I extracted or compiled here for each one of those files. So let's do it very quickly. The first one is going to be, well, for file path in this files list, we are going to go over and try to read the content. So content is equal to file path dot read file, or read text actually. Then we'll pass in the encoding, which is UTF-8. And then, this can always lead to some sort of exception. So I'll just do try and except here, because even if we fail to read one file path, I don't want the entire application crashing out. So I can just say that, hey, just in case we run into any sort of exception here, what I would like to do is continue. Just skip rest of the path that we're going to do. Just move to the next file path, so that doesn't cause us any inconvenience. Now I can try to get the lines, which is just content dot split lines. And now I can go over all of the lines list and search for the pattern in each of the lines. The reason we are going over each line and trying to match the pattern with each line is because I want to spit out the exact line number, right? That's how it will help me. So I can just do for I comma line in the lines list. In that case, I'll do if pattern, which we extracted here at the top, if pattern dot search. Remember, you can use pattern.match here or pattern.search, but if you pass in pattern.match, it will try to start from position equals to 0 and match the entire line. But that's not what we want. We want to search for a pattern within the line. So your pattern doesn't have to start from the very beginning. It can be present anywhere within the line if we use search. But when you use match, your pattern needs to be at the very beginning or at certain position in that line. It has to be a fixed position. But with search, it can be any position. That's why we are using search here. And then I'll pass in the line. After that, I can just go ahead and get the path here. So I have relative path is equal to, and then I'll just have file path dot relative to, and I'll pass in the other path, which is probably invocation dot current working directory. That gives me the relative path. The reason I need the relative path is because I'll be appending it to my list of output. So the output I'm expecting from this particular execute function is that we get something like this. We have, let's say, is equal to signs, then we say whatever path we have dot py, then you have these equals to signs, and then you have on line number 1 something like async def execute. So this line is returned to us. After that, maybe line number 2 or let's say line number 30 also had this line async def execute or something like this. And then maybe in another file also we had this similar execute function that we are searching for. So we again have that file path passed in here, let's say part2.py, and then we have the line numbers again mentioned here. So this is how I want the formatting to look like. If I want the formatting like this, I will need to get the relative path, right? That's what I have over here. And also I have to append it into an output. So for that, I'm going to create at the top an output lines list. And then I can just do output lines dot append, and I'll pass in the 3 equal to sign followed by the relative path, and then I add the 3 equal to signs again. Cool, something like that. Let me put the curly bracket in again, and that's good. Now remember, I only want to display this relative path if we're matching for the first time. For example, if I'm having line number 1 here, that's the time I want to do it. Or whenever I'm trying to match the first path or first line within a specific path in a specific file. So I have to maintain a variable that will allow me to do that. I'll maintain a variable called, let's say, file matches, which is going to be false initially. And now if that file matches is false, in that case, we're going to have relative path here. Then we have the output lines dot append, and then I'll set file matches equal to true, because now for this particular file that we are looping through, we've got our first file match. And after this, we don't want to display this file path again. Then maybe we go to the next file. In that case, again, file matches will be set to false. So we again go over this condition. And we see that, yeah, it is false. So maybe we can append the relative path. And then we will just try to add in the line number where we found the exact output. So I have output lines dot append. Then I'll pass in the I, which is the line number. And then I'll pass in the exact line that we matched. I'm not trying to match the exact matched string. I'm just trying to give the entire line as a context to the LLM. Once we complete this entire for loop, we essentially have all of the file matches and everything is just formatted nicely within output lines. Now, one last thing I'll do for formatting is that I'll just check that, hey, if file matches is still true, in that case, I would like to do output lines dot append, and I'll pass in an empty string. What am I doing here? So let's say I had this particular line, right? I found out all of the matches within a particular path. After that, I'm moving to the next path. I want to leave a line here. If I want to leave a line, this will allow me to leave a line. We're just leaving an empty space, but at the end, we're just going to join every element of that list using \n. So that will help. we'll just get out of this entire for loop condition that we had here, and I'll just check that, hey, if this output line is not mentioned. I just realized I probably defined output lines within this for loop. We don't want to do that. We want output lines over here. The reason for it is, well, output lines, if it's defined within this for loop, will mean that output lines is reinitialized for every file path, and that's not what we need. So if the output lines is not present at all, that means we found no line, or the grep tool basically worked, but it did not give us any output as such, no paths matched. So I'll just do return tool result dot success result, and I'll pass in no matches found for pattern, and then I'll pass in the pattern, which is parameters dot pattern. Otherwise, the output lines is present, and then we just have to return the tool result dot success result. The output of this is just going to be \n dot join, and we'll just pass in the output lines. Then for the metadata, we can pass in the search path. Then we can also say how many matches were found here. So I can just say matches, and matches is just the number of matches we had. Now we're not keeping track of that, so I can just initialize a variable called matches is equal to 0, and every time we have a match, I just append. So I have matches plus equals 1, and I'll just pass in the matches list then, or matches count here then. We can also pass in the metadata here for this particular path. So I'll have the metadata, the path is string search path, the matches is just 0. Cool. I'll just go to my built-in tools where I have init.py. I'll initialize one more tool, which is grep tool. Then I'll pass in grep tool here as well. Let me import that from tools.builtin.grep. Awesome. And now the next thing I have to do is go to the TUI and update certain things. We all know what the procedure is going to look like. The first part is going to the preferred order and defining my preferred order. So for grep, my preferred order is going to be maybe path first, then we have case insensitive, and then the pattern. That seems good enough, I guess. And now I can just scroll down where we have tool call complete. Then I have an elif condition here. And by the way, for each one of these elif conditions also, we can put in and success. So if you want, go ahead. We can just put in and success and success. And even over here for the elif condition, we will have elif, the name is equal to grep, and we are having any form of success. In that case, we'll have matches first, which we want to extract from the metadata. So I have metadata.get, then I have the number of matches. After that, we have to find out the output. But actually, now I'm just thinking that if you're trying to display some result by grep, just having the matches is not enough. Maybe we need more data here. For example, how many files did we search and how many files there were with matches. So maybe let's just have another variable in our grep.py where we just check how many files we searched for this. So we can just do that by passing in the length of files, because whatever is the length of files, that many files were checked. So I'll have files searched, which is going to be the length of the files list. And then we have again this entire thing passed in the metadata as well. Now I'll go back to the tui.py file where I'm just going to get the files searched, which is equal to metadata.get, and then I pass in the files searched. Cool. Once we have both of them, I can go ahead and check if the is instance with matches and it is an integer, which it should be. If it's not, we don't care about it. Then we'll just append it to our summary, similar to this particular thing that we did up for list directory. So I'll just have summary dot append, and then we found how many matches. So matches were found. After that, we are just going to copy paste again, where we pass in the files searched, which is also an integer instance. And then I just say that, hey, we matched these many files, or we searched these many files. So we have searched, let's say 10 files, and then I can just say if the summary list is not empty, in that case I'll have blocks.append, pass in the text, and within the text I will pass in a dot just like we had earlier over here. So I'll just copy, paste it again, then call join on it and pass in the summary. Then for the text we are going to have the style of muted, and now I can go ahead and truncate the text. So I'll truncate text by having the output passed in, then the self.config.model name, then I'll pass in the self.maxBlockToken, similar to everything we've done before, and we again have output display which is equal to that, and now we will have blocks.append, and I'll pass in the entire syntax thing. So we'll just paste this thing again. So we have output display, the format or the lexer is going to be text, theme is monokai, and the word wrap is true. That should be enough. So let me just open up the terminal again and let's search for it. So I'll exit out of here and then let's run it again. This time I specifically want to call the grep tool. So I'll just tell it to find all Python files and hit enter. And as you can see, we get the output here, but the thing is entirely wrong because it did try to use the grep tool, which is good for us. The path was the current working directory. The pattern was also passed in, which seems correct, but then we run into some sort of error here. We get value error, too many lines to unpack, and this error exists because in grep.py we made a syntax error. We are doing for I comma line in lines, but lines is just a list. I have to call enumerate on that so that I can get access to that I index variable. And now if I do that, it should work out. So I would like to exit out of this and retry, and let's see what happens now. And as you can see, grep returns to us .venv. Also, it truncates very quickly. So maybe we can do two things. Instead of having the max block tokens here as 240, we can increase it to be 2400 or something like that. Maybe we can set it to be 24,000 as well. Maybe, I don't know. I'll just set it to 2500 for now. Whatever seems like the right value to you, go for it. This is just for displaying to the user. And the next thing I want to do is ignore all of these .venv files because those are totally useless for us. We're not getting the right results because of that. So how do we ignore that? I told you we just have to make use of this directories. So I'll just have directories, then I have a colon here where I'm just creating a copy of those directories, and then I say that hey, for every directory in this directories list, if the directory is not in one of these set items. So the first one is node modules, or if it's not in, let's say, PyCache, which is another folder we have, or it is not in .git, or it's not in .venv, or it's not in venv. In that case, I want the directory to be present here. Otherwise, just remove the directory. We don't want to iterate over that. And now, let's hope it works out. So I'll just try to exit out of here. And let's rerun it. And the prompt here that I'm going to put here is going to be different from the one I put in earlier, because I just remembered that if you're trying to find for all of the Python files, we don't really need grep for that. Grep is used to find out the file content, right? If a specific term needs to be found out within file content. If we want to search for the file names itself, for example, search all Python files for me, we need glob for that. We don't need grep for that. So to test out grep, I'm just going to say that, hey, listen, we have a hello world.py file. Within that hello world.py file, I want to edit out the hello world text. Or maybe I can just tell it to remove the hello world text for me from all the files that use it. And let's hit enter and see what it does. So as you can see, it tries to grep for the pattern hello world, and then it finds no matches for it. The reason for it is because hello world text doesn't really exist within our thing, because it's specifically hello comma world with a exclamation mark. And since I told it that I want to remove this particular text, it's only searching for this text, nothing else. It's following our instructions. So maybe we can be more explicit, but obviously a good agent should be able to handle this case properly. It should try some other alternatives before just telling me that, hey, we found no matches, there are no files that contain this. So let's try hello world text for me from all files that contain it, and let's hit enter, see what it does. So yeah, as you can see, grep runs. We have hello world.py. On line 0 it prints hello world, and then it edits it out, and we don't have it anymore. Let me bring it back, and as you can see, there's one small issue with the grep tool. It starts with line 0. I want it to start with line number 1. So I'll again go to my grep.py, and here when we are enumerating over every line, I would like to specify the start to be 1, so that we start from 1, so that we can display line number 1 here instead of line number 0. And now we can try to exit out of here. I'll run the same thing again and then hit enter. So it calls the grep tool, then it reads the file because it understands that, yeah, hello world.py has it. Let me just read the entire file. Then it edits it out, and the task is now completed. That's perfect. So that's it about the grep tool. Now I'll come back to using the glob tool because, well, I want to execute my initial file, which is, or execute my initial prompt, which was find all the Python related files. Glob can do that because glob will be searching for the file path names. Grep was searching the file content for a specific pattern. Glob will search the file path names. So let's do that. I'll just copy all of the content within grep, paste it over here, and I'll make certain changes here. For example, the class name should be glob tool. Then we have the name to be glob. After that, we need a description, which is glob pattern, or let's just say find files matching a glob pattern. Then we can just say supports asterisk asterisk for recursive matching. Then the kind is going to be toolkind.read. Then the parameters is going to be glob parameters. And then I'll just create a glob parameters at the top. So the very first thing that's required here is the pattern. And this is not going to be a regular expression pattern. It's going to be a glob pattern to match. We're not searching for the content or anything. We're searching for the file name. Then maybe if you want to few short it, for example, you need to specify some sort of example here that would be good for the LLM to understand. You can just say something like asterisk asterisk /**.ts, for example, to search for TypeScript related files, but I'm not going to do any of that because I just want to see if my LLM understands what I mean by glob pattern. Then I'll also have path. We don't have anything related to case insensitivity. Then I'll just say directory to search because we're not searching a file, right? Because how can we search for a file? We need a list of files to be present. So we will be searching within a directory for the file names. Awesome. So we have the glob parameters here. Let me just pass it in the execute as well. Now the first thing we did is created the parameters just like always. Then we have the search path, which is going to be the resolve path. Then we just check if the search path exists. If it does not, then we have directory does not exist. Then we pass in the search path, and maybe we can also have or not search path dot is directory, meaning the path that we have is not a directory. Maybe it's a file. In that case also the directory does not exist, it's a file. So I'll just return an error in both of those conditions. Now I need to find all of the matching files, and it's quite easy compared to all of the other tools we have done. To find the matching files, we can just make use of the glob function that path gives to us. So I can do it within this try except block. So I'll have matches is equal to, then I do search path dot, and then I call glob on it, and that's it. I just have to specify the pattern here. So I can pass in params dot pattern, and that's it. This glob will return a generator to me. I'll just convert it into a list as it is, and that's it. These are all of the matches. Now maybe we want to filter out all of the directories here because the glob is only related to files. So you just remove all of the directories. So you have matches is equal to, and we go over every path in this matches path that we have. And if this path is a file, then we'll just put it within this list. Otherwise, nope. If we run into any exception, it's not going to be re.error because that's for grep. We'll run into any sort of exception, let's say as e, and we return tool result.error result, and then we say error searching, and then I pass in the exception. After that, we have all of the matches with us. Now we just have to display it out nicely. We just have to format it just like we had done before here. So let me remove this if condition. We have output lines, which is going to be the display. Then I don't think matches is required, but let's just keep it in case we have any UI thing to show up later on. Then I'll have for file path in the matches list, and maybe I can go over 500 or 1000 of these, whatever one you want. I'll keep it 500 for consistency with the grep.py. But since grep also mentioned the line at which this happened, maybe we can go and increase it up to 1000. Because in grep, we also mentioned the path along with the line exactly how it was, right? That consumed tokens as well. So maybe here we can just increase the number of files that we are showing, because at the end of the day, glob is just going to return all of the files. No content of the file is going to be put out. We'll have file part dot relative to, because I'm trying to get the relative file similar to what we had over here for grep. And then I have invocation dot current working directory. So that gives me the relative path. Maybe we run into any sort of error here. In that case, I just want the file part to be as it is. You can put this try except logic in grep as well. For example, when we call relative to here, there can always be some sort of exception thrown here. So you can have a try except path, and as a fallback value, you just use the file path as it is. Because formatting is the last thing we care about. First, we care about the functionality of the app. Considering we have the output as the relative path, I'll just do output lines.append relative path. Maybe we can also convert it into a string because this is going to be a path, right? I'll just remove all of these things because, as I mentioned, glob is very simple. We just append the output lines. Then we just concatenate the output lines. We pass in the metadata as path. The matches is not required, I guess. Maybe file searched is something we can add, but I'm not going to add that. So just the path is enough for me. And I think we have some sort of issue here, and even in grep for that matter, which is whenever we exceeds 500, we are just returning the files, but we have nowhere mentioned that, hey, the files is now getting truncated. We've not said that we are limiting it to, let's say, 500 results or 1000 results. So let's add that as well. I'll add it in glob. If you want to do it in grep, go for it. It should be done, but I'm not spending too much time there. I'll just add here that, hey, if the length of this matches, and matches can be removed from here because I don't want to reinitialize it to 0, I'll use this matches list. If this length matches is greater than 1000, because remember, I've not truncated down the list here. I've truncated down the list here. So it's not stored in the matches variable again. So matches still can be greater than 1000. And if it is, I'll just add output lines.append, and I'll just say ... limited to 1000 results. And yeah, that looks good enough. Now, when we do \n, everything will be on a new line. That looks good. You can do the same in grep. Now I'll just go to the TUI again at the top, or not at the top, in the preferred order. I'll pass in the glob where we have the preferred order. The first thing is going to be the path, and then we are going to have the pattern. So that is a preferred order. Now we can scroll down where we have tool call complete, and then I'll just copy paste this exact thing because our logic should be quite similar, except all of these matches integer stuff, because glob doesn't have a support for all of that. Let me get matches. I don't know, I have difficulty deciding today what I want for my UI. Maybe I will put in matches because I already have it stored here. And I'll say that in the metadata, we have matches. And matches is just going to be the length of matches we have today, because it's a list of path, right? So I just get out its length, and these are the number of matches that we have for glob. Then we can remove this file searched. We don't care about that, because whatever files we search doesn't matter. The output will matter here. Then we have summary. If matches is an integer, we just put that in. And yeah, nothing really other than that matters. So maybe I can just do blocks.append text, and I'll just do the text added here. The style is going to be muted. Then I'm going to truncate the text. After that, I'm going to append the blocks. So I'll just paste all of that over here. So we have truncate text. We pass in the output which we get. Then the model name. Then we have the max block tokens. Also, let's remove the summary list from here. And then we have the output display, text, theme, and everything is just put in. So that's awesome. Now I'll just remove rest of the things from here that I copy pasted. We don't need it. And that's pretty much it for glob. We extract the matches, then we truncate the text and display the output. Now let's try to run it again and pass in my prompt that I wanted to earlier. Find all Python files. And that should be enough prompt. Let me just hit enter. And it uses shell. The reason it uses shell instead of glob is because I did not register it in init.py. So let's go ahead and have glob tool here. Then we have glob tool imported here from tools.builtin.glob, and that's pretty much it. Now close all the save files. Let's exit out of here. Let's try to run it again. And this time we'll say find all Python files for me, please. Let's see what it does now. So it does use glob, and we have 2302 matches. Hello world.py, main.py, everything gets printed out, including everything from .venv as well. And finally, all of that is just truncated out. Maybe we increase the max blocks tokens to a lot. Maybe we want to reduce it down to maybe 500 after this. So go for it. But yeah, glob is working. Again, what it did is that the pattern was ****.py. So it found out recursively that if there's any Python file present within any folder as well, and if it's present in the root directory as well. So in the root directory, it's in the root directory of the current working directory, alright? So it searched for main.py, it searched for hello-world.py, and then it went into every folder and searched for any py ending files. So that's it. That looks good. Now the next tool we want to work on is web search. This is a bit different from all the other tools we've worked on till now. All of our editing or reading related stuff is done. There are 4 more tools to add, which are web search, web fetch, memory, and to-do list. They are all related to helping provide better context as such. All the core tools are really done. We need all of these core tools to have an agent. Now, these are extra tools that would really improve our agent. For example, web. If you have a documentation online and you want your agent to read that, web fetch and web search would really help with that. So first, let's have web search.py. The difference between web search and web fetch is that web search is interested in finding the results for us, kind of like Google search, but web fetch is that you have a URL with you, you just call that specific URL to get all of the results. So that's about web search and web fetch. Let's go to grep again. I'll just copy this entire thing, paste it over here, or actually let me do glob because glob is much smaller, so it's easier to edit. And here, I'm just going to change out everything. So let's quickly edit out the names. So it's not a glob tool anymore. We have web search tool. The name is also web_search. Then the description of this is going to be search the web. Let me spell it out nicely. Search the web for information. And we can just say returns search results with titles, URLs, and snippets. Okay, that's going to be our output of this function. We want the title of the web page, the URL related to a web page, and whatever content was relevant to that search item. Also let me rename this to web search. Cool. Now the tool kind is going to be, well, the network operation, right? Because all of the web related operations of web searching is going to be network related. Then we have web search params, and now I'm going to define it at the top. It's going to be quite simple. The first thing is going to be the query. The LLM is going to give us a query to execute. What do we want to search for? And then we have a description where we are going to have a description, let's say search query. We don't have to specify much details. The LLM would obviously know what a search query means. And then we are going to have max results. How many results do we want from this? Do we want 1, 10, 15? So we are going to have max results, and by default the value is going to be 10. Also, it's going to be an integer. It's going to be 10 because by default, all the search engines go for 10, including Google. So we have 10. Then we have greater than equal to, which is 1, and less than equal to, which is 20. Maybe you can set this to 200 or whatever you want, but I think we won't need more than 20 results. After that, we have the description, and this is going to be quite simply the maximum results to return, and we'll just say default is 10. Okay, that looks good. Now we can just take this web search params, which is set as a schema, and use it to create the parameters here. Now we can remove everything because there's no file related operations that we are going to do. We are simply just going to use a library called DuckDuckGo search. And if you're not familiar with DuckDuckGo search, this is it. DuckDuckGo is essentially a web search engine similar to Google, and they provide a package for us. And actually, if you notice here, this package has been renamed to DDGS, and we can use pip install DDGS instead of using this DuckDuckGo search. So if you go to this URL and instead of DuckDuckGo search for DDGS, you'll notice that the name has changed. It's now Duck's Distributed Global Search, and you can use any search engine of your choice from here. You can have Bing, Brave, DuckDuckGo, Google, Grokpedia, Moji, Yandex, Yahoo, Wikipedia, anything really you want. We are going to stick with DuckDuckGo because it doesn't require us to pass in any sort of API key or anything. We don't have to put in our credit card information either, so that's all good. We're going to use this to fetch or search for a particular query and get the results, similar to Google search. So let me just install this. We'll do pip install DDGS, and then I can just put a try except block because, when you're trying to fetch results from an external package like DuckDuckGo search over the network, it can obviously return in some sort of exception. So if we run into any error, we'll just say tool result.error result, and I'll pass in a search failed, and I'll pass in the error message as well. After that, I'll have the DuckDuckGo search used, and if you notice in the documentation, they've mentioned how to use it. So here you just have to do ddgs.text, and then you can search for any query and you'll get the result, and the format will be title, href, and body. So title is the title of the article, href is the URL, and body is the snippet that we are searching for. So let's use this only. So I'll just copy this entire line, paste it in over here, and I'll import ddgs. Also have to remove all of these things. So I'll remove OS path, that's not required. We'll also remove all the path related stuff because web search doesn't require all of that information, right? And then at the top, we can just do from DDGS, we'll import DDGS like that. And now I can just call ddgs.text where I pass in the query, which is parameters.query. We can keep rest of the things similar, but if you want, you can change it. For example, region, time limit, page, whatever you want, or you can take it from the LLM because the LLM might know better, because in the LLM system prompt, we are passing in the date we are in. So if it's able to calculate, if it wants the most recent news about something, it can just do 7 days minus the date we are on, and it might work. So that's something you can look into. But anyways, we have the results with us now. What I like to do is just print out these results over here. Or actually, let's not return the results here. I'll just return it with success, and we'll just try to see it on the terminal because we do know what the output of that is going to look like. It's going to be a list of dictionary within which we have these title, href and body. Let's extract them. So we'll have if not results, just in case results is empty, we'll just have return tool result dot success result, and I'll say no results found for, and then we can pass in the query as well. So we have params.query just to ensure that the LLM has the right context, but I think it will know the right context even if you don't pass in the query here, because LLM is the one that provided us with the query, right? Now we want to format the output before we can display it. So we want the search results showing up. So I'll have output lines is equal to, and then I have an f string which just says search results for, and then I pass in the parameters dot query, and maybe that's enough. So these were the search results for this specific query. After that, I can go over every result in this results list and append it to this output line. So I have for I comma result in enumerate results, and we know that the starting value of this enumerate is going to be 0. I want it to be 1. And now I can just do lines.append. Then I have an f string. Also, it needs to be output lines, where I'll pass in the index. I'll put in a full stop so that we have something like number 1 dot, and then we have the title, then the URL, and then the href. So if you want, you can prefix this with title and have result at title. After that, I'll just copy, paste again, and then we have URL, and maybe we can indent this so that everything's nice. Also, we can remove this I dot. So we have something like this, 1 dot, and from dot we have the URL displaying. Maybe the LLM understands that better. And many times it can be the case that the body is not present. In that case, I'll just do if result.getBody. So body is not null. In that case, I'll just do output lines.append, and then I append the body. For body, I can just say that, hey, this is the relevant snippet. So we can just call result at body. And finally, after that, I'll do output lines dot append, and I'll append an empty string so that there's some space left between the first result and the second and the third and fourth, and so on. After that, I'll just go ahead and return tool result dot success result, and I'll pass in the first thing, which is \.join. Then we have the lines, which is just output lines. Then we have the metadata, which is equal to, and for the first time in so long, we don't have to pass in the path because that's not relevant. If you want, you can pass it in here, which is invocation.currentWorkingDirectory. But in our case, I'm just going to pass in the number of results we have. So I'll just have results, which I can pass as the length of the results. And maybe we might also want to pass in the query through metadata. Obviously, it can be fetched from the arguments as well. So either ways you can do it. Either pass it through metadata or the args will catch it. I'll just rely on the arguments. And that looks pretty good to me. So I'll just move to the next part. But before that, I'll just copy this metadata and attach it over here when we have another success result, which is, length of results. And maybe instead of doing length of results, we can just do 0. Either one is fine because here we have captured that the results is not going to be present. It's going to be an empty list. So that's awesome. Now we can just add it to init.py where we have web search tool, and then I'll just copy it, paste it here as well. Then we have imported it. Now let's go to our TUI.py where we can try to search for this. So we have an elif condition. We can paste it here, and then we have web_search and success. Now from the metadata, we want to extract the results, right? So I'll just have results is equal to metadata.getResults. If results is an integer, I'll just append it to summary. So we have summary as an empty list, and then we have summary.append. I'll pass in these many results were found. So results. So 10 results, 20 results, whatever. Then I also want to get access to the query. For that, we can just do query is equal to args.get, and I'll pass in the query. Then I'll just copy paste this again. So if query is found as a string, in that case, I'll just have summary.append, and maybe we can do query just like that. So we don't even need a string. Also, let's just put it at the top of results. That's good. After that, we'll have blocks.append, and I'll append the text where I pass in the dot, which is going to be a separator, and then call dot join summary. So this entire thing essentially. Then I can paste that in over here. Everything works out. And we only want to do that obviously if summary is not an empty list. Then we have blocks.append. Great. Then we truncate the text. So we have the output, and then we display it. We will still display it in a syntax. But if you want, you can style this out very nicely. And yeah, that looks like it. Pretty simple. So I'll just try to start the agent and let's see what it does. Maybe I can tell it to find the latest news for me. So search the web for latest news, and then I hit enter. So yeah, it does call the tool web search query is the latest news. And then we do get the output as well. The output is, well, the query shows up, which is latest news. Then we have 10 results for it. The first one is the title, latest version for the truth of the truth. Then we have Google News, NBC News. That's not really relevant because it just points out the latest news sources. We're not really interested in that. Maybe we can tell it more specifically. Give me news on Avatar movie. Search web for me, please. Maybe, in the training data of the LLM, there's something related to Avatar movie and it does not search the web for me. So I'll just explicitly say search web for me. And then we get all of the search results as well. We get 10 results here, and that's enough for me. So I'll just abort it and exit out of here. So that's good. Now the next tool I want to work on is, well, web fetch. We search the web. We have this particular URL, for example. I would just like to go ahead and extract that particular URL. Also, the URL is just incorrect because here I passed in title 2 times. Instead of title, I need to pass in href, and that should work, I think. So maybe we can try this again. I'll just copy this entire thing. Let's run the agent again, paste it here, and then we get the correct URL as well. So that's awesome. Seems all right to me. Now, all we need to do is give the LLM the capability to go to a particular URL and read that. To do that, we can't specifically use this entire engine, the DDGS part, because this is just for searching the results. It's not for going to a particular web page and fetching that. So to make it work, what we are going to do is go to that URL, get that data from the URL. For example, maybe we want to scrape this particular web page. So we'll just go to that web page. We'll try to extract all of the content from there, basically scrape it off and return it to our LLM. So let's quickly create that. It should be quite easy. It's just an HTTP fetch that we want to do. So we have web fetch.py. Then it's going to be basically the same thing as web search in terms of the structure. So we have web fetch tool, then we have web fetch over here, and then for the description we can just say fetch content from a URL, and it will return the response body as text. Nothing else. Very easy. Then we have web fetch parameter or web fetch parameters. I pass that in. It will extend the base model. The only thing, or actually 2 things that we require here is URL as a string, because what URL do we want to fetch from? So this can be http:// or https://. Then we have a timeout. Let's say in 120 seconds or 30 seconds, we don't get the response. What do we do then? So we just time out. So that's the timeout response. By default, let's set it to be 30, and it should be greater than equal to 5, because in 1 second, I don't think anything will happen, and it should be less than equal to 120 seconds. then we can just say request timeout in seconds, and by default it is set to 120. Now we can try to pass in all of the parameters here. So we have web fetch parameters. And after that, the first thing I would like to do is just validate the URL, because LLMs do hallucinate URLs a lot as of now. So first, let's just parse if the URL is accurate. We'll use URL parse method from urllib.parse. We'll pass in the parameters.url, and that will give us a value here, parsed. If this parse result exists, good. If it doesn't, then we have an error. So if not parse.scheme, or let's say parse.scheme is not in HTTP or HTTPS, despite me telling the LLM that, hey, the argument should be HTTP or HTTPS, still a possibility that might not happen. So yeah, we just handle that. And then if it's either of these cases, that it's not in HTTP or the scheme does not even exist, in that case, I'll just do return tool result dot error result, and I'll pass in that the URL must be http:// or https://. By the way, URL parse is not a very good indicator of the web page existing or not, because if you just go into this URL parse, you'll just see that it passes a URL into 6 components, which is scheme, which is HTTP, HTTPS. Then you have net location, path, parameters, query, and any fragments. So it's essentially kind of a structure parsing, maybe a regex. You can think of it like that. So it's not a very hard yes or no that the URL does exist, but it just validates if the structure of URL is right or not. After that, we'll try to make a web fetch request, and to do that, I'm going to use HTTPX. If you're not familiar with HTTPX, you can search it on PyPy. HTTPX is a fully featured HTTP client library for Python 3. It includes an integrated command line client, has support for both HTTP 1 and HTTP 2, and provides both sync and async APIs. We are interested in the async API, that's why we are using HTTPX. Now, how do we use this for our web use case? Well, first we'll open up an async client connection. We'll do that using a context manager. So we'll have async with, and then I'll have HTTPX. Let me import HTTPX at the top, and then we'll have async client. Cool. Now I need to pass in the timeout. So the timeout is equal to HTTPX dot timeout, and then I pass in the parameters dot timeout. Then we'll also set follow redirects to true. This essentially means that if a web page redirects us to a new page using 301 or something like 302 status code, it will just follow that web page, and from there, whatever content we get, like 200 or 201 or maybe 500, we'll get that. So we're just following the redirection that the web page might do. After that, we'll just get this as a client, because we are opening up a context manager, right? We'll get access to the async client itself. And now I'll just pass in client.get, then pass in the URL that we want to fetch. So we have params.url, and this will be a response. Now the response is again coroutine, so I'll await it. And now I have the response. Now whatever response I have, I just want to check if the status code is 200 or 201 or any of the acceptable status codes. If it's not, then I just wanted to raise an exception. So I'll have response dot raise for status, and if there's any error, it will raise the HTTP status error. And we are handling all of the exceptions here, but I would like to be more thorough with this approach. So first I can check for the httpx.http status error, which is the one this one will return in case of any exception. And I'll just say that, hey, return tool result.error result if this happens. The error string is going to be HTTP. Then I pass in the response status code here, and I need to get access to this E. So I'll have E here. So we are telling the LLM what status code we got, because LLMs are really good at understanding what status code is. And we can also maybe attach a reason. So we have e.response.reason phrase. What is the reasoning? that we have for this. So that's good. Then maybe we can also handle the timeout error that might happen. So I'll have except httpx.timeout exception, and we'll return this tool result.error result, and then I'll say request failed and pass in the error message. That looks good to me. And if there's any other exception, I'll again just say request failed. So actually there's no need of this timeout exception handling as such. We can just remove it, because in both the cases we're just returning the entire error message with the message request failed. And that's good enough for me. So I'll just try to decode the response from here. So I'll just remove this entire thing and then say text is equal to response.text. Also, I can just put the text here just in case the raise for status doesn't raise any exception. We do get the text. Or actually, let me do it outside, because even if we run into... And then once we have this text, we can display it directly. But before that, I would just like to truncate the output if it's too long. And again, we can just do if length of text is greater than 100 into 1024. That is 100 kilobytes. I'll just do text is equal to text, and I have 100 into 1024 plus, and then I can just do \n ... truncated content, and yeah, I can just return the success result after that. From here we can pass in a lot of metadata, for example what status code we got. So let's just attach it here. The status code is response.status code. Then maybe you want to display the content length, which is just going to be response.content, and I can just do the length of this content because it's going to be in the bytes format. So I'll just say these many bytes. And if you want, you can also display the content type, but I'm not interested in displaying that. So yeah, that's good enough for me. I'll just go back to our TUI, but before that, let me just remove this import of DDGS, not required. Now I'll go to the TUI. Similar to web search, we'll just copy paste our stuff. So we have a web fetch here. And if it's a success, then what do I want to extract from here? I want to extract the status code. So we do that. After that, we have content length. So we'll do that as well. And then I'll just check if the status code is of integer. In that case, I'll pass in the status code to the summary. After that, the content length, if it's of integer, we'll just attach it. So we have content length in bytes. Then you might also want to display the URL. Also, this needs to be metadata.get. But for the URL, we'll be using the argument. So we have args.get and we pass in the URL. I'll just copy paste this again. So I have if URL is of the type of string. In that case, I'll just append the URL as it is. Then we check that, hey, if the summary is not empty, in that case, I'll do blocks.append and I'll pass in the dot, which we had in every single one of these. So I'll just copy this dot, and actually it's already done. I don't have to do that. So let me just remove that line. So we have dot join summary, then the style is muted of that. Then we have truncate text for the output, and then we display the output nicely. So let's try to run it and see what happens. I'll just exit this. Also, I've not registered the web fetch tool. Let me register it. I'll go to init.py, and here I have web fetch tool. Then similar to that, we have web fetch tool here. Let me import it. That's it. Now let's run it. So we have python main.py, and I'll say get me the box office collection of avatar by searching on the web. Let's see what it does. And we do get the web search, but it just gives me the search results. It's not really looking for the answer. Maybe this is an opportunity to improve the system prompt for web search related tools. I'll not get into that. You can definitely go ahead and tweak the system prompt to your liking. I don't think there's any mention of web search related or web fetch related tools. You should add it. What I'll do is tell it that, hey, what does this URL tell us? So maybe it can fetch the content from this URL and try to give it to us. I'll say get avatar 3 collection from this particular URL and then hit enter. And as you can see, it does call web fetch tool. It passes in the URL as I listed out over here, but then it runs into an error saying sequence item 0 expected string instance integer found. So I can just say that everything we have here is going to be of the type of string, or I can just convert this into a string before I append it to summary. Both of them fine. Now let's try to run it again, and directly I'll just pass in this particular prompt so that we call the exact tool. System prompting and changing the prompt is up to you now, and this is the data that we get. There's these many bytes. This is the URL and the status code was 200. If you examine this web result, you'll notice that we have not tried to extract any text from here. We just gave the entire web page to the LLM, because doing that is totally possible. There are packages that you can use for it, but I don't want to spend much time on it because the LLM is able to understand code really well, right? If it's able to understand code, this is an HTML code. It is able to understand it and it will give us the output. That's the logic behind giving the entire web page. However, it would be more efficient if you just give it the entire text by scraping it. I just don't want to get into it. You can look into dependencies, or you can just try to extract data from the HTML code yourself. So I'll just close this, and now I'll move on to the next tool. And the next tool we are going to work on is todo.py. Now, what is this to-do list? Why do we need it? Well, whenever the agent is working on something complex, it might want to make a plan of what it needs to do next and what it needs to do after that. So let's say I tell it to create a Netflix clone for me using HTML, CSS and JavaScript. So it will just create a plan of how it wants to go about it. First, it will go ahead and create the HTML file for me. After that, it will create a CSS file for me, then a JS file for me, and then maybe it will create tests to test out this HTML, CSS and JS application. So those are 4 steps. It would be good for an LLM to just make a plan before that so that the user knows what's going on and agent is kept on track of what it needs to do. Because if there's a to-do, and with each prompt that we give it, or each turn that happens, the LLM will be able to reiterate what it wants to do. That will help it to better remember what it needs to do. For example, let's say I given the prompt. Now, if the LLM just goes and creates these 4 files, it might create it for HTML, CSS and JavaScript because the context length fits, everything is good. But if it turns into something complex, it might forget that HTML was done, CSS was done, and maybe it just starts writing the test for it. It doesn't go to the JavaScript part. We need to reinforce in its mind what it needs to do. It's just a clear separation. That's why we'll first tell the LLM that, hey, create this to-do list through our system prompt. Then it will create this 4-step to-do list for us. Then it starts working on the first item. When it's done, it will just say that, hey, I worked on this first item, it's done now. Then we have the second item, I'll work on the second item now. Then when it's done, it will tick it again. Then it goes to the third item, then it tick marks the third item, and then it goes to the fourth item, and then ticks it up. And then the entire request is fulfilled, and there are no more tool calls. The entire agentic loop will break. This is a more systematic way to go about things, and even for the LLM to remember. Also, if it doesn't break down the request in 4 steps, it might try to do that in one single step. So in one single message, we say create Netflix clone using HTML, CSS and JavaScript. It will just go ahead and create those 4 files in just one turn. We'll have one message from the LLM saying there's 4 tool calls you need to make. One write file which writes to index.html, one write file tool call to styles.css, one write call to script.js. That's not good, because the LLM, if it tries to do everything in just one message or one turn, will not do as good a job as it can if it was broken down into 4 turns, because in the first turn it will solely focus on HTML, so it will have a better representation of the syntax. It will have more clearer structure. Same for the CSS, where it will focus more on the design. Same for the JavaScript, where it will focus more on the interaction. So the output is just going to be better. Obviously, it's going to consume more tokens, but the result will be dramatically better. You can try this experiment on your own as well. So in one message, you can try telling the LLM that, hey, please create Netflix clone for me using HTML, CSS, and JavaScript. And then you can try telling the LLM that, hey, first create Netflix clone using HTML, CSS, and JavaScript, but first create index.html, then create styles.css, then script.js, and the output will be much better. Obviously, the problem with this part is that you have to type in 4 messages, but our agent will just automatically infer and convert it into, having understood why we need plans, let's go to our to-do. It's going to be having the same structure as rest of the tools. So let me just go to web search or web fetch, any of them. I'll just copy and paste it in over here. Now let's edit all of these text. Let's rename the class. So the class is called todos tool, and we are going to call this todos as well. Then the description is going to be manage a task list for the current session. And then we can also say use this to track progress on multi-step tasks. So, we are clearly defining when to use them and when to avoid it, because the user's request can be very simple. And in that case, we don't want to over-engineer something for them. It can be a simple line change. So yeah, don't use the to-do list then. After that, we are going to have the to-do parameters. So we'll have to-dos, params, and then we can also remove DDGS. We're not going to use it. And now, the first thing we're going to have is an action. The action is going to be of the type of string. And what this action does is lets us know if the action is going to be an add to do, or it's going to be a complete to do, or is it going to be list all the to dos or clear off all of the to dos. So we can just say action and then say it can either be add, or it can be complete, or it can be list, or it can be clear. Cool. So adding a to-do just adds one element to the to-do. Complete means we've ticked it off. Then we have list, so it lists all of the things in our to-do. And then we have clearing off the to-do. Now there's only going to be one to-do per session. So that's important to keep in mind, because if there are 2 or 3 to-dos in just one session, the agent will obviously get confused. The agent thinks quite linearly. It doesn't think like a graph. So it doesn't make sense to have multiple to-dos. The other thing is going to be the ID. So we'll get a string or a null value, and by default it's going to be null. And then we have a description where we say to do ID for completing. So whenever you try to complete a to-do, you have to let it know that what row are you trying to check off. For example, if I go back to Excalidraw, I told you that we're going to have to-dos with 4 steps, right? So for the first one, maybe it completed it and it wants to tick it off. How is it going to tick this off for the first element? So it needs to specify some sort of ID so that it can tick it off here. That's why we're using the ID. After that, we have the content, because what is the content of the to-do, and then we can string or null have it, and then we have a null value by default, and we say description saying to-do content for add. If it's trying to complete an action, we don't need the content, but if we are adding something, we do need the string value. Or even if we are listing, we don't need the content to be present here. Now we can take this to-do's parameters and add it as the schema. Now, the description is checked off. The kind of this is going to be memory. It's the first tool that is memory. Other than that, we're going to have another tool which is memory, which saves users' preferences or details about the user. But this is also a memory, right? We're trying to remember some sort of to-do list. And yeah, that's pretty much it. Now I can just create a parameters here, which is to do parameters. And then there's another thing we require here, because think about it. What is a to-do list? How are we going to store it? Well, I told you that there's going to be an ID. So essentially there's going to be a mapping between ID and the content. The ID is going to be the to-do ID that the LLM specifies, and the value is going to be whatever content the to-do gives us. So for that, we have to maintain some kind of dictionary. And for that particular reason, we're going to have an init function as well. So we'll have something like init here. And since we are in a class that extends from this base class, we'll have to pass in config, which is of the type of config. Let me import it from config.config. And obviously this init is going to return nothing. So we have given the config to our base class, and now we just have to maintain a dictionary of to-dos. So we'll have self.todos dictionary, obviously a type of string comma string. The first string is the ID, the second string is going to be the content, and then we have an empty dictionary. Cool. After that, we just have to determine the action that's happening here, and based on that action, we are going to update this to-do dictionary. So let me just remove off everything other than the tool result.success result, which we will probably take reference from, or actually we might not. Let me just remove that as well. Now we can just have if parameters.action is equal to add. That is the first possible value, add. If you want to make this concrete, you can also lower this and check if it's equal to add. If that is the case, then first we'll have to check if the ID is present or not. If that is the action, first we'll have to check if the content is present or not. So we'll check if not parameters.content, that means the content is not specified. We'll just return the tool result.error result saying that the content is required for add action. You can obviously make this more detailed and descriptive, but I'll just say for add action, and then maybe we can also make it say content like this, because content is a special value. If the content is present, in that case, I just have to do self.todos, and the ID needs to be equal to params.content. But we might not have the ID over here. ID is only required when we are trying to complete an action. Whenever we have add, only content and action will be present. When we have complete, action and ID will be present. Whenever we have list, we will only have action present. Why? Because the LLM might not give us a unique ID every single time. It might just reiterate the same ID again and again for add. We don't want to take that risk when we can generate our own ID ourselves. So we'll say that to do ID is equal to string, and then I'll create it using UUID. So I'll just create UUID.UUID4, and let me just import UUID, and maybe I can truncate it down to 8 characters. That should be enough for me. The entire to-do ID string is not required. Only each row of my to-do list needs to be unique. So 8 characters or even 4 characters will just do the task. So I'll set this to-do ID as the key, and then params.content is the value, and then we'll return tool result.success result, and then we can pass in added to-do, and then maybe I can give it the to-do ID. So I'll give it in the same format as we store it, kind of in a mapping value. So we have to-do ID here, which is going to be equal to parameters.content, right? So this is important context for the LLM, because this to-do ID is created by us. So the LLM obviously needs to know that this to-do ID, what this to-do ID is, because in the future it will have to update this to-do, and for that it will require the ID. So we are just giving that context to the LLM. Now another action can be complete. So we have params.action.lower is equal to complete. In that case, we'll just check again if the params ID is specified or not. So I can just copy paste similar thing. So here we have if the params.id is not specified, in that case we'll return tool result.error result, and then we have ID required for complete action, and maybe we can format this similarly. So we have ID like this. Cool. After that, we check if the ID that was specified is even present in this to-dos dictionary. If it is not, we again have to return the error. So if this params.id is in this self.todos dictionary, well, if it is not in todos dictionary, then we want to return this error result, because if it is, that's valid for us. We'll just mark it as complete. So I'll just say to do not found. That seems like a good enough error. And then I'll just pass in the parameters.id. Obviously an f string is also required. Now once we do get the valid id, in that case we'll just do content is equal to self.todos.pop, and I'll pop off the parameters.id. So whatever element was present within the todos dictionary that had the key as params.id is removed, so we get this entire content with us, and then we can just return the tool result dot success result saying, yeah, we completed the to do where the params.id was the id and the value is the content. After this, there's the other action of list. So we have params.action. If it is equal to list, in that case we just have to list out all the to-dos. So first I'll just check that, hey, is there any to-dos even present? Because it can be the case that we added 4 to-dos, we completed the 4 to-dos, and since we pop off all of the to-dos, we don't have the to-dos remaining. And list will most likely always be called whenever we have to check if all of the to-dos are done, if we have no more to do. So we'll just check if not self.todos is remaining. In that case, we'll have return tool result dot success result, and then we can pass in no to-dos are left, right? Because it is a success. Everything was great. But if we do have to-dos, then we have to display it out. So we'll have to-dos like that within a list. Let me just remove the space, probably not required because everything is going to be on a new line. And then we'll have for to-do ID content in self.todos.items. And I'll just append the to-do ID with the content every single time. So I have lines.append. Let me just call append here. And maybe I can format this nicely. So I'll leave some indentation here. And then I'll have to-do ID. Obviously, it's going to be an f string here. And then we can pass in the content or just the content like that. And then we can return tool result dot success result again. And this time we're just going to do \n dot join, and I'll pass in all of the lines. So that is it about the list. Now the last action that can be performed here is going to be clearing of the entire list. So in that case, I'll just do self.todos.clear and we clear off everything. That's it. And I'll just return the tool result dot success count or success result, and I'll say cleared all to-dos, or maybe instead of saying all, I can be more specific and say how many to-dos did I even remove. So I can just count the length of the to-dos before clearing, right? So we clear it off, but before it, we have a certain count, and then we just have cleared, let's say 5 to-dos or 7 to-dos or whatever. Now, if it's none of these actions, the LLM hallucinated. Because of that, we have the wrong thing. So I'll just return an error result. So there we go. And now in the error result, I can say very simply unknown action, and I'll pass in the parameters.action. That's it. So yeah, that is it about this to-dos tool. Let me just register it using this get all built-in tools. So I have to-dos tool. I'll import it from tools.builtin, and I'll add it to this all list as well. Now we just have to go to the UI, and you can make the UI very complex, and I do have a complex UI with me, but I'm not going to write that down because it's going to take a lot of time, and you might know how to go about doing that UI, because remember, it's a to-do list. It's essentially a table that we are getting. We have status, whatever to-dos are present here, it's going to have some sort of status attached to it. Then you have the ID, and then the description of the task it is going to perform. So based on the status, if it's completed or it's a work in progress or it's still pending, based on that, you can show the different styles of the to-do table, and then obviously create a table out of it. We have already created a table. You can take a reference from that. But I'm not creating that complex UI. I'm just going for a very simple one because I want to make this tutorial a bit short. So I'll just do tui.py, and here, similar to this web fetch, I'm just going to do a case of to-dos. And this is going to be very simple. We don't have any summary. We don't have anything. We just have an output. And the output is just going to be displayed within a syntax. As I said, go ahead, create a table. It will look much better, but I'm just going forward with this one. As simple as things can get. So I'll just save this. Let me remove a space. And now I'll just open up the terminal, create the agent, and I can give it some sort of complex task. And if it doesn't use the to-do list, then we can update the system prompt to be more aggressive in a way so that it always uses a to-do list for complex tasks. Maybe even a 2-step process, it will start using a to-do list. But I'll just say create WhatsApp UI clone using HTML, CSS, and JavaScript. Ensure you plan it out nicely and get this working. Let's see what it does. As you can see, the to-dos are called. So the very first to do is a content where we have one line added, and the action is add. It adds the to do with this ID, plan the WhatsApp UI clone structure. Then it adds another one, create the HTML structure for it, the UI. Then it calls add CSS styling for the UI components, and then it says implement JavaScript functionality for chat features, and then it will test and verify the UI clone. So these many actions were taken together, because the LLM just called all of them together. So if you want to avoid this, you can create another action that will be add all. So it can just take in a list of to-dos, and then it can add the to-do to a list directly. So instead of having 4 tool calls, you just have one tool call with action add all. Also, you can update this UI to look much better. For example, you can maintain the to-do dictionary here, and then whatever is the state of the to-do dictionary, you just keep on updating that. So let's say we got add action over here. We just add the to-do to our dictionary here and display it out nicely. So instead of displaying one to-do add here, one to-do add here, you just display both of the to-dos together. So you maintain kind of a persistent state here. Okay. So yeah, our assistant is now planning the WhatsApp UI clone. Then it goes ahead and creates a write file. Then it completes the to-do because it created the HTML structure. Then it creates a CSS file. Then it again calls completed to-do, and then it goes on and on. So the UI part of this looks quite horrible, but the LLM does work very nicely. And maybe if we want to see the output of this, we can open up the index.html file. And this is the WhatsApp clone it comes up with. Not totally bad. There is some structure to it, but obviously a bunch of bugs that can be fixed. If you change the internal model, I'm sure we'll get a better output as well. For example, if you use Claude or something like that, you'll get a much better output. Your agent is really very good if your LLM is very good. So yeah, that was about to-dos. As I mentioned again, if you want to maintain some kind of persistent state on the UI side and display it, for example, you keep track of all of the to-dos, and you also keep track of, let's say, something like this, where if the previous tool call was a to-do call and the next to-do call is also a to-do call, then you just merge both of them together. That's also possible to be displayed in the UI. So you can do that as well. So up to you. There's lots of opportunities in terms of UI development, in terms of any changes to the to-do list that you want to do, but I'll just keep this and we can move forward. So the next thing I'm interested in, and the last built-in tool, is the memory.py file. So this will help us remember users' preferences, and we are actually going to store this in the file system. So any user related memory, for example, the user might say my name is Rivan. I want to remember that. So I'll store it in an append only log behind the scenes in the user's file system. And whenever the application loads up, I'll load the memory up from that file system and then append it to my system log. Or an alternate way of going about it is you tell in the system prompt that in case the user mentions something about their preference and you don't know about it, then you can just check the memory tool and try to fetch the relevant details about it. Two possible ways, but first let's just write down our memory tool and then we can see what we need to do about it. For the content of the file, we're going to go to the to-do, copy everything and paste it in memory. And now we can have the memory tool instead of the to-dos tool. Then we can name this as memory. After that, the description is going to be store and retrieve persistent memory. Use this to remember user preferences, or if you want to store any other preferences, you can do that. Something like important context that needs to be used across every single application, or maybe some notes. So yeah, all of these things. After that, the kind is still memory. The schema is going to be the memory parameters, and then we're going to create that class. Now, what is memory parameters going to take? It's going to have action as well. The action can be set. It's not going to be add. Then it can be get. So you set the memory, then you get the memory, then you delete some memory, then you list some memory, or you clear off all of the memory. Let me pass in the single inverted comma as well. So that's it. After that, we don't need the ID here, we just need a key and a value. So the key needs to be a string or a null value because, well, you will need a key when you're trying to set or get a value or delete a value. Because you'll need a key if you want to get or delete a value, but when you're trying to set a value, we are going to create our own key. And when we are trying to list all the memory parameters or list all the memories that we have stored or clear them off, we don't need the key. After that, we'll also have the value, which will also be a string or a null value. And let's update the description here. So the value is just going to be value to store, and this is required for set operation. Let me just pass this in backticks. After that, we will have the description for key, which will be memory key. And let's just say this is required for set, get, and delete operations. We can also put this in backticks. Now, if you want, you can say that the memory key is not required for set, because when we are setting the key, we can just create our own ID, just like we had in to-do. But it is also possible that we might want to override a value, and in that case the key can be given off by the LLM. That's why we are taking the key. Now that we have all of this done, we can remove the init function. We won't require it over here. We don't have to maintain any sort of dictionary here. The reason for it is our source of truth is going to be the file system. We are going to store actual user preferences or notes, whatever, in the actual user directory. So instead of having an init, we're just not going to have that. We're going to reference the file system every single time. Then we're going to create a parameters with memory parameters, and then we will listen for each action. So the first action can be a set, and if it is a set, then I want to check if the key is present. And if the key is not present, so let me pass in key should be present, or the value should be present as well. So let's say if not params.key or not params.value, in that case, we'll return the tool result.error result. Okay. Now the error message for this is going to be key and value are required for set action. Of course, you can format this nicely by doing key like that and value like that as well. But after this, I'm not going to do it for any other error result. You get the point. But if we do have a key and a value, then we want to set the value. And as I mentioned, if you're setting a value, it should directly go within a file system. So we are going to have a persistent memory in the user's file system, and we'll try to store the data over there. Now, where are we trying to store the data? For that, we are going to go to our config loader file. If you remember the config/loader.py file, where we had created get config directory and get system config path. These were related to the configuration paths where we stored any configuration files, right? Like config.tuml file. Similarly, there's also another one where we can create, which is the user data directory. So essentially, whatever data you want to remember about a certain application, you'll create it in that directory. For example, Chrome does it. If the Chrome wants to remember certain things about you, it will create that data directory and store all of the data like your browsing history, bookmarks, cookies, passwords, cached images, all of that. In macOS, it's generally stored in this location where we have root folder, where we have library, application support, followed by whatever is the name. For example, for Google Chrome, it would be something like this. But in our case, it would be AI agent, something like that. The key point is all of the applications store their data if they want to in the file system using this folder. And we're going to make use of that. So we can have def get data directory, and then we are going to return a path from here, and the path is just going to be return path. Then we have user data directory, which comes from this platform directories package. And now I can just pass in the app name, which is AI agent. Now we can use this get data directory within memory. So let's try to load up the memory. For that, I'm just going to create a helper function, which is def load memory. It's going to have self and it's going to return a dictionary. Then I can try to get the data directory, and I'll import this from config.loader, and this is just a data directory. Now from this data directory, I want to get this directory if it exists, and if it doesn't exist, then I will create it. So I'll just do data directory dot make directory parents is equal to true. So it will create this entire directory and the parents if required. And if it already exists, then it doesn't have to return any error. It's still fine. It can just create that directory or give us access to that directory. And now I can just do return data directory / and then I'll pass in user memory dot JSON. So what have I done here? I tried to get the path to the data directory. Then I tried to create that directory if it doesn't already exist. And if it exists, it's totally fine. We don't do anything. And then we will try to go to that data directory and access the user memory.json file. This data directory will also have other things with it. For example, when we try to do checkpointing and session management, we will store the data in this get data directory, whatever path this get data directory gives to us. So there'll be a user memory.json file, and there will also be folders related to checkpoints and sessions. And in that folders, we'll store all of our checkpoints and sessions. We'll talk about that later on, but you get the point. All of the data that we want to store will be stored here. And now I can try to load the memory. So I don't really have to return anything from here. I'll just say this is the memory path. Now the first thing I'll check is if the path exists or not. If the path does not exist, that means the file is not created. If the file is not created, then I'll just say that the entries that we found, the memory that we found is just empty. So here we'll return a dictionary with entries, and the entries object is just going to be an empty dictionary. This entries dictionary or this entries key is going to have the value where there will be some sort of memory. This is maybe the key that it gave us, and the value will be stored over here. Let's say the user likes whatever. So this will be the storage format. Then you have another key where you just store something else and then you give it a value. So this is what the data is going to look like. But if the part does not exist, the file does not exist, that means no file has been stored yet, no memory has been stored yet, it's just empty. But if the path exists, then what I want to do is read the text of this entire file, and since it's going to be stored in a dictionary format, essentially a JSON format, we are going to return that value. So I'll just do try, then we have content is equal to path.read text, and I'll pass in the encoding, which is UTF-8. After that, I'll just do return JSON.loads, and I'll return the content. Also, let me just import JSON. Then we have exception, and if we run into any sort of exception, then I just want to return this empty dictionaries object. Now we will call the load memory option here, or the function here. So we have self.load memory, and it will return to us the entire memory. Now I'll store this in the dictionary object, and then I'll just do memory at entries, because that is the object, right? Memory at entries. Everywhere we have entries key, and at this key we are going to store our params.key, which we get from the LLM, and set it equal to params.value. Cool. So as I mentioned before, the dictionary structure is going to look something like this, where you have entries, then you have another object, and then you have some sort of key, and then there's a value storing the user's preferences. Okay. And now I want to save this memory. So what did I do? I loaded up the memory from file system, I updated the memory, and I now want to push back the updated memory to the file system. So I'll just create a helper function for that as well. So we have save memory, then we have self memory as a dictionary, and we are going to return nothing from here. And all I need to do is first get access to this entire user memory stuff, and then I can just write to this particular file. So I'll do path.write text, and I'll pass in the entire memory dictionary that we get. But remember, this write text requires a string and memory is a dictionary. So what we're going to do is json.dumps. So we'll dump the entire thing here, and then maybe we can pass in an indentation of 2 just in case the user wants to take a look at it. It's formatted nicely, and ensure ASCII is equal to false. Okay. You don't really need that last argument, but it basically means that the value should not necessarily be ASCII values. It can be something like a Chinese character as well, or a Hindi character, because I don't think they're part of ASCII. And many times the LLM might hallucinate. For example, I've seen Gemini models return Chinese characters while they're typing out English. So it's totally possible. And in that case, we want this ASCII to be set to false. Otherwise, all of the characters will be escaped that are non-ASCII. So having done that, we can just take this save memory and call it in over here. So we have self.saveMemory, and then we'll pass in the memory dictionary that we updated here. Then I can remove these 2 lines, and then we have toolResult.successResult, and maybe I can just say set memory, and I'll pass in the parameters.key. After that, we have get, and it's going to be quite similar now. We have all of the helper functions that we might need, I think. So we'll just check if the parameters.key is not present, then I'll just say that key is required for get action. Then I will try to load up the memory. So I'll have memory is equal to self.load memory. I'll check if the parameters.key is not present in the memory either. If that is the case, that means a memory with that key does not exist. So I'll just have return toolResult.successResult memory not found, and then I have parameters.key. Otherwise, we do have the key, so we'll just try to return that memory. So again, we'll have toolResult.successResult, and then I'll say memory found. Then I'll pass in the parameters.key, and then I'll pass in the value associated with that, which is memory at entries, and then we pass in parameters.key. So memory found, this was the key, this was the value. After that, we might have the delete operation. So again, for delete, we do require the parameters.key to be present. So if the parameters.key is not present, then I'll just return the same error. Then we'll try to load up the memory again. And then I'll again check in the memory if parameters.key is not present. And actually, we don't have to check in memory, because if you remember, the memory structure looks like this, where you have the entries key, and within that, you have the parameters.key. So we'll have to do something like if parameters.key not in memory.get, and then we'll call in the entries, and if it's not present, then an empty dictionary, because entries can also not exist, right? If this is the case, then we'll return that memory not found, and then I can copy paste this exact same thing again in delete as well. If parameters.key is not present, then we'll just say memory not found. Otherwise, we'll go ahead and delete the memory at entries at parameters.key. Then I'll try to save the memory, and I'll pass in the memory object, and then I'll return the toolResult.successResult, where I just say that, hey, I deleted the memory, we are all good. So I'll have deleted memory, and then I have parameters.key. Obviously, it needs to be an F string, and that's it. Then we have the other action, which is listing all of the memories out. And for that, we don't really need a key. All we need to do is load up all of the memory up front. Then we try to get all of the entries. So we have memory.get entries, and if it's not present, an empty dictionary. and then I just check if the entries is not present. In that case, we'll return a tool result.success result, but the success is going to be that we did not find any memory. So we'll just say no memories stored. That seems like a good enough line. And then I can try to list everything. So I'll have a lines list similar to how we did in to do. So we have stored memories, and then I'll go over every memory. So we have for key in sorted entries.items. Also, we will be getting the key and value pair here. So there are items, and then based on the key, we are sorting everything, and then we just get the key and the value. And I'll just do lines.append. Then I have an if string where I leave some space. Then I pass in the key, and the value will just be the value. And now we can try to return the tool result.success result. Since we have everything in the lines, we'll just return that, where we have a \n.join, and then we pass in the lines. Now the last condition that we might have is the clear off part. And I'm just going to copy paste it from the to do because it's going to be very similar. So I'll just paste it here. And now if the parameter.action is clear, then the first thing we want to do is load up the memory. Then I'll do a count of the length of memory dot get entries, how many ever entries we have. Then I'll set memory at entries equal to an empty dictionary because we're clearing off everything. And then I'll just call the save memory function, and then I can just remove this todos.clear, and I'll just say cleared count memory entries, and that's pretty much it. And if there's any other action we don't know about it, we'll just say unknown action parameters.action. That looks good enough to me. Now I'll just go ahead and register this tool. So I'll have memory tool at the bottom, which is our last built-in tool, except for subagents that we'll add shortly. And then we have the memory tool here. Now we just have to go to the TUI.py. It's really going to be very similar to to-dos. We just have to display the syntax. Again, go ahead if you want to make this a good UI experience, but we'll have the name as memory, and then if it is a success, then obviously we're going to have the output display. We're going to display it here, but before that, we'll try to get the action that was taken, and we can do that using args.get action, and then we have the action. I'm not explaining this further because we've already talked about this quite a bit. Now, if the action is of the type of string, and action is not empty or null or whatever, we will just have summary.append, and then I'll append the action that was taken. And then we'll also have a summary list here. After that, we also need the key. So we can also try to get the key here, which is key is equal to args.get key. And then if the key is also present, we are going to do a similar thing. So if key is instance of a string and the key is present, then we'll do summary.append key. And now if the summary exists, then we'll just do blocks.append, then we pass in a text where we have this dot symbol that we have talked about so many times. And actually I think the code here is very bad because we're doing the same thing again and again. Maybe we can create some sort of helper function, do some abstractions around it, and reuse them again and again. Then we have the style here, which is muted, just like everything we've done before. Also, let me just try to add in some metadata here. For example, whenever we try to get something in the memory, I would like to say if we got a value or we did not get a value. For example, here we are having if params.key not in memory.get entries, memory not found. So we did not find a value, right? So I'll just attach a metadata here saying that found was false. We did not find whatever we were looking for. So I'll just copy this metadata again. And here when we try to return a value, we do have the found because the memory was found. So we'll set it to true. And when we are trying to list as well, we can again attach this metadata, found is set to false, and then we return the success, the found is set to true. So yeah, whenever we try to get some sort of value, either through get action or list action, we'll just attach this metadata and display it on the screen in the TUI. So I'll again have found is equal to metadata this time, not args, and then we get the found value. Now, if found is an instance of Boolean and found exists, and then we'll just have summary.append found, we'll write down the found string if found is set to true, otherwise we'll have missing. Also here, I'll have to update my instruction a little bit. I'll just check if found is an instance of Boolean and found is specifically not null. Because if it is null, then we don't want anything related to it. So if it is not null, that means it has certain value to it, a true or a false. So if found is true, then we write down found, otherwise missing. I don't think this carries a lot of value, because if found is an instance of Boolean, then found is not going to be null. So this is kind of unnecessary. I'll just remove it. And yeah, this looks good to me. Now I can try to store some preferences about me. So I'll just exit out of here, open up our agent. Also, I forgot to do one thing. At the top, we forgot to pass in the preferred order. So the preferred order for memory and to-dos is also required. I forgot about that as well. There's going to be action, then key, and then value. As it is, nothing too different. And then for to-dos as well, we are going to follow something similar, where we have maybe ID first, and then you have action, and then content. I think this would make more sense for to-dos. So yeah, let me restart the agent again. So what can I tell to our agent? Maybe I can tell it, I'm Rivan Ranawat. Remember that. So, and maybe it should also acknowledge me by that name every single time. So I'll just say acknowledge me with that name every time I talk to you. And let's hit enter. So as you can see, the memory did get called, the action is set, the key is username, and the value is Rivan Ranawat. So it set memory username. And then it says, hello Rivan, I will remember to address you by that name every time we interact. How can I assist you today? Awesome. Also, as you can see, it did say set, which was the action, and then the key username. Then maybe I can try to exit out of here. Then I'll again have this called, and I'll say, what is my username? Then hit enter, and let's see what it replies us with. And as you can see, the output here is your username is not provided in the current context. If you're referring to your system username, you can check it by running the whoami command in the terminal, etc. So it doesn't really remember that username. And the reason it doesn't remember it is because I told you there are two ways to go about it. First, we can explicitly tell the LLM that, hey, you have to call this tool of memory so that you can extract my name. The second thing is we attach it to our system prompt, and that's what I'm going to do. I'll go to the system prompt here and attach whatever memories are coming in or we are storing directly in the system prompt. So what I'll do is take in the user memory from the parameter here, and then I'll just check, or by the way, user memory can be null as well, and by default it is null if it's not specified. And then I can just check if the system or if the user memory is present. And then I can just add the if condition of if the user memory is present, then we create a function of get memory section where I pass in this user memory. And now let's create a function to get the user memory. And I'll just paste it in. You can again copy it from GitHub. But here's the thing, remembered context, the following information has been stored from previous interactions, and this is the memory. Use this information to personalize your responses and maintain consistency. Of course, you can edit this prompt further, but this is all I want. Now, whenever this get system prompt is called, which is in context manager, I'll pass in the user memory. So I'll get the user memory from the constructor, and then I can just pass in the user memory to this get system prompt. Now, whenever this context manager is instantiated, which is in session.py, we'll just go over there. And by the way, if you're wondering how I do that, I just press command and click on the class name, and I get to this dialog where I can just go to this context manager. And now I can pass in the user memory. And how do I get access to this user memory? Whatever function was present in this memory.py file, which is the load memory, we can just copy this and create it in session.py as well. So we'll have def and something like load memory here, where we just get the data directory from config.loader. And if the part does not exist, we just return null because we don't have any memory. So we don't want to display anything. Also, the return value here is going to be string or a null value. But if the path exists, we'll read the text, we'll load up the JSON file, and we can just say data is over here. And then we can try to get all of the entries by doing data.get entries, and an empty dictionary is going to be the value if it's not present. Or actually, let's not have an empty dictionary. We'll just say if the entries is null, in that case, we are going to return null. But if the entries is present, then we'll just have an output like this. So we have lines is equal to user preferences and nodes, and we just try to print out all of the key and value of the user preferences. And once we have all of those lines, we can just return a \n.join and we pass in the lines. Also, the value here should just be the value. So we have key, comma, value, and then we just pass in the value. Okay. If there's any sort of exception, I would just like to return null, that there's nothing over here. We did not load any memory. Now I can just call this self.load memory and pass it as the value to this user memory. So we have self.load memory like that, and that's it. So that is it about the user memory. I would like to test it, but before that, I'd like to update the system prompt a little bit more. So we checked for the user memory. There are still more things I would like to add here. For example, the environment section. So I'll just add a comment here, environment. And what this deals with is getting all of the environment related stuff. What machine are you on? So for example, if you're running on Windows, we need to tell the LLM that you're running on Windows so that it can run shell commands that are Windows specific, right? We don't want to run anything Mac specific then. Then we can just scroll down and add a new function here to get the environment section. So the first thing we'll need is the date of today. I told you before also that we are going to attach the date here so that the LLM has more context about what year it's operating in. So we'll import the date time. Then what system are we running it on? What is the release version? So we import platform as well. Then we just display everything. So we have environment. The current date is formatted nicely. Then you have the operating system, then you have the working directory, and you pass in the config.current working directory here. Remember that. That is quite important because whatever working directory we are in, based on that, it will be able to make much better decisions. Then we also create a function to get shell info. The user has granted you access to run tools in service of their request, use them when needed. And now we can create a function to get shell info. And the function looks something like this. We import the operating system, we import system, and then we say if system.platform is equal to Darwin, then we just say that we want to get the shell environment, otherwise the default is ZSH. Then if it's Windows, then we have PowerShell, and by default we are just doing shell. Of course, Pylance knows what platform we're running it on, and for that reason it's able to gray out rest of the things. But yeah, this is required. It just gives us the shell value. Another thing I would like to add is related to tools. The only section that talks about tools is probably this one, get operational section, where we have tool usage, and it talks about parallelism, file operations, file creation, task management, sub-agents, all of that. I would also like to create a specific section that talks about the tools in more detail. So I'll just have another function parameter here, which is tools, which is going to be a list of tools. And then I'm going to import tools from tools.base. And then it can also be a null value. And by default, it is going to be a null value. And now if this tools is present, then I'm going to add this get tools guideline section. Now I can scroll down and create this function. So let me just go at the bottom and add it. So this is the function. Now let's try to understand what it does. First, it takes in a list of tools again, and let me just have that. It returns a string, and it divides the tools into two types. The first one is regular tools and then sub-agent tools. We are going to create sub-agent as a tool next after we've tested out memory, if it's working properly or not. But the regular tools is just going over every tools, and if the t.name does not start with sub-agent underscore, then it's a regular tool, because none of our tools start with sub-agent underscore. And if it's a sub-agent, we will see that we created, or we give it with the name of sub-agent underscore whatever, like sub-agent underscore investigator or sub-agent underscore reviewer. Then you have the guidelines where you have tool usage guidelines. You have access to the following tools to accomplish your task. And then we go over every tool, we extract its description and try to attach it to the guidelines. Then we also do the same for sub-agents. We just go over every tool, extract the description and just attach it. That's why the description property in the tools were very important. This basically instructs the LLM how to use the tool. Then you have the guidelines where you have the best practices. For file operations, you use read file before editing to understand current content. We've talked about this. Use edit for single file surgical changes. Use write file for creating new files or complete rewrites. And whenever editing two or more files, always use apply patch instead of multiple edit tool calls. Apply patch is more efficient and allows batching multiple file operations in a single atomic operation. I'm going to remove this line because we have not implemented the apply patch tool. However, in the repository, you will find apply patch created as a file in built-in tool. So if you want to take a look at that, you can. I'll be sure to add in some doc strings and comments to explain how that works, but it's quite straightforward. All we try to do there is parse the LLM content and just do whatever we've tried to do in write file and edit. So I'll just remove this part. Then we have also, since we don't have apply patch, we can remove this line. We just say use edit for surgical changes, and you write file for creating new files or complete rewrites. Then search and discovery is grep, glob and list directory. Shell for running commands. Prefer read-only commands. Be cautious with commands. Then we have to-dos to track multi-step tasks. Mark tasks as completed as you finish them. And then we have memory to store important user preferences. Retrieve stored preferences when relevant. Then we have the guidelines related to sub-agent tools if they exist. Great. That's all about tool guidelines. So our LLM should be able to call the tools more clearly and in a better manner. So now I'll just go to get system prompt in manager because I have to attach this tools list. And to this manager also, we are going to get a tools, which is a list of tool. We import that from tools.base, or it can be a null value. Then I take this tools list and attach it to this system prompt. Now, whenever this context manager is called, we just attach the tools list, and the tools list is fetched from this tool registry. So I'll just take this tool registry, put it above context manager, and then the tools can be fetched using self.toolregistry.getTools, right? Because getTools gives us just a list of tools. That looks good to me now. Let's try to run this entire application now and let's see how it behaves. So I'll run it and we run into an error. Module datetime has no attribute now. And I think we've run into a similar issue before. This happens because we imported datetime. What we need to do is from datetime, import datetime. And now we can try to run it again. This time it works. Maybe I can ask it, what is the date today? Let's see what it replies. And it does reply with the current date is Monday, December 29, 2025. Awesome. That is the date today. Then I can ask it the next question. What is my name? Let's see if it uses that. And then it says your name is Rivan Ranawat. Awesome. So the memory is being stored. Now I can just tell it something about me, that I love clean code, but I'm unable to do so. Can you remember that? And as we can see, the memory action is set, the key is coding preference, and the value is Rivan loves clean code but struggles to write it. That's more understandable than whatever I wrote here. And it says, I've noted that you love clean code but find it challenging to write. I'll keep this in mind for future interactions. Awesome. So the memory feature is done. Obviously, memory is a very big part of agents. There's a lot you can do. This is a very simple memory system. You can expand it further by adding long-term memory, short-term memory, because certain memories might be such that they're only required certain amounts of time. But other memory pieces are such that you always require them. And there are tons of memory types like short-term memory, long-term memory, episodic memory, semantic memory, all of that. So yeah, and you can also look into optimizing the system prompt based on that memory, because let's say the user stores 1,000 memories, you don't want to list out all of the memories in the system prompt. That's why all of these systems are built where you use RAG or something else so that you only fetch relevant memories. But anyways, our time for this is done. Now the next feature I would like to get started with is sub-agents. So what are sub-agents? Sub-agent is essentially the main agent calling another agent within it. That's it. So an agent right now can call, let's say, a web fetch tool or a web search tool. Similarly, it can also call a sub-agent tool, and that sub-agent tool just creates another instance of the sub-agent which is more focused. It does one task really well. There are also general sub-agents that can just do any task, but many coding tools just have specialized sub-agents. They only do one task and do that really well. Now, what is the motivation behind having sub-agents? The main driver is the context window management. So when the main agent needs to do deep exploration, like reading dozens of files, searching through a code base, experimenting with different approaches, it will quickly exhaust its context window and lose track of the original task it's given. When a sub-agent is called, it gets a fresh context window dedicated to a focused subtask. For example, let's say a user asks that, hey, I want to add rate limiting to our API endpoints, and there are several API endpoints. Without a sub-agent, the main agent would go and read multiple files, right? It would go and read server.py, it would go and read users.py, posts.py, middleware.py, configuration if that's present, cache if it's present, all of that. So these are tons of files that it needs to read, and each of these files can be a lot of tokens, right? For example, the users.py will have all the endpoints related to users, and those might be, let's say, 10, 15, 20 different endpoints. So it will consume a lot of tokens for each of these files. So by the time it figures out the architecture of this entire application and loads in the particular context, it has already consumed tons of tokens in just exploration of the context, and it hasn't helped us with the original task yet. It hasn't written any code yet. So the original task is now far away in the context window. That is a problem. The LLM might just forget what the task was, and it just keeps on exploring with the sub-agent. So instead, what can be done is that the main agent is present here, it will just call a sub-agent, and its task is to explore this entire code base. So it goes and explores the entire code base, then it gives us a summary of what exists in that code base, and then for each task, we can just go ahead and write the file or edit file or whatever needs to be done. For example, when we are trying to add rate limiting, most likely the LLM does read all of the files that are present here. For example, server.py, users.py, posts.py, and middleware.py. But then it notices that, hey, we have a middleware.py, we have a configuration.py. I just need to edit 2 files out of this. We don't care about users and posts and server. And for that particular reason, this sub-agent is really good, because it has read all the files, and then it says that, yeah, I think middleware.py is the file you have to edit because it contains all of these things. Users.py, posts.py are just API routes. You can leave them as it is. Server.py is just about starting the server. It doesn't have anything rate limiting that we can do. So yeah, the summary will help us to make our edits later on. And the context remains clean because we just have the summary, which might be, let's say, 1,000 tokens, and then write and edit file tokens instead of this massive bunch of tokens that came in over here. So our original loop of agents, so our original agentic loop is still pretty lean, and that helps us to remain focused on the task that the user gave. That's why we need a sub-agent. Now let's go ahead and create a sub-agent. As I already hinted previously, the sub-agent is going to be exposed as a tool. So what I can do is in the built-in tools itself, I can go ahead and add sub-agent, or I can also add it in agent folder, because essentially sub-agent is just an agent. So in both of those folders, but I think I'm just going to go ahead and create a new tool here, and let's call this subagent.py. Now the reason I'm not putting this in built-in tools is because we are going to structure our subagent code such that it will be very easy for you to let your users create subagents on their own. By default, we are going to have two subagents. One is going to be the codebase investigator. It investigates the codebase, and then you have the code reviewer. It reviews the code changes and provides feedback. But we are going to write code in such a way that you can just easily extend this subagent's capability to allow your users to create their own subagents. Claude Code added this new feature very recently, and we're going to structure our code such that using the config.toml file that we created, the user can specify their own subagents and run them. I'll talk about that. This is not a feature of our application yet, but the code will be written in such a way that you'll be able to extend it. So go ahead, add that feature on your own. It's really helpful if the user can just create whatever subagent they want, right? And we have a configuration system in place, we can just use that. But first things first, let's go ahead and create a subagent tool. As I mentioned, this subagent tool is going to be a tool so that LLM can call it really well. Then we are going to have an init function. Then we get a configuration system because our base tool also has that. And we just call the base class like that. Already looked into that. Then what we are going to receive is a subagent definition. So to create a subagent, we need different aspects. First, we need the name of the subagent because that's its unique identifier kind of thing. Then you have the description of the subagent, similar to other tools. Everyone has their own description. Then what is the goal of the subagent? Then what tools is the subagent allowed to call? Because our main agent is allowed to call any tool we have registered using this built-in init.py, right? All of these tools are allowed to be called by the main agent. But our subagent is more focused. It can just call specific tools. So we'll just expose specific tools to it to call. And how many turns it can go for, how much timeout seconds is available. So, if the subagent doesn't do its work in, let's say, 5 minutes, we close it. If it doesn't do it in 10 minutes, we automatically close it so that the subagent doesn't keep on running for an infinite amount of time. So those are the things we need. So what I'm going to do here is just create a definition, and let's call this subagent definition. And then I'm going to create a class here called subagent definition. And then here it's going to be a data class first of all. So let me import from data classes, data class. And now I can define all of the properties. So the first thing is the name. You'll see how this name is being used because remember, when we were writing the system prompt, our name for subagents was something like subagent underscore and whatever the name is specified over here. Because all the subagents need to have subagent underscore for us to know that those are subagent tools. Then we have description, which is going to be a string when the subagent needs to be called. Then you have a goal prompt, what this subagent needs to do, and we'll have a string for that. Then we have allowed tools, which is a list string or null value, and by default it's going to be null. But obviously we're going to have multiple tools allowed. Then you have max turns, which is going to be an integer. Let's say it can go for 20 turns. Maybe you can put 30, 50, whatever you want. Then you have timeout seconds, which is going to be a float value, and this can be 300 or 600. I'll give 600, which is 10 minutes. Now I'll take the subagent definition and initialize that as well. So what I've done here is just taking a subagent definition from init. The reason we take a subagent definition is so that whenever you have to add the feature of creating your own subagent, you'll be able to just pass in something like a subagent definition class with all of these properties. And that makes it really easy, right? In the config.toml, you just say something like, hey, I'm going to have a subagent, and maybe you give the name as code reviewer, but we are going to have that by default. So let's say it's a fast API subagent. So it just writes fast API code really well. Then you have a description and so on. That is creating your own custom sub-agent. There's nothing more to it. Now we have to initialize all of the properties of a tool, specifically name, description, all of that. But for the name, we know that the name is going to be sub-agent underscore followed by this name. So I do need self.definition.name, right? So that I can give it the name. That's why we're going to create @property where I have a name and then I have self and I'm going to return a string from here, and the name is now going to be subagent underscore self.definition.name. It's only a function because it needs self, and that's why I prefixed it with an annotation of property. After that, we require the description as well, which is just self.definition.description. So I'm just going to create a property description like that, and I have self.definition.description. Great. For the schema, we can just go ahead and create it. We have class subagent parameters, and then we extend the base model. We'll import that from Pydantic. And now let me just first import it from Pydantic. And once we have imported it from Pydantic, what I'm going to do is just have one thing that we need from the LLM, which is the goal. We need the prompt, right? Nothing else is required. The name, we already know what subagent is being called because we have the name given here. That is good enough for now. Let me have a schema here, which is just going to equal to subagent parameters. Then we are going to set is mutating to true. So we have a function is mutating. We get the parameters, which is going to be a dictionary, string, comma, any. Let me import any from typing, and I'm going to return out a Boolean value, and what it will do is return true, nothing else, because subagent will mutate. Or you can also take it from the definition saying that, hey, is it going to mutate? And by default, the value can be false and the user can set it to true. But anyways, this is good enough. Now we'll just have our execute function, and then we can look into how to create a sub agent. We are going to get a tool invocation here. Let me import that. Then we are going to return a tool result. Everything remains the same, similar to what we did in other tools as well. And now we are done or ready. The first thing is getting the goal. The first thing now is getting the parameters. So we have parameters is equal to, then I'll have subagent parameters, pass in the invocation dot parameters. As of now, our parameters only has one property, which is the goal. But in the future, you can obviously extend your subagent and have multiple more things. After that, we'll just check if the LLM has specified goal. If it hasn't, or we'll say params.goal. If it hasn't, then we'll return tool result.error result and say that no goal was specified here. And maybe we'll say for sub agent as well. Also, I forgot to do one thing. I have to give it a field value. We'll import that from Pydantic. Everything is going to be the same except the description, and the description is going to be the specific task or goal for the subagent to accomplish, achieve, whatever you want to type. Also, let me fix some spelling errors. Yeah. This is important because we saw in the system prompt, this description was used in the system prompt to tell the LLM how to pass data to this property. Great. Now that we have goal, what do we want to do? Well, first of all, I have to create an entire agentic loop again. So similar to my agentic loop in agent.py, I'm just going to go ahead and open up this agent similar to how I did it in the main.py. If you remember, we had something like with agent here. Then we processed each message that came in by doing async for event in self.agent.run. I'm going to do a similar thing in subagent as well, because essentially it's just an agent calling an agent. So we'll have a try block here. Then we'll have exception as E. Then we have some stuff to do here as well. For example, if there's any exception, we will need to tell the LLM what the exception was and all of that stuff. But I'll get to it in just a minute, or actually 2 minutes. But first, let's just try to complete this agentic loop. So first things first, I'll create an agent. Let me import that agent from agent.agent. After that, I need to pass in the configuration, right? Now, what is the configuration going to be? Is it going to be self.config that we had at the top? Maybe. It can be that config. Allow the user to pass in something like allowed turns and max turns, right? We can take these two values and override it in the configuration dictionary because these are the two values that can change. Think about it. Name, description were needed because they were needed for the tool. The goal prompt is needed so that the LLM can call it. But allowed tools and max turns are things that are related to the configuration system. Timeout seconds is just something we need to handle ourselves within this agentic loop because we just keep running and seeing how much time has gone out in this sub-agentic loop. But allowed tools and max turns are something that we will define in the configuration system, and we have access to max turns already. What we don't have access to is allowed tools. So I'll add in allowed tools here, which is going to be a list of string, or it can be null, and we can specify a field here where the default value is null, and the description is if this value is set, only these tools will be available to the agent. If you don't specify the description, that should be fine over here, but this is what this allowed tools do. Now remember, allowed tools is in the configuration. That means it can be used for agents and sub-agents both. So we need a way to filter out these tools in the tool registry. So think about it again. So the user through the configuration system tells that this sub-agent that we have is only going to have read related tools. For example, read file or list directory or grep or glob. Those are the 4 tools that are allowed. Rest of the tools that we have defined in this built-in init.py need to be ignored. The edit, rewrite file tools, all of them need to be ignored. But we have not done any filtering of those logic yet. So we have to do that. So wherever this get built-in tool is called, which is in tool registry, we have to add this logic, right? In this registry.py file, whenever we are trying to get the tools, here I can just say that I want to filter by allowed tools if it's configured. So I'll check if self.config.allowed tools is specified, and we don't have access to config here. So we need that configuration here. Let me import it from constructor. And whenever this tool registry is called, I'll find all the references, and it's only called within this create default registry. I'll pass in the config as well. And now whenever we try to get the tools, I just check if self.config.allowed tools is present. Oh, I've not defined the config yet. Let me do self.config equals to config. And now whenever I try to do if self.config.allowed tools is not null or it's configured, in that case, I'll just do self.config.allowed tools. I'll create it in a set format. Why? You'll get to know in just a minute. So we have allowed tools set. And then I'll go over every tool that is present in this tools list and check if this tool.name is present within allowed tools. If it is, then these are the tools that we want to configure. Otherwise, nope. So I'll just take this allowed set, pass it in over here. And then these are the tools that are actually allowed. So we have overridden this tools list that we created. And this is the reason why we created a set, because here the lookup time will be O of 1. So I've converted it into a set. All the duplication of the names of the tools will also be removed. And at the same time, since this is a set, we can just do an O of 1 operation here. So we go over every tool that we appended and just check if that name is an allowed set. And then we set it to tools again. The benefit of doing it in get tools is that when we call get schemas, which is called within agent.py, whenever we want to tell what schemas of tools we have, for example, if you do find all references, you'll see this is called within agent.py, specifically when we are trying to pass in all of the tools that we have available. So those tools that are not in allowed tools configuration are removed out if the allowed tool schema is set. So that's good for us. Awesome. Now we can go back to our subagents.py, scroll a little bit down. We can try to pass in the correct configuration system. So first of all, it can be a configuration system by default that the user specifies for the entire agent list. Alright. But there are some properties that can be overridden. So what I'll do is create a config dictionary, which is equal to self.config.toDictionary, and we'll have to create this function of toDictionary within this config system. And it's not a lot of work. All we have to do is call model dump. Since we are in base model by Pydantic, it's very easy. So we are going to return a dict of string comma any. We'll import that from typing, and then I'll have return self.model dump, which is given by base model Pydantic, and then we'll just pass in mode is equal to JSON, and we're done. Now I can call the .toDict, which just converts the entire model into dictionary. And now I can override certain values, for example, max turns and timeout, or sorry, not timeout, the allowed tools list. So I'll have if the max turns is specified, and I think max turns is always specified. So we'll just do config dictionary at max turns is equal to self.definition.max turns. Then we have if self.definition.allowed tools is not none. In that case, we'll have config dictionary at allowed tools is equal to self.definition.allowed tools. And then we just have to convert this entire subagent configuration system into a Pydantic model. So we have subagent config is equal to config, and we pass in the entire config dictionary by destructuring it. Now I can just pass in this entire subagent config where only two properties are changed, but if you want to expand this agent or subagent, you can. And now we have as agent. Now the very first thing I would like to do is just go over all of the events and call agent.run. So async for event in agent.run, similar to everything we've done before, I need to pass in the message, which is the prompt. And remember, the prompt is given to us. It's the goal prompt over here. It's what the LLM gives us. And then I need to pass in the message or the prompt. Now for the prompt, there are two things that we need to do, or actually three things I would like to talk about. First, we have to create an entire prompt, and in that prompt, we are first going to have the identity section of what this specific subagent is going to do. We'll tell it that it's a specialized subagent and stuff. Then we'll give it the definition.goal prompt, which is this part. This is basically a high-level overview of what this LLM is good at. For example, it is a codebase investigator. It should use read file, grep, glob, and list directory to investigate. It should not be able to modify any files. The job is to explore, understand code, all of that. So that is the goal prompt. This goal that's coming from the LLM is more like a task. So what is the task that this subagent should complete for this specific code base? So that is the difference between this goal prompt and this goal. Both of them are going to go into the prompt. So let's orchestrate an entire prompt here. So let's just call it prompt, which is equal to, and I can paste it in. You can also paste it in from the GitHub repository, but this is what the prompt says. You are a specialized subagent with a specific task to complete. This is the task that it wants to complete. Like, it has to investigate the code base. It can only use whatever tools are specified. And then we say what is the exact task that it needs to do. And we get that task by doing parameters.goal. And then we say important, where it only needs to focus on completing the specified task. Do not engage in unrelated actions. Once you have completed the task or have the answer, provide your final response, which is kind of like a summary. And then be concise and direct in your output. You can also change this based on whatever behaviors the subagents exhibit. Now we can take this prompt and pass it in. Now I hope you understand the difference between this parameters.goal, which is the task, and the high level goal of what the subagent needs to do. And then I can try to track the activity of each event. So if event.type is equal to, let's say, agent event dot tool call start. Let me import agent event, and then we have tool call start. In that case, I need to append the tool calls, and this is quite similar to what we did within the main.py when we had to call all of the events and stuff, right? But this time the difference is we don't have to display whatever the subagent is doing on the main screen. On the main screen, we'll just get to know that, yeah, the agent has started doing its stuff. There's one codebase on the UI it will only show up as one sub-agent doing the task. It won't show what the sub-agent is exactly doing in, because that's the point. Whatever the sub-agent does, it's only related to investigating the code base. We're not interested in the very specifics of what it does. We are only interested in the output that the sub-agent gives us. That's why we called it a sub-agent. So now I just have to append all of the tool calls so that I can just store it. At the end, when we try to give out a summary, we'll just show all of the tool calls that were done. That sounds good. So we'll have a tool calls list at the top, which is going to be an empty list. And I'll just take this tool calls and add it every time we get a tool call start. So I have tool calls.append, then I get event.data.get, and what is the name of the tool that was called. I am only interested in the tool call name, right? If we go to main.py, we get the call ID, the name, what was the tool kind, and any arguments, because those helped us in displaying it out to the user. Now we don't have to display anything. So in that case, I'm only interested in the name, because when we try to give a summary, we'll only show the name of the tool. Nothing else matters to us. Then we have event.type is equal to agent event dot, let's say the text completes. In that case, we have a final response with us, because the text completed, right? So we have final response is equal to null, and we'll just do final response is equal to event.data.get content in this case. After that, it can also result in some sort of error, and if it's an error, then we are just going to do agent event dot agent error, and then we can store multiple things. For example, the first one is the error output, which is by default null. And then we can just set error is equal to event.data.get error, and if we don't find it, there's an unknown error that occurred. And the final response can be, hey, the sub agent error is error. Also, let's have this sub agent. Great. And then we can break out of this loop because it's an error. We just get out. Another thing I would like to display out when we try to give out the result to the user and to the LLM, because remember, this sub-agent is still a part of the bigger context, right? When we give a summary, we need to append it to the context. And we will be appending to the context similar to the other tools. Whenever we did return tool result.success result, it just got added to the context, right? Because that's the way we handle things. So I would also like to tell it what was the termination reason. Why did this agentic loop get over? Maybe because there was some sort of error, or maybe there was a timeout and we need to handle the timeout case as well. So yeah, let's have a variable called terminate response, which is going to be goal by default. So the terminate reason is just that we hit the goal. So that's done. And if you want to be more explicit, you can say hit goal, but I just think goal is enough. And now let's handle the case where the agent might have a timeout, because here, let's say the user specified 5 minutes as the timeout. 5 minutes is up. Let's just get done with it. So here I'll have a deadline which is equal to async IO. Let me import that. Dot get event loop, whatever event loop we are in, and we get the time. So this is the current time, and then we'll just add the self.definition.timeout seconds to it, because that is our deadline. Whatever time is right now plus the timeout limit given by the user or by us. And now within this agent.run, every single time we get a new event, I'll just check for the timeout. I'll check if async IO dot get event loop dot time is greater than the deadline, because deadline was instantiated only once at the top when we created the agent for the first time. In that case, I'll have the terminate response is equal to timeout, and then the final response is going to be that the sub agent timed out. And then we can break out of this entire mess. Calling our main agentic loop a mess is quite interesting. But anyways, now if the tool call starts, we have not terminated. If the text completes, we have not terminated yet. But if there's an agent error, we have terminated. In that case, I'll just add the terminate reason to be error. So this seems good to me, but there's one thing you might be wondering. What about max turns? We have not done anything about that, right? Well, we have. When we have max turns here, we add it to the configuration system, right? And then when we call the agent here, we pass in the specific configuration system. And then when we call agent.run, within here, it calls the agentic loop. And in agentic loop, what we are doing is self.config.max turns. These are the number of turns. So it will go on for a maximum of 20 turns. And when it's not able to go more, it will, or it should be returning an error here that we hit the max number of turns. So this agentic loop is now errored out. These are the max turns we can do, for example 20. So here I'll just add a return or yield agent event.agent error maximum turns and the max turns reached. And that would mean that this agentic loop returns an agent error here. And since we are yielding it, that's good, because in subagents.py, we yield it, we get the event here, and whenever we get an error, we just say that the response is error, the subagent error route, and the error message is given out. Perfect. Now, in the exception, whenever we run into any sort of error, we want to handle that as well. So this is going to be very easy. The terminate response is again going to be error. Then we want to draft a final response here. We also want the error reason. So we have error is equal to string of error, and then we just say final response is equal to, and then have subagent failed, and then we pass in this error object. Finally, after all of this execution, if everything works out, either if it's an exception or if it's any of these events, we do get the response with us, where we are just going to have a result. This is going to be the final result, where we have multiple things to pass in, right? The first one is subagent, and then we pass in the name of the subagent, self.definition.name. Let me format this nicely. So I'll put a single inverted comma here, and then I say that this agent completed. Did it complete successfully or with error? We'll add it on the next line, which is termination reason. So the termination reason is just going to be terminate response. Then we have the turns used. Then I have the tools that were called, and then I can pass in all of the tools here separated by a comma. So I'll just have comma.join, and I'll pass in the tool calls if the tool calls exist. Otherwise, it's going to be null, and that is going to be in a string format. And then we have the result with us, which we created at the top, which is here. The result is going to be whatever is the final response if it exists. Otherwise, there's going to be no response. Now, if we run into any sort of error on the UI, we have to display this error message in red, right? So if we have an error object, which is over here or over here, whenever we run into an error, I'll just say return tool result dot error result, and I'll pass in the result here. So everything that gets displayed is in red, so the user knows we ran into an error. If it doesn't terminate with error, then we'll have tool result dot success result, and then I'll pass in the result again. But this time it's going to be in green. So we do all of the processing. Let's say 20 turns get done over here, and at the end we just have a result with the final response. And that final response is just the LLM giving us a summary of whatever it did and found out. Now the next thing I have to do is over here outside of this class create subagent definitions, and we are going to have two default subagents. There's going to be a codebase investigator subagent and then a codebase reviewer subagent. Let's create these predefined subagent definitions. So the first one is name, codebase investigator. The description is that it investigates the codebase to answer questions about code structure, patterns, and implementations. The goal here is that it is a codebase investigation specialist. The job is to explore and understand code to answer questions. They can use the tool like read file, grep, glob, and list directory to investigate. Do not modify any files. And the allowed tools are read file, grep, glob, and list directory. No other tool is allowed. So write file, edit, all of that is filtered out. And the max number of turns is 15, but maybe we can remove it because we do want it to be the default one, which is 20. Then we have the code reviewer, which is again a sub-agent definition. Then the name is specified code reviewer. The description is it reviews code changes and provides feedback on quality, bugs, and improvements. The goal is you are a code review specialist. Your job is to review code and provide constructive feedback. Look for bugs, code smells, security issues, and improvement opportunities. Use read file and grep to examine the code. Do not modify any files. Maybe we can again give this code reviewer list directory as well. So it has list directory because it's trying to review the code, right? So it might have to look over several files. And then maybe we can also give it glob, but just to demonstrate that glob is not allowed here, we'll not give that tool. But logically, it would make sense to give it that tool. And max turns, we can just set it to 10 this time so that we don't use the default one. And maybe the timeout seconds here can be 300 instead of 600, so 5 minutes. And now I'll just create a function similar to our init.py file where we add get all built-in tools. Here we are going to have get default subagents. So we have get default subagent definitions, and we return a list of subagent definitions from here. And the list we return here is codebase investigator and codebase reviewer. And now we can call this function within the registry.py file. So here at the bottom, when we create a default registry, we can go over every subagent tool or subagent definition in this particular function, get default subagent definitions, and we'll import it from tools.subagents. And now I can go ahead and register these subagents because similar to the default built-in tools, we also have to register subagents, right? Because subagents are also tools. And now we can just do register. And now I need to pass in the tool. And the subagent definition here is a subagent definition. It's not a tool. Remember, subagent definition is just a data class. It has no dependency on this tool. However, it does have a dependency on subagent tool, and subagent tool has a dependency on tool. So what I can do is call the subagent tool here like that, and let me import subagent tool. And then I can pass in the configuration and the definition. So I'll pass in the configuration as it is, similar to what we did for tool class here. And then I'll pass in the subagent definition, which we have here. And they both are registered in our tool registry. So they are mentioned within this tools. And now within get tools and get schemas, which are basically two most important functions after invoke as well, what we do here is filter out the allowed tools. So we have the subagent tool here. It appended that tool, and then it checked if allowed tools is set up, and for both our default subagents, the allowed tools is set up. Then we filter out the tools that are not specified. So that is it about subagents. I think we can go ahead and try to ask it to review our code. So I'll open up the AI agent here, and we run into an error. Cannot import name agent from partially initialized module agent.agent, most likely due to circular import. The problem is that in agent.agent, we are indirectly referring to subagents.py, and in subagents.py, we are accessing agent.agent. So there's a circular loop going on. To fix that, what I can do is instead of importing agent.agent at the top and agent.events either, I'll just remove both of them and call it when we try to execute the execute function. So here I'll have both of these imports done. So they're imported only when they're required, not when the tools are being registered. So this is lazy importing. And now if we run it, it gets initialized. Understand what I did here. Instead of initializing everything at the top, so everything gets imported, what I'm doing is importing these modules only when they're required, whenever this execute function is called. And now maybe I can try to say use subagent codebase investigator to help me understand this codebase. And this codebase refers to this current working directory. We are passing that in through the system prompt. So let's hit enter. And as you can see, subagent codebase investigator is the tool call that was done. the goal is specified, understand the code base structure, patterns and implementations, and the agent sub-agent will do its thing. We don't see anything. We'll only see the output once it's available to us, which is just the final response. If you want to display everything, go for it, but I don't want to convolute this entire screen. The point of sub-agent is so that we only get to know the output. Also, we can't see the output here, and it says it seems the sub-agent did not provide a response, and then it starts to read all of the files itself. I'll just stop it because we need to understand why this error occurred. The agent returns a text to us. That is the final response. But in our case, probably the agent did not return any text, and for that reason, we don't have a final response. So what we can do here is try to capture another event, which is the agent end event, right? So if we run into an agent end event, then we get a final response and the usage. So I'll just check if the final response is not none, or if it is null at that point, then we'll just do final response is equal to, and then I do event.data.get, and I try to get the response. Cool. Now let's try to run it again and see what we get. So I'll just run the same thing. I'll paste in the same prompt, and let's hope this time it works. So while the agent is doing its stuff, I realize there's some sort of other error, which is tool_result.error that we are returning. We have to return error result, not just error. And now we can try to see what it does. And actually, we run into the same issue, I believe, which is that the sub-agent did not return anything. And since we fixed this part where we are returning an error result, maybe an error is being returned from here. So let's try to run it again and see if it worked. Otherwise, I'll have to debug and see what we did wrong. So I'll paste in the same prompt and we run into the same issue again. Let me just stop it again. I wonder why that is. So I'll just go offline and try to debug it. But I think maybe the error is something related to this, where the event type is agent event type and we are trying to handle agent event. So maybe we can try to do things differently. Instead of doing agent event, we do agent event type. Let's import it from agent.events, and I'll just cut this from here, paste it down here instead of agent event. So we have from agent.events, we import agent event type. Bad naming causes these issues, so you should probably look into renaming them. But yeah, now I think this should solve the error. Again, the issue seems to be that the event.type is of the type of agent event type, and we were doing agent event, which was something else. Agent event is defined within events.py, where agent event is a class and we call certain things on that. But the truth is, agent event type is the one that contains everything. It contains agent start, agent end, agent error, all of that. Changing to agent event type should work. Let's hope that. So I'll paste in the same prompt again, and this time, hopefully it works. And we do run into an error. This time it's a different one. Sub-agent codebase investigator completed. Termination was error. The tools called were none, and the sub-agent failed because type object agent event type has no attribute tool called start. So let's try to see what it is. This is tool called start, which is capital case. Then we have text complete, which is capital case. Then agent end is also capital case. Agent error is also capital case. These were the errors. And now I think we'll be able to run this properly. So we are very close, and then run this. Earlier, what we were doing is agent event dot, and then we called agent start or agent end or agent error, right? And these were functions. They were not really enum attributes. Then we switched to agent event type, but we were still using these names. That's why we got a bit confused, or actually I got confused. I think you might not have, but anyways, I think this should fix everything. So let's see what the output is. So we do get the output here. The codebase investigation is complete. Here's a summary of the key findings, and then it gives us the codebase structure, code architecture, key components, everything. And it does kind of So we do get the output here, but the output is not displayed in the subagent codebase investigator because, well, we have not changed anything in the TUI to display the output of the subagent. But we know that the LLM does get that context in, so everything worked out because, this output shows up, which is trying to infer whatever the subagent said over here. So now let's try to go to this TUI.py and handle this case. Now subagent is not going to be something I explicitly code up in preferred order or in the TUI in tool call complete. What I'm going to do instead is I'll just add an else condition here, and within that else condition I'll just check if we are running into some sort of error. If we are running into some sort of error, then we'll just do blocks.append text and pass in an error. Correct? That sounds reasonable. But then I will remove all of this out of this error case. Understand what I did here? If our tool call doesn't match any of the tool calls present here, then we'll execute this else case where we check if the error is present and we're not running into a success, then we have blocks.append text error. Great. So it will append the text. And then we just try to display the output here in a syntax block. That's what we want, right? Because whatever is the output of subagent, I would like to display it in syntax. That's great. So with this else condition, we are handling everything. We're handling the error case properly, because in error, the output will display. And if it doesn't display, we just say no output. And for our subagent, we just want to display the output, nothing else. Because from subagent, we are just returning an output, right? Now let's try to run it again and see what works. Let me get out of here. I'll clear off this entire thing. And then I'll say investigate and understand this code base. Let's hit enter and see what it does. So this is the output that we get. And yeah, the subagent codebase investigator completed. The tool calls were all of these tool calls. The result is codebase analysis summary, and it gives us the entire analysis of what it is. Now you can obviously go ahead and add a better goal prompt here so that it is more descriptive with whatever it says. It is more specific about what things it needs to tell in the final response about the investigation, because obviously it's very good at investigating. It does call so many files, right? So that's impressive. We will move on to the next thing. But before we do, I would like to encourage you to pause the video here, add the feature of creating your own subagent. So in the config.py, we can have something like a new class, which is subagent config. And then you take the subagent config from this config class, or you can take a list of subagent configs because users can specify multiple subagents. And then you register all of that subagents using tool registry. Simple. Just add that feature and you'll understand a lot more than you already are by following this tutorial. So go do that, and then we'll get to the next feature, which is tool discovery. So what is tool discovery? Think about it this way. We have all of the built-in tools here, and we also have the subagents, which is technically a built-in tool. But if you've created the feature of creating your own subagent, that's not a built-in tool because you're giving the ability to the user to create their own subagents. Similarly, we want to do that for other tools as well. We want people to be able to specify their own tools that we can call. That is what tool discovery is about. To be very specific, what I want is that the user can specify a tools folder within .ai agent folder, and then I just go ahead and maybe have one tool. Let's call this test tool.py. And in here, I'll just paste up some test tool that I've created. It's quite similar to all of the other tools we've created. We have a parameters, which is specified as a schema here. Then the kind of the test tool is passed in. Then you have description, the name of the tool, and an execute function. And what this tool is doing is that it's just creating an output saying test tool received. Then it passes in the message that's coming from the LLM, and it says tool was discovered from, let's say, .ai agent /tool /test tool.py. So this is just a tool that spits out the test message from LLM. We want to enable our user to be able to create such a tool. So as you can see, this is created within tools testtool.py, and I've not mentioned this testtool.py within the built-in init folder where, we register all of our tools. So I want this particular feature such that any user can define whatever tool they want within this tools folder, and then we just dynamically load it and register it so that the LLM can call them. So I'll keep this test tool over here, and we'll test it later on when we've added the tool discovery feature. Now you might ask, what is the purpose of this? Well, the user can specify their own tool. So if they have a complex workflow, they can execute this tool call, which will do all of the complex execution logic, not like our logic over here where we just spit out the output message. This can be a very complex, let's say 10-step process, which happens behind the scenes with just one tool call. So that's a really good way to not load up our context, because if we provide 10 tools that can do a similar task and then you need 10 tool calls in that order to apply this tool call, that's inefficient. Instead, you can just have one tool created where you pass in the name, description, the schema, whatever you need from the LLM, and then you just write down your own logic here, because at the end of the day, we are creating it for coders, developers. So they can just write down code for this and execute it every single time. And that will be much better utilization of context and much efficient as well, especially if they intend to use a tool several times in one workflow. And if they want to use it across multiple projects, that's also something we'll allow by using the configuration directory, similar to how config.toml was done. In this AI agent, the config.toml was specified for this particular project, and then a system-wide configuration, which could change anything. We are going to do a similar thing for tools as well. So let's go ahead and create a file within tools folder called discovery.py, and then we can go ahead and create this class. Let's call this tool discovery manager, and here we are going to get the init function. Within init, we are going to get the configuration, which is going to be config, and we are going to get the tool registry as well, because this tool discovery manager will get the registry, because we will need the registry, right? So that we can register all of our tools. And we can't create an instance of tool registry in this init function because there's one tool registry that loads up all of the tools. If I reinstantiate it, the tools will again be an empty dictionary. I don't want that. So there we go. And now I can just do self.config is equal to config. Then we have self.registry is equal to registry. And that's it. Now I can create the function called discover all. So I have discover all self, and what it's going to return is nothing. It will just register all of the functions or tools after discovering them. And now I can decide what I have to do here. First, I have to search in the current working directory for any folder which is .ai agent, tools, and then all of the tools are present within this tools folder. And all of the tools are going to end with .py because we are not supporting any other language. Your tool has to be written in Python so that we can execute it. So let's just create a helper function here, which is discover, and I misspelled everything. Let's say discover from directory, and here I have to pass in a directory. So the directory is going to be self.config.current working directory. Okay, and now I'm going to create a function that will help us discover the tools from directory, and it will register all of the tools as well. So we have self, then we have a directory, and this directory is going to be of the type of path because self.config.current working directory is a path. And this function is also going to return nothing. It's just going to call the registry and register everything. Now the first thing I have to do is go to this directory path that's given to us. So for example, the current working directory, and within that I'll go to .ai agent and then tools. So let's have tool directory created here, which is equal to directory / and then we have .ai agent, and then we have / and then tools, right? Because tools is going to be a folder. And now I can just check, similar to everything we've done so far, if the tool directory does not exist, or let's say this tool directory is not a directory either. In that case, I'll just return. I don't want to execute any further because it should be a directory. It should exist. After that, I will go over every file within this tool directory, and I mentioned to you that every file that we are going to go through is a Python file. So I'll be very explicit. I'll say for the Python file in tool directory .glob. If you remember this, it just iterates over a specific number of files that follow this pattern. We've created a tool for that, so I'm sure you know about this. And then we have asterisk.py. So any file that ends with asterisk.py. We're not looking into subfolders, which might be created within tools. If you want to add support for that, you can by doing something like this, but I'm not interested in that. After that, I'll just check for one edge case, which is if the Python file starts with, let me just say Python file, if it starts with, and actually I have to convert this Python file, which is a path, into a string. So I'll get its actual name, which is .name, and then this .name will give us a string. I can call starts with, and I'll pass in a prefix, which is __. So if the Python file name starts with underscore, so for example, you have ___ init.py, or if you have ___ main.py, something like that, we want to ignore it because that is not going to contain any relevant information. It never does. Now what I want to do is load the tool module. So as we know it, the Python file that's created here is not directly importable. I can't do something like import .ai agent and then we have tools test tool.py. That's not something that we can do in Python. Python only knows how to import files that are in specific places. For example, you've installed the packages, or let's say this project folder. Now, it might get a little confusing because this is the AI agent that we have, and within this AI agent, we are creating the tools folder. So you might think that, yeah, it should be easily importable. And the truth is, yeah, it is importable, but think about it this way. You're not having the tools folder in this AI agent. You're going to have it in your project. Let's say you're developing a React.js application. And in that React.js application, you have the front end, the back end, and along with that, you have this tools folder, this .ai agent folder, and then, the test tool.py or whatever tool you create. In that case, how are we going to import this particular file, right? How will our agent even know about that file? We'll be able to import here, but we'll not be able to import in your project because think about it. This is our project where we are developing the AI agent. So obviously anything related to AI agent will be imported here. But in a React.js application, which is completely different from this particular project, where you're initializing what was created in this project, you won't be able to import. And that's why we have to import the module. So we are going to create a function that will solve this problem. It will manually teach Python about a file that Python doesn't know exists and is useful to us, and allow us to import it so that, once we have the file with us, we can get its content, like test tool, and then call its execute function and just register all of it. Also, to understand this better, I think it would be better to understand how the Python's import system works. And you can think of it like a library catalog. So when you do import request, Python looks up requests in its catalog, finds the book, and brings it to you. But if you have a custom tool file in the catalog, but the custom tool file that we created isn't in that catalog, it's like a book that's someone has left on a random shelf that was never registered either. So we have to create a function that will do three things. It will create this catalog entry. It will create an empty book placeholder and fill in the book by reading the file. Might sound very complicated, but it's just 4 or 5 lines. We're going to create a function, let's say load tool modules, and then we have a self, then we have the file path, and the type of this is going to be path as well. And from here, we are going to return the module. So it can be of the type of any, and we'll import from typing any. Now what I want to do is give this module a name, right? So that if I have a module, I can import it correctly. For example, tools.registry is a module. That's how I can import it. If I want to import some other file that is not in a project, which is the AI agent project, it's in your project. I've talked about this. In that case, we will need this file path to extract the name. So we can just do file path. But the problem is file path is something like test.tool.py, right? I want to remove this .py. So to remove it, what I can do is call .stem on it. So stem will have the final path component minus its last suffix. So if you have this complicated path of .ai agent tools test tool.py, it will just grab test tool. It will ignore everything else. So that is our module name. But the thing is, this tool name can conflict with any other name that our tool might have. For example, if the user creates read file.py, so the tool will be called read file now, and that conflicts with our tool that we created. Maybe the user didn't intend to do that, because why would anyone want to override a read file? So in that case, I would just like to call this discovered underscore tool underscore file path.stem, so that it's a bit different from the other tools that are present. After that, I will have the spec created. Spec is essentially an entry that just specifies the name of the tool, the location where it is, and how to load it so that Python can figure it out. So we'll have spec equals to importlib.util, and I'll import importlib.util at the top. So we have importlib.util.spec from file location, and then I will pass in the name of this library, which is module name, and then I will specify the file path, which is the location, and we have the file path with us through the parameter. So again, this spec is just going to tell us, or tell Python, what is the name of the module, what is the location, and how do we load it, or how should Python load it. After that, I just want to check if the spec returned is not null, because it can be. So I'll just do if spec is none, or let's say spec.loader is none. In that case, I'll return an import error, because we did not find that module. So we'll just say could not load spec from, and let's specify the file path here, which is this. Now wherever we call this, we'll have to do a try except. So remember that. After that, we would like to load the actual module, because here, remember, this is a spec. It is just a specification. It is just a card. It doesn't really do anything. But we can put it to use by doing importlib.util.module from spec. So it will create a module based on the provided spec, and then we will pass in the spec over here. So that is our module. Now what does this function do? It just creates an empty container. So it creates an empty module object labeled with the module name that was specified within the spec, which is discovered tool and whatever is the name of the tool. So discovered tool test tool. It's just an empty container as of now. So obviously the next step is we register it with Python so that Python knows about this module, and then we execute this module so that all of the stuff gets fit in within this module. So we'll have sys.modules. Let me import sys from system, and then we specify the name of this module, which is module name, and set it equal to module, not module name, just module. This system.modules is Python's master list of all of the loaded modules. So we just add our empty box to this list so Python knows it exists, and then we're just going to go ahead and load this empty box with the actual content. So we'll actually run the file and fill all of the box or the container that was empty. So we'll have spec.loader.exec module and pass in the module. So with this line, what's happening is that the system will essentially read the Python file, execute all the code in it, and it will put all the classes, functions, variables into our module object. After this, we are just going to return module. And now, after this point, if we just try to do module dot, let's say, test tool, that is valid, because it's importable now. Module does have access to it. So if we do discover tool, test tool.test tool, it is importable. So here we are returning the module. That's great. Now we can go ahead and call this function over here where we have self.loadToolModules. Also, this should be over here. Let's fix the indentation, and then we'll pass in the Python file, right? because Python file is the entire path, and that is our module. So now that we have the module, obviously the next step is to find all of the tool classes that are present within a module. So we'll go over the module, we'll get each object and just check if it extends tool, because that's what we are interested in. In every tool that we create, the class is going to extend tool. If it doesn't extend tool, this is essentially not useful to us. What's useful is this test tool, because it extends tool, because this is what we are going to use to register our tool. So now let's create another helper function that will find all of the tool classes. So we have def find tool classes, then we get self module, which can be of the type of any, and from here we are going to return a list of tools. Let me import from tools.base, and now let's find all of the tools. So we have tools as an empty list, and then we can go over every object within this module. So when we do directory, it will list all the names defined within this module, and I can try to get the object from here, which is get attribute module comma name. So what we are trying to do is module dot name, whatever it is, that is going to be our object. So let's say we have test tool as our module, or discovered tools test tool dot, and then we have the name of the module, the actual name, which is dot test tool, right? So we try to get that object here, and now we are just checking if this object that we get access to, is it even a class? Because when we are going over the names that are defined within this module, even this class can be present, test tool parameters, or the user might define some other helper functions as well. We want to ignore all of that. All we are interested in is a class, and specifically a class that extends tool. So we are first going to check if it is a class. To do that, we can do inspect. Let's import inspect, and we have to use the second one, just import inspect, and then we can say is class. And then we pass in the object that we got over here. Now, if it is a class, and it should also be a subclass, so I'll pass in object and tool here, meaning this object extends tool. In that case, we're going to do tools.append and pass in this object, because it is a tool object. So we have a list of tools, right? Because yeah, we are just appending that object. Also, we can put another check here to handle another edge case, that object is not tool. Let's fix object here. What does this line do? It just verifies that object is not a tool, because it should be a subclass, but it should not specifically be a tool. Otherwise, it's of no use to us, and it can be. And then we'll have object.module. Let me fix this again. Object.module, if it is equal to module.name. What this check does is that it ensures that the file was not imported, that the tool that we are going after is not imported. It was actually created in this particular file, because when we do directory of module, it might also contain things that are imported. So yeah, this is just ensuring that the objects module is equal to the module's name, and it is not really the file that was actually imported, not defined in this file. So once we have appended everything, we are just going to return the tools from here, and that's it. We will call this function here. So we have tool classes is equal to self.find tool classes, and I'll pass in the module. After that, I'll check if there are any tool classes. Let me name this tool classes, because there can be multiple tool classes. If there are no tool classes, I'll just continue to the next Python file. I'm not returning, remember. I'm in a for loop here where I'm going over every Python file. So I'll just continue so that I can go back to the next Python file and not waste much time ahead. And after that, I'll just do for tool class in all of the tool classes that are present. I would like to instantiate this tool class and pass in the config directory, because remember, each of our tools that we create needs to have its own configuration directory passed in. So here we have a tool, right? Here we had the init function, and each tool needed to be fed a config system. In that same manner, we're going to have the config directory initialized here as well. So we'll have tool is equal to tool class, and we know this is an actual object. This is an actual tool object. So what we're going to do is call it like that, and then we'll pass in self.config. Now this is not the actual tool here. It's going to be the class that extends tool, because we've put all of the checks necessary for that. And now I would like to register this tool. To register it, I'll just do self.registry.register and pass in the tool. And that's pretty much it. We have registered the tools. Now all I need to do is put this entire thing in a try except, because here I have raised an exception if spec is not present. So I'll do a try and except here, saying if we run into any sort of exception, then I would just like to continue. Maybe you can log it out. It would be a good idea to log it out, but I'm just going to continue here so that we move to the next iteration and do nothing after that. But a logger would make a lot of sense here. So yeah, we discover from the directory and it's done. Now the next thing I would like to do is not just discover from our current working directory. I told you we also need a system-wide discovering feature. So similar to this config.toml, we are going to have a system level configuration passed in. And for the directory, we are just going to pass in the get config directory that we initialized in config.loader. If you remember, this config directory was where all of the apps allowed the users to specify their own configurations. I think OpenCode has done that. Even Claude Code does it. I think even Codex does it. And now even we do it. So yeah, we passed in the get config directory here, and that's it. We have registered all of the files. Now what I like to do is call this discover all function where it's required. And where is it required? Well, in session, right? All we need to do is call this discover all function and everything else will be taken care of. The reason for that is we are just calling the self.registry.register here. So it will get stored in our tool registry, and that tool registry is kind of like the singleton instance. There should only exist one instance of it which contains all of the information about that tools, all of the tools we have. Even for MCP, when we create it, we are going to have self.registry.register. That is the point of having this explicit registry system. So let's go to our session.py, because that's where we initialized everything else, including tool registry. And here we're going to create an instance of tool discovery. So we have self dot, maybe we can just call it discovery manager instead of tool discovery manager. And we'll instantiate this tool discovery manager. And let me import it from tools.discovery. And now I can pass in the configuration, which is self.config, and then we have registry, which is self.toolregistry. And after that, maybe I can just call the get all tools from here only. So I'll have self.discoverymanager.discover all tools. That seems like it. Now let's go ahead and see if this works out. So I would like to exit whatever we have right now and rerun it. Okay, cool. Now let's tell our LLM to specifically call test tool. That's not a tool that exists in our built-in tools, but if it calls it, that means everything is working. Let me hit enter. And as you can see, the message is, hello, this is a test message, and test tool received, hello, this is a test message, and tool was discovered from this particular file. Now what I'd like to do is delete this test tool. After that, I'll try to exit this system. And now I'll create the AI agent again and say call test tool. Let's see if it calls it. And as you can see, the test tool function is not available. Please use the provided tools to accomplish your task. If you need to test something, you can use the shell tool to run commands or scripts. That's awesome. So our tool discovery feature is working. The users can specify their own tools in their project like we did with testtool.py. And execute any tool of their choice. So this was about creating your own tools, registering them, and for them to register, all they have to do is create a .ai agent folder, tools, test tool, and then they have to do from tools.base, import tool, all of that. Actually, in their case, they will have to import AI agent as well. So something like from AI agent.tools.base import tool, they'll have to do this entire thing because right now we are in AI agent folder. So we don't have to specify the folder we are in. But if you're doing this tool creation in some other folder like your React application, which is quite different from this AI agent that we are developing, in that case, they will have to specify this AI agent, and this AI agent is going to be a package that will be installed on your system. Because even when you have to install Claude Code, for example, what do? You go ahead and do npm install -g Claude Code or codex CLI or anything. So from npm, you're just trying to install Claude Code. So it is installed on your system, and that's how you're able to run it, right? So when you install Claude Code, rest of the things also come pre-installed. For example, all of the files that Claude Code has so that you can run it. And from there, you do get access to this tools.base or whatever exists so that you can create your own tool. Now, I'm not very sure if Claude Code has support for it. OpenCode does, and the same logic can be applied for OpenCode. So yeah, that's about tool discovery. The next thing we are going to work on is MCP. MCP is also about tools, but the difference between tool discovery and MCP is that in tool discovery, you have to define your own tools. But in MCP, you can just use someone else's tools that they upload, because there are multiple MCP registries similar to NPM, for example, where you can find any tool of your choice and run it. So for example, if I want to talk to Google Drive, there's an MCP created for Google Drive, so I can just talk to my LLM and it will directly fetch data from my Google Drive. That's what MCP allows. It's essentially third-party tool calling, and that's how it's different from tool discovery. Now, you can also create your own MCP servers and get it all working, but you can also use someone else's MCP servers, and every tool has support for MCP. Cursor has it. Claude Code is the one that created MCP. OpenCode also has support for that. So let's dive a bit deeper on what MCP means, what is its full form, and how does it work so that we can start to code it ourselves. MCP stands for Model Context Protocol. Protocol is really the big thing over here. MCP is nothing more than just a set of rules that are defined so that the AI agent knows how to talk to external tools and data sources in a standardized way. Let's understand the problem that MCP solves. Imagine you're building an AI application. Let's say it's an AI assistant that needs to access your calendar, read your emails, query a database, browse the web. Without a standard protocol, every AI application has to write custom integration code for every tool. If you have 10 AI apps and 10 tools, that's potentially 100 different integrations to maintain. So instead of having those 100 different integrations, you just have one integration. You can think of MCP like USB for AI. Before USB, every device like a printer, mouse, keyboard needed its own proprietary cable and driver. USB said, here's one standardized interface, everyone built to this and everything works together. MCP is really just the same thing for AI and tool communication. There are three parts to MCP. The first one is the server, MCP servers, which expose capabilities through tools, resources, prompts, basically through a standard interface. A server might just wrap a database, an API, or a local file system. For example, if you want to read your email, Gmail can expose an MCP server out, and those MCP servers can contain tools, resources, and prompts. You know what tools are because we created a bunch of tools already. And one MCP server can have multiple tools. For example, in Gmail, you might want to have a tool that allows you to create an email. Then you have another one that gets an email. Then you have another one that gets all of the emails, right? So those are all the three different tools. Then you can obviously have more. So in one server, you can have multiple tools, and then you can have multiple servers as well. Great. Now, what are resources and prompts? I just searched up on Google, and I think this is a pretty good Definition: resources are read-only, structured data like documents or profiles that provide context for an AI model. That's it. While prompts are reusable, parameterizable instruction templates that define consistent workflows or conversations for the model, often surfaced as UI elements like slash commands for users. So you can think of resources as data feeds, example the employee directory, whereas prompts are user-initiated workflows, example summarize a document that combines resources and tools to guide the AI to do that task. So I'm not diving deep into this. Our AI agent is not even going to support resources and prompts, but if you want, you can go ahead, add support for it. I'll talk about how you can add support for them. But yeah, these are two things that also exist in a server. We'll just be focusing on tools. Then the second thing other than MCP server is MCP client. So MCP clients are basically the AI coding agents like Cursor, Claude Code, or even normal Claude that connect to these MCP servers and discover what's available, and then they can invoke all of the capabilities when needed. So they can call the accurate tool, or they can call the accurate prompts, all of that. And the third thing is the protocol itself, MCP. The protocol handles all of the boring stuff. It will list the available tools, then it will tell you how to call those tools, how to stream those results back, all of that. That's handled by MCP. Obviously, the benefit of MCP is that you build a tool once and use it with any MCP compatible model. And the model doesn't need to know how a tool works internally, it just needs to know its interface. And obviously you can compose multiple servers together. Your AI will have access to everything. For example, in this image, the AI can have access to Slack, Gmail, database, GitHub, or any other web API. We are especially going to be focusing on MCP client because MCP servers are not really a part of AI coding agents, right? MCP client is. So the MCP client usually does connection, discovering, translation, and returning the results back to the LLM. Let's understand them. The first one is connection. The MCP client needs to connect to MCP servers. How do you connect? There are two ways that are mainly used. The first one is standard input output. So if you have a server that can be run locally, you can just pass in the command and the arguments, and then the MCP client will connect to that MCP server. And the second one is if you have a URL, maybe it can be HTTP or SSE, which is server sent events, which is essentially a one-directional WebSocket. You can learn more about it by asking an LLM or our own coding agent, by the way. So these are the two methods that we are going to support as well. The second part of MCP client is discovery. It can discover what's available, what tools do I have access to, what can I call. So that's one thing we're going to look into. The third one is translating the LLM's intent into actual tool calls with proper JSON RPC formatting. That's not something we have to look into because we're not going to be creating the MCP client from scratch. We're going to be using a package for this, and the package is Fast MCP. So similar to Fast API, Fast MCP also exists, and it can help us create MCP servers as well as MCP clients. We are only going to be focusing on creating a simple MCP client. And obviously we just have to return the result back to the LLM in a format it understands, and we have all of the setup done, right? We have created our own built-in tools before. We can just leverage all of the infrastructure for that, just add our MCP related stuff and pass it to register it to our tool registry. As easy as it gets. So now let's go ahead and code it up. The first thing I want to do is update the configuration, because there are certain details I would require from the user about configuration of an MCP server. For example, I would like to know if they're using the HTTP or SSE transport, or are they using the standard input-output transport. If they're using standard input-output, they have to specify the command, the arguments, all of that. And that's why we're going to go to our schema, or let's say config.py, and here we're going to create an MCP server configuration. So let's have MCP servers, which is going to be a dictionary of string, MCP server config. So in the string part, you're going to specify the name of the MCP server, and the value is going to be a class that we are going to create, which lists out all the other things. For example, what is the command, what is the URL, so that we can infer if we're using standard input output or HTTP or SSE. After that, we're going to have a field here. By default, it's going to be MCP server config. That's the value. And obviously this needs to be a dictionary, so let me just pass in dictionary like that. Now I can take this class MCP server config. I'll extend this to base model, and then we can define all of the parameters here. The first one is going to be enabled, which is going to be a Boolean value, and by default it is true. In our config.toml file, you can enable or disable an MCP server as you like it. Even in Cursor, you're able to do that by going to mcp.json file and enabling or disabling something. Then you have startup timeout seconds, which is how much time should we wait for this MCP server to load up, and if it doesn't complete in these 10 seconds, or let's say whatever the user specifies, then we'll just say that the server did not load up. Then we have things related to standard input output transportation. So when you have a standard input output, you're really having a local server. And if you have a local server, you want to specify how you can run that local server. So the first thing you have is a command, and then you have a string or a null value, and by default it is null. Then you have args, which is a list string, and by default is just going to be an empty list. Args is just like whatever arguments you need to pass in. For example, if you have an MCP server hosted, let's say on NPM, and actually let me show you an MCP server that we are going to use, which is @model context protocol /server file system. This is created by the official model context protocol team, and this is just a Node.js server implementing MCP for file system operations. It has all of these features, and we'll be able to see all of the features. So to run this particular file system, what we are going to do is pass in something like npx, and then you have, let's say, -y, and then you have the name of this server. This is how you can run this model context protocol through standard input output. Then you have the environment variables, just in case you have to set up any environment variables, because many times, let's say you're interacting with Slack or Gmail, some environment variable is going to be required because you just can't get access to someone's email account like that. You need to pass in some data. For example, the API key or the username and password, whatever is required. Now we'll pass in the default factory here, which is going to be a dictionary. And then we have the current working directory, path or null, and by default it is null. After that, we are going to have the HTTP or SSE transport, and all we require here is a URL. This URL is going to expose all of the information, and you can find multiple MCP server URLs online, or you can create your own MCP server, run it locally, and you'll have something like http://localhost 8000/SSE, and that is going to be your URL. So once you do that, the MCP server will be able to contact and list out all of the tools that are present within your server. Now I just have to validate the transport that's present, because either the command and the args should be specified or the URL should be specified, because if both are not specified, in that case we don't have a valid MCP server. We do need a transport layer present. So we'll just have @model validator. The mode is going to be after. Now let me import model validator from Pydantic, and now we can just create a function validate transport. Then we have self, and we're just going to return an MCP server config from here. And since we are returning an MCP server config from here, and the function is defined within the class itself, then we are just going to import from future annotations. Once we do that, we'll be able to use the MCP server config here. And now we have to check if the command is specified or the URL is specified. So I'll just have #command equal to self.command is not none. If the command is not none, we have a command. Otherwise, we have a URL, which is self.url is not none. Now, if we do not have a command and we do not have a URL, we have a problem. So in that case, we'll just raise a value error and we'll say MCP server must have either command, which is standard input output, or it should have URL, which is HTTP or SSE. Great. Now let's say we have both. That is also a problem. If has command is true and has URL is also true, we have to say, again, we are raising a value error, but this time we should say MCP server cannot have both command and URL. Okay. So that is a validation we have to do. Rest everything is fine. We have passed in the MCP server config here. And now in our config.toml, if we want to ever have an MCP server, what we can do is specify something like this. So you have MCP servers dot file system. MCP servers refers to this particular attribute. And since this is a dictionary, in this TOML, we have to create a table. Table just refers to a dictionary in TOML. All right. So we have MCP servers dot file system. So file system is going to be the string key over here. And then the server configuration is specified below, where we have command equals to npx and rest everything is arguments. So we have -y at model context protocol server file system. And then you also specify the path where this server file system is initialized. In my case, it's just going to be desktop AI agent and a temporary folder, but you can also remove this temporary folder, no problem. If you don't specify this path, what will happen is that the LLM will try to access outside of this current working directory, and once we add stuff related to approval system and sandboxing, it will cause problems because we don't want to allow any MCP server to create any file just like that outside of our current working directory, because then it can lead to some pretty horrible things, especially if you have a wrong MCP server installed. So yeah, this configuration is specified. It should be present within this MCP servers. Now I have to take this MCP servers, register it with tool registry. But to register the MCP server, first I need to get access to all of the tools that are available within this MCP server. And for that particular reason, I'm going to open up the sidebar. Let's close all of the folders and I'll go to tools. Specifically, I'm going to create a new folder called MCP, and within that we have a client.py. So we're going to have an MCP client created which will interact with the MCP server. And as I mentioned, we are going to use fast MCP as the client of choice to simplify things for us. Otherwise, it will be a 1,500 line code piece, and I don't want to spend time on MCP. So let me install fast MCP quickly. Let me exit out of this part. Then I'll just do pip install fast MCP. Now that it's installed, I can go ahead and create a class. Let's call this MCP Client. Then I'm going to have an init function. And within this init function, we're going to first get the name of the MCP server. After that, we're going to get the configuration, which is specifically MCP server config. So this time we are not having the config class here. Instead, we are having the MCP server config. So whenever we instantiate MCP client, we expect to get this MCP server config only. And this is why we are having the name here and then the config, because remember, in our configuration, the MCP server config does not have any name attribute. All it has is the details related to MCP server config, and the value or the key here is going to be the name in the dictionary. So we'll pass both of them when this MCP client is going to be instantiated. Another thing we'll require is the current working directory. So let me import that from path. Obviously, all of this is going to return nothing. So let me just have none returned here. Now let's initialize everything. We have self.name equals to name, self.config is equal to config, self.current working directory is equal to current working directory, and we are also going to create a status of the MCP client. Remember, this MCP client that we are creating is just for one MCP server. It is a simple MCP client that keeps track of the connection with one MCP server. We are going to create multiple of these MCP clients. So there will be multiple MCP connections. Obviously in our AI coding agent, we only have one MCP server defined. But in the future, you can just go ahead and add as many MCP servers as you want, and there'll be multiple MCP client connections. We are also going to store the status of this MCP server. Is this MCP server connected, disconnected, or is it connecting, or is it in an error state? What is it? So that we can display it out to the user whenever they want, especially when we add support for / commands. For example, when we try to do something like python main.py, these commands that are present, you can also do something like /mcp to know all the MCP servers connected, or /tools to know all of the tools that are connected. And those tools will also list out the MCP servers. So here, let's just create an enum of MCP server status. This is going to be a string enum. We've created enums many times before. So I will go fast. We have disconnected, which is equal to disconnected. Then we have connecting, which is equal to connecting. Then we have connected, which is equal to connected. And then we have error. Then we just have the error here. Great. Now we can also initialize the status here, which is self.status equal to MCP server status dot disconnected. So whenever MCP client is instantiated, it will be disconnected. You have to explicitly call the method of connect. Once connect method is called, it will go ahead and start the MCP server, try to connect it. Let's also create a client here. So we have self.client, and client is private so that it cannot be exposed outside. Then you have client from fast MCP. Let me import that at the top. From fast MCP, we import client. Then here, the type of this is going to be client or null, and by default it is null because we have not instantiated anything. To instantiate, we will call the connect method. So let's define the connect method as well. And by the way, the reason we are doing connect method not in the constructor is because it needs to be an asynchronous function. Init can obviously not be an asynchronous function. So we have async def connect. I'll pass in self, and then we return nothing here. And first, I just want to check if the server is already connected. If the server is already connected, connect was called for no reason. I don't want to establish duplicate connections. So I'll just return here itself. So if I have self.status is equal to, let's say, MCP server status dot connected, in that case, I'll return nothing to do here. But if it's not connected, in that case, I'll set the status to connecting explicitly. So MCP server status dot connecting. After that, I'll try to figure out what transport we are in. Based on the transportation layer, we are going to pass it into client. So we have self.client instantiated here, and the client needs to be created here. But to the client, we need to pass in the transportation layer, right? Because it only makes sense. How should the MCP server connect to a third-party tool or a third-party server? What is the transportation layer? So we have to figure that out and pass in the details. And we have extracted all of the details through the MCP server config. All we need to do is wrap it with fast MCP related methods. So we'll have def create transport, which is a helper function, and then we have self, and here we are going to either return standard input output transport or the SSE transport. Now let's import both of them from fast MCP. So we'll have from fast MCP dot client dot transports, we'll import SSE transport and standard input output transport. So these two things will do all of the heavy lifting for us. All we have to do is initialize them. So I'll first check if self.config.command is present. If command is present, in that case we have the standard input output transport. So we can just go ahead and return standard input output transport here. The first thing we'll pass in is command, which is self.config.command. Then we have args, which is a list of self.config.args. Then we have the environment variables. Now, what environment variables do we pass in? Well, the environment variables should be whatever the user already has in their system, whatever environment variables are present, along with the updated environment variables that have been passed through this configuration. So here I can just have environment is equal to os.environment.copy. This is something we've already looked into. This gives us all of the environment variables. And now I can just do environment.update and update it with the new environment variables that have been passed in. So yeah, there we go. Now I can take this environment variable and pass it in over here. Then I can pass in the current working directory, which is equal to, and I'll pass in self.config.current working directory, and it needs to be converted into a string. And if it's not specified, because it is an optional value, right? If it's not specified, in that case, we are just going to have self.current working directory, and that also needs to be a string. So I'll just pass it in here. This self.current working directory is coming from here. It's not coming from the configuration system. This is the real current working directory. Now let's say the command is not specified. In that case, it needs to be the URL, right? Because we have validated that either of those transport methods are present. So here we'll just say return SSE transport and pass in the URL, which is equal to self.config.url. Awesome. Now I can call this create transport here and pass it in for the client. So we have self.create transport. Now the next thing we have to do is connect to the client. And for this, we'll be using the context manager. If you remember, there was something like with self.client as client, something like that. We're going to use that, but instead of using this with command, we're going to call the internal function that supports it. We're going to do await. This is why we needed an asynchronous function. We have await self.client dot, and then you can just call a enter like that. So a enter is just asynchronously entering, and we've created this in agent.py as well. So I'm not going to dive much into it because I've already explained how this works. But essentially, we've called this a enter instead of manually calling with something. The reason we are doing it is because we are connecting here, but we don't want to close off this client connection as soon as this function gets over. Because think about it. If you do something like with self.client as client and do your stuff here, and once this function gets over, this with is also completed. We don't want that, because once we have connected, we want this connection to persist. And that's why I'm calling a enter here. We'll call a exit explicitly when we have to disconnect, and we'll create a function for that as well. Since we already have async await, let me just pass in a try and except as well. So I'll have try, except, exception as e. And obviously, if we run into any sort of error, the status will be converted to MCP Server status dot error. And maybe we can also raise the exception from here. We don't really need e here. Let's just do except exception. Great. So yeah, we have created the client connection. We have entered it. Now we have to call the tools related to this client. So the first one is, well, we want to discover the tools, right? If you want to discover the tools, we can just call the function self.client.list tools, and that will give us all of the tools. I can await it, and then I have all of the tool results with me. And now if I want to know what tools there are, I can just do for tool in tool result, and then maybe let's also maintain a dictionary for all of the tools that we have, right? That makes a lot of sense, because once we have all of the tools, we can easily register all of the tools. So think about it. We just call the connect function. Once we've called the connect function, we can call the register function, and that will register all of the tools for us. Now remember, each MCP server can have multiple tools, and then we can have multiple MCP servers. So this one just has multiple tools. So this is what we are going after as of now. The type of this is going to be a dictionary where we have a string as the key, and the value is going to be MCP tool info class that we will create. That MCP tool info will store all of the information regarding an MCP tool, like name, description, the schema, what server does it belong to, all of that. So we'll have class MCP tool info, and this needs to be a data class. Let's import from data classes data class, and then we can just have name as string, which is the tool's name. Then you have the description of that tool. This is quite similar to all of the registration or all of the tools that we saw in tool.py or base.py. I don't remember. Yeah, this one. So we have name, description, all of that. And yeah, these things will be useful when we try to create a fast MCP tool. I'll talk about that in, let's say, 10 minutes. So I have input schema next, which is a dictionary of string comma any. Let me import any from typing. And then we have a field where we have to import it from data classes. This time it's not Pydantic, it's data class. And now I can pass in default factory, which is a dictionary, and then the server name, which is by default an empty string. So these two things are absolutely essential, but for input schema and server name, we do have default values present. Now we can take this MCP tool info and pass it in as the value for this tools. And now we can go ahead and update this dictionary. So we'll have self.tools at, and let's say tool.name, because tool result will return the tool to us. So you can think of tool result as a list of dictionaries. We're going over each dictionary item and then we're printing out its name. That is going to be the key, right? Because that's the unique identifier for the tool. And then we're going to set it equal to MCP tool info. And now we'll pass in the name of the tool, which is tool.name. Then we have the description, which is tool.description. And if it's not specified, it's just an empty string. Then we have input schema, and I messed up the indentation. Next thing is the input schema, which is equal to tool.input schema. This is how we get it from fast MCP. And we'll just check if it has the attribute of tool input schema, then we use that. Otherwise, an empty object is good enough. And finally, we have the server name, which is just equal to self.name, because self.name that we are getting, this thing is the name of the server. Once all of this happens, this entire for loop is over, the MCP server is connected. So we'll have self.status is equal to MCP server status.connected. And yeah, that looks good to me. That's about the connect function. Now, before I forget, I'll just create the disconnect function as well. So I'll have async def disconnect. We have self, we'll return nothing. And then we'll just check if self.client is present. If it is, then I'll just do await self.client. And then we'll just call a exit. Similar to how we called a enter, we are just calling a exit. And now we remember in a exit, there were 3 parameters that we needed to pass in. So I'll just pass in null for all of them. I'll just go to agent.py to demonstrate what I'm talking about. These 3, exception type, exception value, and execution exception traceback. So we just pass in null values for all of them. And after we have done that, we can go ahead and set the client to null. Also, I can go ahead and set the tools to be cleared off. So I have self.tools.clear. So it just empties all of the tools that we have. And finally, we'll just have self.status is equal to MCP server status.disconnected again. I just have to remember to call this disconnect function. Also, it should be self.client is equal to null. And that's about the MCP client. This is really all we'll need. Now remember, this is for one MCP server. You can have multiple MCP servers. So I'm going to create a class that composes this MCP client. So MCP client is used within it for every server that's present within this configuration system. So let's say we have another one here and it's called file system 1. We'll have another MCP client created for it. So we need an MCP server manager, right? And that's what I'm going to create here. Let's call this MCP manager.py, or you can just call it manager, whatever works for you. And this is very easy, class MCP manager. Then we are going to have the init function here. Again, just like before, we're going to get the configuration, but this time we're going to get the actual configuration because we do want the actual configuration now. We can't just have one MCP server config like we did in MCP client because we are going to manage multiple MCP servers here. So we're going to get multiple MCP server configs and they're all present within this config. So let's have self.config is equal to config, and then let's also initialize a list of clients that we have. So we'll have self._clients, which is equal to a dictionary, and it's going to be a string MCP client. Let's import it, and by default it is an empty dictionary. So the string here is going to refer to the MCP server name, and MCP client is, well, whatever client is there. So for file system, we'll have one MCP client. For the next MCP server that's added, there's going to be a second MCP client, and the name will again change. There are mainly two functions that we are interested in right now. The first one is initialization, and the second one is registering all of the tools. So initialize will just initialize and connect to all the configured MCP servers and add it to this client's dictionary. And the register is just going to parallelly register all of the MCP tools with our tool registry. Simple. Let's go ahead and create async def initialize, which is just going to have a self. It's going to return nothing. And the first thing I want to check here is if it's already initialized or not. So for that, I'll have to maintain a variable. If it's already initialized or not. By default, it is going to be false. That means when the MCP manager starts, it's not initialized. And if it is initialized, then we've created multiple MCP connections. We don't want that. That's why I'm just going to return out quickly. Now let me get access to the MCP configurations. And to access that, I can just do MCP configs equal to self.config.mcp servers. Those are all the configurations, right? And it's a dictionary of string, MCP server config. The string refers to the server name. And if there are no MCP configs, then we'll just return very quickly. There's nothing to do. But if there are MCP configs, then I'll go over each server in this MCP configs dictionary. So we get the name of the server, we get the server config in MCP configs.items, and then I'll just check if the server config is enabled or not. If the server config is not enabled, in that case, we will just continue. I don't have to do anything about it. It's just disabled. Why will I instantiate it for no reason, right? And now, let's say it is enabled, then I'll just do self.clients at name is equal to, and I'll establish an MCP client. I'll pass in the name now, which is going to be the tool, which is going to be the server's name. Then we pass in the entire MCP server configuration, which I'll do here. So let's say config is equal to server config. And then finally, we pass in the current working directory, which is self.config.current working directory. Let me prefix this with current working directory. So self.config.current working directory is different from server config.current working directory. I think we've used self.config.current working directory multiple times, so no need to explain this further. But remember, all we have done here is created MCP clients for each one. We have not initialized them yet. The reason we have not initialized them is, let's say I call .initialize here, or whatever the function was, connect. If I call connect and await, I would have to wait for each MCP server to complete so that we can go to the next one. So if I have 20 MCP servers, I'll have to wait for 20 MCP servers to connect. So one MCP server connects, it takes 10 seconds, let's say, and then the second one connects, that takes 10 seconds again, then the third one, and then the fourth one. So just imagine if you have 100 MCP servers and each takes 10 seconds, you have to wait 1000 seconds. That's more than 13-14 minutes. We don't want that experience. So what I'm going to do is just have the MCP client stored here. After that, what I'm going to do is create a bunch of tasks whose entire job is just to connect. So we'll have for name comma client in self.clients.items because we just appended to this for loop, because we just appended within this for loop all of the dictionary items. What I'm going to do here is call client, which is this client dot connect, and all of this needs to be within a list. So these are all of the tasks. And one thing to remember here is just calling connect is not enough. Because if you're just calling client.connect, what's happening is we're not taking into account the timeout. And the user might have specified something related to the timeout as well, which is startup timeout seconds. So we have to wait for those many seconds as well. So I'll have here async IO. Let's import async IO. And then I'll call dot wait for. Then I'll pass in the client.connect within the specific function, and then I'll call await. So these are all of the connection related tasks that we have. Also, I'm not liking that we are not getting any sort of auto correct here, so to say. And the reason for it is clients is not defined properly. We don't have to do is equal to, we have to do the type, because the type of self.clients is this. And now we should be getting the auto helper functions, whatever you want to call them. I forgot what it's called. But yeah, these are all of the connection tasks that we have. All I need to do is gather all of these tasks and execute them together. So I'll do await async IO dot gather, and I'll pass in all of the connection tasks here. And if they return any exceptions, it's fine, I'll handle them. So it's true, so that the user also knows that some sort of error occurred here. And if it goes well, then we are just going to have self.initialized equals to true. It's instantiated, and that's it. That's the initialize method. The point of doing these two lines is just so that all of the tasks are parallelly executed, not executed serially. After this, we are going to have the register tools function, and this should be quite easy. We're going to get a self, we're going to get the registry, which is the tool registry. Let me import that. And now from here, we are going to return, well, we can return how many tools we registered. So let's just return that. Initially, the count is going to be 0. We registered 0 tools, but then we go over every client in this self.clients.values, because remember, values contains all of the things we care about. We don't care about the server name when we are trying to register the tool to our tool registry. All we care about is the tool related information. So values will give us all of the MCP clients, and that does not contain the server name. Then I'll just check if the client.status, if it's not equal to MCP server status, let me import that. And if it's not equal to connected, we just continue. If it's error, if it's connecting, I don't care. I just want this thing, the tools that we are trying to add to our registry to be already connected. Then I'll go over all of the tools. So we have for tool info in client.tools, and we don't have the tools exposed outside. So let me go to this MCP client, expose out a property of tools. So I have @property def tools. We are going to return a list of MCP tool infos. All I need to do here is return a list of self.tools.values. Those are our tools. So now in the MCP manager, I can get access to this tools. And for every tool info that we get, we have to call registry.register MCP tool. So that's a function we'll have to create, because just calling register is not enough. The reason for it is when we try to display stuff on the UI side later on, as I mentioned about the slash command, like the slash tools or slash MCP, it will be easier to differentiate between the MCP tools and the normal tools if we maintain two different dictionaries here. So we'll have self._MCP tools, which will also be a dictionary of string comma tool. And then we create a function quite similar to register function, but what it does is registers an MCP tool. Then we have the name of the tool, and then you have the tool itself. Then we can just do self._ MCP tools. Then we have the name passed in here, which is just equal to tool. And if you want, you can have logger.debug, registered MCP tool, tool.name, or let's just say name, whatever. After that, we can go to MCP manager and call this register MCP tool. But before I move any forward, I would like to merge these MCP tools and normal tools. For example, when we call get, this get is called within invoke. So when we are trying to execute a tool call, if for an MCP tool get is called and we just check in self.tools, that's not enough because tool can also exist within MCP tools. So I'll have elif name in self.mcp tools. In that case, I'll have return self.mcp tools at that particular name. Even in get tools, a similar thing will happen. So we go over every tool and try to append the tool, but we'll have to do that for MCP as well. So we'll have for tool in self.mcp tools.values, tools.append, and then we'll pass in the MCP tool. Let me just say that. And then we have all of the filtering logic here. And that looks good enough to me. I'll go back to MCP manager now. And specifically when we're calling register MCP tool, I have to pass in the name of the tool and the MCP tool itself. And now I'm thinking about it. We don't really need a name here. It's just same as the register function. So I'll just do tool.name is equal to tool and again your tool.name. Sorry about the confusion. We're just doing what we did in register, but just storing in a different dictionary this time. Not in self.tools, but in self.mcp tools. And again, the reason we are storing in MCP tools is so that we have a clear differentiation between what are MCP tools and what are tools, so that if in the UI we want to display anything, we can display it nicely. To register an MCP tool, we'll have to pass in a tool. Now, what tool do we pass in? Well, for that, we'll have to create an MCP tool. Similar to all of the built-in tools we've created, we have to create a tool for MCP as well. So I'll have mcp tool.py, and what I'm going to do here is just copy a built-in tool. Let's say something like list directory, as simple as it. And here, I'm just going to paste everything out. Then I'm going to have no parameters here because remember, in tool, the schema was either a dictionary or a base model. And I told you a dictionary will be required if we have MCP servers. And since we have an MCP server now, we're going to have a dictionary as the schema because the user is going to specify in a dictionary format. And we don't have a fixed schema of how the things are going to look like. For example, in list directory parameters, we know we are going to always get a path. We know we are going to get an include hidden. But if the user is specifying their own tool, how are we going to know what schema it is going to be? So let's just put it in a dictionary format, right? So I remove this line. We remove everything related to Pydantic. The tool name is now MCP tool. The name here is going to come from the init function because when you instantiate MCP tool, you can pass in the name of the tool. At this particular point within this class, we don't know what the tool's name is going to be. All we know here is kind, and for kind, we can pass in toolkind.mcp because it's an MCP. The description needs to be created differently. It will be given to us through the constructor as well. So we have def init. Then we have a configuration passed in. Let's call this config. Then we are also going to get the tool info, which is MCP tool info. Let's import it. Then we have the name of the MCP server. So that's a string. And this init is going to return nothing. Then we call super.init. That's good. Then we have self.toolinfo is equal to toolinfo. Remember, I've done this as private. I don't want this to be accessible outside. Then we have self.client, which is equal to client. And we need to get access to client as well. So we have an MCP client coming in. You'll understand why we need client. Specifically, it will be needed within execute, because if we try to execute an MCP tool, what should happen? The MCP tool should be called. So client has that function already. That will simplify things for us. I don't think we have created the call function within it, but we will. Then we have self._name is equal to name. or we don't need to do self._name, just self.name is fine because we have to instantiate name. Remember, we have to give this MCP tool a name. So self.name will do just that, and it's set to this name. And then that looks good enough to me. The next thing we require is the description, and I can set that over here as well. Self.description is equal to self.toolinfo.description. Then I can also specify the schema here, which is self.schema is equal to, and then the schema, we already know what that is going to look like. We have discussed much about this. The type here is going to be object. This is essentially the schema that is passed to the LLM itself, right? So we have type object, then we have properties, which is, well, based on the input schema, that will be the properties. So the input schema is present within this MCP tool info, right? So I'll just do input schema is equal to self.toolinfo.input schema, or if it's not specified, if it's null, it's just an empty object. And now I can do input schema dot get and try to get the properties object within it. And if it's not specified, it's an empty dictionary. The next thing we have is required. So required is input schema dot get required, and it's an empty list if it's not specified. These are the things we dove into when we were first creating the tool, so I'm not going to talk much about this. Then we also have self.is mutating, and it's just going to be true, nothing else. Oh, I just remembered is mutating is a function that we'll have to create. So let me just create it. We have def is mutating. We get the parameters. We're going to return a Boolean value from here, and the Boolean value is just a true. So we have initialized everything. We have the schema, we have the name and description, we have is mutating true because we don't know what the MCP tool is going to do, right? So we are just assuming that it's always going to be true. It's always going to change some state. Now within execute, we have to change some stuff. So let me just remove the schema from here, this description from here, and all of the content within execute so that we can just focus on this execute function. Now we have to call the tool, and for that we'll have to go into the client and create that function of what should happen when it's called. Because for us it's very easy. Self.client, which is the fast MCP client, already gives us a function called call tool. So we just have to pass in the tool name, the arguments, and it will call the MCP tool and return the result. If you want to know more, you can go ahead and go to the core operations where we have list tools, then we have executing tools, and here you can see call tool is present, where you have whatever the function name is, the tool name, and then the arguments associated with it. So let's have async def call tool, then we get a self, then we get the tool name, which is a string, then we get arguments, which is a dictionary of string comma any. Now remember, in our built-in tools, we called the tools ourselves. For example, in read file operation, we went ahead and read the file, whatever the file's result was, we returned that. But in this MCP, we can't really call the tool, right? Because this MCP server is not with us. We don't have the code for it. We don't know what to do with it. Because that MCP server can be related to Google Drive or Slack or hundreds of other things. I don't know what it is about, and I don't have the code associated with it. So how am I going to call the tool? Fast MCP does, because behind the scenes, it has created a connection with that server. It knows what the server does. So it will just call that server with that specific tool. Whatever the server returns to fast MCP will return to us. So here we are just going to first check if the self.client is even connected. And if it's not, then we are just going to raise a runtime error because that is an issue. The client should be present. And we'll just say not connected to the server, and we can pass in the name of the server. Or let's say another case can be that the status is not connected. That means the MCP server is disconnected in error state or it's still connecting. Even then we'll raise a runtime error. But if that's not the issue, we have the client, everything is proper, we'll just wait for this result. So we'll do await self.client.call tool, similar to what we saw in the documentation. I'll pass in the tool name and the arguments. So that is the result. Now that result, if you notice here, will have a data attached, it will have content attached, and within that content there will be text. If we have the text, I'll just append it to our output, and if it's any other thing, I'll just convert it into a string and return it. I'm not looking into much formatting issues. The LLM will be able to understand everything. So we'll just go over every result within this result.content because that's what matters. Result.contain contains a list, and within that we can have the text or any other data point. We'll just extract that. We're not interested in result.data, which gives us access to structured data, because I'm more interested in the text. That's it. Let me say the output is equal to an empty list. And if this item has the attribute of text, in that case, I'll just do output.append and pass in the item.text. Otherwise, it doesn't have a text attribute. I don't know what it is. So I'll just do output.append, convert this item into a string and just return that. So finally from here, we'll return the output, which is going to be \n.join, and I'll pass in the output. Another thing I would like to share is if it's an error or not. And the good thing for us is that this result does contain the variable related to error. So if it's an error, it will return result.isError set to true. We have an error, a syntax error, because I forgot to put the colon here, and that's it. Again, if you want to do more stuff, you can look into the documentation. FastMCP is great. You'll get all of the documentation properly listed out here, and you can create your own MCP client, more complex and more functional. Now, all I need to do is an MCP manager. I have to call this particular tool. Now, all I need to do is go to MCP tool and execute this function. So I'll have a try and except block here because as we saw, it can return an exception. If it does, we'll just do return tool result.error result. And then I'll pass in MCP tool failed and I'll attach the error message. So let's have exception as E. And in the try block, we'll just try to do result is equal to await self.client.call tool. Then I'll pass in the tool name, which is self.toolinfo.name, and the arguments is just invocation.parameters, right? Because the LLM can still give us the parameters here. That is going to be the arguments that we want to call this tool with. Now this result returned to us is a dictionary. It can either be an error or an output. So I'll extract both of them. I'll have result.get output, and if it's not specified, it's an empty string. Is error is equal to result.get is error. If it's not specified, I'll just default to false, and then I'll just say if it is an error is true. In that case, I'll return tool result.error result, and I'll pass in the output. And if it's not an error, then I'll just do return tool result.success result, and I'll pass in the output again. So that's it for this execute function. Now what I need to do is use this MCP tool within this MCP manager, because that's the point. We created this MCP tool because register MCP tool required a tool instance. So here I'll create MCP tool equals to, and let's create an MCP tool. Let me import it, and then I'll pass in the tool info, which is just tool info here. Then I'll pass in the client, which is the client here. Then we have the config, which is self.config. And then I need to pass in the name. The name here is going to be just the toolinfo.name. So that is the tool's name. But many times it can be the case that the tool names overlap. And if the tool names overlap, that is a problem, because the way we are storing information, we'll just override other tools. So what I'm going to do is prefix it with the name of the server. So I'll have here an f string, where we have toolinfo.name, which is the name of the tool, and I'll prefix with the name of the server, which is client.name. So the server name underscore underscore and then the tool name. Then I'll pass in this MCP tool here, and then I'll just do count plus equals 1. And finally, after this nested for loop, I can return the count. That's it. So that is about the registered tools. If I want to call this registered tools, where do I call it? Well, first I also have to initialize it, right? So what I'll do is take this class MCP manager, go to our session.py because that's where everything is. And here first I'll have self.mcp manager is equal to MCP manager. I'll just create an instance. Then I have to pass in the configuration, which is self.config. And now I can just take this MCP manager. So I have self.mcp manager dot, and first I have to call initialize, and this initialize is coroutine. And if I have a coroutine, I cannot call it within init. So to make this work, what I can do is again have async def initialize function here. Then we're going to have a self. Then we're going to return nothing from here, but I can just call the self.mcp manager.initialize. So once we have initialized, I can just do self.mcp manager.register the tools, and then I can pass in the entire tool registry. So I have self.tool registry passed in here. But the key thing to remember is that this self.tool registry passes in the tools to this context manager, and then the context manager creates a system prompt out of this. So within the system prompt, the tools might never be passed, the MCP tools specifically. And we don't want that because we want a clear description of what the specific MCP tool does so that the LLM can call it. So for that reason, what we're going to do is just have context manager or null here, and by default the value is going to be null. Then within this initialize, we register the tools, and then we set the context manager as well. So we have self.context manager is equal to context manager. We'll pass in the configuration, we load the memory, we get all of the tools, and at this point I want to be extremely sure that the tool discovery manager has also passed in all of the tools. So I can just call it before as well. So initialize will be called here, right? And that needs to be awaited. I forgot about that. Then we register the tools. Then I also want to discover all of the tools present within tool discovery. Now I just need to ensure that initialize is called. Now wherever this session is initialized or constructed, I have to call this initialize function. So let's see. I think it's within agent. So I'll find all of the references. Yep, it is an agent. And now whenever we call session like that, we'll have to call initialize as well. I can specifically go within a enter and call self.session.initialize here and await it. So this will ensure that all of the things within this initialize are done. For example, the MC manager, the discovery manager, and then context gets all of the tools, because tool registry.get tools will get all of the tools, the default tools, the tool discovery, and the MCP tools. So now let's try to exit out of here and let's see if it works. So I'll have python main.py and we run into an error. We get attribute error, none type object has no attribute enabled. That means server config is not present. So we'll go to MCP manager where we have server config, and just to see that all of this stuff is present or not, I'll just print out the MCP configs. Now let's try to run it again and see if we get any value printed out. And we do see file system as the key, but none is the value. Since we do get the file system, there might be an issue in how we are doing MCP server config. And if I just scroll up to MCP server config, we'll notice that we have if condition here, and if everything is fine, we're not doing anything. However, we do want to return MCP server config if everything goes well, right? Because model validation will validate, and if everything goes well, it will return an instance of MCP server config. But I've not returned it So what I need to do here is call return self. Once we do that, this error should go. So let's try it again. And now we get another error. The error is in MCP manager. I passed in wait for, but I forgot to pass in the timeout. So what is the timeout? We get the timeout from client.config.startup timeout seconds. Let's try to run again. And this time we still see the output of file system. We get MCP server config, enable true, startup time, everything is fine. But then we see secure MCP file system server running on standard input output. That's also a good sign. These two lines are coming from the MCP server itself because we have not logged any of those lines. They're coming from the MCP server connection establishing. So that's good. But then we run into another error where we say an async io.future, a coroutine or an awaitable is required. And this error exists again because of MCP manager.py. Here we are awaiting async io.wait. We don't have to await it because I told you that we are waiting for the connection tasks. So we are loading up a bunch of async items here and then we'll await all of them together at the end. So we'll just have python main.py again. And now we run into another error. The error is attribute error, property schema of MCP tool object has no setter. So we have to go to MCP tool. We have done self.schema like that. To fix this, what we can do is go to the tool and have the schema properly set up like a setter, or we can just create a property of schema and just use that. So here I'll just do @property. Then I have def schema where I have self. And I'm going to return a dictionary of string any from here. Let me import any from typing. And then I'll just have the same thing here. So I can't set self.schema equal to something. However, I can just create a property function and do that. Alternatively, you can just go to the tool base class and here create a property.setter for schema and that should work. So now let's try again. And we do see the output. I would like to remove this print statement now. The debugging is done. So I'll remove it from MCP manager. Let's just try to exit it and see what happens. We still get this output. If you want this output to be disabled, you can do that. So when we try to create a transport in client, over here, we can pass in the log file, and log file can be path because it requires a path, and we can pass in os.dev null. So it will not write it anywhere and we won't see it out on the screen either. So let's just try to run it again. And this time, as you can see, we don't see anything. Let's try to call some tools. Now it's the file system server. These are the tools that are available. What I like to call is list directory. But if I try to call list directory just like that, it will call our list directory tool, the built-in tool, not the MCP one. So what I'll do is go to this config.toml. Here, the name of our server is file system, right? And I know that the tools are prefixed with file system. So what I'll do is say call file system __, then the list directory tool for me, please. Now let's see what happens and we run into an error. Attribute property schema of MCP tool object has no setter. And we don't have to set it to self.schema. We just have to return the value. I forgot about that because earlier also the same error was there. Self.schema could not be initialized. We have to return from here. That's why we created a property function. Now let's try again. I'll type in the same prompt. And as you can see, the MCP tool does get called. The path is just a full stop. And then we get directory.aiagent directory.venv. And then there are files, all of that. The MCP tool is also working. Encourage you to pause the video, create your own MCP server. You can create your own MCP server using fast MCP again, and then run that MCP server. You can also follow some tutorial on YouTube, but create your own MCP server, then pass it in through this config.toml, pass in the URL and see if the SSE transport layer also works properly. I'm going to skip that, but yeah, that is something you can look into. And with that, we have the MCP support. One thing I would like to do is go to the MCP manager here and create a function to shut down all of the MCP servers, to disconnect all of the MCP servers. So I'll just have def, which is going to be async def shut down. Then we have self, it's going to return nothing. And first I have to collect all the disconnection tasks, which is equal to client.disconnect. So first I'll have to get access to this client. So what we'll do is go over every client that we have. Cool. So we have for client in self client. And now I can just do await async IO dot gather, and I'll pass in all the disconnection tasks here, and we'll set return exceptions to true. If there's any exception, it will return. Then I'll also set clients to clear up everything, and then I'll just set initialized to false because it's not initialized anymore. So remember, this client.disconnect is the function we created in MCP Client, and in MCP Manager, we're just disconnecting all of the LLM clients, and now the shutdown needs to be called within agent. So I'll just go to agent.py where we had a exit, if you remember. And here we said if self.session is true and self.session.client is there, we close the client, we set session to null, and here I'll just add another thing. And actually we can just do it over here and say await self.session.mcpmanager.disconnect. And it's not disconnect, sorry, it's shutdown. And yeah, that will shut down everything. So here I'll just check, and self.session.mcpmanager is also there. In that case, we'll call shutdown, and it should most likely be there. So that is just gracefully quitting all of the MCP related stuff. Now let's run it again. I'll just say call, and let's try to call a different tool now. So we'll have call file system _, and let's try to find a better tool. Let's say get file info on, let's say main.py file. Let's hit enter and see what it does. So it calls file system get file info. Path is main.py. The size is 4719. Created at this time. Is directory false? Is file true? Permission 644. So that's amazing. So we have added support for MCP nicely. Now the next thing I would like to get into is context management, because we have a bunch of tools available. And remember, everything about tools is done. Now the next thing we are going to work on is context management. So let's understand the problem and why we need context management. So LLMs have a fixed context window, right? There is 128,000 tokens or 256,000 tokens, all of that. Now, whenever you're coding with an agent, the context will fill up fast because you've set up your initial instructions, which are 7,000 tokens or something. Then all of the file content that needs to be read, then the tool calls and the output of that tool call. Then you have multi-turns. So within multi-turns, you'll have lots of content, right? And then there are error messages, all of that. So this just means that the agent will have their context filled up very fast. This is why we need context management. Now, how do we solve this context management problem? How do we actually manage the context? You can think about it in human terms. Let's say you're in a 10-hour meeting, but you can only remember the last 2 hours clearly. What would you do? Well, you take notes, right? You will summarize the key decisions that were taken, what are the action items for you, and whatever pending items are there. You'll just summarize all of those items. That is called compaction or compression or summarization. So you're just asking yourself, how do I summarize this meeting? Similarly, an agent can just take its conversation history and tell another LLM to just summarize it for the LLM. And the summarization should include things like what are the pending items, what are the items to do, what are the items that have been done, and specifically for the AI coding agent, everything is written down in files or is being read from files, right? So we can tell the LLM to specifically list out the paths to the files so that we don't have to spend more tokens on listing the directory and all of that stuff. We can just tell that, yeah, tools/base.py has this particular thing, and the agent worked on X, Y, and Z for this base.py, right? That's so much simpler. And in case the agent has to touch base.py again, it can just look up the file and read the file. So essentially we go from, let's say, something like 200,000 tokens and summarize it down to, let's say, 10k tokens. After we have those 10k tokens, it doesn't have any of the information related to the tool calls it did or the files it wrote, but it does have the context about what each file that it created or touched does and what are the pending future items. So based on that information alone, it can go ahead and on demand load other things it might need. For example, it knows that for the next task, it needs to load up, let's say, the tools/base.py. In the context, we have written down that tools/base.py does this task, and it might be used for a pending action item. So in that case, it will go ahead and read this file again. So we are taking advantage of the fact that everything is in our file system. So we can just write down the path to it, and whenever needed, we can read it. So on demand, reading the files. This is what we are going to rely on. And this is what our compaction prompt is also going to be, because remember, compaction is just telling another LLM that, hey, please summarize this entire conversation for me. So let's go ahead and create the files that's required. So I'll specifically go to the context folder, and within that I can create a new one. Let's call this compaction.py. Now this compaction will be used within the AI agent, and it will work closely with the context manager. So let's call this class chat compactor, or you can just call it compressor, whatever you want. Then you can have the init function, and the first thing we'll need here is the client, right? Whatever is the LLM client, because I have to send a request to the LLM to compress things. So I'll just create an instance or take the instance from the constructor, and after that I'm going to create a function async def compress, and this is going to be the main compressor. What it will require is a context manager, so I'll take that as well. And let's import context manager. So to compact, the first thing we'll require is all of the messages in the conversation history, and context manager is storing all of that. If you notice, we had messages here. Messages stores all of the messages. So we can just call get messages function, which will give us the entire conversation history. So I can just do messages is equal to context manager dot get messages, and then we have a list of messages. Then I'll make a quick check that, hey, if the length of messages is greater than 3, in that case I'll just return none and none. Why am I returning a tuple from here? Well, that's because the return type of this function is going to be interesting. It's going to return first a tuple. Obviously the first element of this tuple is going to be a string, or it can be a null value, and this string or null value is essentially the summary string. So we ask the LLM to summarize and give us the compression prompt to summarize. So that's what it stands for. And the next thing we are going to return from here is a token usage. So how much token usage was done for this compression that took place. So I'll just have none here. Once I have that, I will build up the compression request. So to build a request, first let me just go ahead and do a try except, because in try except we might run into some sort of error because we are dealing with an LLM, and I'll just return none comma none from here. Also let's just remove as e. And now what I'll try to do is self.client.chat completion, things we have already looked into, and pass in the messages list. And this is going to be a compression messages list that we are going to develop in just a minute. And the second thing I want is stream is equal to false. I don't want stream is equal to true. The reason for it is, what's the point of having a stream of messages? All I need from this client is one big message of the summarization, and I'll add it to my context after that. That's why stream is equal to false. Since this is going to return an async generator, we'll have to do async for event in self.client.chat completion, and after that I can just check if event.type is equal to event type or stream event type, sorry. Let's import it from client.response, and if it is equal to message complete, because remember in chat completion, when we are doing a non-stream response, we are sending a message complete when the response is over. So if we have reached the event type of message complete, in that case, I would like to get the usage because even the usage is being sent, right? Let me just go back to client chat completion. We're passing in the usage, which is this token usage. We will get the summary string. So I'll keep track of both of them. So I'll have summary is equal to an empty string, usage is equal to null, and then I'll have usage is equal to event.usage, and summary is just plus equals event.textdelta.content. After this for loop gets over, we are just going to get one message anyways. And once we do that, we'll just check if not summary or not usage. That means summary is an empty string or a null value, or the usage is a null value. In that case, we are going to return null comma null because we did not get anything correctly. After that, we'll just return the summary comma usage if we get both of them, right? And now we have to build up the compression messages. So to get the compression messages, it's going to be relatively easy. All we need to do is create a list here, which is going to be a list of dictionary. The first one is obviously going to be a role of system because we want to attach a system prompt for compression as well. And this system prompt is going to tell how the compression should take place, what the summarization should include. So we have the content, and this is going to be get compress, or let's say get compression prompt. You can also call it get compaction prompt. That would be more ideal because this is called compaction. So now I'll go to system.py file, which is within the prompts folder. And down here, I'm going to paste another function, which is the get compression prompt. We're going to use this compression prompt. If you're copying it from GitHub, you might already have this get compression prompt. So what is this prompt saying? Well, it's saying to provide a detailed continuation prompt for resuming the work. The new session will not have access to our conversation history. That is an important line. That's because we're not just summarizing here. We're saying that, you need to summarize what you did. Along with that, you need to write kind of a continuation prompt for the LLM so that it can continue the task. So it's not just summarization. It's also a continuation prompt of what it needs to do next. Then important is that it needs to structure the response exactly as follows. So it gives its original goal. So it states the user's original request or goal in one paragraph. Completed actions. It should not repeat these actions. Otherwise the LLM might get confused, because think about it. You have 20 turns. You have 20 messages of you and LLMs or agents back and forth. And the agent has completed certain tasks. Here, it goes ahead and lists all of the actions it did. Now, in a new context where the LLM doesn't know what it did previously and all it relies on is this particular paragraph, it might see completed actions. Okay, these were the completed actions. It will not know that it doesn't have to repeat this. These are already done. We are just explicitly saying it out loud. And it will list specific actions that are done and should not be repeated. Be specific with file paths, function names, changes made, and use bullet points. After that, it will describe the current state of the codebase or project after the completed actions, what files exist, what has been modified, what is the current status. In progress work is the pending work, what was being worked on when the context limit was hit, any partial changes. And also, since we have described here that the context limit was hit, the LLM will have more idea of what it needs to do. Then there are remaining tasks, what still needs to be done to complete the original goal. It has to be very specific. Next step, what is the next immediate action to take? Be very specific. This is what the agent should do first. Key context, so any important decisions, constraints, user preferences, technical context, or let's say assumptions as well, that must persist. Be extremely specific with file paths and function names. We are reinforcing this because the LLM needs to pass that in. This is something we are relying on very strongly. And the goal is to allow seamless continuation without redoing any completed work. So that is the compression prompt. We can just take this and call it in over here. Obviously. So now that we have the system prompt with us, the next thing is the user message. So we'll just pass in the role of user, and then the user is going to have the content here, and for the content, what do we pass in? Well, we can pass in all of the messages here, but the problem with that is the way messages are structured. It gives a list of dictionary where the role is system, content is given, and it will pass in the role and content again and again. For example, it will again pass in the role system and then content system prompt. After that, there will be a user message. So it will again add role user and the content of the user. Then there will be a role of assistant and whatever it did to complete the user's query. This is problematic because if we attach it to this content, we are messing up the entire context, right? Because this content is a dictionary which has all of these roles and contents, which might just confuse the LLM. So instead of passing in the messages, what we're going to do is format these messages so that we can pass it in correctly. So I'll just create a helper function called format history for compaction, and then I'll pass in this messages list. Now I'm going to go ahead and create this function. So I have def format history for compaction. Then we have a messages, which is a list of dictionary of string comma any, and I'll import from typing any. And obviously the output of this is going to be a string, because all we need is a string. We do not want a list of dictionary. The LLM will get more confused because of that. However, if we structure properly that this is the conversation that needs to be compressed, and then we pass in what the tool result was in a string format, that will be much better. So what I'll do is go over every message in this messages dictionary. I'll check what the role is. So let me just get the role here. And if it's not specified, it's an empty string. Similar to that will be content. So message.get content. And then I'll check if the role is equal to system. If it is, then we are going to continue so that we don't have to write the system prompt down. Because if we write the system prompt down, there is no point. Like, the LLM will also try to include that in its compression messages or the compression prompt, and we don't want that. Imagine the 6,000 line system prompt coming in and the LLM trying to figure that out. After that, we'll just check if the role is equal to tool. In that case, we're going to append it to a string, right? We'll get some content out of this tool and attach it. So first, I'll go ahead and create the output list here. The first string here is going to be, here is the conversation that needs to be continued. Then maybe I'll just give a \n here so that there's a 2-line space, because at the end we'll just concatenate all the elements of this list. So there will be 2 lines left. Now let's try to extract the tool ID, which is equal to message.get, and then we'll have tool call ID. Otherwise, it's an unknown tool call ID. This is quite important because if we pass in the tool ID, the LLM will just have more context. It will have that continuation, because if there are 3 tool calls that are essentially the same, the LLM will just understand it better, right? Because if the assistant says, this is the tool ID that I told the user to call, and then we attach the role of tool where the user did call the tool ID, that's a confirmation that the tool was called. After that, what we're going to do is truncate down the content that we have over here, because there's no need of passing in the entire content. Anyways, it needs to get compressed. So why should we even pass it in? So we'll just truncate it down to, let's say, 2000 characters. And we'll just say if the length of the content is greater than 2000, only then we do that. Otherwise, we'll just say content. And then we'll again say if the length of content was greater than 2000, then we truncated. And in that case, we're going to have truncated plus equals, and maybe I'll have a \n ... and then I'll have tool output truncated. Then I can go ahead and append to the output. So I have output.append. Then we have an f string where the tool result is present. Then we pass in the tool ID. Then we have a \n where I pass in the truncated response. So this is us just trying to format the output nicely so that the LLM understands it better. Then another role that can happen is the assistant. In that case, I want to get all of the tool calls that were done, and all of the content that was done. So first I'll just check if there are tool calls that happened. If there are tool calls that happen, then I'll go over every tool call in that list, and I'll have function is equal to, let's say, tool call dot get function, and it's an empty object if not specified. Then we have the name. We've looked into this many times, so I'll just go a bit faster. We're just trying to extract all of the arguments from here, and we'll just quickly do that. Awesome. And now I'll just check if the length of the arguments is greater than 500, for example. If it is, then I'll truncate down the arguments to 500 characters. And then we'll just have output dot append, or let's not append it to output just yet because we are in a for loop. Maybe what we can do is create another list called tool details, which is an empty list. And then we'll go over each element of this tool call and append it to this tool details. So we'll have some indentation here. This is how we are planning to format it. Then we have the name of the tool call. Then we have the arguments passed in, right? So let's say the name of the tool call was hello world. This was the tool call. And then you pass in all of the arguments. For example, A is equal to B, C is equal to D, whatever. So this is how we are saying the tool call should look like, or the result should look like. And we'll do that for every tool call. So in this list, we just have this indented kind of thing. And now after we get out of this for loop, we'll just do output dot append. And then I'll just say, hey, the assistant called some tools, and then I'll put them on a new line. Then I'll pass in this tool details, but tool details is also a list. So maybe I can just do plus \n dot join, and then I'll join the tool details. So everything goes on a new line. So though this is the formatting for tool calls, now another thing that an assistant can give us is the content. So we'll also attach the content here. So if content, then we'll have truncated is equal to content, and then let's say we go up till 3000 characters. If the length of the content is greater than 3000 characters, otherwise we'll just pass in the content. And if the length of the content is greater than 3000, then we'll just append to truncated a thing that says response truncated. And finally, after that, we'll just have output.append. We'll pass in the assistant on a new line and pass in the truncated thing. Also, this has to be an if string. Now, one thing we can do is maybe we can shift the content a little bit up, because when we display to the user, the first thing that gets shown up is the content, whatever the LLM or the agent told us that it's going to work on X, Y, and Z, and then the tool calls show up. So this is how I'm formatting it. Then I have an else condition here that the role is of the user most likely. In that case, again, we're just going to do the truncation. So I'll just copy this entire line, all right? And then let's paste it. Let's indent this properly. So truncated is content, let's say up to 3000 or 1500 characters. If the length of content exceeds 1500, otherwise we have the content. If the length of the content is greater than 1500, we'll just add message truncated. And then we just say that the user responded with this truncated message. And finally, at the end, we'll go ahead and return everything from this function. So after this for loop gets over, we have return \n dot join, and I'll pass in the output. Maybe I can do this better. I can pass in \n. So 2 lines are left. Then we have a clear separator, and then we again have \n. So just a clear difference between this is what the assistant said, this is what the tool call did, and this is what the user related messages were. Now I can copy this, and we have already passed it in over here. And this seems to be the function for compression. Now all I need to do is call this compress function within the agentic loop. So I'll go to this agent.py and figure out how do I call this compression in the agentic loop. So in this agentic loop, we have the turn beginning. Then we go over all of the messages. and try to fetch another response, then we call the tool and all of that. So where exactly do we want this compression? Well, we can just put the compression at the very top, right? Before we are going to call the LLM again, we can put in a compression part. We can check for the context overflow here, and then we can compress based on that, because we just don't want compression to begin just like that. I do not want to go ahead and have something like chat compressor and then call the compression method here, because then it will compress for every single message. Even if I have 8,000 tokens well under the limit, it will still go ahead and compress it. So instead of doing that, we'll check for context overflow. And to check that, first we'll have to keep track of all of the usages that are happening. And to track the usage, we do get message complete event sent by the chat completion. So if you notice here, for either of these stream or non-stream responses, we get the message complete where we get the usage, and we want the usage here as well. So we have to keep track of that. So here we'll have usage, which is of the type of token usage. Let me import that, or it can be a null value, and by default it is a null value. And then if we get an event, let's say the event's type is equal to stream event type dot and its message complete, then we get access to the usage. So I can just do usage is equal to stream, or let's say event dot usage. The first thing is if there are no tool calls, we'll return. We can check here if usage is present, it's not null, then I want to set the latest usage. So within the context manager, I can go and create a variable, or let's go to manager.py. And here I can create a variable that keeps track of the latest usage. So I'll have self.latest usage. This is not the total usage. We'll have another variable created to track the total token usage. But what we are interested in is just the latest usage as of now. So we'll have token usage created here. Let me import that from client.response. And maybe since we're here, let's just create a total usage as well. And that will be token usage as well. So these are just two objects instantiated. Everything is 0 for them. Then we're going to go ahead and create two functions. The first function is going to be to set the latest usage. We'll get a usage from the parameters here. And what it does is it sets the latest usage to this usage that's coming in. Then the other method that's going to be created is add usage. It also gets another usage, but the difference is it will set the total usage, and what it will do is instead of setting the usage, it will add up the usage. Because think about it, latest usage is essentially what was the usage in the last message. Latest usage is used for tracking the context length. Because think about it, if we go back to this ChatGPT, I give it one message and then it responds. So the latest usage for this LLM will be given by the response over here. Then I ask another message, the latest usage will be given over here, because latest usage will have this message, and this message in the prompt, in the message history. So these will be taken as the prompt tokens. This will be the completion tokens. So the latest usage covers everything over here. However, if we try to use add usage for this particular thing, what will happen? I send in one message, right? So that is tracked. Then I get this response. This is also tracked. And then I send another message. And in that message, the previous history is also appended, right? Because I told you LLMs are stateless. So these two messages are also kept track of. So these are also taken as system messages or system prompts. So these are again called prompt tokens. And then this is also called a prompt token. So I have to add up this entire thing again. And this will keep happening for other LLMs as well. And this will keep happening for other messages as well. This latest usage will just help us know what the latest usage is so that the context limit can be checked. And the next thing we have is the add usage. Add usage is so that we can display to the user when they type in a command like /stats. This is a command that we're going to support. If the user passes in /stats, I want to show the total usage that's done, because we are charging them for this total usage, because it did take us this much total usage as money. So we'll charge them that much. But latest usage is so that we can check what context limit was hit. I'll just repeat this point again because it's quite important. You can skip ahead if you understood it. But essentially, latest usage till here includes the usage of this message, and this message all once. Total usage means it will include this message 2 times, because you first sent a message, you got this response, so it's counted once, and then when you send another message, these two are again included in the conversation history. And that's why you're charged for it again, and then you are also charged for this token. So this is the total usage. But to understand what context we are on, we just have to check how much these messages cost us once till here. So this was, let's say, 1 token, this is, let's say, 10 tokens, and this is, let's say, 3-4 tokens. So it's about 16-17 tokens. This is the conversation history. If we include them 2 times, there's no point of having the context limit, because if we are including that 2 times, well, it doesn't make any sense. So having understood that, let's go back to agent.py, and here we can check that if usage is present, then I'll have self.session.contextManager.add usage. So that will give me the total usage. I'll pass that in. And similar to add usage, I'm also going to set the latest usage. And as it goes, we'll return out of this tool calls. And a similar thing also needs to be done if there are tool calls. After we do for tool result and tool call results, we add the tool result to the context manager. After that, we can just check if usage is present. Then we are going to have self.contextManager, set latest usage, and add the usage. And maybe you can also yield an agent event notifying the user that the compaction took place. That's totally valid and actually a good user experience, so go for it. And now that we have kept track of this entire usage, we can go at the top and check for the context overflow. And for that also, I'll have to go to the context manager and create a new function this time. And this function will just check if we have reached the compression limit. Let's call this function needs compression. And then it's going to return a Boolean value. And then we just have to check if the context needs compression. So first thing we'll require is the context limit. And we can get that from self.config.model. Let's say not name, we need the context window. So that is the context limit. Then what are the current tokens that have been used? And for that, we can just do self.latest usage.total tokens. And then we have to just return if the current tokens exceeds the context limit, then yeah, we've reached our limit. But here's the thing. Why do we want to do a neck and neck? Let's say the current tokens is 256 or 258,000 tokens and the context limit is 256,000. That's pretty bad, because many times it can be the case that tool results cannot be truncated down a lot. Nothing can be truncated much. When we give the result to the LLM, what will happen is that the LLM will just say that, hey, listen, this is out of my context window. So instead, maybe we can use some sort of limit here. We can say that if the current tokens is greater than context limit into 0.8, for example, that means 80% of its limit. So something like 200,000 tokens, in that case, we need the compression. So this is what we're doing here, and we'll call this function in agent.py now. So we can check if self.session.contextManager.needs compression. In that case, we have to call this compression method. For that, we will need a chat compressor, and I can create an instance of chat compressor in agent, but I think for each session, there'll be a different chat compressor instance. So let me just pass that in over here. Also, if you notice, chat compactor or compressor requires a client, and the client instance is created within the session. So let me just go to the session and instantiate it. So I'll have self.chatCompactor is equal to chat compactor. Let me import it. and then I'll pass in the client, which is self.client. And since the instance is created here, I can go back to agent.py, and here we can just say that we'll have self.session.chat compactor.compress. And then I need to pass in the context manager. So I'll just pass in the self.session.context and it will return to us a coroutine. Let me await it. And once I await it, I'll get a tuple with summary and usage given. Now this summary and usage can be null as well. So first I'll check if the summary is present. In that case, it's implied that the usage is also present because they both come in one package. If summary is not null, usage is also not null. So I'll just do self.session.contextManager.add usage, and I'll pass in the usage. And similar to that, I'll also do add latest, or let's say set latest usage, and I pass in the usage. Awesome. And now what I like to do is replace the context history. So what I need to do is go to the manager, and the messages list that we are trying to maintain here, I just have to clear it off and pass in this summary that the LLM gave us. But that's not how easy I'm going to make it. I'm going to add in a few more steps. So let's just go back to manager, create a new function now. So I'll minimize everything, and we have a new function now. Let's call it replace with summary. So we are trying to replace all the messages with this summary, but I'll try to do some kind of manipulation here. We'll give it the continuation prompt that the LLM gives us, and before that we'll clear off all of the messages. So I have self.messages.clear, or maybe I can just set it to an empty list again. After that, I'll add the continuation prompt as context, and it looks something like this. Since it's a big prompt, I'm just pasting it in, but let's go through it. I'll specifically tell the LLM that, hey, there's a context restoration. Previous session has been compacted. The previous conversation was compacted due to context length limits. So giving our new LLM some context about what's going on. Below is a detailed summary of the work done so far. Critical actions listed under completed actions are already done. Do not repeat them. This is very important because the LLM will just start doing them. So I'm reiterating that. And now I'll pass in the summary within these clear separators, and I'll say resume work from where we left off. Focus only on the remaining tasks. Maybe we can also tell it can also focus on the tasks that are in progress. So you can tune this prompt a little bit more. By no means is this perfect. So yeah, after that, I'll add it to the messages, and for that, I'll just do self.messages.append, but I just can't pass in this message, right? Because it's a text. Messages requires us to pass in a message item. So let me create that message item. So I have, let's say, summary item, which is equal to message item. And then I pass in the role, which is the user, because the user is saying all of this. Then you have the content, which is the continuation content. And then you have the token count, and then we can just pass in count tokens. We'll pass in the continuation count, and then the model, which is self.model name. Great. Now I'll pass in the summary item. Is that enough? No. I'm going to do a bit more manipulation here. The second step of this is going to be to add the assistant acknowledgement. We'll tell that the assistant replied to us that, yeah, I've reviewed this context, the original goal, what was required, which actions are already completed. Essentially, I've gone over this entire state of the project, and I'll continue with the remaining tasks only. And we'll start from where we left off. So this is some kind of manipulation, reinforcing the LLM that, yeah, you said this to us earlier. Even though the LLM did not tell us, we're just telling it so that it works in a better fashion. So I'll paste this in, and this is quite similar to what OpenCode does to compact their things. So as you can see, I've reviewed the context. I understand the original goal, blah, blah, blah. After that, we'll again create this message item and append it to the messages list. So let's call this acknowledge item. And then we have the role of assistant, acknowledge content, and then we pass in the token count, and then we can pass in the acknowledge item here. Now you can also try removing this and see what the output looks like. But in my experience, this acknowledgement makes it work much, much better, because if the LLM says, yeah, I've already worked on that, it just works better. It's like us gaslighting the assistant, telling us that, yeah, you did say this earlier. So the LLM is more inclined to work in this manner. Okay. After that, finally, we can have another one where we are saying to the LLM that, yeah, sure, go ahead, continue with the remaining work only. Because if the messages ends with the assistant might not reply. So we do need the messages ending with the user. So we have this continue content where it says continue with remaining work only, you know, just reinforcing the same thing again and again, because we just don't want the LLM to do the work that's already done. So we'll have a continue item, which is equal to message item. Let me just copy paste what we had over here. And then I'll pass in this continue content. The role is of the user. Then we count the tokens, which is the continue content. Also here the count tokens should be acknowledge content. Then finally let's do self.messages.append and we'll pass in the continue item. All we are doing is gaslighting, nothing else, and it does seem to work, so that's good. Now I can go to this agent.py and do something like self.session.contextmanager.replace with summary, and I'll pass in the summary, which is this text, right? So what it will do is clear off all of the past messages. It will replace with our summary. It will gaslight a little bit. And also we'll set the latest usage and add usage based on whatever we get from here. Obviously that's not very correct because we added our own stuff as well. For example, this continuation content, all the extra tokens that are added here, for example, these things, then the summary is accounted for because that's what the usage was. And then these things, then we have these tokens as well. So these are not accounted for, but it's just a difference of, let's say, maximum of 500 to 1000 tokens. So I'm not worrying too much about it, but if you want to be perfect, which you should be, then you can go ahead and add that in. I'll close all the save files. Let's restart and see if I made any mistakes. Nope. But there's one thing. It's very hard to reach the context limit of 256,000. If I start to do that, I'll have to wait for an hour or maybe 30 minutes. I can't do that. So what I'll do instead is go to our config.py, and here within the model config, I've set the context window to be 256,000 here. Maybe in the .ai agent config.toml, I set the context window to be something like 16,000 tokens. So as soon as we hit the 16,000 token limit, it will just compress. Now let's start it and see what happens. I can tell it to create a YouTube clone for me, please. And I'll tell it to one shot and let's see what it does. So I stopped the agent midway after it went on for a while. The reason for it is it was going on for too long, but I would like to show you certain instances where we can see that the agent started continuing after doing a compaction. First of all, I cleared off everything and started again behind the scenes because I forgot to put using HTML, CSS and JavaScript. It started creating it in React and I did not want that. Otherwise it would take a lot of time. Despite that, it took a lot of time. So it went on and created index.html and then styles.css and the script.js. All right. After that, it said that it created this basic clone and I did not open it. I did not open the index.html. I just did doesn't look good, do more work, because I wanted it to hit its limit of 16,000 tokens of context window. So it went ahead and added a few to-dos and started working on them. After that, it went on for a while and updated a few things. After that, there's something I want to show you. So when I scroll down, it again does action list. So it lists the to-dos. The reason it had to list the to-dos is because it started working on something, right? And then compaction occurred. Once the compaction occurs, it has no context of what to do, so it just calls the to-dos list so that it can see any pending work that needs to be done. After that, it just says that let me add realistic video cards, which is the second one because it did improve the UI design and layout previously. And then it goes ahead and completes all of this task. Once all of that is done, it goes on with the next step, enhancing the sidebar, which is the to-do over here, and then it works on that part before I abort the operation. So there are 2-3 more to-dos to do, but as you can see, once it hits the context length, it starts rereading the files that are necessary and keeps working on that. So that means the compaction is working well. We don't have to worry about that. I'll just go back to config.toml and remove this context window of 16,000 because 256,000 is our limit. Let's get back to that. Now the next thing I want to do for context management is pruning. What is pruning and what problem does it solve? So just imagine that, you've been debugging a complex code base, not a simple code base, a pretty complex code base, and you've asked your agent to do it. Your conversation with the agent is now, let's say, 100 turns or even let's say 50 plus turns, and it contains everything: file reads, tool calls, error messages, failed attempts, all the successful fixes, even the LLM hallucinations that might exist. So the context window is now stuffed with information, most of which is no longer relevant to the problem we're trying to solve right now. So it is a problem, right? We are burning tokens, which directly correlates to money. We are approaching the context limits, and then we'll have to do compaction, and compaction just results in kind of lower quality because it has to reread the files and stuff. And the third problem, which is quite overlooked, is that the model starts getting confused because it's trying to attend to a bunch of irrelevant and old information. So how do we solve this problem? Well, you can think about it in the way your brain would do it. So let's say you are trying to do it manually. AI agents don't exist as of now. You're still in 2021. So you finally fix a bug, let's say after an hour of debugging, the good old days. And once you do that, your brain naturally forgets the problem that you were facing and like what the exact specific line numbers and code pieces were. You just remember something like, oh right, the issue was, let's say, some race condition that was present in the auth middleware. So you compress the session of what's not relevant into a simple summary, right? Now pruning is teaching the agent to do the same thing. And there are few strategies in pruning. One is a sliding window pruning technique. The next one is summarization based pruning. And then there's relevance based pruning as well. In sliding window, this is the one that we are going to do. It just keeps the last n messages and drops everything else. So let's say it will keep last 20,000 tokens and remove everything before that. Then there's summarization based pruning, meaning it will periodically pause and ask an LLM to summarize of what happened so far, and it will replace the old messages with the summary. So it's quite similar to the compaction part. And then there's relevance based pruning. So it will score each message or turn by how relevant it is to the current task that the agent is trying to solve. And it will keep all the high relevant stuff. It will prune away all the low relevant stuff. So we are going to go ahead with the sliding window approach. Specifically, our approach is going to prune the old tool outputs. So what it will do is go backwards through the tool results until there are, let's say, 20,000 tokens to save. And then it will clear off the output of those older tool results. And that's it. This is based on OpenCode's pruning approach. And we're just going to do that. So we're going to go to this context manager.py. And here I'm going to create a new function. This function is prune tool outputs. We're going to get a self here. I'm going to return an integer. Even if you don't return anything, it's totally fine. But my point is to return the number of tokens that have been pruned. So the very first thing I'll do is count the number of user messages there are. If there are less than 2 messages, I don't need to prune anything. There's no need. But third message onwards, I can start into pruning. So I'll have user message count, which is equal to sum. And let's say we'll add up for every message in cell of messages. And we'll do that if message.role is equal to user. Great. So that is the user message count. If the user message count is less than 2, then we are going to return 0, that we did not prune any tool output. After that, I'm going to go over every message in self.messages. But once I do that, what am I doing? I'm going over the system prompt, then the first user message, then the first assistant message, then the first tool message, and so on. What I want to do is go in the reverse order, because the idea here is that the old tool calls don't matter anymore. The new tool calls matter a lot more. So I'll do reversed cell.messages so that we go from the newest messages to the oldest messages, and we only want to process the tool result messages because anything else won't take that much space. If the assistant says I want to call a tool, that doesn't take up much tokens. What takes up much tokens is the tool result. If the role is tool and we're telling the LLM that, yeah, this is what the output of the tool is, that is what costs messages. So we'll have tool call ID as well. In this case, what we want to do is prune. So we'll have message dot token count. Now this is the reason why for every message we had stored a token count associated with it. So these are the number of tokens. Now this token count can be a null value. So if it is a null value, in that case I'll count the number of tokens, pass in message.content and self.model name. But most likely the token count is going to be present. After that, what I can do is store the number of tokens that are present in total. So total tokens is 0, and then I just do total tokens plus equals tokens. And now I have to check if the total number of tokens that we have exceed a threshold. If it exceeds a threshold, what I want to do is start pruning. So I'll define a variable at the top in context manager, and I can just call it, let's say, prune protect tokens, and let's set it to 40,000. These are the values that OpenCode also uses. Then we have prune minimum tokens, and let's say this is 20,000. So prune protect tokens means that we keep the last 40,000 tokens of tool outputs and just prune everything else. So we are protecting 40,000 tokens of the most recent tool outputs. And prune minimum tokens means that we prune only if we hit 20,000 tokens to save. That means, let's say we have 200,000 tokens of just tool outputs in our conversation history. In that case, what's going to happen is it will check, yeah, there are 40,000 tokens of tool outputs. Great. So we are going to protect those 40,000 tokens in terms of recency. And we will only prune away if we can free at least these 20,000 tokens. And after 40,000, yeah, we'll be able to save 20,000 tokens. So that's great. Because in reality, there are 160,000 tokens more to delete, right? Because if 40,000 are being saved and 200,000 tokens are being used in the conversation history, 160,000 tokens need to be deleted. So it's greater than 20,000. So yeah, we're going to go ahead and delete it. So I can come back over here and just check if the total number of tokens exceeds self.prune minimum tokens, or let's say prune out protect tokens. In that case, yeah, we're going to start pruning everything. So I'll keep track of the pruned tokens, which is equal to 0. And then I'll just do prune tokens plus equals tokens for this particular message. And then I can also have a list of what things do I want to prune. So I'll have also this should be equals. Then I'll have a list to prune, which will be a list of message items and initially an empty list. And I'll just append to that list. So I have to prune dot append and I'll pass in the message. Why are we storing message in this to prune? Why are we not deleting the tool output here itself? The reason for it is after the for loop is over, we have the total number of prune tokens, right? How many tokens are we going to remove? If those prune tokens are greater than the minimum number of tokens that are required, in that case, I can just go ahead and return 0. Or let's say if it is less than self.prune minimum tokens, because if it is greater than, I want to prune. But if it is less than, that means we have not reached our 20,000 limit. In that case, I'll just return 0, that I don't want to prune this tool output. We cannot free up at least these number of tokens. Obviously, you can set this to 0. So you just kind of, remove all of the tool outputs after protecting the first 40,000. But yeah, your choice. After that, I can keep track of a variable that will help me know the number of messages I marked as pruned and, deleted their tool calls from. This is just there so that I can return this prune count at the end. The integer value that's returned from here really has no value. We're not going to do anything of it. But just in case you want to store it in some sort of session so that you can do a marketing gimmick or something related to this agent, that yeah, we saved you 40,000 tokens because we are such a good tool, you can go ahead and do that. I'm not interested in it. Now I'll go over every message in this toPrune list, and all I need to do here is message.content is equal to, and then I'll just mark this as old tool result content cleared. Okay. After that, I'll just set the token count to count tokens, and I'll pass in the message.content, and I'll have self.model name. Now there's one edge case that we have not talked about, and also, by the way, you have to do pruned count plus equals 1 here so that this is correctly updated. But the edge case that I'm talking about is, what if we've pruned the tool outputs, we reached a certain limit, we started pruning the outputs, and then we added more messages, and now it's time to prune again. In that case, certain messages might be pruned, but still they might go over here and we might try to prune it again. Why do we want that redundancy? So to stop that, what we can do is go to our message item here and have an attribute which is pruned at, which is either of the type of datetime. So we'll import from datetime, or it can be null as well, and by default it is null. This is only set as the value if the tool result was pruned, and therefore this value is only present for tool results. Now what I need to do is scroll down, and here I'll just set message.pruned at equal to datetime.now because the pruning is now done. Then I can scroll up a little bit where we have for message in reversed, and if the message.role is tool, in that case first I'll just check if the message.pruned at is not null. In that case we have hit the already hit the compacted tool results, which is like the pruning boundary. So we have hit the last message that was pruned. All the messages after that are obviously going to be pruned. So we'll just break out of this loop and we don't have to prune anymore. Otherwise what will happen is it will start taking into consideration all the other messages that were pruned, and it will count these number of tokens for, let's say, 100 tools, and then it will add it to this prune tokens, and it might result in prune minimum tokens limit being hit. Why do we want to do that? That's why we break out if pruned at is already true. And that is it about pruning the tool outputs. Now I'll just go to agent.py and call this function. The first place I would like to do it is when we have no more tool calls to do, because when we have no more tool calls to do, we're just going to return from here, right? And we have calculated the usage. After calculating the usage, we can just say, yeah, I want to prune it. So I'll have self.session.contextManager.prune the tool outputs, and that will return an integer, but an integer I don't care about. If you want, you can log it out and see for yourself. But yeah, I'll just copy this line again, and before we end this turn, I'll just prune again. So just after usage again, I'll just check, hey, can we prune the tool outputs properly? And if we can, all the tool outputs will be pruned. This obviously works on a bigger scale when, we've consumed 150,000 tokens or so. If you want, please go ahead and experiment with it. It should work as expected and result in not much loss of the quality of the agent while saving the costs. So that's good. I'm not going to run it because I'll just hit my free limit tier for today and I don't want to do that. Now let's move on to the next feature. And what we are going to work on next is the approval system. So you might remember that in our toolsbase.py file, we had created something of a function called getConfirmation. This function's job was to give us information about what is happening in this particular tool. For example, we will have the edit tool or the write tool, and that is going to return this tool confirmation. It's not going to return tool invocation, by the way. It's going to return tool confirmation or a null value. So if something is not mutating, for example, a read file, it returned null. But just in case we were going to have something like a write tool or an edit tool, we just sent out some information regarding what this tool is going to do, and after that will come the approval system. So approval system will take the details that we give from this getConfirmation function that is within the tool. It will call it and then it will check if that is safe to run. If it's safe to run, then we are going to go ahead and execute it. But if it's not, then we are going to block it at that particular point, ask the user for their confirmation. So the user can just say that, hey, listen, this is fine with me. You can run this command. I think it's safe to run it. And then the things will happen. So obviously this is not needed for the tools that are not mutating anything, because if the state is not mutated, any operation is just fine. But if the state is mutated, in that case, we'll need getConfirmation. And getConfirmation is a function we only created in this base tool. It's not created in any of the tools that extends the base tool. It's not created in edit file or let's say write file or shell. These are the three places where we are going to add this getConfirmation function. So let's go ahead and add that. But first of all, we need some information about the approval system. The approval system is basically in the config.toml file. The user can specify what type of approval they prefer, and it can be one of multiple values. So let's just go to config.py. And here I'm going to scroll down and create a new attribute, not in MCP, sorry, in the config. And we're going to call this approval. And this is going to be a enum. So we'll have approval policy like that. And by default, it's going to be approval policy dot something known as on request. I'll talk about that in just a minute. But yeah, now let's go ahead and create this enum of approval policy where we are going to have a string enum. We've created enum multiple times, so that's that. The first value here is obviously on request, something we just created. On request means that it will ask for confirmation based on whether the operation is mutating or not. So if let's say there's a write file or edit file, it's mutating, so it will ask for approval if it's outside the current working directory. And if it's not mutating like read file or anything else, it will not ask. It will just start reading the files. Then we have on failure. So whenever there's a failure, what to do, self-explanatory. Then we have auto, which means it will auto approve all the safe commands, but it will auto reject all the dangerous commands. Then we have auto edit, which just means that it will auto approve edit related stuff, but it will knock out everything else. After that, we have never. So that means it never asks for any approval. And the final thing is YOLO, which is an acronym for you only live once. It just auto approves everything. Even if it's a dangerous command, whatever, it will just approve every single thing. And people do like to use this command for some reason. I would definitely not recommend it, but yeah. Then we have approval on request by default. Now the next thing I'll do is create a new folder here. Let's call it safety. So it will contain all the safety related things. We're only going to have one safety mechanism in our thing, which is approval.py. But later on, maybe you want to add sandboxing feature or something else related to safety. You can expand this folder. Just like everything we've done before, we are going to create a class of approval manager. We're going to get an init function. And within this init function, the first thing we are going to get is the approval policy. what is the approval policy we signed up for, or what did the user set up. And if the user did not set up, by default, it is on request. Then we have the current working directory as well. And the next thing we are going to get is confirmation callback. So this is a function that we are going to actually get from the main.py. So within main.py here, we're going to create a function called confirmation callback or confirmation, where, it's the UI. So whatever UI you have, you can just pass it to this approval system. Another way of doing this is you can just yield the agent event and then listen for the agent event in this process message and then call the specific UI. But I'm just passing in the entire callback so that whenever we want, we can display the UI. So confirmation callback does just that. This is going to be a callable, so it's not going to be a function that's already called, right? It's going to be a function itself. So we are going to have a callable where we have tool confirmation. Let me import that from tools.py or toolsbase.py. And then we have awaitable boolean. Let me also import awaitable. And if this function is not specified, then we have null, and by default null is specified. So just in case the confirmation callback is not passed in. Now let's instantiate everything. And if you're still confused about this confirmation callback, don't worry. I'll explain it to you when we start to use it. But I'll just initialize it as and when we go. Then self.approval policy is approval policy. Then we have self.currentWorkingDirectory is equal to current working directory. And self.confirmation callback is equal to confirmation callback. After that, obviously from this init function, we're going to return null. The first function that we want to have here is check approval. So based on this approval context that we get, we have to give an approval decision. And the approval decision is the approval approved? Is it rejected? Or does it need confirmation from the user? If it needs confirmation from the user, we are going to ask the user that, hey, please specify yes or no based on the dialog box that we show on the UI part. So obviously we need some context to make an informed decision of whether the approval was given or not. So we have to create two classes, one for the context, whatever we are going to get from the parameters, and the second one is the decision of the approval. So are we approving? Are we rejecting? What are we doing? So let's quickly create both of them. The first one is an enum of approval decision. So let's create that. It's going to be a string enum, and we'll import from enum. Then we have approved, which is just approved like that. Then there's rejected, which is just like that. And then we have needs confirmation, which is just like that. Awesome. After that, we are going to create a new class called approval context, which is just the context required for us to make an approval decision. So we have @data class. We're going to import from data class's data class, and then we have approval context correctly passed in. What context do we need to make a decision? Well, the tool name would be nice, something we would like. Then there's parameters, which is going to be a dictionary of string, any. We know what the parameters mean. We have talked about that in tool confirmation as well. By the way, all of these values most likely are going to come in from the tool invocation. So if you remember in write file.py, if we go, we had invocation, right? That gave us the parameters. So context is just going to have those filled in from there. After that, we have is mutating. It's going to be a Boolean value. Then we have the affected paths so that we know what paths are affected. This is very important because for write file or edit file especially, if we know which paths are affected, we can just compare it with the current working directory. If the path is within our current working directory, in that case, we auto approve. Otherwise, we can't auto approve. Obviously, that also depends on what type of approval policy they have. But let's just say if the approval policy is on request, which is the default one, all we need to do is check the current working directory and see if the path is within that. Cool. Then we have a list of paths that are going to be passed in here. Then we have a command string, null, and by default it is null. The command will be useful when we have shell related operations or shell related approval because some commands can be dangerous and some commands can be safe. So we're going to parse that as well. Then we have is dangerous, just in case we've pre-tagged it of what the approval is. So we have that as false by default. Now we can take this approval context through the parameters. So we have context, approval context, and here we are going to return approval decision. And now we can go ahead and create this function. So how do we check for the approval? Well, first of all, if anything is not mutating, that means it's auto approved, no matter what approval policy we have. If it's not mutating, it will not cause any harm. Let's just approve it. So we'll have if not context dot is mutating. By the way, this is not always the case that if it's not mutating, it's going to be fine, because your LLM can obviously read the .env files. So yeah, you can handle that case as well, and any other case you can think of, but I'm going easy over here. We have return approval decision dot approved. After that, we have to check for the command safety, and after that we'll check for the path safety. That's it. That's how the approval system works. So first one is checking the command safety. So if the context dot command is specified, then I want to check if this command is safe or not. And for that, maybe I can just go ahead and create a helper function here. Let's call this assess path safety. It will pass in the path, which is going to be the path. And then we'll have the, oh, by the way, this is not path safety. Sorry, it's command safety. I was just thinking about path for some reason. And then we have command as the first, or actually the first one should be self. Then we have command, and then we have policy. And we don't need to take the policy, we already have it in the constructor. So to assess the command safety, what do we do? Also, it's going to return an approval decision from here. So yeah, how do we determine command safety? Well, first we have to create a list of commands that are either dangerous or they are safe, right? That's how we know if the command is safe or it's dangerous. So I'll just copy paste. You can also copy paste from the GitHub repository, but this is my entire list. These are all of the dangerous patterns related to file system destruction, disk operations, system control, and all of that. Then we have safe patterns that can be auto approved. Now a question that you might have is, why do we need both dangerous and safe patterns? Well, we need both of them because we have multiple approval policies. One approval policy might just check if it's dangerous, and the other approval policy might just check if it's safe. And based on that, we have to give an approval decision. So that's why we have both. Now, once we write the code for command safety, you'll be able to understand better. But first, I would also like to create some helper functions here. The first one is dangerous command function. It takes in a command string and it returns a Boolean value. What it checks is if a command matches any dangerous patterns that are specified here. All of these patterns are in the regex format. If you look at it closely, this is remove, which is a command. Then you have a regex pattern of \s plus. That means you can have multiple spaces. After that, you can have -rf, which is optional, or you can also have --recursive, meaning it will just remove all of the folders present recursively. And you can go ahead and try to understand each regex pattern here. But yeah, so what we need to do here is go over every pattern in this dangerous patterns, and if the regex.search, and we've already looked into the search from regex in some previous code. So we'll just pass in pattern, the command, because we have to search in this pattern if this command matches, and we'll ignore the case. If this is true, then we'll return true because it is a dangerous command. Otherwise, after the for loop, we'll return false, that none of the patterns matched. Now, similar to this, we will also have a function of is safe command. We'll get a command string. We'll search in every safe pattern, and we'll just return true if this is the case. Otherwise, we'll return false. Now I can just use both of these functions over here. So if the context.command is there, we have to call in self.assess command safety. And within this assess command safety, I'll check first for dangerous commands. So if it is a dangerous command, in that case, I need to pass in the command and I'll just return approval decision dot rejected, right? Because if it's a dangerous command, I want to auto reject. But there's one approval policy that will have to approve no matter what, which is the YOLO. So even if it's a dangerous command, we'll just check if the policy, or let's say self.approval policy, is equal to approval policy dot YOLO. In that case also we'll have return approval policy dot approved, or approval decision dot approved, right? After that we'll check for other things. So again, we just want to approve everything that is YOLO, right? So I can just extract it at the top here. So if the approval policy is YOLO, we'll just approve no matter what. After that, we can check if it's a dangerous command and not YOLO, because if it's YOLO, it's already been approved. Then we reject it. And now I've checked for the dangerous commands as well. I'll just check if the policy is equal to approval policy dot never, and never mode just rejects all of the mutations that might happen. So we'll just check here if it's a safe command, because if it is a safe command, then we want to approve it. If it's not a safe command, then all I need to do is return approval decision dot rejected. As mentioned, never will just reject all of the mutations that might happen, and if safe command will just check for that. Because if you notice, all of the safe patterns here are list, directory, echo, cat, and then the development tools, all the read-only stuff. So it's pretty safe. Now let's say if the approval is auto or failure. In that case, we just want to approve. So we'll check if self.approval policy is in either approval policy dot auto or approval policy dot on failure. In that case, we'll just return approval policy dot or approval decision dot approved. Now the reason I can do this very safely is because it is not a dangerous command, because we've already checked for dangerous command. So whatever we get here is not a dangerous command, so we just auto approve it. But for never, we have to deny all of the things that are mutations. That's why we have to check if it's a safe command. After that, we have the auto edit. So if self.approval policy is equal to approval policy dot auto edit, in that case, we have to check if it's a safe command, because auto edit will approve the edits, but not any shell command, for example. So we'll just have if it is a safe command, then we have command passed in, then we'll return approval decision dot approved. Otherwise, we will return approval decision dot needs confirmation. This time, it's not going to reject it upfront. It just asks for the confirmation. And this is going to be a big deal for us, because whenever we have needs confirmation, we will bring up our dialog box to display. After that, finally, we have the last case, which is safe command. If it is a safe command, then we will have return approval decision dot approved, because at this point, it's going to be on request. We have handled auto edit, we have handled needs confirmation, we have handled auto edit, we have handled on failure, we have handled auto, and all the other things like never and YOLO. One thing we have not handled is the on request. And if it's on request, then I'll just check if it's a safe command. And if it's not a safe command, then I'm just going to do return approval decision dot needs confirmation. I won't outright reject it, because on request means we have to ask for the user confirmation if it's not a dangerous command. And if it's a safe command, all good to go. So yeah, that's about it. This was the assess command safety. Now I can just have the decision here, and I need to pass in the command as well to this assess command safety. So I'll have context dot command passed in, and we'll say if the decision here that we got is not equal to approval decision dot needs confirmation, in that case we'll return the decision, because if it needs confirmation, then we're going to create another function called request confirmation and ask for the user's confirmation. Anyways, if the command is done, that's good. Now we need to check for the path safety. So we'll go over every path in the context dot affected paths, and then we have to assess the path safety. Path safety, as I mentioned, is very easy. If path is relative to the current working directory that we get from the constructor, that means the path is present within the current working directory. In that case, the approval is approved because we don't need any confirmation then. Anything happening outside of our current working directory needs approval. So let's create a variable here. Let's say path decision, which is equal to, and we can instantiate this to be approval decision dot needs confirmation. And if the path is relative to the current working directory, then we are going to have approval decision dot approved, right? So we can just set path decision equal to approval decision dot approved. And if it's not relative to that, then it needs confirmation, which we've already defined by default. And if it does need confirmation, then we're just going to return the path decision. Now, after all of these paths are also done, I want to check if there's explicit dangerous flag. By the way, this approved here does not return because think about it. When we are going over all of the paths and we just approve one path that's correct, that's going to be a problem because the second path in this affected paths might be something that should not be approved. It should need confirmation because let's say the one path was changing approval.py, which is in AI agent directory, but the next one is writing to the desktop folder, which is not in AI agent. That means we've returned approved, but it should not be approved. That's the key issue here. Finally, let's say at this point everything feels safe. We'll just have if context dot is dangerous. That means there's an explicit dangerous flag setup. In that case, I want to return approval decision dot needs confirmation, right? Because it does seem potentially dangerous to us. But we don't want to do it if the approval policy is YOLO. That means we always approve. So we have if self.approval policy is equal to approval policy dot YOLO. In that case, we'll just return approval decision dot approved. And let's say after all of this also, we did not get anything wrong. That means we just have to return approved. Because let's say a path was being modified here, everything is in current working directory. So as of now, we have approved, then nothing is dangerous. That means we still have approved. And finally, we'll just approve it, correct? So that is for checking the approval. Now the next thing I want to work on is requesting the confirmation. It's not a difficult thing to do. All we need to do is create an asynchronous function called request confirmation. We get a self, we get a confirmation, which is of the type of tool confirmation, and it's going to return a Boolean value of whether the confirmation is requested or not. And we'll just check if the confirmation callback is present. Let me just get that confirmation callback. And if it is, then I want to call that. And it's going to be an awaitable, the response of that. That's why I'm going to do self.confirmation callback. And then I'll pass in the tool confirmation. Whatever is the result, it's going to be a Boolean value because that's how we defined it in the constructor as well. And then we just return the result. But if the confirmation callback is not there, that means we don't have any callback. We can auto approve and we'll just return true. So that's it. Nothing too complex here. The only reason this function was created is because this entire approval manager scenario is going to happen in the base.py file, and there we don't have access to the confirmation callback. We can pass it in, but it will get a bit messy. I don't want to do that. So instead, I'll just attach it to the approval manager and create a wrapper around it. This is also not a good solution. You might want to re-architect the system, but it gets the job done. Now we'll just go to the base.py file, and actually, sorry, instead of saying base.py, I wanted to say registry, which is the tool registry, because whenever we try to invoke the function, this invoke function is called within the agent.py, if you remember, and it just calls the tool. So before we call any tool, that's the time I want to check for the approval system, right? So think about it. the first thing that happens is the LLM gives us a tool call. We display to the user that, yeah, this is the tool call that we are going to do. The tool call has started. So let's say we are going to write a file, and what is the content of what we are going to write? XYZ. So that shows up, right? So that is the tool call start. After that, we generally display the output. But before displaying the output, and the output is fetched from here, by the way, which is tool.execute. Instead of doing that, I can just have the approval layer here. So if the approval goes through, I'll have the request confirmation dialog box showing up, and we can ask the user, do you approve this or do you not approve this? Yes or no. If the user says yes, then we can display the next dialog box, which shows all of the details that were done, right? So we're going to get the approval manager from this invoke function. So I'll have approval manager, and this approval manager can be null as well. And by default, it is going to be null. So let me import it. And if this approval manager is with us, we are going to do some stuff. And it's not going to be self, it's just if approval manager is there, I'll just call the tool dot get confirmation, because if you remember, if nothing is mutating, we return null. So that's a potential null value, but if there is certain thing to be passed in, it will be passed in through this tool confirmation. Now, within write file, edit file, and shell.py, we'll have to update this get confirmation, because the point of this tool confirmation is passing in the context about the tool. What is it doing? So that we have the context to make a decision. And I told you, based on this tool confirmation that we are going to get, we are going to extract certain information and pass it to our approval system. So I'm going to take a detour here. What I'm going to do is go to our writefile.py writefile tool class and create a function of getting the confirmation. So we have get confirmation, we get an invocation, which is tool invocation, and it's going to return either a tool confirmation, and we'll import that from tools.base, or a null value. Now obviously we will need the parameters to make an informed decision. So we'll have parameters, write file parameters, and we'll then deconstruct it into invocation.parameters, just like what we've done multiple times before. The next thing is resolving the path, similar to what we did in execute. So I'll just copy paste it. Now I have the path we are going to write to. I will be returning the tool confirmation from here. I won't be calling the parent class because I know exactly what to return from here. The first thing is the tool name, which is self.name. Then we have the parameters, which is equal to invocation.parameters. Then we have the description. And for the description, we have to pass in, maybe we can pass in the action that's taking place if we're creating a new file or if we are updating a new file, and all of that logic is created down here. If it's a new file, we have this action, and if it's a new file, if the part does not exist. So I'm just going to copy the logic pieces from here. So if it's a new file, if the path does not exist, and then for the action, we can copy this line. So I'll just paste that in. Great. So I can pass in this action as the description. So let's say it says created file, and then it passes in the path, whatever path we created the file in. Obviously, we need more information here. For example, the diff view, because we also want to display to the user what is the thing that we are doing within this write file. Because it would be so weird to just tell the user that, yeah, we are writing in 10 lines. That's not enough information for the user to make a decision of approval, if they want to approve this write file or they don't want to approve it. That makes sense. Within this tool confirmation, we are going to update it and add more UI elements. For example, we are going to have the diff. We also displayed that in the tool result, I believe. So we add the diff here. Similarly, we are going to have it in this tool confirmation as well. Then we have the command, just in case we want to display that. Then we have the affected paths is dangerous, all of that. So whatever we created in the approval.py for approval context, I told you all of that is going to come from the base.py essentially, or let's say each tool. So we have command and then is dangerous, and also the affected paths. So let's just copy that. And maybe we can give it a default value here that the default factory is going to be an empty list. Now we can pass in the tool confirmation correctly within the right file and within the base.py as well. Let me update it. Now we don't need to update this in the get confirmation method of base.py. The reason for that is these are all display elements. We don't want to do anything by default. We'll override them in the right file. So here we can pass in the diff, for example, and now we need to create the file diff. And to create a file diff, it really depends on whether it's a new file or not, so that we can get the old content and create the file diff. So what I'm going to do is just copy this entire line. We're just copy pasting all of the logic from here. And if it's not a new file, we get the old content. And let's initialize the old content to be an empty variable at the top here. After that, we'll have diff is equal to file diff, and then we can pass in the path. We can pass in the old content, which is just old content. Then we can pass in the new content, which is parameters.content. And then if it's a new file or not, based on the variable is new file. And then I can pass in the diff here. Great. After that, we need the affected paths. The affected paths is just the path that we are writing to. After that, we have is dangerous, and it's not dangerous if it is a new file, because overwriting is more dangerous. The user might lose their previous content. So yeah, it is dangerous. So that's it about write file tool. I'll just copy this entire function and paste it in the edit file tool as well, because a similar thing needs to be done there. So I'll just paste it here. We do get the tool confirmation and tool invocation. And obviously we also need the edit parameters. So let me copy that and get it here. After that, we resolve the path. We again check if it is a new file. It's a new file if the path does not exist. Then we'll just check if it is a new file. In that case, we want to create a diff, which is going to be a file diff, where the path is just the path. Then the old content is equal to empty string because that file did not exist previously. Then the new content is equal to parameters.new string. And then the new file is going to be true because yeah, it is a new file. And from here only, we can just return the tool confirmation because we have enough information. So I'll pass in the tool name and everything. So let me just copy it and paste it in over here. So tool name is self.name, parameters is invocation.parameters. Then we have create new file, and then I pass in the path. Diff is this. Affected paths is just the path we are editing, and is dangerous does not need to be passed in because it's dangerous if it's not a new file. It is a new file, so it's not dangerous. Great. Now, if it is not a new file, in that case, I would like to read the old content, and I'll just copy paste what we did previously to read the old content like that. So I'll just replace all of this with old content is equal to path.read text. And then we can check that if the parameter is replace all, in that case, the new content is equal to old content.replace, and then we'll pass in the parameters.old string. And then I'll pass in parameters.new string as well. Now, if you're confused about that, you would like to revisit the edit section because we're just doing this part over here, just replacing everything. So in the else block, we can pass in new content is equal to old content.replace, and then I'll pass in parameters.old string, parameters.new string, and then 1 because we only want to replace once. So that is our new content. Now I'll create the diff where I'll pass in the new content as the new content variable. Path remains the same. Old content variable is already created and it's not a new file because I just checked above. It's not a new file. Then we don't really need this action variable. I know it's going to be editing the file. So I'll just say edit file. And this is the path. The diff is also created. The affected paths is this. Is dangerous. Well, we are editing the file, not really overwriting the file. So maybe we can set is dangerous to false here. And that is enough for edit tool. Now the final tool we have to worry about is shell. because shell can mutate some things as well. And actually shell is going to be very easy. I'll just copy paste it. It's going to be much smaller than write file and edit file. The first thing is importing tool confirmation. Then we are going to have the shell parameters. Then we'll resolve, well, we don't need to resolve path here because it's not a file related operation. There's no new file either. So we can actually just remove everything other than return tool confirmation. And the first thing I'll check here is if it's blocked. So that means that the command that the shell gave out is blocked or not. So if the self dot is blocked command and I don't see it, maybe I created it. Oh, I did not create a helper function for this. This is basically what is blocked command does. So I'll just copy it and paste it over here. You might want to create a utility function, but for every command in blocked, if blocked is in the parameters.command, in that case, we'll return the tool confirmation. And this tool confirmation is going to have is dangerous as true because it's a dangerous command. Affected paths is not present with us, so we can remove it. The diff is not present with us, we can remove it. The description is going to be execute, and then I'll pass in, let's say something like blocked, and then we can just say parameters dot command. So execute this blocked command. Then the parameters is the same, tool name is the same. The command is not blocked, it's unblocked. So we can just pass in these two things. The description can be just execute, no need to pass in blocked. And then we can just pass in execute this command, which is parameters.command. So we'll pass in the command here, which is parameters.command. Even at the top, we can pass in the command, which is equal to parameters.command. Affected paths is not there, and is dangerous is just false because it's not blocked anymore, right? How can it be dangerous? So that's it. That's about the shell tool. If it encounters any of those commands, it will just return an error. It also passes in the command so that our approval system can take a further look at it, and we'll have a more complicated list of commands that will be run through that. So we can close, well, all the save files, and now we come back to the registry where we pass in tool.getConfirmation. That getConfirmation is a coroutine, so I can await it. And I'll get access to the confirmation variable. Now that confirmation variable can be null. Remember that. This getConfirmation can return tool confirmation or a null value. If it returns a null value, I don't want to return anything from here. I don't want to do anything else for that because it's approved. Whenever we get a confirmation null, we don't have to ask for the user confirmation. That's the point. So I'll just say if confirmation is there, that means we want to ask for confirmation. In that case, I'll create the context of approval context so that I can call the approval manager. And now I'll import from safety.approval. I'll pass in the tool name here, which is just the name. Then I have parameters, which is equal to the parameters. Is mutating is equal to tool.isMutating, and I'll have to pass in the parameters again here. Then I have the affected paths, and we get that from this confirmation. So confirmation.affected paths. Then we have the command. We also get that from confirmation. After that, we have is dangerous, which is confirmation.isDangerous. So that is all of the context. I can just call approval manager and check for the approval. That means we'll request for an approval decision, and I'll pass in the correct context here. I'll have to await it to get my decision. And if the decision is, let's say, rejected. So if decision is equal to approval decision, and I'll have to import approval decision as well. If that's rejected, in that case, I just have to return tool result dot error result, and I'll say, hey, the operation was rejected by safety policy. Maybe you can also give more information about why it was rejected if you want. But yeah, let's say otherwise the decision is equal to approval decision dot needs confirmation. If it needs confirmation, we'll have to request for the confirmation dialog box, right? So that we wait for the user's approval. So we'll have approved is equal to await approval manager dot request confirmation, and we'll pass in the tool confirmation here, which we have already. So this confirmation, we just have to pass that in. And let's say the user does not approve it. In that case, we'll have to again return the error message. So I'll just copy it and paste it here. Tool result.error result, and we'll say user rejected the operation. So we'll go user rejected the operation. Yeah, that is it about our entire approval system here. And let's say the decision is approved. In that case, we just come over here and to execute the tool, whatever is the result, we return it. But in case we need confirmation, we request the confirmation, and if the user does not approve it, we just spit out the error message saying, yeah, the user just rejected it. What can I do? Now all I need to do is wherever this invoke function is called, I need to pass in the approval manager. And I can create the approval manager at the top, but instead of doing that, I'll do it in the session. The reason for it is everything else is in session as well. So yeah, we'll have self.approval manager, and we'll just create an instance of approval manager here. Let me import it from safety.approval, and I'll have to pass in the approval policy. We get that from configuration, right? So I'll pass in self.config.approval. So that is our approval policy. After that, we'll require the current working directory, which is self.config.current working directory. And finally, we need the confirmation callback. As I mentioned before, the confirmation callback is going to come from the main.py, where we are going to create a function, and that's going to be our next step. But as of now, it's going to be empty. What I'm going to do is take it from the agent here. So we are going to have a confirmation callback here, and that is going to be of the type of callable, tool confirmation, everything we've looked in the past. So let me import it from typing, tool confirmation, and then awaitable. By default, the value is going to be null. And then we can just pass in self.confirmation callback is equal to confirmation callback. And then I can just set self.session.approval manager is equal to this self.confirmation callback. Alternatively, what you can do is just pass it to the session, but I don't want to type out this big thing in session as well. But yeah, as I mentioned, there's a lot of nested dependencies. You might want to get rid of that, but for our code, which is a big spaghetti, this is fine. And actually, we don't need this line confirmation callback. Let's remove it, and we can just set approval manager to confirmation callback. And now whenever we call the invoke function over here, we can pass in the fourth argument, which is the approval manager, which is just self.session.approval manager. Awesome. Now the next thing we have to do is whenever the agent is called, we have to pass in the confirmation callback. So in the main.py, we're going to create our confirmation callback. And that confirmation callback is just going to be a UI tool. That's why we require it from the main.py. It's going to show the dialog box to the user. So let's design that. You can also create it in the TUI, by the way. And I'm going to do just that. I'll go to the TUI here. I'll create a new function, and let's call this function handle confirmation or confirmation callback. Well, confirmation callback was called because that confirmation function was passed as a callback. So that's why I'm calling it handle confirmation here. And then we're going to require a confirmation, which is going to be the tool confirmation. So let's import it from tools.base, and here let's get started. So we are going to have an output list here. The first two objects are going to be the text, where we just pass in the tool name. So we'll have confirmation dot tool name passed in. The style is going to be tool. If you want to look at the style, we can just go here, and the style of tool is just bright magenta bold. Nothing too fancy. After that, we have the confirmation description, which I'll pass in. So confirmation dot description, and the style of this can be in the code format. After that, I'll just check if the confirmation has command attached. If it has, then I would like to display that. So I'll have output.append, and then I'll have a text where I pass in the $sign. If you remember, that's what we did when we had to display the shell output as well. And now I can have confirmation dot command, and then I can pass in the style, which is warning. After that, we have the diff. So if confirmation.diff is present, in that case, I would like to get the diff text, which is confirmation.diff. And just doing the diff will give me the file diff. What I want is the actual diff. So to do that, I can just convert it to a diff. This was a utility function we had created before, and that gives us the diff text. I would just like to print it out. So there we go, output.append, pass in the syntax. And this is something we've looked into so many times, so I'll speed through this. The theme is going to be monokai, and then the word wrap is going to be true. After that, we're going to check, or not check, we'll just leave a line. So console.print or self.console.print, and then we can do self.console.print and print out the entire panel here, where I'll pass in the group of the outputs. Then I have the title, which is a text where we just say approval required, and the style is going to be the warning. The title align is going to be left. Border style is going to be warning, because it's a warning, right? We are asking for the user's confirmation, so you would like to have that style. Then the box is box.rounded, and the padding is 1,2. Just like we had for other panels that we created. Now I would just like to call this function within main.py, where we'll also create this function. Now what I like to do is call this function when the agent is being created. So when we try to run in the interactive mode, we can pass in the confirmation callback, which is self.tui.handle confirmation. That's it. And when we run in the single mode, we don't have to pass in the handle confirmation, because we are assuming that we are in a non-interactive mode. The user just gave us one prompt. They don't want to hear anything about that. They just want it to run. So it's in a non-interactive mode. So we'll not pass in any confirmation handler. So it will not ask for any confirmation. It will directly start running the tools. However, if you want to be more explicit, you can ask for the argument here, or for the option where the user can specify if it's an interactive or a non-interactive mode. And if it's a non-interactive mode, then you pass it. Then you do not pass in the handle confirmation. Otherwise, you pass it in. So yeah, this seems like it. Now I would like to test it out. So let's run python main.py. And the first thing I'll ask it to do is write to desktop hello world.py file, because we are outside the current working directory. If that works, great. Let's hit enter, and we run into an error. The error is that the tool.getConfirmation requires one missing positional argument. So I'll go to the registry and see what getConfirmation requires. It requires invocation, and I did not pass that in. Cool. Now let's try again. So I'll run it again, and I'll copy paste the same prompt. Let's try again. And now we have another error. Function object has no attribute check approval. So this approval manager thing does not have check approval. And the reason it happens is because if you go to session.py, or actually agent.py, here we have confirmation callback, and we're setting it to approval manager. That's not correct. We want approval manager dot confirmation callback to be this confirmation callback, not the approval manager to be confirmation callback. So I messed that up, my bad. Yep, that looks good. Now let's try again. Let's paste this again. And now we have another error. Object none type can't be used in await expression. And actually, before we resolve this error, there's one thing I forgot about, and that is in the TUI, we handle the confirmation. We have the panel here, and it just says approval required, but we have not given the user the option to approve or to disprove, right? So we'll have to prompt the user to give us a yes or a no response. So we'll have something like prompt, which comes from the rich package. So I'll have something like from rich.prompt import prompt, and this just allows us to ask the user a question, and this is what I want to ask. And the question is, on a new line, do you approve this request? If you approve, the choices are, well, a yes or a no, or let's say the user is more explicit with yes or no. And the default value is no, because we think it's going to be bad. And the response is this. Whatever the user says, we'll store it in response, and we'll just return a boolean value from here. So response.lower in, let's say, yes or yes. So this function will return true if the user says yes, otherwise false. And the return value of this function is going to be a boolean. And everywhere we said that this handle confirmation is going to have an awaitable value. Maybe it's time to change that. We'll go over here and we'll say that the return is not an awaitable boolean value. It's just a boolean value. And wherever this confirmation callback is called within this approval manager, this is also going to have the awaitable removed. Great. Now let's close all of the save files. Let's retry. So I'll paste in the same prompt. And by the way, we do get the approval required text box above. It's just that we don't see any output correctly. So it was probably because of our issue that we just solved right now. Let's try to pass in the same prompt here. Let's hit enter. And we do get approval required write file, but the text here is empty. Now the reason approval required shows up an empty text is something we'll have to investigate further. But what I'll do is set approve to null. No, we're not approving this. And then we see an error again saying object boolean can't be used in await expression. And that's because we don't have this as an asynchronous function anymore. So we'll just remove the await from here. And as a result, this is not an asynchronous function either. And wherever this request function is called, that's not an await either. So everything is now synchronous. That's good for us. And maybe we can try to write again. This time I can give a different prompt. Maybe I can say create a dummy Python script. Let's hit enter and see what it does. Oh, I forgot to talk about desktop, but it did create this dummy script.py for us, and we can see it over here. It's in our current working directory, so that's a good test as well because it did create it over here. Now let's try to do something in the desktop folder. I'll just copy this prompt, clear off everything and retry. And this time it will be create dummy Python script in desktop. Let's hit enter. And then we get asked for our approval, and this time we see the entire diff properly. The reason for that is probably because previously it tried to write in the same thing again, and that's why we did not see any difference as such. But this time, since we're creating a new file, we can see the difference. So this time let me say no, and it says user rejected the operation, and then the assistant says the operation was rejected. Let me know if you'd like to try again or need assistance. I'll just say try again, and I should be getting the same thing again. Great. And this time I'll approve. And I do see that this approval required changes into write file properly. And we see the dummy Python script has been created successfully. And it is just typing out really slowly, probably because of the TPS issue. By TPS, I mean tokens per second, by the way. So that's it for our approval system. You can also try it for shell and edit file. I think they should work, and if they don't, it will be very silly errors like I've not passed in the correct parameters or something, so you can test that for yourself. But I'll just exit out from here and focus on the next feature. And what we are going to work on is hooks. What are hooks? Hooks are like user-defined scripts that run at specific points in the agent's lifecycle. You can think of them as callbacks, but external. So if the user wants, they can pass in any executable code before, let's say, the agent runs, or before the tool is run, or after the tool is run, or after the agent just completes, or whenever there's any error. Why is this useful? Let's say the user wants to auto run tests after there are code changes. So let's say our agent edits the code and they want the test to run automatically so that they immediately know if something broke. In that case, they can use the hooks. Or let's say they want to auto commit after each task that the LLM does or the agent does. So you can just set up a git checkpoint, and this makes it easy to revert if something goes wrong. Or let's say you want a Slack notification whenever the agent starts a long running task, and that's where this hook can also help you. That's how we're going to introduce hooks, just pieces of code that the user can run before the agent starts, after the agent starts, before the tool call is happening, and after the tool call is happened. So let's go to our config.tuml or config.py so that the user can set up the hook related configuration. All I'm going to do is say two things. The first one, hooks should be enabled or not, and the boolean of that is by default going to be true, or maybe we can set it to false. And then we are going to have hooks, which is a list of hook config, and then we are going to have a field where the default factory is going to be set up, and then we'll pass in the hook config. Now let's create the class of hook config, which is going to extend the base model, and then we are going to pass in, well, the name of the hook. So, we are going to have four types of, or let's just say we're going to have multiple hooks, right? What is the hook's name? Then there's going to be a trigger of when did this hook get triggered. So you have a hook trigger enum here, and I'm going to set that up as well. So we have class hook trigger, and then we'll have a string enum, just like we've seen multiple times before. And this is when a hook should be triggered. So you have before agent, which is going to be, well, before agent. Then similar to that, you have after agent. So there we go. After that, we are going to have the after tool or before tool. And I'll just write that down. After that, we have after tool. So it's just what should happen after and before the tool call is done. And if there's an error, what should happen? So that's also present here. Great. So I have the hook trigger passed in. The next thing we're going to have here is the command that the user wants to run. And by default, it is going to be null. And if there's any script that the user wants to run, that can be null as well, or a string value. Now, what is the difference between a command and a script? A command is something like, let's say, Python 3 main.py. Maybe I want to execute this, or let's just say there's tests.py that we want to run. That is a command. But a script is something like a shell script. Maybe you want to echo out something. So you pass that in. Whatever, you can basically pass in .sh file, which is a shell script. So we're going to run that script. After that, we have timeout in seconds. You know what that means. And the default value is 30 seconds. And then you have enabled. And by default, this hook is going to be enabled, but you can enable or disable each hook as we wanted. And then I just want to validate that either this command or the script is mentioned, because yeah, that's how things go. Then you have model validator. Then we're going to pass in the mode, which is equal to after. And then I'll pass in def validate hook. From here, we are going to return the hook config, and we're not going to make the same mistake we did earlier. So I'll just return self before I forget it. Now I'll validate the hook. So if the self.command is not present, and let's say the self.script is also not present, in that case I'll raise a value error and pass in hook must either have, let's say, a command or a script. And yeah, we've returned self. That's great. So this is our hook config, and the user can pass in a bunch of hooks. Now we just have to create a new folder called hooks and integrate it with our AI agent. So we are going to have a hook system, which will just go ahead and list out all of the hooks and create the specific triggers. For example, before agent, after agent, before tool, all of those functions also needs to be created so that we can call it in the main agentic loop. So we have class hook system, and I'll pass in the init function. We are going to get a config. So that's going to be of the type of config. Let's import it. And then we have self.config equal to config. After that, we are also going to have a bunch of hooks. So I'll just check the config if the hooks are enabled or not. If the hooks are not enabled, then we don't want any hooks to be present. So it's going to be an empty list. So let me just go ahead and initialize hooks to be an empty list, and this is going to be a list of hook configs. All right. This will just make it easier for us to run each hook as and when we need it. After that, let me fill in this hooks list. So first of all, I'll just check if the self.config.hooks is enabled or not. So if the hooks is not enabled, in that case, I don't want to proceed any further. I'll just return. But if the hooks are enabled, then I want to do something. So let me just remove this not and pass in the if condition here. So I'll have self.hooks reinitialized to be hook for hook in self.config.hooks if that hook is enabled as well, right? Because each hook can be enabled or disabled. So we only want to pass into this list the hook if the hook is enabled. And that's pretty much it. That is all of our hooks. Now what I want to do is create a function specifically to trigger the before agent part. So I'll create a function that runs a script or the command that the user has specified, and it should be triggered before the agent is started. So I'll have def trigger before agent. I'll pass in the self. I'll pass in the user message that we get. You'll get to know in just a minute. It's going to return nothing. After that, I'll go over every hook in this self.hooks list, and I'll just check if that hook's trigger is equal to the hook trigger, and let's import it from config.config, and if it's before agent, because we only want to trigger hooks over here that are before the agent. Think about it. This function will be called in the agentic loop here, just before the agent starts. So maybe somewhere over here. Now before the agent starts, we want to run a bunch of code pieces that the user has specified through the configuration.toml file. So I can just create a function that will run all of those code pieces, right? So I'll just have here a function that will allow me to run the hook, and it's going to be a helper function. I'll pass in the hook, and I'm creating a helper function here because we're going to have multiple functions like trigger before agent. We'll also have trigger after agent. We'll also have trigger before tool and after tool. So we'll be using the same helper function every single time. The only thing that will change is this particular line where the hook trigger changes. So here, let's create this function def run hook. We get a self, we get a hook, which is the hook config, and we return nothing from here. The first thing I'll check here is if the hook command is present. If the hook.command is present, then I want to run the command. And how do we run the command? We've already taken a look at that in shell.py. If we have any command to run, we just use the shell and we call this particular line async io.create subprocess exec, right? So let me just copy this entire line from here. We don't really need all of these lines of standard output and standard error because we don't have to do anything related to the output. The reason we don't have to do anything about the output is because the user already has a code they want to run. Why are we going to do anything about the output that their code runs? It's already stored if they want to store it, or it's discarded if they don't want to store it. So let me just paste in the entire thing here, and I also have to indent this nicely. So I'll just indent everything. And now we have an asynchronous function to convert it to, and I'll also call await self.runHook here before I forget it. This makes the trigger before agent also asynchronous. So we'll have that. And now let's understand what we need to change. First, we'll have to import async IO. That's good. Then we are going to pass in the command that we want to run. So I'll pass in the hook.command here. Then the standard output remains same. Standard error is the same. The current working directory needs to be passed in, which is just self.config.current working directory. Now the environment is going to be whatever is the os.environment.copy, right? So we'll just have import os.environment.copy or get whatever you want. That gives us the dictionary that I'll pass in over here. And I will start a new session every single time. Then we wait for a particular amount of time, and the time I'm going to wait is hook.timeout in seconds. and that gives me standard error, standard data. I'm not interested in that. I'll just await. Great. After that, if the platform is not Windows 32, in that case, I'll pass in this thing. We've already looked into that. I won't explain this any further. After that, I can remove this tool result.error result, but maybe you can raise an exception if you want, but I'll just remove it. I don't want to do anything if there's an exception. So that is it about the command. Now, if there's a script that's present, and it has to be present because we have already added the validation. So if the script is present, then what do I want to do? Well, this is essentially a .sh script, right? So what I can do is create a temporary file that has a or a suffix of .sh, and then I can just execute that sh file, right? So to do that, what I can do is with temp file, let's import temp file. So it just helps us create a temporary named file, and then I can pass in the mode that we want to do it in. I want the mode to be write because I'm trying to write to a file. After that, I can pass in the suffix of the file, which is .sh, because I want the file to end with .sh. That will allow me to execute a shell script. After that, I'll have delete equals to false, and let's say I use this as a file. Then what I want to do is write the script, correct? Whatever is the script that we get from hook. So hook.script. But just doing that is not enough, because let's say the hook.script is echo and it tries to echo something. That's not enough. The reason for it is we have not added the bang operator. Whenever you have a shell script, you need to add this bang or shebang, I don't know what it's called, but you need to add something like this, where you have a hash, ! /bin/bash. So you're running it on bash, and then you pass in the script, and then you mention the script path, which is just equal to, let's say, the file's name. And now, since we've created a file that looks something like this, I'll just show it to you. Let's say it's called temporary.sh, right? So as you can see, there's a terminal icon beside it, and I can pass in anything I want. For example, the echo command that I was talking about. Let's say I echo hello world. Now, if I want to run this particular script, what will I do? Well, I can just do not Python ./temp.sh, right? But as you can see, permission denied, because I need special permission to execute it. Similarly, over here, I have stored the script path, but first I'll have to give the valid permissions so that I can run this particular file. So first, I'll just have a try, and finally here, so after everything works out properly, what I want to do is os.unlink and unlink the script's path. And this can also have an exception, but I'm not handling that over here. And now what I can do is give it a permission. This path needs to get the correct permission. So I'll pass in os.chmod, which stands for change mode. So it is just used to modify the file and even a directory's permissions. So I'll pass in the script path here, and then what is the mode that I want? The mode that I want is 00755. The 00 is used to denote that the digits that are going to follow the 00 are in base 8. That means we are writing in octal. We are not writing in decimal format. So this is decimal format. We're writing in octal now. And the 7 here represents the owner, which is the user permission. And the user permission is 7, meaning it's read, write, and execute permissions. 5 here stands for group, meaning read and execute permissions are there for group, but no write access. And 5 is for the world. It just means read and execute permissions. There are no write access for them either. And this is the permission generally given for executable files and scripts. After that, we have given the permissions that are required. I can just go ahead and do await self.run command now. And run command is basically this thing. So let me extract this out within a helper function of itself. So we have something like async def run command. Then we have a self. We return nothing from here, and I'll just paste this in. Cool. Let me just indent this properly. So this will execute whatever command we want. So I'll take this command as a string from here. I'll pass in the command, and now I can just call self over here. So self dot run command. I'll pass in the command, which is hook dot command. And similarly, also this needs to be awaited because this is an asynchronous function. So I'll await it. And similar to this, we'll have self dot run command, and the command that I'll pass in is the script path. Maybe we can also pass in the timeout because that's not something we've looked into. So we pass in the timeout here, and I'll get the timeout integer from the parameters. Then when we call run command at the top, we can again pass in hook.timeout seconds. And here, when we run the command, we'll again pass in hook.timeout in seconds. Great. So this is how you execute a script, and this is how you run a command. Now I just need to call this run hook over here before the agent, and that's enough work for me. But now you might wonder that, hey, why did you take in a user message string over here? The reason for that is there's something else we need to do, and that is building the environment variables. Because if I'm writing a script, let's say a temporary.sh or in the config.toml, I've passed in the script that I want to write, and there I want to know which hook is being triggered, or I want some information about what the user's message was. So before the agent starts, I get to know what is the user message, right? And maybe in the script, I would like to use that information to do something. Or I would like to know what working directory is the agent in so that I can use that. Or what was the tool that was called? What was the error we ran into? All of these details are very useful information that the script owner might require. And it would help them if we can just provide it to them. And that's why I took in a user message. So before the agent starts, all we have is the user's message to us. So we can just take that and pass it to the environment variables, so that the user can just reference the environment variables and create their own script. Hopefully that makes sense. If it doesn't, we'll create a test script later on to test our application, and then you'll understand it much better. But for now, let me create a helper function which is build environment variables. This will get the trigger, which is the hook trigger. It will get the tool name, which can be a string or a null value, because if you're having an before agent, you don't have a tool name. If you're having an after agent, you don't have a tool name. Similarly, for user message, the value can be string or null, and by default it is null. Even over here, by default it is null. And similarly, for error, we are going to have either an exception or a null value, and by default it is null. Now let me go ahead and build the environment variables. So the first thing is os.environment.copy. That's good. Then I'm going to pass in my own environment variables. Now I want these environment variables to not conflict with the already existing environment variables, so I'll choose them safely. I'll have AI agent trigger, for example, which is just going to equal to trigger.value. So this just refers to the hook that was run before agent, after agent, before tool, what was run. Also, I think I misspelled in the configuration. Okay, yeah, after needs to be lowercase. After that, similarly, we are going to have an AI agent current working directory, which is going to equal to the string of self.config.current working directory. After that, we'll just check if the tool name is present. If it is, similar thing, we'll have AI agent tool name. So what tool was called, and then we'll pass in the tool name, and then I'll copy paste these if conditions again. The second one is user message if that's present, and I'll have AI agent user message, and I'll pass in the user message here. The third thing is error if that's present, and then we'll have AI agent error, and I'll pass that in as the value. After that, I'm just going to return this environment variable, and the return type of this function is going to be the dictionary of string comma string, because we have an environment variable to return. After that, I can just call this function over here where we have environment is equal to self.build environment, and now I can pass in the hook trigger, which is hook trigger dot before agent. Then I pass in the user message that we get from the parameters, and this environment variable can be passed to run hook. And now in the run hook, instead of using the environment variable over here like os.environment.copy, what I can do is use the same set of environment variables. So I'll have again environment, which is a dictionary of string comma string. I'll use this environment variable and pass it in to run command, which will also get this environment. And it's just a lot of parameter passing as of now. And I'll just pass in the environment variable here. And we don't have to pass in the environment variables here, I believe. So that's good. Also, if you want, you can set this delete to true so that the script is deleted as soon as you run it. But then you would have to shift this try and finally block inside of this with, because as soon as this context manager gets over, the file will be deleted. And maybe after that, you can also remove this unlinked part because you're already deleting the file, right? So no biggie. So that's about trigger before agent. Similar to that, we are going to create a trigger after agent as well. And we are going to get the user message, but we're also going to get the agent's response, right? Because after the agent runs, we have the entire agent response with us. I would just like to send that across. And then I can pass in before no, that's going to be after agent. And similar over here, we're going to have after agent. And we've stored the user message to the environment variable. I would also like to store the agent response. So let me just update it manually over here. So we have AI agent response is equal to agent response, and then we go up till, let's say, 5,000 characters if you want, but I would just like to store this entire response. And then we run the hook as usual. Now, similar to this before agent, we are also going to have before tool call. So let's have async def trigger before tool. Then we get the tool name that was run, which is going to be a string. And then we get the tool parameters, which is a dictionary of string comma any. And we import any from typing, and it needs to be capitalized. After that, we are going to pass in the tool name here. So that's there. And now I just need to do environment AI agent tool parameters is equal to, and I'll pass in the tool parameters. Ideally, it should go within this build environment function, because, you know, if you're taking in tool name, why not take the AI agent tool parameters as well? But I'm too lazy to change it again, but you should. Now let's have the hook trigger to be before tool, and this is also going to be before tool, and that's it. After that, we're going to have an after tool as well. Here we're going to get the tool name, tool parameters, and the tool result, which is going to be of the type of tool result. Because if you remember, anything that gets returned from a tool result or the tool call is this tool result, even if it's an error, success, whatever. After that, we again do this self.build environment. We pass in the tool name, and this changes to after tool. This also changes to after tool, and the tool parameters are also set up. After that, we have the AI agent. Instead of tool parameters, you have the tool result set up, and then you have tool result dot, and we just convert it to model output because we are not interested in what this LLM might actually have over here. For example, the diff or the truncated, all of that is not necessary for us. What we are interested in is what is the error or what is the output. So yeah. And then we just run the hook. After that, we are going to have our first or last one, which is trigger on error. So it's not happening before or after anything. It's just happening on an error. And all we get here is an error, which is of the type of exception. Then we have a build environment. We'll just pass in the error. And here I'll say hook trigger is on error. I'll remove this environment variables, not needed. We just have to store the error. And here also we'll pass in the error. Awesome. That's all. So we've created all the functions that we need. And now we are all set to integrate this hook system within this agentic loop. So similar to everything, we first have to initialize it, and initialization of this is also within session. because each hook that's present is specific to one session. So we'll have self.hook_system is equal to, and then we pass in the hook system like that. Let's import it. And now I can just call self.session.hook_system wherever I want. The first thing that we can do is run this hook system. So here I can just pass in something like self.session.hook_system. And then I can just trigger before agent. And then I have to pass in the user message, which is just message. Great. I'll await it because this trigger before agent is an asynchronous function. Now I'll copy this line because I'll also run it once I've completed this entire agent run. So I'll have self.session.hook_system.trigger after agent, and then we'll pass in the user message. And then we also want to pass in the final response or the assistant response, right? So that's this one. Now I want to trigger the before and after tool calls, and to do that, I'll have to go within the tool registry or the invoke function, right? Because invoke function is where everything is called, all the tools are called. From there, I can get access to the tool result. So if the tool is null, we are returning the tool result.error result. What I'll do instead is set this equal to result. Then I'll return the result. But before doing that, I can just say, hey, give me access to the hook system. So this hook system that we have is going to be present here. Let's import it. Yeah, let's have it before approval manager. Hook system should always be there. And then we can just call hook system dot trigger after tool. Makes sense, right? If the tool is not present, we can return either trigger before tool or after tool is the same thing. But to give the user clearer information, we triggered before tool, but there's really no tool. So there's no before tool. We did after tool. That's just an indication to the user that there's no tool found. And I'll pass in the name of the tool. Then I need to pass in the parameters, which is parameters like that. And then I will have the result, which is what I created here. I'll await this and I'll copy this line because we'll use it multiple times. Now let's move on to the next thing. Now, if there are validation errors, we are returning a result. So what I'll do is store this in a result variable. Then I'll trigger this after tool, pass in the name, parameters and result, and then I'll just return the result. Similar to what we did with this tool is null. Before we get started with this invocation, I'll trigger before tool because this is the time that we are actually going to trigger some tool. So we are going to trigger before tool. And now whenever we try to return the result after this, we are going to have after tool again. So let's see where we are creating a tool result, and it's over here. So what I'll do is result is equal to tool result.error result, and I'll have hook system.trigger after tool, name, parameters and result, and then we'll return the result. Similar thing over here. We are returning the tool result.error result. So I'll have result, then I'll trigger after tool, and then I'll return the result. Same thing again and again. So these were for all the failures. Now if it's a success, then we are going to get the result. And even if it's a failure, we get the result over here, and then we are returning the result. But before we do that, I would again like to trigger after tool and pass in these parameters. So this is how we are triggering before and after tool operations. So that looks good to me. And with that, all I need to do is see where this invoke function is being called, which is within the agent.py, and I'll pass in the self.session.hook_system, and I'll get that and pass it above approval manager, because if you hover over this, approval manager is the last thing. Hook system comes before that. So yeah, we are all set. Now let's try to see if it works out. I'll open up our agent, but before I open up our agent, I have to configure the hooks. So what I'll do is go to the config.toml file, and this is the file specific configuration system. And here I'll add in my hook. As I said, hooks is going to be a list. So what we'll have to do is hooks like that. You remember when I said that the model needs to be passed in, it needs to be passed in like this, not like this. If you have a list, you pass it in like this. And now we'll pass in the name, if you go back to our configuration.py file, you'll notice the exact schema that we need to pass in. So name, trigger, and command or script. That's what I'm going to pass in. So the name is going to be, let's say, test before tool. And obviously the trigger of that is going to be before tool. So make sure you pass that in correctly. The same wording as this one. Then you have the command. And let's say the command for me is going to be python 3 /scripts/test tool.py. So I'm going to create a new folder called scripts in my current working directory and create a new file called testtool.py. So let's create a new folder, scripts, then we have testtool.py, and I'll add it in over here. This is the script. So we have a main function, we are getting all of the environment variables, and it shouldn't be unified agent. It should all be AI agent trigger or AI agent current working directory, AI agent tool name, AI agent user message, whatever we created early on. I don't remember the wording. And this is going to be AI agent error as well. Then we create a dictionary out of it. We pass in the timestamp. We have the trigger, current working directory. I forgot the AI agent response, but you can pass that in as well. And then we just log it to a specific directory, which is, well, I forgot to put the desktop AI agent. So it goes in this specific folder and creates a hook.log file. I like to see the hook.log over here, but you can just store it anywhere. This is just an example of what this AI agent can do. Obviously, you can get more creative. You can add the Slack APIs so that you can create a notification, tons of things to get creative with, because this is just any code piece you can run. This is what we are doing. It's just a sample test file. And similar to this test before tool, I'll also create a test, let's say, before agent. Just before the agent starts, I would like to see what's happening. And then we have a command which just runs the same thing, but this time the environment variables are going to differ because the tool name is differing. So yeah, let's try it. Also, by the way, you need to put in the hooks list again over here. They're thought of as one element and the second element. So that's good. Now let's try to run the agent, and we run into an error. It says hook system forgot to pass in the positional argument. So we'll go to session.py and pass in the configuration here. Now let's try again. And this opens up, that's good. And I'll open up my file explorer as well, so that if we have a hook.log showing up, we can see it. And let's just tell it to echo out hello world. Yeah, that sounds good enough. Let's run it. And it just prints out the hello world. And the reason we don't see anything is because I made a small mistake, and that is I did not set hooks enabled to true, because by default hooks enabled is equal to false. So I'll just set this equal to true, and now let's try to run it again and see what happens. So I'll type in the same prompt, let's hit run, and we get cannot access local variable result where it is not associated with a value. So I can go to the registry.py and see where this is. And this is the before tool. Now before tool does not require any result. So let me remove it. And now we can try to run it again. Again, the same prompt. Let's hit enter. Despite that, we are not able to see it. Most likely this time the issue is that within the configuration.py, we passed in a default factory for hook, which is just hook config. Instead, it should be a list, right? Because we have a list of hook config. So let's try to rerun it and see what happens. So I'll echo out hello world and let's run it again. So it prints out hello world, still doesn't show up because I believe we still have a lot of bugs to figure out. So the first one is that when I have run command here, and whenever I call it, I'm passing in the environment variable here, but I forgot to pass it in over here. So let me pass in the environment variable when I'm trying to run a script. After that, this timeout here is not an integer, it is a float. After that, we get the tool parameters, right? Let me see where they are. So wherever we get the tool parameters, I would like to convert them into a string format because that's what the environment variable requires, a string. instead of a dictionary. So we'll have JSON.dumps and I'll pass in the tool parameters here. Let me import JSON. Now similarly, whenever I have tool parameters here, I'll do that. And for this toModel output, it returns a string to us. That's good. And whenever we have an error, we have to pass in the exception here. So when this run build environment is called, we'll have to pass in the string of error. We cannot pass in the exception object just like that. And then, so yeah, that's all. Now let's try to run it again. I'll pass in the same prompt and it says hello Revan. I think I might have discovered the real reason behind this not working, and that's probably related to how the command gets run. So we have to go into the hook system, and when trigger, let's say, runs, so when we are trying to run a command, we are doing create subprocess execution, and then we pass in the program. But here, when it passes in the program, we are passing in essentially something like Python 3, right? Python 3 ./script/testtool.py. But when we do that, create subprocess exec treats this as an executable that needs to run, not a shell command. So what we need to do instead is run a subprocess shell. Then we pass in the command and stuff. So we have the environment variable. You can set start new session to true. After that, we'll wait for this process to communicate. If there's a timeout error, we will just go ahead and kill the process and wait for it. To make this work, what we can do is pass in a try here. Then let's indent everything. And then we have except. And then I can just try to print out the exception if we get any, so that I know where the error is even happening instead of just shooting in the dark. So let's run it again. And I'll pass in the same prompt again. And it doesn't seem like we see any exception. So I went offline and tried to figure out what the error was, and the error turns out to be the silliest thing ever. So in config.toml, we have a model here where temperature is 0 and then hooks enabled is equal to true, right? But the problem is that if you set hooks enabled true within this model, it will think that hook is enabled for this model dictionary or model table. What we need to do is put it above this model and then it will work out. The reason I got to know that is because I went here and printed out the self.hooks, and the self.hooks was an empty list. So I printed out self.config.hooks enabled and that was false. So obviously the issue was something related to the configuration, and I just shifted this up and it worked. That's good to know. I did not know that was how the TOML worked, but it makes sense. And now let me just start python main.py and let's try to print out echo hello world to me using shell, and then hit enter. Let's see if the log shows up, and we do get hook.log here. We get before agent and before tool. This is the current working directory. The tool name is, well, exit is also a tool name for some reason. I think stuff is getting printed out a bit weirdly. Maybe I have some more bugs in hook system which are related to the environment variable. Yeah, that is the issue. When the tool name needs to be passed in, I'm passing in the user message. So yeah, that is my fault. What I need to do here is user message is equal to user message. And now I need to scroll down and fix this for everything. So user message is again equal to user message. After that, we have the next one where we have before tool. So tool name is equal to tool name. And then we have after tool where we have tool name equal to tool name. We have the error which is equal to error. So that's it. Now let's copy this prompt again and exit out of here and then run it again. This time hook.log is empty. Let's see it happening in real time. Fill it up in real time. So let's run it. And we do get before agent. Then we get before tool. And since we have not set up any hook for after tool, we do not see the output, but that's also something you can configure. And yeah, so we have before agent, current working directory, tool name is null because we are in before agent. There's no tool call. The user message is present here. The error is not. Then we have the shell. That's amazing. So that means our hook.log gets filled in thanks to the script that we created, which is somewhere over here. And then we have a test tool.py file here, which fills it up. So this is the file that's running thanks to the configuration that's done over here. Now, similarly, you can try to run a script as well before or after agent, whatever you like, and use the environment variables as you feel like. But that's it from my side. Now let's move on to the next feature, which is loop detection. Many times what happens is that your AI agent starts following a loop. Maybe it calls a shell tool which says echo hello world, and then it does some read file, write file, but again after that it calls the shell tool and then it does read file, write file with the same content. That is problematic because it is going in a cycle, right? You don't want that. Or many times it might just happen that your agent is doing a shell tool call with hello world echoed out, and then it keeps doing that for 4 or 5 times or 100 times, whatever. So that is a loop as well. So it would be good if we can just detect those cycles or repetitions that are happening, because maybe the LLM hallucinated or got confused. So it started doing those weird things, and we just detect that loop that's happening and then we kill it off and we steer the LLM away from that action. Now, I don't really have an example to show to you because it just happens on specific instances, and it happens mainly with cheaper LLMs. With better LLMs, I've not seen that happening, but definitely with cheaper LLMs, it does happen, and I've seen that with Gemini models as well. So let's just implement that loop detection and integrate it within our agentic loop. It's very easy. So let's go ahead and create the file in the context folder, which is going to be loop detector.py. You can create it elsewhere as well, but I think context is the most appropriate place. Then I'm going to create a class of loop detector, just like we've done for everything else. Then we have an init function, and here I'm going to have two things. The first one is going to be the max exact repeats, which is the exact number of repetitions that we want to catch. So let's say the number is 5 or 3, whatever you want. This means the max times the same action can repeat, and after that it will just error out and tell that, yeah, we are in a loop. After that, we have the max cycle length, which just refers to the cycle length we want to detect, because if we have something like, let's say A, B, in that case we have a cycle. So I want this cycle can go on for, let's say 5, or maybe we can set it to 3, and if it exceeds this 3 limit, in that case we are in a cycle. After that, I'm going to create a history which is going to keep track of all of the actions that are happening, and based on these actions I can just determine if we have a max length or max cycle or max repeats, right? So what I'm going to have is self.history, for example, and this is going to be a private variable. The type of this is going to be a deck, and we're going to import deck from collections. Deck stands for doubly ended queue, and we're going to use it for the simple reason that I want a property of use here. There's one simple property, max length. So if the max length is provided, it will limit the number of items within this collection or within this queue. So if we have, let's say 20 items, that's the number of items I want to keep in this deck. Otherwise, I don't want to keep track of all of the elements, right? Why should I waste my memory on that? So it's just a simple optimization, and we can set this to be, let's say 20. Now I'm going to have two functions here. The first function is going to be record action. So whenever the loop has to be detected, first we'll have to record the action that's happening. Maybe we get the user the agent response, or we get the tool call that's happening. So I would like to record that action, and once I've recorded it somewhere else, I'll just check for the loop. So just to give you a perspective, we'll go to agent.py, and here, let's say whenever we try to call a tool, that's when we'll record one action, and whenever the user or the agent response comes in that case, I'm going to record an action as well. And if I want to detect a loop, I can do it anywhere I want. It doesn't have to be in one fixed place. So we are going to have two functions, record action and the loop assertion, where we just check if a loop is detected or not. So here the first thing we're going to get is an action type, and the action is essentially, is it a tool call? Is it the response? Was it what is it? And if there are any other details, they will be passed through a map here, which I'm going to copy, and then we have any. So it can be any details that are passed to us, and we'll get those details as a dictionary. After that, I have to compute a signature for an action so that I can store it within the history. Because if we have a tool call happening, what I like to do is get the tool name, get the arguments, and then just append it with the response if there's a response as well, and add it to this history. So that is going to be our signature. It's going to be a list. This history here is going to be a list of a string, by the way. So deck is going to be a string here. And this list is going to be, let's say the first element is a string, and then there's going to be the tool call that's happening where we pass in the tool name. So let's say the first tool name was shell. After that, we're going to pass in an OR operator here so that we have a separator between these two. And the next thing that will come in here is the tool arguments. So we'll have the key, and by the way, everything will be within this string. So we have shell, then we have the tool arguments. So let's say the key is command, and then what is the command's value? What did the user say or the agent say? And we'll have something like echo, and there is maybe hello world, something like that. So this is going to be the action recording that we're going to do. And if we want, we can also add some truncation here. And when this loop detection gets more complex, you might want to hash this thing so that, you don't store the entire string, which can be very long. Instead, what you do is store a hash of whatever string you have, so that you just have to compare, let's say, a 16-digit string instead of comparing a very long 100 character, 200 character string. So yeah, now the reason we are storing this in history is so that whenever we try to detect a loop, it will get much easier for us to detect the loop. All we have to do is match the strings correctly. We're just trying to have it in a good format. So the first thing we'll have is, let's say, the output, which is equal to, and I'll pass in the action type. After that, I'll just check if the action type is equal to tool call. If it is the tool call, that means the tool call is also present. In that case, we'll have parts.append or output.append, and then I'll pass in the tool name. So to get the tool name, I'll just do details.get and pass in the tool name. If it's not specified, it's just an empty string. After that, I'm going to get all of the arguments from details as well. And if they are not specified, it's just an empty dictionary. Then we'll just check if the args is a dictionary. In that case, I would like to go over every argument that's present. But if I just do args.keys, we know the args is not really sorted. We want it to be in a consistent order so that whenever we try to create some sort of action, it repeats. For example, if we have 2 shell calls or 3 shell calls that are happening, but their arguments are a bit different. Maybe if one time it gives us command is equal to echo hello world, okay? And maybe the timeout is 30 seconds, and the next time the same shell tool call is called, and this time what's happening is that we have shell, but first the timeout is given out to be 30, and then we have command is equal to echo. It's the same thing that's repeating, but the argument has changed, and when we try to compare both of them later on to detect a cycle or a repetition, it will not be the same because the string positions have changed. So I want this to be in a consistent order, and for that reason, I'll sort them. Once I've sorted them, what I'll do is output.append, and I'll pass in the key here. So we have key, and then I have to pass in the value, which is going to be string of args at k. So that is our value. And if you want, you can truncate this down to 50 characters, but I'm not going to do that because if we truncate it down to 50 characters and, there are 2 actions that are same until the first 50 characters, and then from the 51st character, they start looking different, that will be an issue. So I'm not truncating it down. But if you want to keep this short, you can. In our simple AI agent, it won't matter because we don't have that many arguments in any case or in any tool. So we are safe that way. After this has been done, we have recorded the tool call related stuff. If the tool call is present, that means we have the tool call. But if the tool call is not present, then we will check for the response. That is the assistant response. And that is very simple. All we need to do is output.append, and I'll pass in details.get and pass in the text variable. So that's it. That is the response. You can truncate this down as well. Also, if it's not present, let's say the text, we'll just pass in the empty string. After that, finally, what we'll do is return a join operator on all of the elements within this output. Because I told you, everything that we add here is going to have an operator joining them. And we don't have to return anything. What I'll do here is store this as a signature variable and then just have self.history, and I forgot to take in self. So we have self at the top and we have self.history.append, and I'll pass in the signature. So that is it for recording the action. Now another function I'm going to create here is to check for the loop. We can just create that function check for loop. We are going to get a self and we're going to either return a string or a null value. And the entire point of this function is to check if a loop has been detected. And as I told you, there are two types of loops: exact repetition, so the same action can be repeated a maximum of, let's say, 3 times. That's what we have stored here. And a cycle, which is a repeating pattern of actions. So the thing I showed you, A, B, A, B, A, B, if that happens 3 times, that one. So what is the algorithm that we're going to use to detect a loop? Well, to detect a cycle of, let's say, length n, or in our case, the length n is 3, we need to have at least 2n actions, right? Because if there's a cycle, we're going to have A, B, for example, and then A, B again, and then A, B again. So to catch a cycle of length n, our cycle of length 3 needs to have at least 6 elements. It can be greater than that. For example, the loop might be A, B, C, and then we have A, B, C again, and then we have A, B, C again. But a minimum of 6 elements should be present. So we check if the last 2n actions form a pattern where the first n actions exactly match the second n actions, right? And this will indicate the sequence if it has a repeating action or not. So let's take an example. Let's say our history has these elements A, B, C, A, B, C. Now what I'll do is check the last 6 items. So our first half is going to have A, B, C. And luckily for us, our history only has 6 elements, by the way. But it can obviously be more than that. Maybe there's a D, E, F as well. But what I'm interested in is the last 6 elements. I'll have my first half as ABC and the second half as ABC. And if they both match, then the cycle is detected. And for us, it's very easy because everything here is deterministic. The actions we are recording in history are all deterministic. That's how we've positioned it. So let's go ahead and check. So the first thing I'll check is if the length of self.history is less than 2. Because if it is less than 2, then we don't have anything. After that, I'll check the exact repetition. I'm not checking for cycles yet. First, I'll check the exact repetition, meaning if the same action is repeated n times in a row. And that's very easy, right? So the first thing I'll check is if the length of self.history is greater than or equal to self.max number of exact repeats. Because the history needs to have at least 3 elements so that we can know if there are 3 repetitions. After that, what I'm going to do is get the last 3 most recent elements, and to do that I can just say recent is equal to list of self.history, and we are just converting this queue within a history. We are just converting this queue into a list, and then I'm trying to extract the last 3 elements. So to do that, I can just do minus self.max exact repeats until the end. So this will give me the last 3 or last, let's call this n, so last n number of elements. And then I can just convert it into a set and see if the length is 1. Because if we convert it into a set, all the duplicate actions will be gone and we'll only have 1 element. So if the length of set of recent elements is equal to 1, then I'll return that, hey, the same action is repeated let's say self.max exec repeat number of times, right? So I'll just say times. So this is how I check for the repetition, quite easy. What about cycles? Well, for the cycles, I told you we need at least 2 times the max cycle length. So first I'll check if the length of the self.history is greater than or equal to self.max cycle length into 2. Because yeah, we're just having 2n number of actions if you want to detect a cycle. After that, I'll have the history converted into a list again. So I have self.history passed in. After that, for every cycle length in the range from 2, minimum of self.max cycle length plus 1 and the length of history divided by 2 plus 1, we're going to create a loop. Now, what does this line even mean? Well, we are trying to check cycles of length 2, 3, 4 up to the max cycle length, right? Because I told you there can be a cycle which is just 2 cycles or 3 cycles or 4 cycles. For example, you can have AB, 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 right? Or you can have ABC, 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 or you can have ABCD, ABCD, ABCD. So we want to go from 2 because there should be a minimum of 2 elements, and we'll go until the minimum of self.max cycle length plus 1. The plus 1 is done because we are having a range here. Range does not include the last element. So if you have 4 here, for example, it only goes from 2 to 3, including 3. It does not include 4. And that's why we have plus 1 here. And we have length of history divided by 2 plus 1, because let's say the length of history divided by 2 is lesser than the max cycle length. That is also possible because let's say our max cycle length is 10, but the history only has 5 elements in that. So 5 divided by 2 will give us 2 plus 1, 3. So we'll go until 3. We don't have to go until this 11 element. So we'll terminate based on the length of history. After that, I would just like to get the last 2n number of actions. So I'll have recent is equal to history, and then we'll have minus cycle length multiplied by 2, whatever cycle we get here. So for example, when we are trying to detect if there are 2 elements within the cycle, so we'll get the last 4 elements from the history. Or if we have 3, we'll try to get the last 6 elements from the history. And now we have to split them into 2 halves so that we can compare if they match. And if they do match, we've detected a repeating cycle. So if the recent and then we have the cycle length is equal to recent and then cycle length in the beginning until the end. If this is the case, then we are going to return that we have a detected repeating cycle of length, and I'll pass in the cycle length. So this way we have accounted for the cycles as well. And if it doesn't return anything, that means we're going to return null from here because we have no loop. Now we just have to call both of these functions within the agent.py. And as I mentioned to you before, the first thing that we'll have to do is if the response text is present, then we'll check for the loop detection. And first we'll also have to go to session and create this loop detector. So we'll have self.session, or let's say loop detector is equal to loop detector. And this is especially useful because each session should have its own loop detector. If it doesn't, then let's say multiple sessions are present and the loop actions will just get appended to the same session. We don't want that. After that, we'll have self.session.loopDetector. And I'll pass in record action. And what is the action type? Response. And I'll pass in the text here, and the text is going to be response text. If you want, you can truncate it here, but again, I'm not interested in that. Then I'll just copy this, and when we are going over every tool call here, I'll record the action again. So once we have sent to the UI that the tool call has started, I'll have loop detector.record action, and I'll pass in tool call. I'll pass in the tool name, which is equal to tool call dot name, and I'll pass the arguments, which is tool call dot arguments. So we have recorded this action as well. And just after we have recorded this action, I would just like to see if there's a loop here, because in most likely you'll have multiple repeating tool calls. The assistant text is not going to loop that much, but what will loop is the tool call. So you can also have the record action somewhere over here, and we'll also have the loop detection here. So I'll just catch here that, hey, listen, if serve.session.loop-detector.check for loop, if it returns a value to us, so let's say value, or let's say loop detection error, and if the loop detection error is present, in that case, I would like to steer the model in a different direction. So what I can do is create a prompt to break this loop. And I can add it to our system.py prompt, or if you want, you can create a new file that looks into this, but we'll have something like this. So system notice loop detected. The system has detected that you may be stuck in a repetitive pattern, and the loop description is present here, which we get from the parameter. And this is just the loop error that we have returned from the loop detector. So these things detected repeating cycle of length, same action repeated, all of that. To break out of this loop, please stop and reflect on what you're trying to accomplish. Consider a different approach. If the task seems impossible, explain why and ask for clarification. If you're encountering repeated errors, try a fundamentally different solution. Do not repeat the same action again. So that's just us trying to steer the model away. And now I can just call this create loop breaker prompt, and I'll import it from system.py. And whatever this loop prompt is, I need to pass in the loop detection error into it, and then I can just add it to a context. So I'll have self.session.contextmanager.add user message. This is not an assistant message, not a tool result. It's a user message, because we are manually interrupting and saying that, yeah, you've gone into this infinite loop. And then we have this loop prompt passed to it. That's it. After this, maybe we can call continue so that we don't execute this tool call again. That is it for loop detection. Now, I really don't know how to test this out, because I don't know how to send the model into a loop. But one thing I can recommend you to do is go to the agent.py, and then whenever this agent event is done, you can go here, create a new thing called loop detected. And whenever the loop is detected, you can notify the user that, yeah, we've run into a loop, so we are manually fixing that. That would be a good user experience, I believe. And then you can also create a function here. And then whenever we actually catch a loop, you can just have something like yield agent event and pass in the loop detected thing here. I think that would be great. And then in the main.py, you can handle that scenario. But anyways, now I would just like to test this out. Maybe I can specifically prompt the agent, please loop the same shell command with same arguments 4 times. Maybe that will help us know if the loop is detected or not. But really, we have no way of knowing if the loop was detected or not. So I'll just manually go ahead and say print loop detected. And then let me just copy this prompt, and I'll exit out of here and retry. So let me paste this in and hit enter, and we run into an error. The error here says that the deck object has no attribute append because I misspelled it. It should be dot append with 2 P's. Now let's try again. Let's paste in the same prompt, and it asks me for the shell command and arguments. Fair enough. I'll say echo hello world is the command. Run. And then we run into another error. Is instance args2 must be a type, a tuple of types or a union. And the issue is that is instance args should not have the value passed in. It should be a dictionary, small issue. Now let's try running again. Pass in the same prompt. So I'll say echo hello world is the command, run. But if you see, it just passes in the command as for I in 1 to 4 do echo hello world. That will not help us detect the loop. So maybe I have to tune my prompt a little bit. Well, is the command 4 different times by calling shell tool every single time. Let's see if that works. I'm not very good at prompting. And yeah, that does work out. So we have shell echo hello world, then we have echo hello world shell, then we again have echo hello world, and then we just see loop detected. Then we also run into an API error saying unexpected role tool after role user. Now the reason we run into that error is because, well, think about it. What are we doing? Well, we are first adding all of the tool calls as the response, right? So here we have the assistant message where we are adding the tool call. We are registering the tool call that's happening. Then we're going over all of the tool calls and executing them and adding them to our context later on. So we have the tool call results added here. But in between, we have checked for the loop detection here. So if there's a loop, we are suddenly adding a user message. So what's happening is we have the assistant response. Then let's say there's a tool response. Then we have the assistant again. Then suddenly you have, let's say, the user response because you detected a cycle, for example. And then you have the tool response. Now a tool response cannot follow a user response, right? That doesn't make sense. An assistant can call a tool and then you have the tool response. And that's the issue for us. So what I'm going to do instead is, instead of having the loop detection over here, I can just push it out over here. So if we have the tool call results, after that, we'll add the loop detection. So this will also allow us to catch any assistant response looping if that's happening, and the tool result as well. So let's try again. I'll pass in the same prompt. I forgot to copy it. Anyways, let's just try to write a similar prompt. So we type out the prompt, call echo hello world using shell tool and 4 different tool calls. Let's hit enter. And then we see loop detected. Great. So it calls the shell commands and then it says loop detected. I've successfully executed the echo hello world and we're also out of the loop. I'm going to remove this print as well. Now the next thing I would like to get started on is this command support. We are almost nearing the end of this AI agent, but the feature I want next is all of the command support here. So if I have something like this, I open up my agent, I have /help, /config, /approval, /model, /exit. These all commands should work. So I'll close everything and then we go to main.py. We have a bunch more of these commands that we support and they will all be shown when we have /help. For example, /MCP or /tools. So yeah, all of them are going to come in and let's get to it. It's going to be very fast because all of it is mainly UI based. What we'll be spending most of our times on is something like /session or let's say /save or /checkpoint, where we have to create those checkpoints and sessions for this to work. So yeah, let's get started on that. So let's scroll down a little bit and then we come back to our agent over here in run interactive. We don't have to worry about the agent within run single. The reason for that is the user won't be able to specify any prompt after just mentioning one single message. But in run interactive, the user will be able to pass in the user input continuously. And that's why over here, after we have checked that the user input is present or not, and then continuing, we can just check if the user input starts with, let's say, a /. That's a good enough indicator for us to handle a command. So here, I'm going to create a function called handle command and pass in the user input here. And this function is going to return a Boolean value, which will say that the interactive mode that's going on, this loop that's going on, should continue or should it not continue. So we'll have should continue as the output here, and by default everyone is just going to say true. It should continue because if you type in something like /MCP, you still want to go ahead with another input. You need this line over here so that you can pass in another input. But if you have something like /exit, you need to return false so that we don't continue. And if should continue is false, in that case, what I'm going to do is break out of the loop. And if should continue is true, then we'll keep continuing. We won't process the message because remember, it's starting with /. If it's starting with /, it's a command not to be processed by us. So yeah, that's good enough for now. Let's go ahead and create this function in CLI. Let's call this handle command. Then we get the message or the user input, whatever you want to call it. I'm going to call it command, and it's going to return a Boolean value. Then what I'm going to do is convert this command into a lowercase character, and I'm also going to strip off any white space, leading or trailing white space. After that, I'm going to check if this command name, and what is the command name going to be? Well, we are assuming that the command is always going to be one thing. So let's say the user passes in something like /exit. So that's one thing. Or the user passes in /tools or /help. But the user can also pass in something like /checkpoint and then the name of the checkpoint. Or let's say /model and then the name of the model, so that we can go ahead and change the model on the fly. That's a functionality we are offering to the user. So if they're processing one message with one model, for example, it's a very simple task. They want to use a cheap model, so they can just change it on the fly. If they want to go ahead with a better model or more expensive model, they can change it on the fly again. So that's a good command to give them. And what they're going to specify is the value next. So the command string is not always just one word. It can be two words as well. So I'm going to split it here. So I'll have parts command.split, and I'll maximum split it into 1. We don't need multiple parts. We're just going to have 2 parts in total. The first one is going to be the exact command name. So that's parts at 0. And then there will be command arguments that are specified. That will be parts at 1. We obviously do this if the length of the parts is greater than 1. Otherwise, we have an empty string for the arguments. The reason we have to do this is because just imagine passing in a command like /exit. That will result in an error, right? Because you're trying to split it. The split parts list is just one element in the list. Then you do parts at 0, which is exit. But what about command at args? It will try to do parts at 1. And we don't have a second element in this list. So we're explicitly passing in if length of parts is greater than 1, then only we want this. Otherwise, we'll have an empty string. Then I just check if the command name is equal to /exit, or let's say the command name is /quit. In that case, I'm going to return false, because I don't want to continue any further. And if it's none of these commands, then we're going to return true, because yeah, it's a normal command. Also, let me just add in an else case here, just in case it's a command we don't recognize yet. We are just going to say unknown command. So we'll have console.print, and then I'll pass in something like error, then /error, so that I can pass in the error message here, which is unknown command. And then I'll pass in the command name, which is this particular name. And this is obviously going to be an S string. And then we return true. We return true for everything other than this first exit, because that's the only time we want to exit. And yeah, I think that should work. Let's go ahead and try it. /exit now. And goodbye does show up. So that's great. This is the first time we peacefully exited. Let me try again and try a command we don't know. So let's say /help. That's not understandable as of now. And it says unknown command help. And we still keep going. That's great. Now let's exit again and start working on the next thing, which is /help. That's the next thing I want to work on. And it's quite easy. I'm going to copy paste the help command actually, because it's just a bunch of commands we have to show to the user. So we'll have elif command is equal to /help. In that case, we can go to the tui.py and here create a function to show the help command. So I'll just paste in the function and let's go through it step by step. So we have the commands showing up, and notice here I've put in 2 hashtags. The reason for it is we are going to use a markdown to display stuff. So this commands will be converted into a second header kind of thing. Then you have all of these bullet points which say, well, /help is show this help. then exit or quit is exit the agent, clear is to clear off the conversation history. Then you have show current configuration, then changing the model, changing the approval mode, showing the session statistics, listing all the available tools, MCP, saving the current session, checkpointing, listing all the checkpoints, restoring a checkpoint, listing all the saved sessions, and to resume a saved sessions. And then we just have the tips that just type your message to chat with the agent. The agent can read, write, and execute code. Some operations require approval and can be configured. And then I'll just do self.console.print, pass in the markdown, and I have to import that from rich. So we'll do from rich dot markdown and we'll import markdown. Great. Now all I need to do is use the TUI to display it. So self.tui.show help. It shouldn't be a private function, by the way. So let me remove it. It can be used outside of the file. And now I can call the show help function just like that. Nothing else. And obviously after that, it will return true because we're not returning anything from here. Now let's try to run this again and see if that works. So we'll have /help and it lists out everything. So we have /help, which is in this particular theme. The reason for that is, if you'll notice, I've put this in backticks, and backticks relates to code, and based on our agent theme, that's how it works. So yeah, there you go. And that's a pretty good looking terminal in my opinion. Now let's get on to the next thing. So the next thing I'm interested in is clear. So we clear off the conversation history. And to do that, we can just do elif command is equal to /clear. In that case, what do I want to do? Well, I just need access to the context manager so I can close it, right? So I can do something like self.agent.session.contextManager, but there's no clear method here. And I can't access the messages history here because messages is a private method or private variable. So I need to go into the context manager and add a clear function. So we'll have something like def clear and it will have self, it will return nothing. And what will it do? It will just self dot messages to an empty list. Or you can just set dot clear to this and that should be fine as well. So let's come back to our main.py and call this particular function, which is dot clear. Another thing I would like to do is clear off the loop detection as well, because if you remember, the loop detection also had some variables that were being stored, right? In history, we were storing everything. Now, if we have cleared off the conversation history and we're trying to find out the next thing, I would also like to clear off the loop detection. So for that, I can just do def clear. Then we'll have a self, it is going to return nothing. And similar to the previous one, we are just going to do self.history.clear, or you can just set it to an empty deck again. And then we are just going to call self.agent.session.loopDetector.clear. Maybe after that, I would like to tell the user that, yeah, we cleared off the conversation history. So I'll have something like self.console, or let's just say console.print, and I'll pass in success. I'll pass in a closing success again, and then I'll say conversation cleared. That looks good. Now let's try again. So I'll just open up my Python main.py. I'll type in some message, hey, what's going on? And it says I'm here and ready to help with coding tasks. I'll just call clear now. So the conversation is cleared. And then let me try asking, what did I say previously? And it just says you mentioned that you love clean code but struggle to write it. That's coming from our memory, because I did say that in a previous feature when I was trying to figure out memory stuff, right? So it doesn't remember what I said over here because the conversation was cleared. So yeah, that works well. Let me exit out of here and let's get started with the next thing, which is showing the configuration. So if the user passes in something like elif command is equal to config, I want to show all the configuration related details. Not all the configuration details, but the basic things like what is the model that's being used, what is the temperature, what is the approval, what is the working directory, what is the max number of turns allowed, what are the hooks enabled. Only those information. Maybe I don't want to display everything because the user can just go to the config.tuml and figure it out themselves, but things that matter. So all the model related information except the context window, that's not something the user should be concerned about, because for them, the context window should not exist in the first place because they're using our agent, we're managing their context. And I'm just going to paste it in because it's just a lot of console.prints. So yeah, there you go. We already have a good configuration system. We can just make use of that. So at the top, we do have self.config that's created, right? We have instantiated it. So let's just use those things over here as well. So self.config.temperature, self.config.approval_policy.value, because approval policy was an enum. Then the current working directory, the max number of turns, the hooks enabled, all the configuration related items, the source of truth is going to be self.config all the time. That's how we made our application work as well. So yeah, you can copy the same, or you can decide which ones you want to choose and show. So yeah, up to you, but this is just a simple thing. So I'll just go quick on this. So we have /config and we do see an error. It says config object has no attribute approval policy. That's because self.config.approval is the value, not approval policy. And now let's try again. So we have /config and we do see current configuration. Then the model shows up, temperature, approval, which is on request, working directory, max number of turns, and hooks are enabled. That's good. Now let's give the user some ability to change the model's name, to change the approval mode on the fly. Because model name and approval policies are something that the user might want to change based on each turn. As I mentioned previously, if you're using it for a simple task, you can use something like Claude Haiku, but if you're having an expensive coding agent task, you will use Claude Opus 4.5 or whatever is the latest Opus. So we'll have something like elif command name, and the command name is here. If that is equal to /model, then I'm waiting for the arguments as well. This is the first time we'll be using command arguments. So if command arguments are present, and they should be present, then what I'm going to do is self.config.modelName. That's how easy it gets. And we'll set it equal to the command arguments because we are expecting the command arguments to have the model name passed in. Something like /model and then whatever is the model, maybe Opus 4.5 is passed in like that. And then we can just print out console.print, and then we have something like success. Then we have a closing success tag, and then I just say model change to, and then I pass in the command arguments. Okay. And I'll just leave a space after that. We have an F string here. Great. Now what if the command arguments is not specified? In that case, we've run into an error because the model should be passed in. Or maybe the user wants to know what model are we using. We can do either one of those. Either you can tell that, hey, you need to pass in the name of the model you want to change to, or you can just display the current model that's being used. And that's what I'm going to do. I'll just print out something like current model is self.config.model name. Now, I'm not really sure if we can change the model name like that because the way we did over here. The reason for that is if we go to the config.py and we have the model name here, we have the property and we created the setter as well. That's great. So that means we can set the model name. I was worried we don't have a setter. So yeah, let's start a coding agent again and see if we can change the model name. So we'll have /model first, and it will print out the current model, which is this one. Now I'll shift the model and I need to find a new model now. And to find out the model, I can again go back to OpenRouter and let's just use the same Mimo v2 flash model. And then we see model change to Mimo v2 flash. Now I can again type in model and it says current model is Xiaomi. Let me type in config and it shows the model is updated to the Xiaomi model. That's awesome. You can also see the response changing. So yeah, go ahead, see that, but I'm not interested. Let's move on to the next thing, which is approval. So we'll have elif command name, and it's actually going to be very similar to this one. So let me just copy and paste it. Just that instead of command name being model, we are going to have approval. And if the command arguments are present, then what I want to do is set the approval policy instead of model name. So I have approval equal to whatever is the command args, right? But this command argument can be wrong as well. Nobody's saying that the user is always going to pass in the right thing. Maybe they misspell. So in that case, what I like to do is first check if this approval policy is also correct. And to check it, I can just call approval policy like that. And let's import it from config and pass in the command args here. Because at the end of the day, this is an enum, right? So I can pass in, because at the end of the day, this is just a class. Yeah, it is an enum, but it's also a class. So I can just pass in the name of the command argument, and now I can pass in the approval here. And then whatever is the value, I can just set it to this approval value. Now, if the command argument is not correct, this will raise an exception, and we have to handle that. So I'll do try, then I'll pass in everything over here, and then I'll say except, and if any exception occurs, in that case, what I'll do is print out the error. So we have console.print. Let me just copy this error command and paste it in over here. Maybe I can just say incorrect approval policy. And if we want to be more generous, maybe we can tell the user all of the values that are possible. So we'll have incorrect approval policy, command args, and maybe we can also pass in something like valid options. And these are all of the valid options. And to find all of the valid options, it's going to be very easy for us, because we just have to loop over every policy in this approval policy, right? So I can do something like comma dot join, and then I'll go over every policy in approval policy and print out the P over here. So yeah, a comma separated list of all of the possible values. And maybe I can remove the error for this one, because valid options does not need the error. And then we have a space here. Great. Now let's try. Oh, by the way, I forgot to change the success part here. So we'll just say that the approval policy changed to, and then we pass in the command argument. That's good. Now let's try again by reloading it. So we have /approval, and it says that the current model, it's still displaying the model. I forgot about that, because there's an else case as well. If the command arguments is present, we do all of this. But if the command argument is not specified, then I'll just say that the current approval policy is, and then we'll pass in the approval policy here. And this is the approval policy enum. I would like to show the value. So we have dot value. Now let's try again. I'll exit out of here. Let's try again. And we have approval, unknown command. That's right. This is the current approval policy on request. I'll pass in the incorrect one. So I'll have on YOLO. That is the wrong value. So we get incorrect approval policy on YOLO. Valid options are on request, on failure, auto edit. We misspelled that. We might want to fix that. And then we have YOLO. So we have /approval, YOLO, and the approval policy is changed. And I know that the approval policy for sure is changed, because everywhere we are using self.config.approval in our approval system. So you can test it yourself now. But now I'm going to move on to the next thing, which is showing all of the statistics related to a session. So let's have something like command name is equal to, and then we have stats, and then I can just try to get all of the stats from a session. And I have to create a helper function for it, and also decide what all stats do I want to display from this session. So I'll just go down and create the function get stats, and then we have self. We are going to return a dictionary here, because it's a big thing that we want to return. The value can be any, because we are going to pass in multiple things that can be of any value. And then the first thing I'm going to pass in is the session ID. That's quite important, because the user should know what session ID they are in, because later on we'll give them the ability to change their session as well. Then we have created at, which is something we have already stored. So we have self.created at .iso format. So it just returns the time in formatted format, or in just a particular format, all right? Then we have the turn count, and that is something we are storing as well. As you can see, self.turn count, that's enough. So how many turns has the agent already taken? Then we have the message count, how many messages has the agent replied with and how many have you replied with. So those total counts, and that is present within the context manager. And as we know, in the context manager, we don't have anything that will allow us to get the length. All we need to do is find the length of this messages, but it's a private property. So what I'll have to do is create a new function here and call it @property def, and let's say it is the message count. Then we get a self, and we're going to return an integer from here, and we'll just return the length of the self dot messages. The reason this is a function is because if we try to create a variable here, we'll have to increment the message count every single time. And I don't want to keep track of that. Instead, I can just find out the length of messages, and that's good enough for me. So now I can do self dot context manager dot message count, and that is our message count. Then we have the token usage, how many tokens have already been used, and for that purposes I had created a variable, if you remember, total usage. We don't want the latest usage now, because latest usage was for the context limit hitting. Token usage or total token usage was created so that we track the total token usage, and we tell to the user that, yeah, this is what we have done so far. This is how many tokens you've consumed over everything, and this much token is what you're going to get charged for. So let's go back to our context manager and create a property to get that token usage, because it's a private property again. So I have @property def total usage. Then we have a self. I'm going to return the token usage from here, and then I'll just say return self dot total usage. Now let's come back to this session, and I can pass in self.contextmanager.total usage. Now, if you're wondering, why are we creating all of these private variables if we are going to anyways return them as a public variable? The reason for it is this total usage is only used within this context manager. So anytime you want to change the value of this total usage, you'll have to do it from within the context manager, essentially. But this total usage that we are exposing out will not be able to change the value because we have not set up any setter, right? So yeah, that's the benefit. After that, we are going to have the tools count, how many tools are present. And to find that, we can just access the tool registry, get all of the tools, and then whatever is the list, I can just count the length of that list. So that is the number of tools we have. After that, we have the MCP servers. So how many MCP servers are connected, and to find that, I can do self.mcpmanager. And as you can see, there are 3 functions, but nothing related to the connected servers. To get access to that, I can go to the MCP manager, or I can go to the tool registry to find out all of the servers that are connected. Because if you remember, in our tool registry as well, we had a variable of MCP tools. And those MCP tools are the things that are passed in, and they're only registered if the MCP tool is connected, right? As you can see, if it's not connected, we continue and then pass it in. So we can use either one of those. I'm going to use this tool registry to find out all of the MCP servers that are connected. So let's go to this tool registry and expose out a property that is the MCP servers that are connected. So I'll just say connected MCP servers. We have self. It will return a list of tools, and then we can just return self.mcptools.values. I'm not exposing out the string here because string is just the tool name, and tool already has access to the tool name. Great. Now let's access this connected server. So we have .connected MCP servers, and I can find the length of that. So those are the MCP servers that are connected. And that seems like a good enough thing. Now let's use this getStats function in main.py. So we'll get the stats, which is equal to self.agent.session.getStats. And now I can try to display this dictionary. And to do that, first, let's just try to print out in bold what is the session statistics. So we have bold session statistics, and then we have /bold again. Okay. And after that, I'll go over every key and value in this stats.items so that I can display it out. So we'll have print f, and it should be console.print, by the way. And then we'll have f, and then let's indent. So I'll leave, let's say 1, 2, and maybe 3 spaces. Then we have key and then the value. The key is this key. And that should be enough. So let's go ahead and try it. I'll try to do stats now, and it does show up session statistics. This is the session ID created at turn count is 0, message count is 0, token usage is 0, tools count is 14, and MCP servers is 0. I can try to pass in a message. Hey, how are you? Let's try to run it. And it says one message. Okay, great. Let's try to run stats again. And it gives me turn count is 1, message count is 2, because we had one message here and one message here. My response and the assistant's response. And turn is just 1 because the assistant only replied once till now. And then the token usage, prompt tokens is 5356, completion tokens is 24, and total tokens is 5380. The reason prompt tokens is this much is because we have attached the system prompt. So yeah, that seems to be working in our favor. Now let's go ahead and similarly display all of the tools that are available, including the MCP servers. So we'll have tools here, and we'll try to fetch all of the server tools. And to get all the tools, we'll have to access the tool registry. So we have self.agent.session.toolregistry.get right? So that gives us a list of all the tools. But what we need instead is all of the tools with its name. So what I'm going to do here is first print out that these are all the available tools in bold. And then I'm going to pass in the length of tools. And this is going to be an F string. Let's say this is 14, which all gets printed out in bold. And after that, I'll go over every tool in this tools list, and then I'll print it out. And I want to print out in a bullet format. So what I'll do is replace this with a bullet list, and then we have the tool.name passed in here. Great. Now let's try to run this again. So we'll have /tools, and these are all the available tools. Read file, write file, edit, shell, list directory, grep, glob, subagent codebase investigator, and subagent code reviewer is also present, and our test tool is also present. Test tool was something that we injected using tool discovery. So if you remember, we had .ai agent, tools, and then a test tool. This is different from another test tool.py that we created within the scripts. This is for hooks, but this one was for tool discovery, creating our own tool. So that's also showing up here. That's great. And if you add any other MCP server, for example, that will also show up. So we'll have config.tuml. As you can see, the stuff related to MCP is commented out. Let's just uncomment this, and then it should show up. So I'll just exit out of here. We have to reinstantiate because MCP server detection doesn't happen automatically. That's some feature you might want to add yourself. But let's just go ahead and see all the tools now, and we have 28 available tools. Now what I like to do is print out something like /MCP, and MCP should list out all of the servers that we are connected to. Nothing much. Just all of the servers we are connected to, or the connection is pending, or the connection failed. I would like to see the status of every single one of those servers. So what we'll do is, similar to tools, print out /MCP. Then we have MCP servers, which is equal to self.agent.session.mcp manager and we'll try to get all the servers. we won't be able to use the one that tool registry gives us, because tool registry gives us all the connected MCP servers. What I'm interested in is all of the MCP servers. So I'll just say get all servers, and that should give me all of the servers, whether they're connected or not connected. So let's go to the MCP manager now. And here, let's create a function to get all of those information. So we have def get all servers, and then we are going to list out a dictionary of string comma any. And what are we going to return? Well, I have to go over all of the clients that are present here, because each client represents one server. And then I'll print out its name, status, and the number of tools that are present here. So for name comma client in self.clients.items, I'll just check if, or we don't even have to check anything. I can just do server info is equal to, and I'll pass in the name of the server, which we have over here. Then I have the status of whether the server is connected or pending or what. So we'll have client.status.value. Then we have the number of tools, and that is just the length of client.tools. And then we'll just append it to a big list. So we have servers, which is equal to an empty list, and I'll do servers.append and pass in the server info. Finally, we'll just return a list of those servers. Great. Now let's go to main.py. We have called this function get all servers. That gives us everything. And in bold, we'll just write out MCP servers, and similar to the available tools, we can just say that these are the 3-4 MCP servers that we found out. So we'll have the length of MCP servers, which just suggests what are the number of MCP servers connected. And then we'll go over every server in the servers and then print it out. So the first one is going to be the status, which we'll have as server at status. And then we have the status color equal to green if the status is equal to connected. Otherwise, it is going to be red because it's not connected. Either it's pending or it's rejected, whatever. And this should be status color, not cold. And we have to print it out. So I'll have server name passed in here. Obviously, we're going to have a bullet point still. So we have server name, then a colon. Then within this, we're going to have the status color. Because remember, we have to pass in green or red here, right? So if it's green, we'll pass it in like this. Or it's red, we pass it in like this. And then we also have to close it later on. So we'll have /status color as well. And between them, we're going to pass in the status, whatever it was. So it was connected or rejected. What is it? Within green or red. And yeah, that's how we print it out. Maybe you would also like to add the information of how many tools there are that's connected. So I'll just have a space here followed by a parenthesis within which I'll pass in the number of tools. So we have server at tools, and then we pass in the tools written here. 7 tools, 8 tools, what is it? And that's great. So now let's try to run it again. So I'll just exit, rerun, and then I'll have /mcp, and it says file system connected. Let's try to do a server that does not really exist. So I'll just copy and paste this. Then we have file system 2. Then we'll just have file system 222, something that I know doesn't exist. And now let's try to run it. So as you can see, even if it's an invalid server, our application is able to handle it. That's good. And I'll just type out /mcp, and we say file system connected 14 tools. File system 2 is errored out and it has 0 tools. Amazing. And if we print out all of the tools, they are still available. Oh, awesome. Now let's move on to the next command. And now next command onwards, we are moving on to the session and checkpointing features. So let's go back to our TUI where we have the help function. And here, if you notice, we have basically added in all of these things. Now we need to add in save checkpoints, restore sessions, and resume. We're going to start off with session because checkpointing does require some schema of session to store it. Now, first, I would just like to tell you the difference between a session and a checkpoint. Session is essentially whenever you try to save whatever is the current state of the AI agent. Checkpointing is whenever you try to store the agents up to a certain point. So let's say I pass in 3 messages and the agent does those 3 tasks, and then I create a checkpoint. After that, I can continue that same session and ask more things to do, and then I can create another checkpoint. So a same session can have 3 or 4 checkpoints. So it's the last, the recoverable point that I want. And session is essentially whatever is happening in one AI agent. So to give you a practical example, this is one session. This ID that you see is related to one session of ChatGPT. All right. You can create multiple sessions by creating a new chat. Checkpoint is essentially, let's say, this message and the response. So let's say I create a checkpoint here, and later on I want to come back to this checkpoint. I can do that. Or I put in another message and save the checkpoint till here. So one session can have 3, 4, how many ever checkpoints I want. This is what I'm talking about. So let's go ahead and first create a session, and we're already creating a session, right? We do have a session.py, but now I would like to save that session. How does saving a session and for that matter checkpoint work? Well, we just store the list of messages and other related data that we have in a file. And once we store it in a file, we can retrieve it from the file, and that is just the persistence that we are going to have. That is how you store sessions in AI coding agents. Everything is file system related, as of now at least. So we'll have elif command name. If it is equal to /save, then we are saving a session. So in that case, what I like to do is call a particular method. But first I'll have to create that. And what I'm going to do is within the context, I'm going to create something, or maybe I can create it with an agent as well. And I'm going to call this maybe session manager, or you can call this persistence manager, whatever you want. But this is essentially dealing with all of the persistence related stuff like checkpoints and sessions. So we'll have class persistence manager. This is really a bad name in my opinion, so you might want to change that. What are we going to get here? Where we are going to get init, and then what I'm going to do is pass in the data directory. If you remember, data directory was something we created in the utils, which was the place where all of the data of the coding agent would get stored. We use this get data directory in memory, and we're going to use this for sessions and checkpoints as well. So each session is going to have a new file, and each file is going to be present within the sessions directory. So first I have to ensure that that sessions directory exists. So I'll just have self.sessions. Or let's just say sessions directory is equal to self.data directory / and I'll pass in the sessions folder. So this is the sessions directory, and then I want to ensure that this directory is present. So I'll have self.sessions directory.make directory. If it doesn't already exist, parents will be true, exist okay is equal to true. That means it won't raise any exception. This is something we've already looked into. I won't go much deep. And now I want to change the permission level. So I'll just have os.change mode, and I have to import os now. And then I can pass in this directory here. So self.sessions directory, and then I can pass in the mode, which is 00700, standard for a directory. Later on, we are also going to create a checkpoints directory, and similar thing will be done here. Now let's create a function to save the session, and as I told, we require certain information to save a session. We're going to get that information from wherever this persistence manager is called. Let's create it at the top. We'll have a session snapshot because it is a session that we are going to have, right? And this is going to be a data class. Let's import the data class, and then we'll have session ID, which is a string, then created at, which is a date time. We'll import date time from date time, something we've already looked into. Then we have updated at as well. Then we have the turn count, how many turns have happened in this session. And then we have a messages, which is a list of dictionary of string, comma, any, right? Let's import it from typing. And I'll also have two functions here. The first one will be toDictionary. Both of them will be useful, by the way. That's why I'm creating it now only when we've already reached this point. toDictionary is a function that will convert this entire snapshot into a dictionary format. So we'll have return, and then I can pass in all of these things. So we have session ID, which is self.session ID. Then we have created at, which is self.created at. Then we have updated at, which is self.updated at. And then we have turn count, which is self.turn count. And then finally we have messages list, which I can pass in just like that. Great. Now another function that we're going to have is going to be a class method, and that is going to be from dictionary. So you call something like session snapshot.from dictionary, you pass in a data object, which is going to be a dictionary, and you just convert it into a session snapshot, right? So the return value here is session snapshot. And let's import annotations from future, because yeah, we've already talked about this so much. At this point, it's just boilerplate code for us. And now I'll just return, by the way, we don't get self here, we get class. And then we can just do return class and then pass it in, because this is a class method, right? This is not an instance method. And then I can pass in all of the things again. So we have session ID is equal to data at session ID. And actually, I'll just see you after I've typed in everything so that I don't waste much time. Now we are going to take this session snapshot as the value here. So we have snapshot, which is of the type of session snapshot, and it's going to return nothing. And then we can try to store it in the file. So first I'll have the file path, which is equal to self.sessions directory / and then I need to create a new file, right? Because this was a directory of sessions. Now within that, I'll create a new session or save to an already existing session. We just override the value, and then we can just pass in something like this. So we have snapshot.session ID, because that is our unique identifier. Because if you go to our session.py file, you'll notice here we have the session ID created, and that's just a UUID, a unique universal identifier. And the file that we're going to save, by the way, is going to be .json. So all of the data, like the messages list and everything, will go within this JSON. And then I can try to open the file. So with open, and then I'll pass in the file path. Then I'll have the write mode, because I want to write it. And then you can also pass in the encoding maybe, which is UTF-8 as file pointer. And in that case, I'll just do json.dump, and I need to import it. I'm using json.dump, by the way, not dumps, because dumps does a string dumping. We are trying to dump the entire object here, and I'll pass in the snapshot, but snapshot is a session snapshot. That's why we created a toDictionary method. And then I'll pass in the file pointer, and then I'll also pass in the indentation, which is 2, because whenever I'm trying to store a document, what I like to do is have certain indentation, because even if the user wants to look at it, it's just formatted nicely, you know. And after that, I would like to change the mode of this file as well. So we have os.change mode, and I'll pass in the file path, and then the mode is going to be 00600. 00600 means that all the access is to the owner only, and they have the read and write permissions. So the 6 here represents the user related permissions. Then 0 is for the group, and the 0 again is for the world permissions. 6 means 4 plus 2, because 4 stands for read and 2 stands for write. So 4 plus 2 is 6. So by the way, if you just do 400 here, what will happen is that the user will have only read permissions. They won't have write permissions. If you do 200, they only have write permissions. They don't have read permissions. But 600 is read and write both. And for the rest of them, it's just 0. And if you want to add any debugging, go for it. But what I'm going to do now is just create the persistence manager within the main.py because that's where it is useful. So I'll have something like persistence manager equal to persistence manager, and I'll import from agent.persistence, and then I can call the save method. So I have persistence manager dot save session, and I'll pass in the session snapshot now. Now I have to create the session snapshot, which I can do over here as well. So I have session snapshot is equal to session snapshot, and we have to import that as well from agent.persistence. And now we can pass in multiple things. So the first one is session ID. Well, we do have access to that, so I can just do self.session or agent.session.session ID. After that, we need the created at, that's also present within the session. So we have self.agent.session.created at. If you want, you can create another function within session.py, which is a wrapper around all of this. So like it just encapsulates all of this logic. Then you have updated at, which is self.agent.session.updated at. Then you have the turn count, which is equal to self.agent.session.turn count. And as you can see, turn count is a private variable. I have to fix that. So I'll have @property here, def turn count. Then we get a self, we return an integer, and we return self.turn count. Now I can come back to main.py and have self.agent.session.turn count. And finally, we have the messages list, which is self.agent.session. And this time we're going to access the context manager because that gives us all of the messages. So we can pass in get messages here, and it's a function. So I'll just call it, and that's it. Now I can take this session snapshot and pass it in over here, and boom, we are saving the session now. So I would like to tell the user that, yeah, it was successful. We are printing out the session. Good for you. So we have success and a /success, after which I say session saved, and then I pass in self.agent.session.session ID so that the user can keep track of the session ID. So yeah, let's try it. I'm going to open up the agent again. This time I'm going to ask something like, hey, how's it going? And then let's ask another thing, are you doing good? And now what I'm going to do is save this session. So I'll have /save, and we run into an error. Object of type datetime is not JSON serializable. And that does make sense. We are directly passing in the datetime object within a dictionary and then passing it into json.dumps. That's not right. So what I need to do is go to this persistence, and within this to dictionary, I will convert this created at into ISO format. And then similarly for updated at, we are going to do .iso format. And in the from dictionary, we are going to have data at created at. And this is also going to be a dictionary that's coming from the file system, right? So we have converted it into ISO format when storing it into the file system. And when we are retrieving it, we are just passing it like that. That's not right. We have to convert it back into datetime. So to do that, we can do datetime dot and pass in from ISO format. And then I'll pass in the string, which is data at created at. And similarly, I'll do datetime.from ISO format and then pass in date at updated at. And that's it. That should fix our errors. Now let's try the same thing again. So I'll have, hey, how's it going? I hope everything is good with you and your family. Okay, awesome. Now let's try to save it. And it does say session saved in this particular thing. Now, if we try to go and find out the data directory where all of this is stored, you will find the session with this name .json. But I'm not going to spend much time finding it. What I'm going to do instead is create a function to list out all of the sessions. Instead of having save, or just like having save, we are going to have sessions as well. And that will list out all of the sessions that I have. And now I can go to persistence.py and list out all of the sessions. So I have def list sessions, and we have self. It's going to return a list of dictionary of string comma any. Now I'll just try to go over all of the sessions that are present. Where are they present? Within the sessions directory, and they're present within a file. So what I can do is go over every file within the directory, right? And to do that, I can just do for file path in self.sessions directory.glob. If you remember glob, it will just help us iterate over all of the JSON files, because all of the non-JSON files are irrelevant to our case. Whenever we are storing sessions, it has to be in the JSON format. Otherwise, it's been tampered with. And then I can try to open the file path that we are in. Then I want to open it in the read format, and I can just pass in the same encoding when I was writing it in, which is UTF-8. And then I'll just do data is equal to json.load and pass in the file pointer. So I have to open it as a file pointer as well. And now I can maintain a sessions list, which I'll ultimately return. And that is going to be sessions.append, and I'll pass in all of the data. So the first thing is the session ID. Now the reason I'm not doing something like session snapshot.from dictionary and then passing in the data is because we have the messages list here as well. And I don't want the messages list displaying out to the user when we are trying to list all of the sessions. That's why I'm going to do basically the same thing, but this time excluding the messages. So here we go. We'll have session ID created at, updated at, and turn count as a string. Then the equal to sign will be converted into a colon, and yeah, that looks good. Those are all of the sessions. So at the end, we can just return the sessions, but just doing that is not enough. We have created at and updated at. What if I sort the sessions by updated at? That will just give the user the latest session, right? So we have sessions.sort, and then we'll pass in the key, which is lambda x at updated at. That's the key we are going to sort based on, and reverse is equal to true, so that the latest updated at shows up first, because updated at is going to be within an integer format, right? Because updated at is going to be in a string format, and that string is just an integer, right? An integer that's converted into a string, because created at is a timestamp kind of thing. So what I'll do instead of this is just remove this part. I don't have to convert it into date time. I'll just compare the data, the string objects directly when sorting, and then we'll just return the sessions. So the latest value will be seen at the top. A descending value is done. Now let's try to list all of the sessions. So I'll have a persistence manager created. After that, we don't need a snapshot. I'll remove that. Then we have persistence manager dot list sessions, and I'll pass in all of the things. We don't need anything within the parameters. And maybe after that, I can do console.print within a bold thing, and we can also do it on a new line. Then the bold will be completed, and then we have saved sessions. We'll go over every session and try to print it out. So for s in session, and I did not save that in a variable, so sessions is equal to persistence manager.list sessions, and for session in every session, we're going to have console.print. Then I'll pass it with the indentation here. So we have the indentation, and then I'll pass in the session along with its ID. So we have s at session ID, and after that we'll just pass in the number of turns and what is the last updated value. So turns is just s at turn count. Then we have updated, which is s at updated at, and that is good enough, I believe. So let's try to list out all of the sessions now. So I run the AI agent again. I do /sessions and then hit enter, and we get an error. The error is JSON decode error, because this is one of the sessions that is the one that worked, and the second one that did not work is over here, because created at gave us an error, and this gives us a nice look into how Python's json.dump works. Because here, when you were trying to do json.dump, it dumped the first entry, but in the second entry, it gave an error because we ran into that datetime object value. So as you can see, it does not first convert it into a valid JSON object and try to put in. No, it's trying to put it line by line, word by word, character by character. And if it results in an error, it stops there. So for that reason, we were getting an error. So I've deleted the invalid session, and now let's try again. This won't happen in the real use case because the user will never run into the case where it did not work out. So let's try to say sessions now, and we do get one saved sessions, turns is 2, updated is this particular value. You would also like to store token related information that comes along with the persistence manager. Since session snapshot, we have something like total usage, and then that is going to be of the type of token usage. And here you pass in something like total usage here, which is self.total usage, but you have to convert it into a dictionary. So you do dot dictionary like that, or you create a specific function to convert it into a dictionary and then pass it in. So here you just do that, but I think data class should handle it. We'll see. And now we're going to have the total usage here as well, which is equal to data at total usage. And we have to convert that into a valid total usage. So we'll have total usage class here, and we'll pass in all of the things. Also, this is token usage, not total usage. And here we get prompt tokens, completion, total, and cached, right? What I can do is try to deconstruct it within this particular class. I hope that works out. I've not tested any of this, so let's see. But when we list out all of the sessions, I don't have to tell the user how much tokens were used. So that's fine. And now I'll just delete off the previous session so that we have a good perspective of how things are looking. And now we can go back to main.py where save session is called, and I'll pass in the total usage as well, which is self.agent.session.contextmanager.total usage. Now let's see how that looks like. I'll exit out of here and rerun. Then I'll say, hey, how is it going? And then I'll say save. Session is saved. Let's try to open up the Visual Studio Code, and here we have session ID created at, updated at, messages, and then the total usage, which is 7,616, 24 completion, and 7640 total. And now when we try to list all of the sessions, I can just do sessions like that, and we see one session. That's great. Now what I'd like to do is load up a session if we want. So let's say I save a session, and then 2 days later, I come back to a session. I want to load it up. In that case, everything should be perfectly fit in within my context, within my session, everything. So let's work on that. What we're going to do is again, create a similar command to sessions, or actually save. So let's just copy that and paste it in over here. And then we're going to have resume. Resume is for a session, and if we want to load up a checkpoint, it's going to be restore, because we are restoring a checkpoint. We are going back to a previous position potentially. So we are restoring, but in a session, we are always resuming, because if you try to save a session 3 or 4 times, it will update the same value, because it will try to write to the same file ID, right? It will write to the same .json file, and it will override the value. That's how session works. So here, first thing I'll check is if the command arguments is not specified. In that case, let me go ahead and do console.print. I'll pass in the error. Then I have a /error. Then I have usage is resume. And then you need to pass in the session ID. I think that's enough of an error message. Let's leave it at that. I can go ahead and create a function so that I can resume the previous session. So I'll go back to a persistence, and here I have to create a very simple function. So instead of saving a session, all I need to do is open a file, read it, and load up the session. Because once I load up the session, I'll have all of the details about a session. And then based on that, I can make my decision of how I want to load it. So I have session snapshot or null value because it can potentially be a wrong value that's passed in. Then I have the file path with self.sessions directory. I pass in the session ID. So we are going to get the session ID from the parameter here, and then we are going to pass it in like that, session ID.json. After that, I'll just check if that file path exists because the user can obviously pass in the wrong session ID. In that case, I'll return null. But if the file path exists, then I'll open up the file path. I'll open it in read mode, and then I'll do data is equal to json.load. And then I'll pass in the file pointer. Nothing else is required then. And then once I have the data with me, I can just return session snapshot.from dictionary because I have to return a session snapshot. Until now I have a data dictionary, so I just return that, and yep, that's it. Now I can call this load session in main.py so that I know what details are required to resume a session. So we will have an else here, and then first we have to load up the session. So we'll do snapshot is equal to, and I have to create a persistence manager as well. Let me just paste that in, and then I have persistence manager dot load session, and then I'll pass in the session ID, which is whatever the user passed in through command arguments, and then I'll check if that snapshot exists. If it doesn't, then I again have to tell the user that, hey, listen, we have an error with us. This snapshot that you said does not exist. So we'll have snapshot or session does not exist. But if the snapshot is there, then what are we going to do? Well, in that case, again, we'll have an else condition. This is getting too nesty. Then I'll go ahead and create a new session now. So we'll have a new session object created here, and then I'll pass in everything. All we require is a config. So let's pass in the config equal to self.config. After that, we have to update the variables because in session, it goes ahead and updates the value like created at, updated at, all of that. But we are resuming a session, so we need to go back to those values. So we'll have session dot created at is equal to whatever we had in snapshot dot created at. Similarly, we'll have session dot updated at, which is equal to snapshot dot updated at. And similarly, we're going to have session dot turn count, which is equal to snapshot dot turn count. And for total usage also, we'll have session dot context manager dot total usage is equal to session dot context manager, or not session, sorry, snapshot dot total usage. You might also want to store the latest usage in the session because that's how we manage the session. But I forgot about that, but that's something you should do. I would recommend you to pause the video and do it yourself right now because that's very important. I'm just not going to go back. It will take too long otherwise. And now I have to restore all of the messages and add it to the context manager. And to do that, I'll go over every message that is present within the snapshot messages. And then I'll check if the message.get role is equal to system. I will continue. I will ignore it because system prompt will be regenerated and re-added. That's how our get messages function in our context manager works. But if the role is, let's say, equal to the user, in that case, I'll just do session.contextmanager.addUserMessage and I'll pass in message.get, and then I'll pass in the content. And if the content is not present, it's going to be an empty string. So I'll just copy this line because this will also be required if the role is assistant or tool. So I'll have elif message role is equal to assistant. In that case also, we'll add the assistant message. I'll pass in the content, and if there are any tool calls, I would like to add that as well. So message.get, and then we have tool underscore calls. After that, I'll have another one, which is elif message at role is equal to, let's say, the tool role. In that case also, we'll add the tool result. And for that, I just need to pass in the tool call ID. And if it's not present, an empty string, or we also have the content if we have to pass that in, and that can be an empty string as well. So yeah, that's all of it for the context management. After that, we can just return the session from here. Actually, we don't need to return anything. What I can do after this is self.agent.session and then try to close that session related stuff. And if you remember, what is all of that? Well, if we go back to our agent.py, we were closing the client and the MCP manager, right? These are both the things that we want to shut off. And then we set the session to null as well. Well, I'm not interested in setting the session to null. Instead, I'll just set both of them to close, and then I'll reinitialize the session based on whatever we created over here. So I'll have self.agent.session removed, and instead I'll do self.session.client.close, and I will have to await that. By the way, I'll have to do self.agent.session.close. Similarly, self.agent.session.mcpmanager.shutdown, or what you can do is move both of them into proper functions. So within the session, you have a close function where both of them are called, and within agent.py, you call that close method. But I'm just done working on all of that now. I'm not interested in any refactoring. So I'll just convert this function into an asynchronous function. I'll go back to this run interactive where I'll do await self.handle command. And now everything should work fine. At least I'm hoping that. I'll remove all of these persistence manager stuff. That's not needed anymore. So we've closed down all of the things that we needed to close. And now I'll just do self.agent.session is equal to session. By the way, there's another thing we probably have to do, and that is self.agent.session.initialize, because initialize needs to be awaited. That's why it was not present within the init function, right? So we had to explicitly call that initialize function so that we could have our MCP manager and tool discovery and everything. After that, we set the agent.session to this session that we just created, or actually, we don't have to do session.initialize, my bad. We have to do session.initialize, not agent.session.initialize, because agent is the one that we just closed. We closed it because self.agent.session needed to be replaced with the new session that we created. And that's why the new session needs to be initialized. And then we can just set it to session. And I hope this works in the first try, because debugging this is going to be complex. So we have console.print, and after that we can just say something like success, and then we'll have a closing success as well. Let's put all of them into a string, and we'll just say resumed session, and I'll pass in the session ID, which is session.session ID. I can also remove this console.print, and I believe that should work out. If it doesn't, well, we'll have to debug it, and it's going to be bad. Let's see. So we'll have exit. Let's run it again. I'll just say resume, and let's say I pass in X. That session does not exist. That's good. Then we resume, and I'll pass in this session, paste it in, and hit enter. And yeah, we have an error. It says at property turn count of session object has no setter. So we'll go back to main.py, and we see turn count cannot be set up. And that's because, well, it is just exposed as a property. So we'll go to the session, and here, instead of having property just like that, we'll have a property.setter as well. Or what we can do is just make this a public variable. So self.turnCount, and within this file, I'll just set all the turn counts that were present into turn counts that are public and replace all. So I can just click on this to replace all. And that's it. Everything is updated. Let's see if that works out. So I'll just run again. I'll again type in, let's say, session, so that we have all of the sessions printing out. Then I have, let's say, something like, hey, how's it going? I am happy. Let's say, hey Rivan, I'm doing great. Thanks for asking. Great. Now I can just resume the previous session. So this particular session that we After this, I can just resume the previous session that I had. So this session should be lost. And yeah, we have another error. None type object has no attribute total usage. So if we go to the context manager dot total usage, and this happens because the context manager over here is null and we are setting this to total usage value. We are calling total usage on that. And the reason it is empty is because if you go back to the context manager or the session, you'll notice that the session is initialized with context manager as null. And later on, when we call initialize, the context manager is given a value. So what I like to do now is call this self.session.initialize beforehand only. So we have something like await self session.initialize. So that will initialize all of the values. And now I can update whatever I need. That should work out because context manager is now there. Let's run it again. I'll say, hey, how's it going? I'm happy, so that it just knows what I was talking about. And then I can try to resume a previous session. And then we have another error. Property total usage of context manager object has no setter. So let's go back to our context manager, and here we have total usage, and that's true. It is just a property, not a setter. So we'll have to update that as well. Let me just remove that @ property. Let's expose it outside as total usage. And then I'll update all the self.total usage that are private to be self.total usage that are public. And then let's replace all. And now let's try to run it again. I'll paste in the same prompt. I'll try to resume the same session. And as you can see, it resumed the session that's passed in over here. But there's one problem. The resumed session has a different session ID now. Because think about it, what happened here? We called session, so it initialized a new session ID, and then we did not update the session ID at all. But we are storing it in snapshots, so it should be easy for us. We have session.session ID equals to snapshot.session ID, and now it should work as expected. So let's try again. I'll ask the same question. Then just for fun, I'll say, what did I say previously? And it does say, I said I'm happy. So now let's try to resume the session, and then we get resumed session at this one. So the ID is now correct. And now I can ask the same question. What did I say previously? So the context should shift now because we have a different session that's loading up, and it looks something like this, where I asked it, how's it going? So a bit different. Let's see. What did I say previously? And it just said, you mentioned that you love clean code but struggle to write it. Maybe I can tell it, what did I ask you in my first message to you? And it does say, in your first message, you asked, hey, how is it going? So that's great. That means resuming a session also works. I can also save this session again, and that's a pretty useless session. And I can exit out of here. I can create a new session. You know, whenever I create a new agent, a new session is there, and I can resume the session that I want. So maybe this session. And yeah, we are back into this conversation. So that's awesome. This is why I was telling you that in every session class, we are going to add a new instance of MCP Manager or Chat Compactor, because we can have multiple sessions and I don't want that conflicting. So yeah, that's awesome. Now the next thing we are interested in is checkpointing. So we have created Session Manager. Something very similar to that is going to be in the checkpoints as well. To create a checkpoint, the user just has to pass in /checkpoint. So I'm just going to copy this /save because it's going to look a bit like that, because instead of just saving a session, we are saving a checkpoint. And I've already explained the difference to you. So we have /checkpoint. Then we have the persistence manager. Then we are going to also create a session snapshot, but instead of saving a session, we are going to have save checkpoint, because save checkpoint is going to take in the same session snapshot. We're going to store all the information regarding a session, but at a specific time. That's going to be the difference. Session just overwrites everything. Checkpoint can be created at different time intervals and at different message points. So let's go to the persistence manager and create the save checkpoint function. So you have def save checkpoint. Then we are going to have a self. We are going to get a snapshot, which is going to be the session snapshot. and it's going to return a string. And now we are going to have all of the stuff related to checkpoints. So first of all, I would like to have a directory of checkpoints. So I'll just copy these two lines, paste it down here. We are going to have checkpoints directory, then self.checkpoints directory.make directory. Then we have checkpoints here, and that's it. We'll pass in self.checkpoints directory.make directory, and then os.change mode, and then I'll pass in the checkpoints directory again. Now I can scroll down, and here when we are trying to save a checkpoint, I would like to create a file path. So I'll have file path equal to self.checkpoints directory / and just passing in the snapshot.id is not enough, because a session ID is just not enough. You can have multiple checkpoints within a session. So if your file's name is a session, each checkpoint will just override the value, meaning you won't be able to have multiple checkpoints. So what I'm going to have instead is, first of all, I'll pass in the snapshot.session ID with an underscore. This will really help us later on when we're trying to list all of the checkpoints related to a particular session. And then I'll have the timestamp added here. So the timestamp is going to be datetime.now, and then I'll format this string and I'll format it in this time. So first we are going to have the year, then we are going to have the month, then we are going to have the day followed by underscore, then we have %h, which is hour, then we have month, then we have minute, and then we have second. And now I can just pass in this timestamp after the underscore. So that's the differentiating factor, what time you create the checkpoint on. After that, I would just like to open this file path and save stuff in it, right? So we'll have write, then we have encoding, which is equal to, and then we have UTF-8, and we're going to have this as a file pointer followed by json.dump. Then we'll pass in the snapshot to dictionary, and then we'll pass in the file pointer indent is equal to 2. After that, again, we're going to have the os.change mode. Then we are going to save this file path with 00600, and then we are going to return the checkpoint ID essentially. So this thing that we have here is going to be the checkpoint ID. That's what I want to return from here. So we have checkpoint ID is equal to this thing, and then we have checkpoint ID dot JSON, and let me just convert it into a string, a string, and then yep, that's it. So we return the checkpoint ID from here, and that is us saving the checkpoint. As easy as it gets. Now I can go back to the main.py where we create a session snapshot. So we have the session ID created at, updated at, the turn count, all the messages, the total usage, and then I just need to call save checkpoint, pass in the session snapshot, and we'll get the checkpoint ID from here. Now checkpoint ID is always returned, but it might be the case that, so I can just take this checkpoint ID and say checkpoint created, and then we pass in this checkpoint ID over here. Awesome. Now let's try to run it. So I have Python main.py. I'll just try to list out all of the sessions. This was the session. I'll just resume the session, and I can create a checkpoint here. So it says checkpoint created. And if I go to my folder here of AI agent, here we see the user memory as well, but we want to go within checkpoints, and here is our checkpoint. It has the same stuff as a session. The only difference is that within a session, you can have multiple checkpoints. That is the only difference. So now we have to load a checkpoint, and doing that is almost similar to what we did when we tried to restore this particular thing, this resume session. So I'll just copy it and paste it over here. Now let's say if the user passes in restore, in that case, we first check if the command arguments is specified, because the user needs to have passed in the checkpoint ID. So we have restore, and then the user needs to pass in the checkpoint ID. Then we go to the persistence manager. We try to load a session. Nope. We try to restore a session or load a checkpoint. So we have load checkpoint here. Let's go to the persistence manager and create that function. So similar to this load session, we'll have a load checkpoint. Let me just create it down here and I'll just paste the checkpoint here. So we go to a particular directory, which is the checkpoints directory. We get the checkpoint ID here, which is going to be a string. And then we just go to checkpoint ID.json. Then if the file path does not exist, we return null. And then we just try to open the file and return the session snapshot. Awesome. Now we go back to main.py. We have tried to load the checkpoint. So we get the snapshot. If the snapshot does not exist, we'll just say checkpoint does not exist. And then we get this. We could try to create a session again. Then we update all of the values as necessary. And yeah, we have updated the session as well. This is how easy checkpointing was, because we are just storing session within a checkpoint. So let's try to exit. Let's try to have Python main.py, but actually we don't have a checkpoints list, but we do have the checkpoint ID here. Let me just do /restore and I'll pass in this checkpoint ID. By the way, I needed to update this value here when I had restore, saying that yeah, we've resumed the session, and I pass in the session ID. But I could also say something like, yeah, we've resumed the checkpoint. So I have resumed session, and then we can pass in checkpoint as checkpoint ID. Awesome. Now it won't matter here because we won't be able to see it, but I know that should work. Let's hit enter and we see resumed session. And this was the session that loads up, just like this one. That's great. I'll just ask, what did I say to you in previous messages? Let's hit enter. And these are what I asked. Great. So let's try to exit here. Now the last thing we want to look into is listing all of the checkpoints that are available. I'm not going to get into that because listing all of the checkpoints is as simple as listing all of the sessions. All we need to do is go over all of the JSON files that are present within the checkpoints directory and just add it and display it on the main screen. One thing I would like to say though is that if you want to load all of the checkpoints that belong to a particular session, you can do that. How? Well, all you need to do is go over all of the JSON files, but this time the pattern will change. Instead of having asterisk.json, what you can have is something like session ID underscore asterisk.json. Because remember, whenever we are creating a checkpoint, what are we doing? We are having a session ID underscore. That allows us to filter by a specific session ID if we want to. So if you want to load all the checkpoints that belong to a particular session, this would be really useful. So yeah, you can do that. And yeah, that's pretty much it for this entire AI agent tutorial. There's lots of stuff to do. I'm sure there are a lot of bugs that you'll have to fix, but I've just not encountered them yet. Then there are a lot of prompt tunings that you'll have to do yourself to fit your use case. And there are multiple features that are also left out. For example, AI agents also have the feature of sandboxing. That's something you might want to work on. AI agents also have the feature of LSP. That's also something you might want to work on. And a lot of techniques are still being developed. Also, the tools that we have are kind of basic. You can make these tools much more advanced and much more fast as well if you do certain optimizations. So there's a lot of scope and a lot of stuff to be done. There are also new techniques that are being developed regularly to improve AI coding agents. So let me know if you need a part 2 of this entire course. I'd be happy to create one, but I would really encourage you to try out all these new things and the bugs yourself, because that's where you learn the most. So thanks for watching, and I'll see you in the next video.